Ever wondered how Amazon seems to know exactly what you want to buy? Or how Instagram and YouTube always seem to suggest videos that keep you glued to your screen? And what about Spotify? Effortlessly crafting playlists that match your vibe. With a base salary ranging from 5 to 10 lakhs per annum and an increasing demand in IT sector, data analytics has become one of the most critical aspects for shaping the future. If this wasn't enough already, according to a report by Forbes, the data analytics market is set for an explosive growth. We are talking about growing from 5 trillion Indian rupees in 2023 to over 47 trillion rupees in 2033, meaning analysts are going to thrive and not be replaced by AI anytime soon. Welcome to the Data Analytics Full Course by Intellipaat. This free course has been designed according to the latest market trends of 2024 and is delivered to you by the top industry experts from leading companies like Google, Meta and Microsoft, sealed shut with the most frequently asked interview questions. If you stick to the end of this video, I can assure you without any doubt that you will have enough knowledge to be able to extract meaningful values out of any dataset like true data analyst. Now let's look into the topics that will be covered throughout this video. We'll start by understanding basic topics like what is data analytics, need of data analytics, who are data analysts, followed by data structures like pandas along with topics like what is EDA and why EDA in Python. Then we'll move on to NumPy, where we will learn about multiple EDA operations that you will perform with both NumPy and Pandas. Stepping forward, we'll also discuss about data visualization using the popular Python libraries. After that, we will discuss inferential statistics for data analytics. Finally, towards the end, we will wrap up the session with one industry-grade data analytics project, which you can directly add over your resume to get recognized by the recruiters. After that, we would be also taking you through the most commonly asked data analytics interview questions. If you go through this course properly, we are sure that you can get entry-level data analytics job. So make sure to stick till the end of this video.
We've all heard this term somewhere. It pretty much rings a bell that every time we think about it, right? So analytics with respect to data. Well, what are we trying to analyze is what we need to know here, right? So the formal definition of how it goes, it's basically extracting meaningful information from raw data. It's as simple as that. So we have data, right? So consider anything to be data. If that is not useful to you at that point, it is considered as data. But then if you perform some operation on this data and make sure that it is useful for your organization, this is when the data becomes information. And this information is what is usable for you, right? So the process of pretty much converting raw data into information by performing certain analysis on it can be termed as data analytics, guys. I mean, this is just a very rough definition of what goes in the industry. To give you a better insight of what that means, basically it is the pursuit of extracting meaning from raw data using specialized computer systems, guys. And then these systems, they transform, they organize, and they model the data. End of it is to basically draw the conclusions from all of the data. So you'll have, again, as I've mentioned with the raw example, our goal here is to basically draw conclusions, to identify patterns, to make use of this raw information in a better way. I mean, sure, data can just be used in its raw form, but then not with every case, right? And to give you an example, so think of the data, probably you understand. So let's say you're looking at a huge data set which contains thousands of values. Those are just numbers, right? So having these numbers, sure, as a data analyst, you will understand what you're doing. But then let's say you need to explain it to a person who doesn't know what data analytics is, or you need to explain it to someone, probably your peer or someone above you as well. Let's say you have a business meeting where you have to explain this. Giving the numbers will not really be that great, right? It will not make a very good presentation. So converting all of these numerical data, making it into graphs, making it in a way where everyone understands the data, and showing out graphically whatever insights that you can generate from the data, that can be considered as data analytics as well, guys. Again, today basically the field of data analytics is ever so growing rapidly. And why is it growing so rapidly? Well, because the market demand for it is that much. So we have pretty much every startup companies these days have a requirement for big data as well. So big data, to dumb down the definition, it pretty much means a huge amount of data that cannot be handled by just one machine. If you're stretching out your data across multiple nodes, you have data coming in from various sources. Then you need a method to handle all of this big data that's coming in, to process the data and then to perform analysis on it, guys. So this has been in demand in the market for a while, and for the last couple of years, data analytics has been in the boom, and then it's providing a very straight answer to all of the questions being raised about how all these can be handled, guys. And of course, we're going to need the people who have the skills which is needed, and the skills which are needed to manipulate all the data queries, to translate all these numbers into graphs, and to make insightful analysis on it, right? So that's what is the main key role of a data analytic person. What is the need for data analytics if we have to break it down into 3 steps, guys? So again, we already know that it is on the rise, right? So I can pretty much go about to step out into the open and then tell you that it is not soon that it will be an integral part of an organization. It is already an integral part of every organization there is, guys. So the first important need is, again, we already know that it is a top priority for all of these organizations, ranging from the small organizations all the way to the big guys. And then this is needed to make very good decision making. Well, with respect to you being confused to, let's say, take a decision for you, then looking at this analytics will make your decision making skills and decision taking skills a little bit easier, and it'll be more validable as well, guys. And it'll be more validated as well, guys. And the second thing is to we require new revenue, right? So let's say you have the data which pretty much only a couple of people can make sense of understand. Let's say your market is very niche. In that case, sure, you'll be still making revenue, still be making money on it. But then at the end of the day, if you have to reach out to a broader audience, you need to make sure your data is understood by this broader audience, right? So that forms the second very important need for data analytics, guys. And the third one is to obviously decrease these operation costs for every organization. So this can be a very demanding task if you have to convert raw data into information, process the data, and make out very good visualizations out of it as well. But then if you have the workforce for it, then sure, you can do it. But if not, again, since it's probably a manual task, and until a couple of years ago, it surely was a manual task. And these days, you can implement machine learning and data analytics to pretty much automate itself and make your job easier as well. Our goal, it speeds up your work. It keeps you very efficient in such a way where your data is being visualized, processed very effectively. So again, time is money when it comes to big organizations, right? So on that note, pretty much it helps decrease all of the operation costs with respect to, either waiting in the data pipeline, or waiting to process, waiting to publish, waiting to do some analytics, waiting for visualization. All of these waits, you need not consider them anymore because they will pretty much be reduced to null, guys. On that note, you might be wondering, who are data analysts, right? Data analysts are the people who sit at the end of the chain. I'll just explain the chain in the next slide. So these guys form a very good workforce for the company, where they basically deliver the values by taking in all the data that data scientist might give it to them, a data engineer might give it to them, and then he uses this person, data analyst, uses all of these to answer a couple of questions and then communicate all of the results back. And all these results that he just gives back is basically used to take very good business decisions, guys. It might include analytics of past trends, it may be prediction of what the future looks like, and so much more. And then the common tasks done by data analysts are data cleaning, performing analytics, and then creating visualizations. Well, data cleaning, to come about it, is basically simple, guys. So again, data is raw information, right? To make sense out of it, to pick out information that we only require, and to make sure that, again, efficiency is the game here. If you're pretty much processing data that we pretty much will not require, then it's just a waste of time and resource. So cleaning the data, making sure that your data is just perfect enough for processing, that's a very important first step, guys. So this is the spearhead of a data analyst's role. And then the second one is obviously as soon as your data is clean, you need to perform some very good analytics on it and create very good visualizations, guys. So these four designations you see on the screen right now is basically the designations a data analyst is also known by. So the first is a business analyst. So data analyst is also a business analyst. He or she can be an operations analyst, a business intelligence analyst, and a database analyst as well, guys. So coming to the tasks that they pretty much do, the first important task that we already spoke about was cleaning and organizing raw unstructured data, right? So this is again a very overlooked concept in today's world unless you get your hands dirty with the data itself. When you start to go about doing that, you will realize that cleaning and organizing the raw data is extremely important, because at the end of it, your data might be unstructured, your data might be semi-structured, or it might be a structured data. This will not matter if the data you're processing is of no use at the end, guys. So cleaning and organizing raw data is very important. And then the second thing is the analysis of all of the hidden trends found in the data. So making sense of something, again, maybe predictions in the future, or looking at past trends, generating this sort of an information which you cannot figure out upfront just by looking at the data. This is pretty much the umbrella under which the hidden trends function of a data analyst's work. So you'll be looking at a data, you'll find something very interesting. So let's say you find a trend in your data where pretty much you can access a new side of the market with respect to your sales in the next 5 years, 10 years. And then you were not told this, but then your data was telling you this. So you making sense of the data in which this trend was found, which was not upfront, then this is again a very important skill of a data analyst as well, guys. And the third important thing is pretty much the big picture view using descriptive statistics. At the end of it, sure, we know what the past trends of the company are, we know how the company is going on now, but then if you need to just summarize all of this and say even add some predictions for the next 5-10 years, getting this big picture view of what's happened, what's happening now, and what will happen in the future, not just using very simple statistics, but using descriptive statistics where we'll be picking up each aspect of what's going on and then perform analytics on it and find out what's going on. If we are right at this place, if we are wrong at this place, how can this be improved? How can this concept be checked? How can we reach the clients better, and so much more. So getting this big picture view is again a very important task a data analyst goes about doing, guys. And the fourth one is probably the most important thing a data analyst does, is pretty much the creation of dashboards and visualizations, guys. So as I already told you in the introduction part of the video, where we're starting out with raw information, again a lot of numbers, but if you have to show these numbers at a business meeting, numbers are numbers, some people like them, but a majority of the people who they might not understand the numbers. So making these numbers as your input, creating very good visualizations, giving them a user interface, and giving your customers, your peers, your superiors, your business meeting members, giving them a very good user experience with all of this data, again at the end of it will add up to very good business methodologies, and then it will help you take better business driven decisions again. And again, the same goes for presentations of results to your clients and your internals as well, guys. So coming to the chain of how the data moves around in a firm, I have three important things that I just want to walk you through, guys, in a quick gist. As the first person who is the spearhead of the data for an organization. By spearhead, I mean he's the first one who look at the data, or he'll be responsible for bringing in all of the data from various sources, guys. So data coming in from the various sources, right? So think about all the data you can get from Twitter, or if you're performing any sentiment analysis, think of all the data that can come from all of the big data sources. You can have data coming from your various nodes from Hadoop, so much more. You can have your data coming from your own network, away from your network, and so much more, guys. So the data engineer is a spearhead who handles bringing in the data and making it understandable by the organization, guys. And then as soon as the data engineer finishes his part with the data moves on to the data scientist. The data scientist, he's responsible for working on all of these raw data, converting it into valid information. But then we already told this for the data analyst as well. Well, the data scientist pretty much uses machine learning algorithms. He uses deep learning. He uses, let's say, binary classifications, naive bias. He makes use of so many concepts here our data analysts might not know. And he uses a lot of machine learning and deep learning, as I've already mentioned, to convert this raw data into valid information. And 99% of the time, the information which is being converted into are numbers, guys. So after the data scientist pretty much goes about doing his magic onto the data, and then we have the data analyst who steps in. This person, again, as we've already been mentioning, he is responsible for the prediction of what happens in the future, that is finding out trends, and then the presentation of all these informations to your peers, to your clients, to your superiors, and so much more. This is the basic gist of how data moves around. So the data is first seen by the data engineer. He does his job, comes to the data scientist. The data scientist works his magic via all these fancy algorithms and whatnot, and then pushes the data to the data analyst. The data analyst performs predictions, sees trends, visualizes the data, makes it presentable for everyone to understand, and then eventually goes about analyzing the data, guys. So on that note, we can come check out the type of data analytics that can be done in today's business, guys. There are a couple of types of data analytics, and I'll be walking you through the same. So the first type of data analytics you can go about doing is the descriptive analytics. With respect to descriptive analytics, again, the quick one phrase answer to what descriptive analytics is basically picking out data from a source, summarizing your data, making sure your data can be understood by everyone, that is picking out very good insights from your data, from all the past events, doing some predictive analytics on that as well, and then keeping it ready so your data is descriptive at the end of the day. And a question which goes by to understand the descriptive analytics is what happened in my business. So the answer to this question, what happened in my business, is given to by the descriptive analytics, guys. So most of the time, the data which is generated by descriptive analytics is very comprehensive, it is extremely accurate, and the visualizations are very effective as well. So here's a very simple scenario that you guys can consider. So consider a scenario where an e-learning website decides to focus on a trending course according to the analytics of the search volume of the course content, which pretty much the users go on searching, and all of the revenue generated by the course in the past few months as well. So there are certain technologies, again, we live in a world full of trends, right? So let's say data science is in the boom right now. So pretty much any e-learning company, or any company for that matter, they're going to find these trends. They're going to know that, hey, data science is sitting in the top tier and we need to do something about it. If they have students in data science, then most of these companies are aimed at making the students' life better, right? So even as a firm here in Intellipaat, that's exactly what we do as well. We get this amazing insight from all of our learners for any particular course, and we use all of those insights, all of the feedback that we get, and what's trending in the market, what's latest in the market, and we use all of these to perform analytics, and then pretty much all of these helps us to put out a better course as well, guys. So at the end of it, you can already see how the descriptive analysis is already helping our business, right? And then the next type of data analytics we can check out is the diagnostic analytics, guys. So we already checked out what is happening to my business with respect to descriptive analytics. With respect to diagnostic analytics, you will check out of why this particular thing is happening to my business, guys. To simplify it, again, it basically gives you the ability to drill down to the root cause of why something is behaving just like how it should, guys. So drilling down the data to identify certain set of problems which are present in your data or in the trends that the data shows is a very vital part of diagnostic analytics, guys. And then it basically helps in answering the question for us about why the issue has occurred, So it just takes one look towards the data, towards the analytic result of the data, to understand what the cause behind a problem, if one should exist, as guys. So again, to give you a very simple scenario of how diagnostic analytics would work, let's say consider a company where the sales went down for a month. So let's say they weren't doing as good as the previous months. So to diagnose this particular problem, you will let's say consider the situation where the number of employees were quitting their job and they weren't bringing in a lot of sales. So this could pretty much, this number of people quitting the company could directly impact the sales that they brought into the company. So the sales went down this month because they did not have the company right. They did not have the sales right. So finding out why this is happening and hunting for that root cause, which is basically a treasure hunt with your data, where you go on finding something and taking insights from your data. Finding out that why part of it is extremely important, where you'll be finding out what's happening to the data and why it's behaving this way, guys. So this again is a very vital part of diagnostic analytics. And coming to the third type of data analytics, it is predictive data analytics, guys. And as the name suggests, the quick question you'll be asking is what will happen in the future based on the past trends, guys. So finding out, hunting out, historical patterns that are being used to basically predict all these specific outcomes using, let's say, machine learning algorithms, using deep learning, and using so many more concepts to predict something in the future based on the data we have now is again a very important niche of data analytics, guys. So predicting the future trends and the possibilities in the market based on the current trends, self-explanatory. And then it helps in optimizing all of the business plans for the future because now your business has a direction to head to, right? So you're predicting certain aspects in the future and you know which path leads to better business strategies, right? And this will give you an edge over all of the other businesses as well. To give you a very nice example, think of the Netflix recommendation systems, guys. So this will basically use statistical modeling to analyze all the content that it's being watched by the audience across the world. So let's say there are a couple of TV shows which are very famous in India, but then there might be a couple of TV shows which is trending in the United States and let's say Australia, United Kingdom, so much more. Making sure that the right users in the right geographical area get to know the right recommendations are extremely important for Netflix as a business, right? So this again, predictive analytics will just do them good there, guys. Again, it will provide us with the prediction of all of the upcoming content and the shows that must be watched by all the different class of audience as well. So let's say someone sitting in the United States is very interested in watching an Indian trending television series as well. So knowing Netflix, finding out that this person exists and to recommend an Indian TV show for this person sitting in the United States to watch. Again, this is another very good business opportunity for Netflix. And then if they go about nailing their recommendation system for everyone, it just makes them a better business model, and then it just makes a better user environment for the users to go about watching videos there, guys. So the next type of data analytics is prescriptive data analytics. So as soon as we think of a prescription, again, we think of a doctor, we think of something, a medical appointment or something, right? Here it's again something similar. The question which will be asked here is what should be done? So applying advanced analytical algorithms to ensure that you make very good recommendations, you make sure you're punching out very good strategies that help the business and so much more is a very vital part of prescriptive analytics, guys. So it basically involves breaking down all of this complex information into a very simple set of steps. And these steps are like the prescription we handed out when we visit the doctor, right? And these are the prescriptions which are precautious as well, let's say. They're the precautions basically used to remove any of the future problems that might occur. And it will also help in performing predictive analysis. This will basically help to predict outcome. And eventually that will help us optimizing business as well, guys. So this again demands the use of artificial intelligence and big data. And then the data analyst person will always be in touch with the data engineer as well and the data scientist as well because he's going to need all the help he can get with respect to artificial intelligence from the data scientist and help with respect to big data from the data engineer as well, right? So all these three guys working in correlation make up a business, and I've already told you that. So again, to give you a common scenario of how this would happen, our consider the prescriptive data analytics that Google Map goes about doing, right? So every day we are commuting from our office to our homes, or let's say we're going on a vacation and then we need to get out of the city as quick as possible. So Google Maps has a wonderful API where they map out the best possible route considering live traffic conditions, weather conditions, road closures, and so much more. It considers your distance, traffic constraints, and again, as I already told you, it even considers if it's raining, if you're walking, what's the best route that you can take to walk, what's the best route to take if you're on a car. And now they've come up with the bike route as well. So if you're in a moped or a bike, you can take a different route compared to the person who'd commute with the car, and so much more. So knowing this kind of a prediction into the future and giving you the sort of a prescription to ensure you don't run into any problems along the way is a very important part of prescriptive data analytics, guys. So on that note, let's quickly check out what the life cycle of data analytics is like. So the data analytics lifestyle, it basically defines the analytics process, our goal, and all of the best practices which goes on from the discovery of the data or the project till the completion of this project, guys. So there are a couple of steps involved in this life cycle process, and the first one is business understanding. At the end of it, again, understanding the purpose and all of the requirements that come from your business, and understanding it from the business viewpoint is very important and vital for the functioning of a business, right? This also consists of a very good introductory plan. It consists of a decision plan. It consists of a formal to-do list, let's say, for the business to go on to achieving the target. So the first important thing about the life cycle is the understanding of what's going on around you, and the second one is the data understanding, guys. With respect to data understanding, again, this mainly involves the process where we're collecting the data and we're processing the data in a way which leads to analytics. And then after the analysis of the data is done, we need to pick up some insights that we can go about using from the data. So extracting all of these meaningful insights from the data, again, is a very vital step in the life cycle of data analytics through data understanding, guys. The third part of it is data preparation. So data preparation is the let's say, converting the data from an unstructured form to a structured form, and this involves constructing, let's say, a data set as well. And then this data set will be provided and fed into a model, and then this model will be used by a machine learning algorithm to train, to understand, to see what's going on, to perform predictions, and then it will be given to the data analyst to be visualized using Tableau or any other business intelligence tools, and so much more. So data preparation, again, is a very important phase where the data is actually being transformed, and even at the stage the cleansing of the data is pretty much performed as well, guys. And then comes modeling. Our goal. This step is very important because it involves the selection of various modeling techniques. Applying all of these modeling techniques, making sure the parameters are right, and all of the readings here are right to ensure that your data being converted into the information, raw data being converted into the information, is of the optimal, let's say, it's of the optimal tolerance that can be used for your business usage. And then as soon as your modeling part of it is done, as soon as the techniques are applied and all the parameters are marked, then comes evaluation, guys. So evaluation is a very important phase where, again, the model which is being built, it will be built very rigorously, tested very rigorously based on what you've built in the initial stages, and then so many tests will be performed on this data as well. So evaluating something that you've generated, performing various tests on it, is extremely important. Most of the time this is overlooked, but then these days everyone knows the value of evaluating your data, guys. So this again involves reviewing all of the steps that are, again, needed to carry out to construct this particular model and to perform tests on it is very important. And with evaluation, that's exactly what we do, guys. So the next life cycle concept I want to tell you guys is deployment. Deployment is the last step in the data analytics life cycle, because deploying is when you're sending out your model into the world, for, let's say, by the world I mean, let's say, for your team, for your peers, or let's say even for your client and customers as well. So making your data go from just you seeing it all the way till spreading the data and perform it, spreading the data to your clients, to your peers, or anyone else. If you can perform more tests on these as well. So after deployment, you can have after deployment tests. If something is wrong, again, you can go back to modeling, perform more evaluation, perform more deployment as well. So the thing you need to know here is that deployment pretty much goes about to be the final phase of the data analytics lifestyle, guys. Our goal, and on that note, we can check out very quickly what are the roles of analytics in various industries around us, guys. Again, data analytics has an amazing insight and impact when it comes to telecom industry, because, again, if you've been observing, all the prices of or let's say the calls, the messages, or the internet packs these days have been coming down and down. And there was a time when they were being exorbitantly high as well. So again, the telecom industry realized that if you keep the prices very high to make more profits, then eventually your customers will not come. They will not buy the internet packs. So to keep this in mind, probably they decided, let's say we're having a bad impact right now, so let's drop down our prices to see if it works, and it is, I guess. And this has helped the telecom industry in bringing better business, and for us as users, it has helped us just make it a bit economical and efficient on our side with respect to money as well. And then the retail banking industry, data analytics has a huge impact in the retail banking industry as well, to know what their customer wants, because again, with telecom industry as well, they have a huge amount of customers to play with, right? So they need to understand the view of each customer, the requirement of each customers, and then to find out if all of the customers are actually in the common chain of what's being supplied by the bank, or if the customers are against something that's being sent by the bank. So our goal, that again is a very important thing that you need to check here as well. And then with respect to the e-commerce industry as well, to perform again some analytics in the e-commerce industry, it might be ad recommendations, or there are very big sales which are run by some of the big names in the industry such as Amazon, Flipkart, Myntra, and so much more. So these guys will have to perform extremely heavy analytics on the data that they see, based on the products that they sell, and based on the places, based on the city in which the product sells, or if the people are unhappy with the price. Again, performing analytics has just changed the e-commerce industry, if you may, guys. And the last most important industry where data analytics has touched is the healthcare industry. This has had the most impact with respect to analytics in the healthcare industry, with respect to so many things. Mainly it is with respect to finding out what medication is required by what countries, what amount of medication is working for what population, and so much more, guys. I can probably talk about just the roles of analytics in these industries for days together, and we can still be going on and have a very good discussion of how important analytics has become these days. Again, with respect to insurance as well, what geographical location requires insurance, what the audience are, and so much more. So again, as I've said, we can go on talking about this, but then to keep it to the scope of this tutorial, we can just quickly brief through each of these guys. So with respect to the healthcare industry, this is the formal way of going about analytics. The first one is to again analyze all of these disease patterns, analyze all of the disease outbreak that pretty much goes out. We had a disease outbreak a couple of years back, which is Ebola, and so much more. We had H1N1 and so much more, right? To keep a track of all of these outbreaks, this basically again improves the surveillance with respect to health, and then this gives out good responses to the emergency sectors as well, guys. And then development of better targeted preventive techniques, obviously, and then with the development of vaccines, making sure your vaccines again reach your customers, and all of these where you need to reach your customers, or let's say in this case the patients are very important, guys. So identifying the consumers again in this is the greatest risk of business. So identifying certain customers or patients who are at the greatest risk is again, because they might be developing some adverse health outcomes, and then developing welfare programs to keep a track of their health, to track their health on a daily basis, even a weekly basis, monthly basis, to perform analytics on all of the aspects and the parameters that you're tracking with respect to the patients. Again, that is a very important thing. And lastly, to ensure that they can reduce readmissions, because they might know what the cause of an adverse effect is. And if there are 10 patients with very similar symptoms, then you can perform analysis, and you can at least filter out and find out that all of these 10 patients might have this one common symptom associated with them, and this might be the cause of that. So mapping that for every patient is again very important, guys. So coming to the telecom industry, again, telecom industry pretty much goes about using predictive analysis to gain all of the insights that they need to make better decisions, to make faster decisions, and to make more effective decisions. Again, as I was talking about the internet pack example, again, this was very key in that. And then by learning more and more about their customers daily, and the preferences and the needs, these telecom companies can be more successful in this extremely highly competitive industry as well. It's good for them with respect to business, and it is good for us as customers by bringing down the prices again. So it is used for analytical customer relationship management, it is used for fraud reduction, it is used for bad debt reduction, it's used for price optimization, call center optimization, and so much more. So now that you're looking at data analytics in this way, you realize that data analytics eventually has a big play, or has a big say when it comes to any of these business models, right? So again, coming to banking, as I've already mentioned, analytics is making banks banks become very smart day by day, guys. So it is managing all of the plethora of challenges that the bank faces, and then again, while pretty much going about doing some basic reporting all the way till descriptive analytics, and this is all a must for every single bank, right? Even performing, let's say, advanced prescriptive analytics or so much more, and all these are starting at this age. Banks have started to realize that this will again help you generate very good insights, and this will result in extremely good business impact, and it will help the banks as well. On that note, we need to check out how data analytics is helping in the banking industry as well, right? So it is used to acquire and retain customers, it is used to detect fraud, which is again extremely important with respect to banking. It is used to improve risk control, find new sources of growth for the bank, and to optimize all of the product and generate their portfolio models as well. So as soon as we check out the banking sector again with the e-commerce industry, right? So this is a market which is exploding for the last couple of years. I can say even the decade, right? eBay came up, Flipkart came up, Amazon is again taking over everything, Myntra, Nykaa. Guys, there are so many e-commerce portals today, and to make sure we perform very good analytics on these e-commerce industries is very vital. So how is data analytics used? Again, it is used to improve user experiences, it is used to enhance customer engagement, customize offers and promotions, maintain effective supply chain management, optimize pricing models, minimize the risk of frauds, provide them very good advertisements that pretty much help them pick up products, good recommendation systems where they'll pick up another product after the first product, guys, and so much more. If you've just bought an iPhone, again, you'll pretty much be recommended with a couple of cases that the people have bought as soon as they bought another iPhone. So you might be that person, you might like the case and you might pick it up. At the end of it, you have the case to protect your phone. The business just created more money out of it, right? So again, the analytics, the role of analytics in e-commerce industry is extremely vital. Let's say the people in the e-commerce industry have known this for a while, guys. So coming to the analytics in the insurance industry, again, here as well, guys, this is basically used to enhance your customer engagement, acquire new customers, retain the existing customers, make sure the customers don't leave, prevent the frauds, at the end of it, reduce the frauds, prioritize all the claims that need, because you'll have medical insurance, you'll have again health insurances, you'll have life insurance, you have so much more that you need to take, and all of these directly impact the user, right? So making sure you take the feedback from the user, work on it, and then create some analytics out of it is again very vital, guys. So on that note, we can quickly come to our case study which I was talking about, and this case study is a very famous one. It's basically the house price case study, and here all we'll be doing is predicting house prices, guys. So we'll have a certain set of data which we will use to predict the prices of the houses. So basically, how can we predict the price of a house? There are so many things that you need to know, right? You'll be looking at the locality in which the house is present, you'll be looking at the amenities, you'll be looking at the number of bedrooms, the living space, the number of floors in your house, or the number of cars that can fit in your garage, the size of the garage, the quality of the construction of the house, if it has a swimming pool or not, if it has a spa or not. I mean, so many things. If we have to list down this particular use case, then it will be extremely tough, because each one of us has our own judgment of how we can validate a house, right? Because house is something that's very personal to us. Again, the materials of what was used to go to build the house, the style of the house which is built in, the number of if the house has an elevator, how convenient is the house for disabled people, guys, so much more. So basically, we'll be performing exploratory analysis on this, guy. So exploratory data analysis again is used to find a hidden trend in your data by performing analysis on it, and then at the end of it, the trends will be shown as numbers. But since we already know visualization, we're going to be pretty much using these numbers to visualize all of the data for us, and we'll be doing it step by step. So we'll be finding correlation between the data as well. So again, correlation is basically to check how one variable is linked and how the changing of one variable directly changes the other variable as well. So how these two variables are pretty much hung up together, how changing one variable changes the other can be known using correlation as well, guys. So a couple of steps that pretty much is generally followed in the case of performing exploratory analysis. First, we'll be visualizing all of our data, finding the missing values, and we'll be looking for correlations, guys. And then after this is done, we'll be cleaning the data to check if any issues are fixed, or if we'll be checking out if the data that we have is pretty much being used fully or not. And then we'll go about building a model which is used to visualize our result. It will give us the diagnostic, it will give us the residual diagnostic, ROC curves, charts, graphs, tabs, tables, and so much more. Guys, I do not want to basically overwhelm you with the use case. So to keep this use case very simple, we'll just perform exploratory data analysis at this stage to find out correlations between the data. And as soon as we go about progressing with respect to our data set and to work with, you will understand how beautiful data analytics is, guys. So let me quickly jump into Google Colab, which is basically a Jupyter notebook hosted on the Google Cloud. And here we can go about performing our data analytics on the use case that I just walked you through. So we're going to need a couple of files to run our use case. We'll actually need one file, which is our training dataset file. Let me just quickly add the file to our Google Colab, and then we can go about proceeding performing our analytics, guys. This will just take a second to upload the file. Give me a second. We just actually need one file from out here, but then it doesn't harm to upload it and keep it in your runtime. But then you just check the message, right? So pretty much all of your files are recycled as soon as the runtime is pretty much changed. So the first step for our use case is to load all of the necessary files and the libraries that we require, guys. So the first, again, we'll be using pandas to handle all of our data. We'll be using seaborn and matplotlib to perform plotting operations on all of this data, to perform visualizations on all of these data. And the style that we'll be using is pretty much called as the BMH method. And with respect to the BMH, again, BMH is nothing but the Bayesian method for hackers. And this is a type of a graph visualization method, which gives us graphs which look nicer, and then it helps us to perform analysis better on linear data sets, guys. So the second thing we'll be doing is, again, loading all of the necessary files. One of the important files we need is the training data set, which is this. And here you have the ID of the houses, you have the subclass of where the houses is present, you have the zone in which the house is present, what is the area of the frontage that you have, what is the area lot of your house, what is the street, what is the alley, again, lot shape, lot contour, what is the year the house was built in, what it was remodeled in, what is the size of the roof, again, so many conditions out here. What is the foundation made of? How is the quality of the basement, condition of the basement, the exposure to the basement, again, finishing type of the basement. Guys, just look at how expansive this data set is. This is, again, a data set which is extremely popular among us analysts, where we pretty much like to work on this because it consists of everything and you can perform so much on the single data set and so much more, guys. So on that note, let's quickly find out the information of all the variables that are present. Again, since I was just working with the housing as heating, how is the quality control of the heating? Does it have centralized air conditioning? How is the condition of the electricals? What is the square footing of the first floor, square footing of the second floor? What is the low quality finish and how many square feet of that do we have? What's the living space area? How many full bathrooms do we have? How many half bathrooms do we have? Kitchen quality. Guys, this will go on, right? So all these data is what we need to check out. Again, if you see here, all of these are the values that are present which will help us map something. But then Ali, again, doesn't have many values. You can check out here itself, right? So Ali, it's NaN is basically not a number. So there are not many, Ali or details which we can make analysis out of. So we will not require Ali. Again, coming down, not much of fireplace quality as well. We do not have pool quality control at all. Miscellaneous features are very less. Again, even fencing is very less. So the average is somewhere around 1400, right? So to make sure that are cleaning up our data, very important part of it is to basically how we go about doing it again. We'll just remove all of these data which are less than 30%. So less than 30% of, again, 1460, and then we can have at least 70% of the data to give us some accurate results, right? So as already checked, alley ID, not every house is an ID, so that's removed. Not every house is mapped to an alley. Pool quality control is not there. Fence is not there. Miscellaneous features are very less. So we have dropped all of these columns and we'll not be using these to perform our analytics, guys. And so again, to describe what goes on to do a distribution, I hope you guys know this concept about normal distribution, and with respect to all of the details that we can get out of it when we perform the math operation, guys. So basically we can count the total number of data that's present, with respect to all the individual data. What is the mean sale price of the data? What is the standard deviation? Let's say the mean of the normal distribution is right at the center somewhere here, guys. So the mean is somewhere around 18,000, right? I'm sorry, this is 180,000. If you just keep tracing from the center point down, this is somewhere where 180,000 exists, guys. So again, what is standard deviation is basically the deviation from the mean. So what is there are house values which deviate from this mean as well. Again, 25% deviations, 50% deviations, 75% deviations. And then what is the maximum sale price of the house as well. So all of these can be found out from this particular graph, guys. And if you can already observe, and even if you're not exposed to a normal distribution, this starts out as a very steep curve, but then it ends out with respect to a lot of data here as well, right? It goes on until 800,000. So basically probably from 5,000 or let's say even 400,000 all the way till 800,000, we call these as outliers. These are called outliers because these are very far away from our normal distribution, and then these actually might not be useful for us with respect to our mean or whatever, and these will impact a lot when we are performing analytics with respect to the mean or the standard deviation or anything for that matter. So we will have to actually remove them and not consider them to basically perform very accurate analysis, guys. So on that note, we can pretty much go on to finding the type of the data set and the type of the data that we'll only consider, because in this particular case, since you're playing with numbers, it has to be the numeric data type, right? Again, as you can check out, we have integer numbers, we have floating numbers, and so much more. So let's pretty much go on to print what it looks like after we have dropped the values where we're not using ID, we're not using alley, we're not using so much more, right? So these are all the numerical values that we'll be using to pretty much consider. Again, year built is a numerical value, 2003 is a date, a year, overall condition, overall quality, all these can be rated from a particular scale, right? So again, a square footing is a particular number as well. So the second floor of this particular house has 854 square feet, so much more. So on that particular note, as soon as we check out all of these numbers are present, we can start performing an analysis, guys. So before that, again, we need to just plot all of these to just check what it will look like on graphs, because seeing numbers are one thing, seeing graphs on the other hand are something else, right? So pretty much we'll be developing histograms and we can be checking out, guys. So let me just scroll down a little. Yeah, perfect. So with respect to first floor square footing, the mean is somewhere around here, right? So it's around, let's say 500 square foot, 1000 square foot. And again, look at second floor the square footing, look at the bedroom average, basement finishing qualities, garages, the number of cars that you can park in the garage, and look at the value here too. So the majority of the houses here have 2 spaces to park your cars. The year that the garage was built in. Again, the ground floor living area, how many half bathrooms? So you can see 1 half bathrooms. Again, at this point of time, you have certain values at 0 as well. Well, sure, we can consider values of 0 if it's very important. But then since we're talking about sale price, what is present is more important than what is absent, right? We need to have something descriptive for our analytics methods to work. So in that case, we'll have something called as the golden features list. And this variable will basically contains all of the features that we'll be associating with respect to why our sales price is as high as it is, guys. So this variable called as the golden features list will have all of the features, guys. So basically we're creating a variable where we're finding out the correlation, and then we can already check out the top 10 correlated values which are strongly correlated. By correlated, again, let's say let me give you a quick impact. Basically, we have described this in the descending order, as you can already check out. So the first thing here is overall quality. Again, to transcribe this into literal terms, overall quality of the house, whatever the rating that was given in our data set, is mattering the most of how the houses is being priced. Again, the living area of it, the number of garages you can park is having almost 64% impact of with respect to why the price is like that. Garage area is having a 62% impact. The basement square footing has a 61% impact. And then the year it was remodeled and changes made is having a 50% impact of why the house price, the sales price is like that, guys. So looking at a couple of linear relationships, you can pretty much find out that a lot of values are zeros that I just walked you through a couple of seconds. And look at that. With respect to our, again, the ground floor living area, we have a very little number of zeros. With respect to the sales price, again, check out the basement surface area again. With respect to the total basement surface area, again, even here as well. So look at all these tiny dots which are sticking taking up to zero with respect to sales price. So these have no impact for our sales price because they're not giving us any valid linear data. Look at this again with zero. Oh, it is raised up to a lot, about $600,000, right? So all these are not adding any meaning to our data. So if x is equal to zero, again, this might indicate that that house does not have that feature at all. So if this is zero, this house does, like, I mean, a lot of houses do not have pools here. So pool area is zero. So in that particular case, we need to remove all of these zeros so that we can go on to finding more correlated values that we can actually use to go about working with it. Because again, here's all of the correlated values that we found as soon as we ran this command. Basically, we are sorting it again in the descending order to find out what helps most. And you can see that it's almost 80% of the total quality of the house, which matters when you're buying because of the price of the house, and people are actually preferring this. Living area, second floor surface area has a 67% chances of affecting the price, and so much more. And check out what the golden features list looks like with respect to all of the strongly correlated values we just found. Again, you're remodeled, you're built, so much more. So total surface area, again, number of full bathrooms, the first floor surface area, the garage area, total basement square footing, the number of cars you can park, the square footing of the second floor, the living area, and the overall quality. Again, in this particular order from the least to the highest is exactly what we're trying to find out with respect to exploratory data analysis, guys. So just looking at the data set, you could never figure out why the list price of a house was so much. And once we break it down into simple terms like this, we can find out that there is an 80% impact from the overall quality of the house, which the user is checking out to just consider the house or not. If the quality is very less, he will not pick up the house. If the quality is higher, then sure, he will pick up the house. So 80% of the reason why the price is set like that is a very important aspect of why the house price casing study is important, guys. Again, this has been a very important, very nice data set to work with, and you will get a lot of analytics that can be done using this particular data set as well, guys. Next up, I want to discuss the skills of a data analyst with you guys. So a data analyst is a person who pretty much works with and creates a lot of beautiful visuals, guys. So to do this, you need to understand the basics of mathematics, because if you have to have knowledge of statistics, mathematics is the foundation to go. And after you understand the foundation, you'll build a step-by-step growth, a career path for yourself, where learning becomes the most important thing, because again, having the knowledge of statistics will help you play with a lot of numbers at the same time. And keeping the math part aside for a second, you need understanding of languages such as Python and R programming language as well. Guys, at this point of time, my goal here is to not overwhelm you. If you do not know statistics, if you do not know Python or R or any of these technologies mentioned on your screen, well, fear not. Make sure to stick with me till the end of the video, and I will guide you on a fast track path to become a professional data analyst, guys. And then the next point we have is data wrangling. Data wrangling again is to have an idea to play around with data, throw the data which is not needed, keep the important ones to know that you can work with. Because if you're working with inefficient data, your visualizations will be really bad. It's like, again, if I bring back the food example, adding a little less salt or adding too much salt is bad as well. And to give you a more clarity of data wrangling, let's say you're preparing noodles, but then if you just put the noodles in, fine, it's working. It's working because you're just making use of the part you need. But what if you throw the entire packet of noodles along with the packet, right? It doesn't make sense if you try to boil the packet as well. Here is where data wrangling makes so much sense in the world of data cleansing and pretty much data processing, guys. So you need to understand your data before you do this. And then coming to a little bit of big data concepts, you will require a little bit of knowledge about Spark, a couple of components and tools of Spark. One of it is Pig, and another one is Hive as well, guys. Well, to break it down a little bit simpler for you guys, let us talk about each skills. The first thing I want to talk about is the analytical skills, because data analysts will work with large amounts of data at every point of time. So what is this large amount of data? It can include a lot of facts, it can be a lot of numbers, it can be a lot of figures, and so much more, guys. This, if it is structured data. If it is unstructured data, they can work with images, they can work with audio, video, and much more at the same time. So basically what they'll do is, They need to go through this particular data, they need to understand the data and analyze it to pretty much find some sort of conclusion. So that is a very important skill to have. And then coming to the communication skills, well, again, as I told you at the start of this presentation itself, a data analyst will have to present his or her findings to a non-technical person. So having the communication skill where you can convey all of this really well is extremely important, because at the end of the day, you'll be translating your data, which could be meaningless to someone because they cannot understand it at this point of time, into understandable documents, very good looking dashboards, or again very nice looking reports at the same time, guys. Because again, having a good communication skills will ensure that you can convert a complex idea into something which is easily understood by a lot of people. And this brings us to the skills, next skill set, which is pretty much very important, and this is one among the important skills to have, which is critical thinking skills. Because at the end of the day, again, you'll be looking at thousands of numbers, right? So you need to know where to look, you need to know what to look, what your numbers can do for you, where are the trends, how can you get to those trends, what is your process benchmarking, how can you get to the goal that you set, and so much more, guys. And why is all of this done? Well, all of this is done to make sure that you can have a conclusion to look up to, right? So to simplify it, again, to give you an example, let's say you go shopping for all the food that you have to pretty much cook at your house. So you're going to need vegetables, you're going to need seasonings, you're going to need so many things to cook with it, you're going to need oil for some dishes. So you will plan, right? So most of us pretty much go out once a month or twice a month to bring out all the groceries and store it. So if that's the case, then you need to understand how much of groceries you need every single month, how much you're consuming, right? So you have to set a goal saying, this is the amount of vegetables that I'm going to need for this month, and then you're going to plan it and pick it up weekly, daily, or whatever your schedule is. So how do you set that duration of when you should go pick your vegetables? That is exactly why you need to formulate conclusions to understand how you can go from nowhere to there, guys. And then coming to the most important communication skill is that it'll again work together with the critical thinking skill, which will basically enhance the output of you guys. And then the most important thing I want you guys to contemplate about and think about is that data analysis is an art, guys, because you'll be working with numbers, you'll be working with graphs, visualizations, and everything can look its best, it's most beautiful if you know how to create it, right? So contemplate on that for a second, guys. Again, if you have any questions about data analysts, again, guys, I want you guys to head to the comment section.
So Pandas is an open source Python library which is used for manipulating one-dimensional and two-dimensional data. And the name Pandas is derived from panel data, which is a common term for multidimensional data sets encountered in statistics and econometrics. Now let's look at the types of data structures in Pandas. So we've got one-dimensional and multidimensional data. So if you're working on a one-dimensional data set, it is known as a series object. And the two-dimensional data object is known as the Pandas data frame. And if you're working on higher than two-dimensional data, Pandas would create a panel data for you. So let's properly understand what exactly is a series object. Well, a series object in Pandas is a one-dimensional labeled array which is capable of holding mixed data types like integer, string, floating point number, and so on. Now let's understand about data frame. So a data frame is a two-dimensional labeled data structure with columns which contain data of different types. So here we see that we have a two-dimensional data frame where the first and the third columns are of string type and the second column is numerical in nature. So now that we've understood what exactly is Pandas and we've also understood the different types of data structures in Pandas, let's go to Jupyter and start working with Pandas. So I'll start off by importing the Pandas data frame. So I'll type in import Pandas as PD. So this PD which you see, this is just the alias. So I am importing Pandas with the alias PD. So we have successfully imported this Pandas data frame. Now I'll go ahead and create a series object from a list. So let's see, I will name the list as data and I will give in these values. So the values inside these lists are 1, 2, 3, and 4. Now to create a series object from a list, all you have to do is use this pd.series function. So I'll use pd.series and inside this, I will pass in this list and I will store this in S1,
Our goal.
Now let me print this out. Right, so we have successfully created our series object from this list. So we've got these 4 numbers and these are the index values. So what you see over here is the indexing starts from 0. So 0, 1, 2 and 3, these are the index values and these are the actual values. Now let's see how can we change the index of this series object.
Our
So
goal.
I'll just copy this over here, paste it over here again. So we have got the index attribute over here. Inside this, what I'll do is I will give in different set of values. Now let's say I want the index values to be A, B, C, and D. So I'll just pass in these values for the index parameter over here and I'll store it back to S1. Now let me print S1 over here. So we have successfully created a series object where the index values are A, B, C, and D. Now, if we want, we can actually extract these individual elements with these index values. So let's say I want to extract the value which is present at the index value C. I'll type in S1, I'll put in parenthesis, and inside this, I'll put in C, right? So I've successfully extracted this value. Similarly, let's say if I wanted to extract the element which is present at index A. So I'll type in A over here, right? Now let's say if I want to extract the first 2 elements. So if I want to extract the first 2 elements, I'll just put in a colon over here. I'll put in 2. Right? So I've extracted the first 2 elements. Similarly, if I want to extract the last 2 elements, I'll put in a colon. And over here, on the left side of the colon, I'll put in -2. So this is how we can extract the last 2 elements from the series object. Right? So we have created a series object out of a list. Now let's go ahead and create a series object out of a dictionary. So let me create my dictionary over here. I'll name this as D1. I'll put in curly braces over here. Now I'll create my dictionary. So I'll just start off by assigning the key value pairs. So A, 1. After that, B, it is 2. After that, for C, it is 3. And after that, for D, it is 4. Right? So I have successfully created my dictionary over here. Let me also print this out. So these are the key value pairs. Now, again, to create a series object out of this, I will type pd.series and inside this, I will pass in the dictionary which is D1 and I will store this in S2. Now let me print out S2. So this is my series object over here, right? So all of the keys have been assigned as the index and all of the values are the actual values in the series object, right? So A becomes the index value over here, B is the index, C is the index, D is the index, and the value corresponding to this key becomes the value in the series object as well. Now let's say if I want to resequence the index values over here, let's see how can we do it. I will copy this and I will paste it over here. Now again, I will use the index parameter. And inside this, let's say, instead of A, B, C, D, I want the sequence to be D, C, B, A. So that is what I'll give over here. D, C, B, and A. Now let me run this and let me just print out S2 over here, right? So we have reversed the sequence of these indices. So initially it was A, B, C, and D. Now I have reversed it and now it is D, C, B, A. Right, so this is how we can create a series object out of a data frame and also change the sequence of these indices. All right, so we have work with series. Now let's go ahead and see how to create a data frame out of a list. So I'll just write a comment over here. Creating data frame from a list. Right, so let me again go ahead and create my list. Data equals 1, 2, 3, and 4. Right, so I have created my list. Now I'd have to go ahead and create the data frame. And to create the data frame, this would be the syntax. So I'll type in pd.data frame. So over here, you have to keep in mind that D is capital and F is capital. And inside this, I will just pass in this list. And I will store this in df. Now let me print this out.
Our goal,
right? So we have successfully created a data frame out of this list. Now let's also go ahead and create a data frame out of a dictionary. So I will type in fruit over here. So the name of the dictionary is fruit.
Our goal,
And over here, I will write the key to be equal to fruits. And the values for this key are, we've got all of these fruits. We've got apple, we've got mango. After that, we've got banana. And finally, we've got guava.
Our goal.
So this was the first key value pair. After that, I'll give in the second key value pair, which would be the count of the fruits. So I'll type in count. And over here, I will just set in the count. Let's say there are 10 apples, 20 mangoes, 40 bananas, and 30 guavas. Right, so we have created a dictionary. Now let me print this out. Now let me also go ahead and create a data frame out of this. So you already know we'd have to type in pd.dataframe, and inside this, I will pass in fruit. And I will store this in, let's say, fruit underscore df. Now let me print this out, fruit underscore df, right? So what happened over here is these two keys have turned into the column names. So fruit has become the column name over here, count has become the column name over here, and these values come into the rows, right? So fruits we have over here, and apple, mango, banana, and guava are the row values. Again, count becomes the column name, and these values over here come over here, right? So this is how we can create a data frame out of a dictionary. Right, so now that we've understood the basics of series and data frame, let's go ahead and see how to import a data frame and do some sort of data manipulation on top of it. So I have this customer churn data frame with me. Let me go ahead and import it. So to import a data frame, I'll type pd.readcsv. Now inside this, I will just give in the name of the file. So the name of the file is customer churn.csv, and I will store this in a new object and name that object to be customer churn. Now let me go ahead and print the first 5 columns of it. Our goal will be customer churn dot head. Right, so this is our customer churn data frame, and it comprises of all of these columns. So we've got customer ID, gender, senior citizen, partner, and so on. Our goal. So this is a special function in Pandas which gives you the first 5 rows, right? So 1, 2, 3, 4, 5. Or similarly, let's say if you want to have a glance at the first 10 rows, you just given the value 10 over here, and you can glance at the first 10 rows of this customer churn data frame. Our goal. An analogous function to head is the tail function, which would give you the last few rows. So I'll type in tail over here. Our goal. I'll click on run. So this over here gives you the last 5 rows from this customer churn data frame. Similarly, if you want to have a glance at the last 10 rows, you will just put in the value 10, right? So these are the last 10 rows present in the customer churn data frame, right? Now let's see how can we extract specific rows and columns from a Pandas data frame. So for this, we've got log and ilog functions. So let's actually start working with the ilog function. So let's say I want to extract only the rows from row number 5 to row number 15, and only the columns from column number 2 to column number 4. Let's see how can we do it, right? So I'll start off by giving the name of the data frame, which is customer churn. After that, I will use the function ilog, and I'll put in a comma over here. Right, so whatever is present on the left side of the comma, that denotes one of the rows, and whatever is present on the right side of the comma, that denotes one of the columns. So let's say if I want to extract all of the rows from 5 to 15. So I'll put in 5, I'll put in a colon, and I'll type in 15. Right, so I'll be extracting all of the rows starting from row number 5 to row number 15. Our goal. Similarly, if I want all of the columns starting from column number 2 to column number 5, this is how it will go. Our goal. So let's actually have a glance at this. So this 2 to 5 over here. So since we already know that in Python, indexing starts from 0. So 0, 1, 2. So this would be our column number 2, which is senior citizen. So 2, 3, and 4. Senior citizen, partner, and dependents. Right? So we have extracted column number 2, column number 3, and column number 4. and we have extracted the rows starting from row number 5 to row number 14. Right, so this is how we can extract specific rows and columns from a data frame. Now let's go ahead and see how can we perform some sort of data manipulation. So let's say from this entire data frame, I want only those records where the gender of the customer is female, right? So for this, what we'll do is I'll just start off by typing the name of the data frame, which is customer churn, and then inside the parenthesis, I will give in the name of the column, which is gender. After that, I'll use the double equal to operator and then given the condition, which is the gender of the customer needs to be equal to female, right? Now, I'll click on run and let's see what do we get. So you get a bunch of true and false labels. Now, this bunch of true and false labels basically means that over here at record number 0, it is actually true. That is, the gender of the customer is female. So false over here indicates that gender of the customer is not female. Here again, it is false. Here again, it is false. So again, at record number 4, it is true. That is, the gender of the customer is female. Now, what I'll do is, I will cut this.
Our goal.
I will paste it back inside this, right? So what is happening over here is, from this customer churn data frame, I will extract only those records where this condition is true, right? And I will store this in say, female customer.
Our goal.
Alright, I'll click on run. Now let me print out the head of this. Female underscore customer dot head.
Our goal.
Right. So we have successfully extracted a subset from the original data frame where the gender of the customer is only female. Now similarly, let's say if you want to do some sort of complicated operation than this. So let's say you want to extract only those records where tenure of the customer is greater than 50 and the internet service of the customer is equal to fiber optic. Alright, so now let's start off with the first condition. So I'll give in the name of the data frame, which is customer churn, and inside the parenthesis, I will give in the name of the column, which is tenure. So the tenure of the customer needs to be greater than 50. Alright, so I'll cut this and put this inside braces. I'll put the AND operator and give in the second condition. So the second condition is the internet service of the customer needs to be equal to DSL. I'll type in internet service and this needs to be equal to DSL. Again, I'll put this condition inside quotes over here. Alright, so we've got these two conditions. And finally, I'll put those two conditions inside the data frame. So what is happening is, from this entire customer churn data frame, we'll be extracting only those records where these two conditions are satisfied. And I will store this in, let's say, C underscore tenure underscore internet. Now let me print out the head of this. So it'll be C underscore tenure underscore internet dot head. So let me have a glance at the tenure. So over here, if you see, the tenure of the customer is greater than 50 for all of these values. So 62, 58, 72, 70, and so on. Now, similarly, if I have a glance at the internet service column, then you'll see that all of these values are DSL. Right, so this is how we can perform data manipulation operations on top of the Pandas data frame. Alright, so we are done with the practical.
What is the primary purpose of data analytics? Our first option is to collect raw data. Second is to analyze data for decision making. Third option is to store data securely. And our fourth option is to design databases. So whatever option you guys feel is the most suitable one for the primary purpose of data analytics, kindly drop down your answers in the comment.
So, exploratory data analysis, or EDA for short, is the process of performing initial investigations on data so as to discover patterns, abnormalities, or anomalies and assumptions with the help of summary statistics and graphical representation. Basically, when we have some data on which we want to perform data science and statistical analysis and machine learning modeling, we first need to make sure that we understand what the data represents, shape of the data, what are the different kinds of things that are available in our data, different data types available in our data. If we could visualize our data and understand relationships between individual columns or individual features in our data, that's really good. And all of it and more such as visualization and all, is done in a step called exploratory data analysis. So that's what EDA is all about. Now, EDA allows us to get a better understanding of our data and make important observations on it. In order to understand this, let's understand with an example. If you have a data set which you have no understanding of, you don't understand what the data it contains is, what do the columns represent, how do the columns relate to each other, and which columns are important for the particular task that you are trying to solve. In cases like this, it is very difficult to understand how you are going to solve the problem, how you're going to build the model, how you're going to perform statistical analysis, so on and so forth. So in this sections, what happens is we would like to perform exploratory data analysis in order to get a better understanding of our data. This also helps us understand whether or not the data that we have needs some sort of boost. So, for instance, if we have some data set that's highly biased on one result, for example, we are trying to predict whether or not a particular internship is going to convert into a job. Let's say we have a data set that we want to figure out whether or not we can create a predictive model in which we can feed in some data about an intern and figure out whether or not we should give them a job. Although it's a very specific use case, if all we have is data where people did not get converted into full-time employees, our data set is completely biased. And this is something that we could miss if we don't take time to analyze our data using exploratory data analysis. So if that is the problem, then we would have to get more data so that we can balance out both the probabilities and then teach our model about these things so it has better understanding of what features lead to what results. So now we come to why EDA. Why would you want to perform exploratory data analysis? We've understood what it is, but why exactly would you want to do it? Well, exploratory data analysis is one of the most crucial steps in data science. It allows us to achieve certain insights and statistical measures that is essential for the data scientist. A good understanding of exploratory data analysis process allows us to make some important observations and early decisions that could help us produce or that could help us not take steps that are not needed. So as we discussed in the previous example, if our data set is biased, then performing modeling and using multiple algorithms and trying to figure out the accuracy of each model is not going to be a good idea. Mainly because the data set we have is not good. If you don't have a good data set or don't have a data set that's representative of the reality in the current world, then your model is not going to be good. It's not going to perform really well. So exploratory data analysis helps us perform as fewer steps as possible in order to get the best result. This is why exploratory data analysis is so crucial a step in our data science process. So it performs certain steps to define and refine our important features and variable selection. So it could be that you have a data set that contains 25 different columns, but for what you are trying to predict, only 3 or 4 columns are going to be enough. They explain most of the things or most of the variation in the data or in the column that you're trying to predict. So you only need to use 4 variables. Now, which 4 of those should you use? And if indeed are the 4 variables or are the 5 variables that explain it better? So that exploratory data analysis is important. It allows us to select features that are going to be useful for us. In case we don't use the correct features, we end up with a model that's highly bloated, contains data that's irrelevant, requires users to fill in data that's relevant, and could lead to incorrect or highly improbable results. So we need to be very careful when we're trying to take model columns or columns on which we are trying to model our data on to make the prediction. Now, why would you want to perform exploratory data analysis with Python? There are many other languages out there, including R. You can even perform exploratory data analysis in JavaScript and Java and C++. So why should you use Python? Well, exploratory data analysis using Python is very easy. First of all, Python is probably one of the easiest languages to get started with. This is why Python is so popular in data science community, because many people who perform data science operations or machine learning operations on a particular data set are people who come from the academic world. They don't have much understanding of what programs are, what variables are, what classes are. They only need to write code to get the things that they want to get done better. This is where Python comes into play. It fills the gap. So since Python is so easier to use, and another advantage that Python provides is that it has a number of libraries that allows us to perform tasks related to exploratory data analysis. In case we are performing these tasks ourselves, it's very, very important for us to make sure that the libraries we are using are trusted and used by multiple people, because if it's a library that someone has created, our confidence in it is going to be really low. For example, if it's a library to perform data visualizations, but it's a library that not a lot of people have used, then you cannot be sure that the library is going to give you accurate visualizations, and it's always going to be a bit problematic. In Python, however, there are libraries that have been used by millions of developers and academic people. What they do is they just understand the basics and then they import the data and visualize it and perform the task that they need to perform right at the step. And that's really important for our data set. So this is why Python is such a good candidate for exploratory data analysis, mainly because it's easy to understand, easy to read, it's got a really clear syntax, as well as because it's got so much good tools and libraries around exploratory data analysis and data science in general. It's just a really good experience for developers or people who are getting started with exploratory data analysis or data science, or even professionals. Now, Python has libraries to perform all kinds of tasks relating to exploratory data analysis, such as visualizations analysis, etc. Visualize the data, there are libraries available, not just one library, but multiple. Depending on the features that you're trying to use, you can import either one of the libraries that are available. The libraries for data analysis, libraries for numerical manipulation. There are libraries for many other different kinds of tasks, such as creating neural networks, defining the structure of a neural network, visualizing neural networks, so on and so forth. So this is why Python is so popular. Now, some of the most popular libraries to perform EDA are NumPy, Pandas, and Matplotlib. Now, since I'm assuming that many of you are beginners and you have no understanding of what these libraries are, we will cover what these libraries do in a later point in the presentation. Also, again, if you wish to learn more about these libraries and more about data science and exploratory data analysis and Python in general, stick with us till the end of the presentation, and we'll help you will help guide you to some of the resources that can help you out there.
Just a quick info, guys. Intellipaat offers data analytics course in collaboration with IIT and PowerTech. Through this course, you will master Power BI, data modeling, data mining, and much more from the IIT Madras faculty and industry expert. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to a new height. So visit the course page link given in the description and take the first step towards the career in the field of data analytics.
Now let's take a look at some of the advantages that exploratory data analysis provides us. So it provides us with several benefits. First advantage is that it allows us to spot missing data. Using exploratory data analysis, we can easily find null and missing values. So in case we have a data set in which certain columns have null values or certain columns have certain proportion of the data is missing, we can remove the data, we can fill the data. Although removing the data and filling the data is not part of exploratory data analysis, spotting the missing data is definitely a part of exploratory data analysis, and it allows us to do the same. It allows us to find the underlying structure of data. So on the surface, what we can see is the number of columns, the columns that we have, and the data that we have in them. Underneath the row and columns and the tabular structure of our data, if indeed it is tabular, what we can do is we can understand what the underlying structure is. Underlying structure means what are the different data types that a particular column holds. Are they in the correct format to be processed? What is the range of data that is contained in a particular column? Do columns relate or correlate with each other in the data set? And if so, is it helpful or harmful for the task that I'm trying to perform? So on and so forth. Then there's variable importance. Exploratory data analysis helps us to figure out which variables in our dataset are the most important ones. So in that case, it helps us understand which variables have the highest influence on the thing that we're trying to predict or on the column that we're trying to predict. That way, We can just drop the rest of the columns and only use the ones that have influence on our columns above a particular threshold. And finally, data visualization. Now, we can sit and talk about data a lot, but one of the issues that exploratory data analysis solves is that when we show these statistical measurements to people, first, especially people who are not statistically literate, it's going to be really difficult for them to understand, mainly because they have to firstly scan through the data, then understand which data has higher value, which data has lower value, and then understand the implication of each of them. It's much easier to visualize this data and understand the characteristic of the data that you possess. In this scenario, exploratory data analysis is really, really helpful. It allows us to perform visualizations and explain our data in a better capacity, even to people who may not be that familiar with the data that we have, as well as the statistical analysis that we have performed. Now let's take a look at the libraries that we had discussed earlier and what in exploratory data analysis. I would just like to mention that these are the three libraries that I have picked. These are the most one or at least some of the most common libraries that are being used. Not necessarily the case that these are the only libraries that will be used, or also not necessarily the case that these are the libraries that are going to help you in a particular problem. It could be that there are better alternatives available, and to understand about the alternatives, you need to firstly look at all the options that are available. So I recommend before starting any exploratory data analysis process, take a look at the tasks that you want to perform, take a look at the libraries that are available. These libraries are the most popular ones and for good reason. So these should help you out, especially if you're a beginner. But as you become more and more advanced and more into the exploratory data analysis and data science community, you understand that there are better tools available for the one particular task that you're trying to perform, and it's better to use those tools. All right. So the first one is NumPy. NumPy, or many people call it NumPy as well, it is a numerical manipulation library. In Python, we can perform numerical manipulation using raw Python itself, but it contains a lot of the information that are not relevant for our purposes. Since Python is an object-oriented programming language, which it's fine if you don't understand what that is. But in case you do understand, it stores a lot of information that's not relevant. So when we try to perform complex mathematical operations, those properties about the object orientedness of the particular variable come into play, and they negatively affect the or negatively impact what negatively impact the performance. So in situations like this, NumPy is quite useful. It firstly just keeps all the relevant data. Secondly, it has a lot of functions that allow us to perform these numerical manipulation. Inbuilt functions for calculating the sine wave, the cosine waves, for fast Fourier transform is also available, and many different kinds of numerical manipulations that are difficult to implement by hand are already implemented in NumPy. So you don't have to worry about implementing these things. You just have to worry about using them when the need to be. Then there's Pandas. If you have done a data science with Python for any period of time, Pandas is a library that you must have come across. Pandas is great for data analysis, data summarization, and many other tasks relating to data. It allows us to load data in our Python program using something called data frames. Data frames is a special object or a special way of representing data in Pandas, and it affords us a lot of benefits. It allows us to perform a lot of complicated tasks on our data, such as joining two data frames, filtering a data frame, manipulating data, dropping data, and a lot of different kinds of tasks that by hand are going to be very difficult. So it's a layer of abstraction over these complicated tasks, so you can perform them yourself, and it's very efficient as well. Then we come to Matplotlib. It is a visualization tool or a visualization library, allows us to create charts and graphs and allows us to perform a lot of visualization. Many different visualization libraries such as Seaborn use Matplotlib underneath the hood. So in case you wish to become a data scientist and want to perform exploratory data analysis by visualizing the data, Matplotlib is a library that you might need. You can also use other libraries, but Matplotlib is probably the best one to start with because it's very easy. It exposes you to some of the fundamental concepts that you need to understand when you are dealing with in Iron Python visualization or graphs or charts, they can help you out with that. All right, so we have reached the demo section. Now for the demo, I have already written the code so that I don't write the code and you have to then follow along and look at the errors that I make. I'll explain the code to you now. I told you that you only need to import the libraries that you need. In the current scenario, I didn't need to use any numerical manipulations because the data is already manipulated for me. Then I can use this. I'm using Pandas, Seaborn for interactive visualizations, and also Matplotlib. These are two different visualization libraries. Seaborn is great for creating summarizations of our data sets, and Matplotlib is great for visualizing individual columns. This bit of code here is telling the Jupyter notebooks. Let me just zoom in on it because it may be possible that you guys aren't able to see this. Now, in Matplotlib, it's possible to use it with multiple backends. In this scenario, we're using it with Jupyter Notebook. We're just trying to tell Matplotlib that whatever visualizations that you produce, make sure that they are optimized to be rendered inside a Jupyter Notebook. Now, many people say it's not necessary to do this step. It was necessary previously, but now it's not. But I like to keep it in just in case. Then I am importing a data set. And to give you some context, this is a data set that I have downloaded from Kaggle. You can download it yourself. I would recommend that you do it afterwards, and you can play with it as well. This data set and many other data sets are available on Kaggle for you to perform exploratory data analysis with. You can do it on Kaggle as well. And when you're doing it, you can, using that exploratory data analysis notebook that you have created, you can share it with people. Kaggle is a great platform for that. So you can use it for that. And now we take a look at the first 5 columns, first 5 rows of the data. Now, as you can see, the shape of the data is 5 rows in 81 columns. Now, 81 columns is probably a lot. As you can see that even our Pandas library is refusing to show all of this because it knows that it's not possible for us to show everything. So we have this. Now, we take a look at the information of the data. This tells us about the data set that we have and gives us information about each column, right? So we have 1460 non-null columns, non-null data points with of type int 64 in the ID column. And you can take a look at everything. Here, as you can see, in the alley column, we only have 91 data sets. That means that majority of the data is null. We'll deal with that in a moment. As you can see, the data is quite disparate. Sometimes it's 1460, sometimes it has 1452 data points. So we are dealing with a data set in which we can have null values quite a lot. For instance, pool QC has only 7 values that are not null, others are all null. And as you can see, the data set is quite disparate as well. Some are objects, which are basically string or some other data set other than numerical data set. Some are integers and some are float. Float are basically real numbers. These are numbers with decimal points. So currency could be considered float, and real numbers are considered integers. So your mobile number could be considered an integer because it's not going to have a decimal point with that. Right. So I don't want you to get bogged down into the specifics of the code. What I'm trying to tell you is how we're going to do this. So here what we're doing is we are taking all the columns in which our data is greater than or equal to 30%. So any column that contains less than 30% data, which is it has 1460 columns, but only 30 or less percent of the values are present in that, and we're going to drop it. So any column that contains less than 30% of the data, we're not going to consider it at all because it could have negative implications. So we do that. Now what we do is we also delete the ID column from our data set, mainly because ID is just something that is generated by the database in which it was stored, or maybe not by the dataset, but by the people who collected this data. It's not really important for us. It's important for storing the data, but for analysis of the data, ID is just a number that was randomly assigned to a person. It has no significant value. Now we will print the list of columns that were dropped. As you can see, Ali, QC, friends, and miscellaneous features are the columns that are dropped. ID is the one that we have dropped manually, even though it contained a lot of data. Now we try to do 2 things here. First thing, we take a look at the sale price, which is a column that we are very interested in because that's the column that we're trying to model our scientific process across. So we describe the data, which is we count the number of columns As you can see, it contains every bit of data that is available. The mean is 1,80,921 point some value. Standard deviation, minimum value, 25 percentile, 50th percentile, which is here, then 75th percentile or the third quartile, and the maximum value in the column. This is, by the way, this is something that Pandas is doing for us. We didn't have to write functions to look over the data and figure out the min, max, 25th percentile, and all of that. So it tells us the name of the column, sale price. Data type is float. And now what we do is we try to visualize it. So as you can see, the majority of our data lies in this region.
What?
Yeah. So here and here. This is what is known as a histogram or distribution plot. Since Seaborn allows us to do it pretty easily, we do it. Don't worry about the code. Stick with us till the end of the presentation and we'll show you how you can learn to write the code. Right now, we're trying to understand the process of exploratory data analysis. So as you can see, even though we have a maximum value of 77,55,000, majority of our values are lying between somewhere around these values, right? Now we take a look at the different data types available in our data set. We have integer, we have O, which stands for object. Object basically means that this is something that's not a number. And we have float. This 64 is basically how many bits are used to represent the data. This means that the data could be of high size. You can, by the way, change this all yourself. So here what we do is we say, okay, give me all the numerical data that we have. This is done mainly because we want to be sure that we are only dealing in numerical data. Dealing with data that is not numeric, firstly we'll have to convert the data into numerical formats and so on and so forth. So we're trying to firstly estimate the task ahead of us. We take the numerical data that contains float 64 and int 64, basically not selecting the object data types. We take a look at the head. As you can see, it has 37 columns, which is a massive drop from what we had earlier. Earlier we had 81 columns, out of which we dropped, I think, 4 or 5 because they had a lot of null values. This one is by far something that we have done only to understand what the data is about. Now we take a look at the distribution of our data using histograms. What we do is we basically create a histogram for all the columns. So again, we didn't have to do it ourselves. These are all 31 columns with histograms, and you can take a look at the data. As you can see, it contains a lot of data. Some columns contain a lot of data that's centered around a particular data point. Others are very separate, such as this one. This only contains values that are 0, so that's fine. And you can take a look at the data and analyze it. We're not going to analyze it right now. This is just for you to understand how to generate these visualizations. Then we take a look at correlations. Correlation basically is a number that allows us to understand how how much of our data is how much influence does one column has on a particular column. And we remove the last column because the last row is basically sales, or the last column. Sorry, I'll just remove the comment. So the last column is sales, so we don't have to worry about that. From here, we basically just take all the columns with correlation greater than 0.5. We call them golden feature list. Any column that has a higher value than 0.5 on correlation means it has good correlation for our data. We're taking the absolute value, which means we don't care whether it's negative or positive. Correlation ranges from -1 to +1. -1 means the data in this column decreases. Data in the other column, which is negatively correlated with it, will increase. Positive correlation means data in this column increases. Data in other column, which is positively correlated with this, increase. So we take that and we sort it in ascending values. Now, after doing this, we take a look at the correlations. So these are the correlations. The highest correlation we have is overall quality and GR live area. It's around 80 to 70%. Now what we can do is we take a look at all the numerical columns and we generate for the first 5 months for all fifth values. What we're trying to do is we're trying to create visualizations to understand how a particular column relates to first 5 columns. So for instance, sales price relating to MS subclass, MS lot range, lot area, and so on. And as you can see, we're doing it for everything, and we're doing it 5 plots at a time. Now that we have done that, here is a bit of a code that's going to be a little difficult to understand, so I'm not going to try and explain it to you. But basically here, what we're trying to do is we're trying to create individual data frames or individual feature data frame, as I've named it. Create some temporary data frames based on particular sections, such as we take the column name and the sales price, and then using that data frame, we check whether or not the column's value is not equal to 0, and we create or we add it to the data frame. Then we create an all correlations matrix, and then we try to print it. Now we come to the interesting part. So these are all the 11 strongly correlated values that we have, right? For this one, since we had 81 columns, and now we have reduced it down to only 11 columns that have really high influence on our sales price column. Now to visualize it, what we have done is we have created a one thing called heat map. Let me just zoom in so that you guys can see. I think I zoomed in a little too much. Yeah. And also you can manipulate the size of this plot by when you're writing code. I'm not going to do it right now. But as you can see that some columns have correlation of 0.4, some have, and this is negative, by the way. As you can see, these are color coded. So any column with light color such as blue or purple are negative. Any columns with light the colors such as yellow or green are positive. As you can see, we have 0.83% of correlation with GR11 area and 5 places. And so this allows us to understand what are the particular columns that are highly correlated with each other. Allows us to understand whether or not a column has influence on not just one column but multiple columns, and how does that affect our purposes.
So our second quiz question is, what does EDA stand for? Option 1, exploratory data analysis. Option 2, efficient data aggregation. Option 3 is external data application. And our fourth option is extended data analytics. So again, I want you guys to drop down your answers because this is very easy. This is like the most basic question. So I want all of you guys to give the right answers in the chat.
We have a fancy thing called package in Python. Okay, so those packages are available for free in the market. It has a lot of built-in functions and built-in things that will help you guys to write many codes easily, okay, without going for the detailed algorithm and all. So in that way, these packages are really helpful. So NumPy, what it does, it is used for mathematical and logical operations on the arrays. Okay, and it provides feature for multi-dimensional arrays also. So again, when we tell arrays, Python doesn't have any array. It is built on list only. So basically, when we go through NumPy, when we go for indexing, slicing, and all those kind of stuff, it will only be the list. Everything will be based on the lists. So that's how it goes. Okay, so NumPy can support 1D, 2D, both of the kinds of arrays. Okay, and I think you might be using this Anaconda version of Python, so that will be coming along with Pandas and NumPy version pre-installed. Okay, NumPy will be pre-installed in the Python versions. Okay, Anaconda Python. Okay, now when you use a package, right, what we do, we import the package. Okay, we import the package with something like the syntax is, it can be any package. Okay, alias can be anything. So what is the syntax? Syntax is import, then there will be package name, then there will be as keyword just to assign an alias. Otherwise you would need to type the entire thing throughout the program, and then we will have alias name of np. Okay, so that's what it was. Okay, so now when I say NumPy array, it can convert anything, any Python data structure to arrays. Okay, so that's how it works. Okay, so if I show you like this, what, it is taking time now. What? So see, it has converted both these things. So the first one is a Python list, second one is a Python tuple, right? So when we pass that argument, that tuple or a list to a NumPy array function, it converts them all to a NumPy array. Okay, so that is what this returns. Okay, and whatever we provided, as you see, the outputs are starting and ending with square brackets, right? So that means it is already converted to a list. Now we can perform various functions in NumPy. Yes, so once we have NumPy array created, it can be editable. Okay, because it's a list now. It's not anymore a tuple. So that's why it is editable. Okay. And NumPy doesn't come by default with Python. If we want to use it, we need to install it. So let's say you are not using Anaconda and you are using this kind of a Python user interface. Then what you need to do, you need to install it using command prompt. Okay. Pip install, sorry, we are letting it again and again. Pip install NumPy. So it will find it and it will install NumPy. Okay. I don't have this pip version set, so that's why it is not working, but it should install it. Okay. So that's how it works. That's how we can use NumPy in this kind of functions also. Okay. Now we can have 2D arrays in Python also, like 2D arrays in NumPy also. So how we write it? We write it like this. So we just need to pass 2D arrays. So 2D array means two lists, right? We can pass two lists. So it will be concatenating it to what 2D array. What okay, so it will be changing it to 2D array. So that is how we write it in NumPy. That is how we create arrays in Python. So that's how we do it. So now next will be where it is, and where it is advantageous other than using a basic Python list or Python like that, Python list or Python tuple, right? So by NumPy you are changing, yes, so we are changing data type from mutable to non-mutable. It's the other one, right? Next is ND array object. Okay, so in NumPy, as I have shown you, 2D arrays, right? It can go up to n and then can have any number. So in real world, if you ask me, we don't use more than two max 3D arrays, but yes, it can go up to that. Okay, so like that it works. So next is like why we use NumPy arrays. So in NumPy, this ND arrays will have all the items of same type. Okay, so it can't be one of them is int and one of them is string list. It has to all of them has to be int arrays. Okay, like that. So items can be accessed using zero-based index. As you know, Python arrays, Python lists also starts from zero indexing, right? So here also it remains the same property. It has zero index. So if we go for NumPy array, then if we want to see the first row, it will be like this. So it will give you the first row and this will give you the second row, right? Similarly for columns, if you want to see if you want to see the first column, you need to do this, right? So you need to do this. So you will see the entire values. If you need to see only the first column, then you need to do it like this, like that it works, right? So that's how it will be working. Now for 2D arrays, I will be coming. Okay, I am working on 2D arrays. Sorry, I forgot. So that's how it works. Okay, so we will be coming to that in a few minutes. So 2D arrays, I will show you. So for others, what was the names? A and B, right? 2D arrays, I will be showing you. Not an issue. So for arrays, if you see 1D array, it will give you A0, that will be 1, A1 will be 2, like that. And if you do 1 to 2, then it will be printing only single element because the right hand side index is always left. Okay, right hand side index, it is not up to, it goes up to that. It is not including the right hand side index. So that's why it has two elements. Now if we do this, then it will print all. If we do this, that also will mean the same and it will print the same. It is pretty much like the list that we have in Python. Okay. Now NumPy arrays are beneficial because it takes up the same size of block in the memory for all the objects that it stores. Okay. This part we will see a comparison in the later half of the section, and then we can understand like where it is beneficial rather than storing it in a classical list than NumPy array. Okay. Now next is if you go into check the individual. Yes, right. So it will be begin colon n minus 1. That is how. So right hand side will always be excluded like that. Okay. Next is NumPy array initialization, right? So how do we initialize NumPy arrays? As we have already seen, right? How do we do that? But still, this is how you do it. Okay. So initialize means what we want to do is we don't want to place any list in there. Okay, but what we want to do, we want to have some by default values. Okay, default arrays we want to take it up. Okay, so let's see how we do it. Okay, first one is if you guys are familiar with the terms like masking and all, that is for image processing, and for data processing we will do that. A lot of times we will do that. Okay, so a lot of time we will be using this zero based or one based indexes. Okay, so for creating a zero based arrays, right, what we need to do, we need to have some sort of like some shape of zero arrays. Okay, so that's how you do it. Okay, that's how you do it in NumPy. So what you do, you write np.zeros, then you specify the dimension of the array. Okay, 3 by 4 means it will have like 3 rows and 4 columns. So first one is of, so you can think it like this, it will be np.zeros, then row, comma, column. Okay, that's how a tuple you need to pass it to. Okay, that's this kind of tuple you need to pass it to the Python arrays. Okay, so that's how it works in Python, I mean in NumPy. So that's how you print zero arrays in NumPy. Okay, next is if you want something with an interval, right? So how you do, you write like this, np.array, within bracket we pass what so it will print you another new array. So what we are doing, we are in here what we are doing by array, what 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 yeah what? So in this what we are doing, we are, yeah, right, it's arrange, so it's a range actually. Okay, so what we are doing, we are passing 3 variables. First one is the starting number, second one is the ending number, and last one is the line is the interval that we want to print. So from 10 to 25 we are having 5, we want lists to be 5 separated, right? So first one and second one difference will be 5, like that. So that's how we have, so we have 3 numbers, right? 10, 15, 20, and always remember the right hand will be excluded, so 25 won't be taken up. So till 20 we will go. Okay, till 20 we will print it out. Okay, so that's how this kind of arrays are getting printed out in NumPy. Next thing is this arrange is done, right? Now let's say we want we want to spread some points over a straight line. Okay, so how do we do it? We want to I mean what I mean is, if you think of a 2D plane, right, like x and y plane, if you think of, and we want to spread some points along that line. Okay, so what we will do then, like we want some points between range A and range B. Okay, so here we are giving intervals, right? So we need to calculate the interval, we need to calculate the point difference and all, then we need to provide it here. So that's how it works, right? But we don't want it, we want it otherwise. Okay, we want it to spread along a line like this. So between 5 and 10 we want 6 numbers. It is almost same as NumPy, but it has a bit difference. So how it is differing, I will show you. Okay, next is this lean space. Okay, what length, space, and arrange, right? So arrange, what it does, it takes in 3 numbers, so start number, end number, and so what we do in arrange, we have 3 numbers as a parameter. We take end number, start number, end number, and the interval, and we print out the values based on the intervals. So from start number till the end number, we print out the values based on the intervals. Okay, but in linked space, what we take 3 parameters again, and what we have in there, we have start number, end number, and then we take in number of points in there. Okay, number of points in there. So if we give you a start number and end number, then if we split it into 10 points, then we will get 10 points between the start number and end number. So that is the difference between linked space and arrange. And all these functions we will be using heavily when we go for data science. Okay, because these things we will need, and we will see how do we do that. Okay, now next is how do we do array with the same number. Okay, next is how to create an array with the same number. So this is same for same uses, like that, like for zeros, right? Formats for carving out some masks, like that. Okay, so if you use this keyword, what then if you pass some values, so come on, what if you pass some values, then it will give you that number of the dimension it will take care, and it will give you that kind of an array. So row, then column, and then it will be taking up, so np dot full, it will take up first the tuple of row numbers, column numbers, and it will take up the number to fill that array with. Okay, number to fill, like that. This thing works, this full function works. It can be anything. Okay, it will give you a array full of that kind of numbers of any dimension. Okay, any dimension can be given. Okay, any real world numbers can be given, any integer number can be provided as a dimension. Okay, so that's how this full function will work. Okay, next is to randomize an array. Again, for that masking only. So
what
we do,
what
let's say we want a 3x4 matrix to be randomized.
what
So it will give you some here and there numbers of random numbers. So that will be and those will be structured in a matrix form. Okay, the dimension you pass, in that way it will be organized. So random is this thing. Okay, now we go to how do we access this NumPy arrays. Okay, now let's say we are creating two arrays. How do we access it? Okay, how do we see what's wrong with the array and what not? Let's say I am creating a 2D array. Okay, now if I do print there, so that's how this shape function works. Okay, that's how we can access a shape of an array. So shape function will return a couple of its row number and column number. Okay, so a dot shape returns tuple row num column, like that. Okay, so it will be returning like this. Okay, now the next thing is, what is the use of this shape function? Okay, so this is a tuple, but we can change the values of the tuples. So this will change it. Okay, we can access the shape function of it and we can change the values. Okay, even now we can access like a no, come on, we can access this. Yeah, so we can access it like this. Okay, come on, I have not given print. What is that? Okay, so we can access individual elements of the shape tuple that is being written like this. Okay, like we use like we access normal tuples. Okay, so what we can do with this a dot shape, we can get the tuple, tuple of row number and column number as an output. We can change the shape of the matrix with this shape function, and we can access individual arrays. Let's say you want to see how many rows are there in a data set, right? You can use it. You would want to loop through all the data sets, all the rows of your data set using a for loop. You don't want to go for map and all. So that's when you use a dot shape. And for print a, that's how you use. Okay, for print a, what you do, you just for shape 0, that means you are accessing individual elements of a tuple, right? So 0 will be giving you the number of rows and 1 will be giving you the number of columns, like that. Okay, one thing, so you guys are acquainted with you guys know about lambda functions, right? It was covered.
Yes, sir, correct. But just want to go back to zero index. Zero index, it will return the number of row, correct?
Right.
If you give comma and another zero, then it will give you the number of column. Is it okay?
It's got
No.
one shape is always gives only the columns and rows here. The 0 will give the rows and 1 will give the columns.
Column. So that is a tuple basic, right?
Can you please do that?
So tuple, how it works, number of elements in tuple, we will have a 1D array, right? So 1D arrays can't be having two indexes, right?
Okay.
So
Okay,
it will be 0, 1, like that. So it is an 1D tuple or 1D array, whatever you call it. Okay. So that's
Okay,
how it
thank you.
works. Okay. Now we can have several more examples of NP. This shape function, but I am not going into the detail. But you need to remember one thing: you need to match the number of elements in the tuple. Like we have 6 elements, right? If I want to split it to 3, it won't work because the size of the array is to total of 6, right? So we need to have it multiple of 6 only. That's how we can break. That's how we can reshape. Okay. That's what is about this shape function. Okay. Next is how to get total number of columns. Okay. So again, I am having 10 functions and I want to see the size of it. So it will give you 24. As you can see, there are 24 elements in the array. Okay. So that's how this size function works. And this is another syntax of np.arrange. So here what it takes some number of values. Number of points needed. Will place the numbers between 0 till that number. Okay, so that's how another syntax of arrange works. Okay, so for size function, it will give you the total number of elements in an array. Okay, so that is what size function works for. Okay, next is dimension of array. It is more or less same like this. It is more or less the same thing like that. Like a shape function, so I will put it right in there, but the only difference, it can be modified. Okay, so where were we? We were with this ndim, right? So how it will work? Ndim will return you the, it is not, I mean, it is a bit different from shape. Shape returns you the exact shape of the array, like the number of rows and number of columns, right? But ndim will return you the number of dimensions of the array. Okay, so if you see the ndim, then what we have 2 as a return, right? That means it a total of 2 dimensions, 3 and 2 dimensions, right? So that's what ndim returns. Okay, ndim will return you the number of dimensions of the array. Okay, so that you need to remember. Okay, so that is what you need to remember. So ndim returns you the number of dimensions. Okay, it is not shape, but it is a dimension. Okay, now d type is the array data type that we have already. Okay, next is d type. Okay, d type is to give you the type of each elements in the array. Okay, in the NumPy array, it will give you type of all the elements, and NumPy arrays cannot be heterogeneous, it has to be homogeneous always. So NumPy arrays will return you, I mean the return you homogeneous arrays. So when you do a d type function on an array, it will return you the number of dimensions of the array, I mean sorry, the data type of each of the elements in the array. Okay, so here we have 24 int numbers, right? So that's why we have int 32 as a return type. Okay, so that's how it works. Okay, so that is what is about this d type function.
Our third quiz question is, which Python library is commonly used for EDF? So our first option is NumPy, second Matplotlib, third is Pandas, and our fourth option is all of the above. Again, this is a very easy question, and I expect a lot of right answers in the comment.
Next is, how do we use it for maths calculations? Okay, so any doubts till this part, till this d type? Now if I show you something more, say okay, next is as I have treated now array with like float numbers. So you see the arrays are, the d type is printed as float 64. Okay, so you have you got an array of, I mean the d type as float 64. Okay, so that's how this d type function works. Okay, so and NumPy, as the name suggests, it is used for linear algebra. Okay, so NumPy is used for number mathematics or linear algebra. So you won't be really having string arrays in NumPy. Okay, so you won't be having it. That is not provisioned. So NumPy is only used for linear algebraic operations, and for that we need integers and floats, right? Nothing more than that. Okay, next is NumPy maths. Okay, we can do summation, division, multiplication, and all those kind of here and there stuff with this NumPy. Okay, now how do we do it? Okay, let's get started with a single array. So this is how NumPy summation function works, and it can add up to different things. Okay. Okay, so sum will return you or sum of all the elements, or it can return you sum of two arrays. Okay, sum can do anything, anyone. So sorry. So sum can return you either sum of all elements in a Python array, or it can return you the sum of elements of two matrices. So matrix multiplication, matrix addition, all this logic will be implemented in there. So now what it will do, it will take up two lists, it will add up all the elements, and it will return you the output. Okay, so 5, 10, 2, 3, that means 10, 5, 15, and 2, 3, 5, so 20, right? And for subtract, it will take two arrays and it will subtract the results and it will throw it up to you. Okay, so that's how this subtract and numpy.sum function is used for summing up and finding difference between two matrices. np.sum has a few layers in it. Okay, so it can do a few things, so we will discuss that. So let's say we have seen how it takes in two lists and it sums you up the result and it will show it up to you. Now if you specify an access parameter, then it will do the sum based on the rows or based on the columns. Okay, we print out A and B for you. What yeah. So see, A and B are 5, 10, 2, 3, right? If we do a sum of sum with x is 0, that means it will do you a column wise sum. So that means 5 to 7, 10 to 13. Okay. And if you go for a row wise sum, then it will be x is equals 1. So it will return you 15 and 5, right? So that's how this will work. Okay, and the row wise sum, that's how it will work. Okay, so that's how this functions work. Yeah, that's how this NumPy array sum function works. Okay, so that's how you can get the Give me a second. Yeah. Okay, fine. So this is not how it works, right?
Remove the square brackets and keep only the circular brackets.
Sorry? No, not like that. It won't take it. So x is 1, 5, 2, 7, 10, 3, 13. Yeah, got it. Okay. So two confusions were there. First of all, we like it. Like x is 1, why it is not taking up? Okay, let me check for some example in the PPT. Doing some casual mistakes. Yeah, that's what I have written, right? So 0, 0, 0, 1, 0, 5. So it should be 0 plus 1, 5 plus 0, that is 1 and 5. So it's fine, right? 0, 1, 0, 5, so 1, 5. Yeah, correct. 0, 0, 1, 5, 6. Okay, let me copy this exact example, but it does. Not sum with x is 1 having some problem. Just give me a few minutes, I will do that. Now it is working fine. 0. Yeah, now it's fine. So now if I place it with A, I place with B, if we remove this, as those are already list, how it works. Yeah, now it is looking good. Again. Okay, I will be getting back to you on this. So for now, let's move ahead with the other functions. Okay, so having some kind of a problem, I will check that in the break and I will explain that after the break. So not sure why it is happening, but it shouldn't be happening it like that. Okay, let me go ahead. So some I will discuss it later. For subtract, we already have discussed. For this division also, it will work in the same way. Okay, what is it with some? Sure. Okay, now if we pass two parameters to the divide function, it will divide row wise or column wise as you define with this axis, right? So okay, so divide won't work axis wise. It will just take in two parameters and it will just divide you the numbers. Okay, row wise it will divide you the numbers. So 5 and 2 will be divided like whatever happens in the matrix operations, right? In mathematics, the same thing will be applied here. So in matrix operations, what we do, we just divide the first element by the first element of the next array, second element by the second element of the next array, right? So that is how it works. So that is how this division will work here. Okay. Similarly, we can see the multiplication being worked on. The same thing how we did in matrix multiplication in our class 12 maths. So it will be same thing. So 5 into 2, 10 by 3, so 10, 30. Like that it will work. Okay. So these are a basic few functions that will be needed for our data science courses. And this expa, it will give you e to the power a sqrt, it is for square root. np.sign is for sign value of each of the elements. np.cos for cos value, log for log values. Okay, so these are not really used in data science related things. Let's say I will show you quickly all these examples just to have your basic knowledge about this NumPy. I am showing that to you. So these are not really needed for being a data scientist. So you can just check these values. Okay. Next is the element wise comparison. So we have so that's how element wise comparison does. So it will compare each and every element of the array with another one, and it will return you a list of true falses. Okay, so that's how it will work. Okay, so that's how it will work. It will give you an output of true false. If you change something this to true, then the second element of the output will also be changed to true. Okay, now along with this np.equal, there comes another function where we check the entire array. Okay, if all the elements of the array are same or not. So that one is called so it will give you a single value. Okay, true or false. So it will check the arrays that is passed to it. It will compare those on a broader level, that is on a array level, and it will give you only single output of false or true or false based on the comparison results. Okay, so that's how it is. That's how it works. Okay, next is aggregate function on this on a single array. Aggregate functions always work on a single array, right? So that's what we are gonna see next. Now, if we have already seen this sum function, right? Yeah. So these are a few aggregate functions of the what we can apply to a NumPy array. Okay, come on. Why are we forgetting this? If you write it or not doesn't matter. When you do np.sum, it will automatically be converted to an array. So you can skip it safely. But again, okay. So np.sum a will give you sum of all the elements. Minimum will give you minimum. Max will give you the maximum element. Mean will be the mean of the elements. Okay. So mean means the middle element of the arrays. Okay. Then standard deviation is how the elements differ from the mean. So that's what is standard deviation. Okay, so that is what is about standard deviation. I will try to connect my pad and will show you the formula once. Same thing will happen. Okay, so it will give you sum of all the elements, minimum of all the elements, max of all, min of all, like that. This correlation coefficient is a machine learning term. We will go into it later. I will tell you what is it. So it's not. Let's not worry about it. So except this, have all these things clear. So that's how it will work. Okay, so that's how mean, median, and standard deviation you can take into account. Okay, now what is mean, what is median, I will stack it for the next class for SciPy, because then we will be discussing all this statistical things at one go, and I will give you a brief about all this. Okay, so if you have forgotten this, not an worry, we will be discussing in the next class. So that's fine. Mean, median, mode, and all this thing. So not sure, I am not having my tab with me, so I will have it and I will show you the formulas and all this small stuff. And also what you can do, you can once go through all this basic things. Okay, that's just the basic stats, not needed in entire detail. You can go through the basics, so it will help you understanding what I am covering in the next class. Okay, so that's how it will work. So okay, so this must be clear now. So with that assumption, we will go ahead with to some new topics. Okay, so that is like broadcasting. Okay, what is broadcasting? If we have taken two arrays of different dimensions in here, what would have happened? Let's say we are keeping till this part. What is this error? Axis 1 is not coming through. Okay. Yeah, axis won't work for this kind of cases. Yeah. Okay. So let's say we have this kind of an array to work with. So the first array, if you see, the first array is of 3 by 3, right? So 1, 2, 3 and 4, 5, 6. It is a 3 by 3 array, right? The second array, if you see carefully, we have passed 4, 5, 6, only 3, 4, 5, only 3 numbers. It's 2 by 3. And the next one, if you see, that one is a 1 by 3 array, right? 3, 4, 5, only 3 numbers are in there. So it is an 1 by 3, right? So now when you add it, if you notice it carefully, you will see the second row of the array is also getting added with the same number 3, 4, 5, right? So that's why it is coming 4, 3, 7, 5, 4, 9, 6, 5, 11. Okay, so how this is happening? This is the concept of array broadcasting in NumPy. Okay, so if you see in this diagram, what is happening, this array is getting expanded to match with the exact dimension of this array, of the first array. Okay, so this was an array of 1 by 3, but when it stretches down, it becomes an array of 4 by 3, right? So it matches the dimension of the first array, then only this array addition is possible, right? So this is the concept of broadcasting. Okay, this is the concept of broadcasting. Now, one thing to notice, this broadcasting won't only work for array additions. Okay, it will work for all kind of operations between two arrays in NumPy. Okay, so as you have just seen, this thing all works for this subtraction also, right? So subtraction is also supported. This broadcasting is also done for the subtraction scenarios also. Okay, this is the concept of array broadcasting. So what it does, the NumPy array gets inflated to match with the dimension of the first array, so that the operation that we are supposed to do is possible, is feasible. Okay, so this is what the concept of array broadcasting is. Okay, now indexing and slicing in Python. This, as you have already went through, I will go through this a bit quickly. So let's just see how you do it. So index in Python list refers to an integer position, right? It can either start from minus or it can start from plus. So minus, when we go for, so Python, when positive indexing is done, then the index goes from smaller number to higher number, and then prints accordingly, right? So let's say for this Monty Python, we are going from 6 to 10. So that will take from P till H, right? Because 10 will be excluded. But when we go for -1, and then we go from the larger number to smaller number, because as you know, for negative, everything goes opposite, and the bigger the number is, it is smaller, right? So -12 and -7, it will go from -12 till -8, because right hand will always be excluded. So that's how it will be printing the entire Monty string. Okay, so that is what indexing works in Python list. Okay, now when we do a 6:10, that means that is from 6 till 10. Like that, indexing is done. Okay, next is slicing. Okay, so A0, if you see this matrix 1, 2, 3, 4, 5, 6, and 7, 8, 9, if you go for A0, then it will print all the elements of the first row. And so that's how first row will be 0th index and first column will be 0 index. Okay, if you go then within brackets :1, that will also return you the same thing. Okay, let me show you. That means we are just taking what 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 we return the first element of the first row of the matrix. Okay, when we return A:1, what does that mean? Okay, so :1 is for the so what we want all the rows. Okay, so in 2D arrays, how the indexing works, if you know, so then it will be a comma separated one. So first part will entirely work for rows, second part will entirely work from columns. Okay, so if we write :1, that means for the row part, give me all till the second row. So that is the first row, right? So that's what it is returning, 1, 2, 3. But that list is within a list because we are taking it as a list only. We are slicing it, so it will return a list. Okay, and list of lists. And the first one of A0, we are just simply accessing the first row of the 2D array, and that's why we are getting 1, 2, 3 as a list. Okay, so that's how this slicing works for arrays. Now let's go back to the PPT and let's see what all things we can do. So A:1, extract till row equals 0, that means it is the first row that is being printed, right? Now for the second part, if you remember the indexing and slicing thing, what so the first one will account for the row and second one will account for the columns, right? So if we do :1, that means give me all columns till 1. So that is the first column. So that will give you only 1. Okay. Now if we do 1 : that means give me all from the first column till last. Okay. So that's where we get this 1 : will return you 2, 3. Okay. Now if you remove :1, that means you want all rows and you want columns from 2 onwards. Okay, so that's why it gives you 2, 3, 5, 6, 8, 9. Okay, so that's how indexing and slicing works for NumPy array. Okay, that's how it works. Okay, so we will have a few examples. Let's do it. So okay, so okay, so let me explain. This 2 : means we are wanting the third row of the matrix. Okay, from the third row onwards. So third row is the last row, so only one row will get printed out, and we are giving :3. So that means it will go up to the third element of the column, right? So it will give you the entire column. So that's why :3 returns you 7, 8, 9. Okay, next thing is array manipulation. Okay, array manipulation is to stacking array. Okay, so what is the difference between array manipulation and the sum and other operations that we have seen? So in that case, what we are doing, we are performing some operations on 2 arrays and we are outputting a third array. Here also we will almost do the same thing but a bit differently. Okay, we won't add or subtract those. We will keep the originality of the arrays and we will output something and something. Okay, so what 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 okay, the first function is concat. What 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 okay, so this is horizontal concatenation. Okay, so the arrays will be concatenated horizontally and one is out of bound. It shouldn't be. What okay, we don't have any columns in here, right? So that's why column wise is not possible, but if we had 2D arrays it will be possible. That's what I will create for you. It will be easier for you to understand. What 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 yeah, so this is like column wise stacking, right? So this 1, 2, 3 in here and this 3, 4, 5 in here got concatenated together, formed a new row. This 4, 5, 6 and 5, 6, 7 formed a new row. Okay, if we go for 0, it will be like this. Okay, so this is just column wise. So that this is row wise. That means the rows of the first matrix and the rows of the second matrix will be concatenated to another matrix. Okay, let me print this matrices for you. It will be easier. So see, the first matrix is 1, 2, 3. Second one is 4, 5, 6. When we do row-wise concatenation, right? We just concat the rows at the bottom of the matrix. So 1, 2, 3, 4, 5, 6, 3, 4, 5, 5, 6, 7. Okay. Now, if we go for column-wise addition, column-wise concatenation, then what it will do, it will concat the columns on its own. Okay. It will concat the columns on its own. Okay, so then it will give you a new row output. Okay, so that's how. So what it does, this 1, 2, 3, 3, 4, 5 gets stacked in because this is column wise now. So that will be column wise now. So 1, 2, 3 and 3, 4, 5 will be stacked in together. 4, 5, 6, 5, 6, 7 will be stacked in together. Okay, so that's how the array output will look like. So the columns will be concatenated to a row. Okay, so that's how this concatenation works works. Okay, that's how the concatenation works. Okay, so this is what is about this concatenation property. Okay, next is VStack and HStack for NumPy arrays. Okay, so what is VStack and what is HStack? As the name suggests, VStack is vertical stacking. Okay, and HStack is horizontal stacking. Stacking means the same thing as concatenation with a bit with just a small difference. Okay, that we will discuss now. So before going into VStack, what I will do, I will show you a stack example. Okay, there is another function called stack in NumPy. Okay, So I will show that first, okay, before going into this normal thing, this H stack and V stack operations. Okay, so what it will do for these two arrays only, I will consider. So what say I am stacking A and B with X is 0. So I am stacking A and B on X is 0. Okay. So it is not a list I should pass. It should be a tuple in here. Was what 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 yeah. So this is how the stacking looks like. Okay, this is stacking horizontally. Okay, and if I go to axis 1, this is stacking vertically. Okay, let me print out two separate ones. Might be the quick change I haven't noticed. It should change. It will be 1 2 3 4 5 6 like that. No, yeah, that's the intended output I was looking for. So for horizontal stacking, for x is equals 0. So for again, let me try with 1D array once. 1 second. What 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 yeah, now it is coming fine. Yeah, so that is what is about horizontal stacking and vertical stacking. Okay, so in horizontal stacking, we stack two arrays row wise. Okay, we stack two arrays row wise, and in vertical stacking, what we have, we stack two arrays based on columns. Okay, two arrays based on columns. So as you see, in the row equals 0, the output is 1 2 3 and 3 4 columns. So the two 1D arrays have gotten into a sequence. Row wise they have concatenated, but when it is going for column wise, then for 1D arrays it has concatenated the columns into its rows. Okay, it has concatenated its column into its rows. Okay, so this shouldn't be printing. First of all, this shouldn't be printing like this. Why it is printing? So that's how this stacking works. So again, this for 2D, why this problem I am not really sure. I'm typing the exact syntaxes, but still it is not working. Okay, so for stack, we need to have 1D arrays. If we need to have more than 1D arrays to be concatenated together, then for that we have concat function. Okay. This stack function will only take in 1D arrays into account, and it will stack those accordingly. Okay, so that is what is about stacking. Okay, now if we go into this is what is about stacking. So stacking will take only 1D array into account, but if we need multiple dimension arrays, we need to go for like 2D arrays. Okay, we need to go for 2D arrays. That's how it is. So now let's say I am creating a new array like this. What 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 what. Okay, so if you see this carefully, the stack function, it takes in only 1D array, and if you pass in a 2D array, it doesn't do anything with the array, right? Except what it does, it just created stacked array of its own, or the array A and B individually was stacked onto something, and that's what got written over here. Okay, now here on the contrary, if you see the H stack function that I have written at the bottom of the screen at the last line, it took in two 2D arrays to properly stacked. Okay, so that is what is the difference between this normal stacking and this H stack and V stack. Okay, if you want to go for concat function, concat actually differs in two ways. First, one way, actually just only one difference of concat, that is, okay, let me write it. So what 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 let me do it a bit clearly. Give me a few minutes. What print vertical concat vertical stack what 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 okay, let's see the differences. Okay, now what is 0, x is 1. Okay, so for each stack, that is horizontally stacking, right? So what it did, 1, 2, 3, 2, 3, 4 concatenated in a same row, 4, 5, 6, 5, 6, 7 concatenated in a same row, okay, and return you the desired output that you want to see. So that's how horizontal stack worked. Okay, so this is row wise stacked, but the rows are concatenated together into a new column, right? New row, sorry. So rows are concatenated to a new row and it outputted a different version of a matrix which is having a different shape. Okay, so if you compare the output of horizontal stacking and vertical concatenation, you will see these two are same thing. Okay, these two are same thing. So that is the basic difference between this concatenation and stacking. So stacking is to add up the elements to the same dimension. So when we are doing a row wise stacking, that is horizontal stacking, we are adding the rows, the element to a row itself. Okay, but instead in concatenation, the rows are added up to the entire matrix. Okay, the rows are added up to the entire matrix. So that is the only difference between this horizontal stacking and vertical and the concatenations. Okay, now for the vertical stack, the same thing happened, right? The columns got merged in, just the columns got increased and those elements are stacked into the columns. So 2, 5, 3, 6, 4, 7 have added into the column of the first row itself, which was done in the horizontal concatenation, right? So that's how this concatenation and stacking works and differs. So that means for stacking, the stacking will be along the axis which it is currently working, and for concatenation, they will be concatenated on the same dimension. Okay, so that is the difference between these two. So are these things, these four things clear to everybody, or I need to explain it a bit more? First of all, for stacking doesn't work on 2D arrays, and for each stack, V stack and horizontal concatenation and vertical concatenation, these are the examples that I have written. So are these things clear? Seeing a mixed response. Okay, let's go over this. So horizontal stacking, right? What it did, it had two arrays to work with. Okay, A and B. Okay, so how A looked like, how B looked like. I will show you. Stack, forget about it, it won't work here. What 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 so this 1 2 3 4 5 6, let me write it down. 1 2 3 4 5 6 2 3 4 5 6 7, these two are the rows, right? So when we are stacking horizontally, the two rows, that is 1 2 3 and 2 3 4 are stacked, okay, on the rows. So 1 2 3 2 3 4 are merged in a single row. 4 5 6 and 5 6 7 are merged again in a single row. Okay, and the resultant output is returned. Okay, so that's how this thing works. Okay, that's how this stacking works. Okay, now for horizontal concatenation, what we are concatenating the rows to the entire matrix. So 2 3 4 5 6 7, these two rows are concatenated to the entire matrix, that is row wise. Okay, so it didn't form a new row, instead it just stacked it in the rows at the bottom of the older matrix. Okay, for vertical stacking it's the same thing but on the column basis. Okay, this is now a single column, this is now a single column, like that. And for vertical concatenation it is the same thing as horizontal stack, it added those elements in there. Okay, so that is what is about this 4 operations on this array. Okay, so is this clear now? Okay, next is column stack. It is same thing. Let's see it here only. I need to go in the other slides.
what 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 what
So the column stack matches with the vertical concat. Okay, so which matches with the horizontal stack. So that is the column stacking. Okay, that is what is about this column stacking. And there, okay, that is how it works. So that is not much used, column stack function. Please. So that's how it used. So that is what is a function of this column stack. Okay, so we generally use H stack and V stack a lot, not the other ones. Okay, so if it's clear, we will go into the splitting of arrays. Okay, this is a bit tricky one. So what I will do, okay, so the syntax is, will show you here. The syntax, how it tells is, for the split function is np dot split. It takes 3 parameters into account. First one will be a array, it can be anything. Next one will be index, this I will explain. The next one is axis. Okay, the array, the first one can be any numpy array. Okay, it can be any numpy array. Indices has 2 forms, either integer or a list. If it is an integer, then what it does, it takes into account the array is split from that very index which is mentioned as an integer. But if it is an like section, like an list is passed, then that 1D array will be that array will be splitted from that row. Okay, splitted from that row and column based like that. So it will be coming to an 1D array, the list, it will be then be splitted based on that. So we will see that in a few minutes. Okay, and next one is axis, as you already know, that is having 0 and 1. That is the same thing as you already know. 0 for like a row based, 1 for column based. Okay, so that's how it will work. Now let us go back and work on this A array. Okay, so A, this will be our A array. Now what we will do, we will split this array. So A, the first, second one I am passing an integer, third one I am giving it a column. So see what happened, I provided 2 as an integer value, right? So the array is split onto two arrays. Okay, if I pass 3, it won't be 3. Why it is not equal? It should be equal, right? Okay, why it is not working? Because we have 2 rows and we are splitting it based on rows, right? So it won't work. So that's why we need to split it on a columnar basis. So that is the idea. Okay, so see here, so we have a 2D array, right? So we are splitting it based on row and we are splitting it to two splits. So the 2 arrays will be coming out. Now we are splitting it based on x is equals 1. So that means a columnar way. So we have 3 columns, so it can be split into three parts, right? So that's what is about the split. Okay, that's what is about the split. Let me print it something here. Now this is the easy and simple part. We will get into the critical part in the next part. Critical thing is coming up for you. It's now, let's say I am not passing something as integer. Instead, I am passing it as a list. Let's see how the output differs. Okay, so this is how it will differ when you pass this, like when you pass this pass a list to the integer value. So the array here will be split into 3 parts. Okay, and then those 3 outputs will be given. Okay, so in the list, the first one is the first thing refers to the column. So array will first be split into A:1. Okay. Then the array will be split between these two numbers, that is 1:2. Then the array will split for the last number, that is the array will split into the last number, that is 2 colon. Okay, so this three thing will be outputted based if it's a list is passed into the indices thing. Okay, so this is what is the idea here. So what this basically does, if you see the array in full, it has three elements, right? It is a 2 by 3 array, right? Now I am splitting it from 1 to 2, right? So that means we are splitting into these three parts. That's how split works. Okay. So this array refers to from where it is, from which, along which axis it will be splitted, and this is how it will work. Now, so this is what is to hold true for row wise. Now, if we go for column wise, you see something different, right? So what is this doing now? Here, everything is given for only row, right? But here, everything is done for column. Okay. So see, the first output is 1, 4. The next one will be done for column. The first one that we have seen was done for rows. Now in the second one, the everything will remain the same. Instead, we will do for columns instead of doing it for rows. Okay. So now if you see carefully, these are the splits that you got in there. Okay. 1, 4, 2, 5 and 3, 6. Okay. These are the splits you got from there. So every operation is done like this. So whenever you get an index, you split that array individually into three parts like this. Okay. And then you concat the output of these three separately. So that's what will return you the exact output of the split function. If you split that on the rows, then it will be a row wise split and it will return you the values and the 1D arrays based on its rows. And if you split it based on column, that is x is 1, then it will return you some values based on the columns itself, the column separation itself. That is what the concept of a split is.
Our fourth question is, which data structure in Pandas is used for handling labeled data? Option 1 series, option 2 list, option 3 dictionary, option 4 array. So this can be a little tricky. I am hoping for a lot of right answers in the comment. Guys, quickly drop your answers in the comment.
What is the advantage of NumPy over list? Okay, so this NumPy arrays consumes less memory. Next is this is faster. We will see an example at how faster NumPy arrays can be. And next is more convenient. As you see, in list you didn't had all these methods, right? Sum, min, max, median mode, this concat, h stack, v stack, this all these methods that we have discussed till now. We need to write those on our own. We need to do this on our own, right? So these are the that's why NumPy array is more convenient. And as a data science, and someone was talking about pandas. If you know about pandas already, or if you have read about somewhere, pandas array is only based on NumPy array itself. Okay, it is same thing. Okay, pandas array and NumPy array will go hand in hand. You will see. Okay, so if you understand NumPy array better, it will be easier. It will be cakewalk for the pandas part. Okay, so that is what is about this array part. Okay, that is what is about this NumPy part. Without wasting time, I will go into an example first, then I will come to this one. Okay, example will be somewhere down there. Okay, this one. This is a quick example how it is advantageous based on memory space and how it is advantageous based on its accessibility time. We are having time near equals 0. Sorry for that. Let me increase it. We have another 0, another 0. Okay. So see, here is the example for memory size. What we are doing, we are defining a list, right? Range function returns a list, right? We all know. So we have taken a list here. We are getting size of 1, that is 1, and we are multiplying with len of L, right? So 1 is an int, so it will be, so what is why 1? Because L will return a range of range from 0 to 1000, right? L will return that, so 1 will be the element and it will be int, so that's why we have written 1 here, and we have written len of L. So that means L has 1000 elements, and it will take 28 byte for each element to store from the list basic. You must know this, so that is why it is printing as 28,000. Okay, for that it is printing as 28,000. So for storing 1000 elements in a Python list takes up 28,000 bytes. Okay, whereas for a NumPy array it takes up only 4000 bytes. Why is that difference? So as you know, a dot size is, what is a dot size? A dot size is the length of the array. A dot item size is size of the array stored in the memory itself. Okay, so size of the array stored in the memory, so that's what it gives us 4000. So that is coming as 4000 bytes. So why is that difference? Okay, why is that difference? Why is this huge difference? Now let's go to this PPT. So see, for NumPy array, how we store, we directly store the data into the pointer. So forget about this dimensions, right? Focus into this data. So this is a NumPy array where we have a data head, and the data head points to the data directly. Okay, data directly. So as you might have covered in the list basics, how lists are stored in Python is not directly. Lists are stored on some memory location, and that memory location is returned to the list element. So that's why that is an mutable one, because and tuple is an immutable one, right? Because in tuple you can change the value, because it directly stores the it doesn't have the memory address of it. It is an immutable one. But in list, you will have the memory address stored in it. So whenever you access some element, it is accessing the memory location only, not the direct value. So again, that memory location will have a value. So for storing memory location, it will consider 2 bytes, and for this it will 14. So 14 by 2, 28 bytes for a single memory location it will have. Yeah, list will be having 2 step of data storage. So first one will be a pointer, second one will be a data. Okay, second one will be a data. And no, NumPy is not immutable. NumPy is mutable. We have seen multiple examples, right? NumPy is not immutable. It is not because of this storage that is immutable or mutable. That's what is considered. It is due to some other features. This is just a language construct. So they have made tuple to be immutable, and tuple doesn't store it like this. Okay, NumPy is not immutable. NumPy is based on list only, so it is totally immutable. But the storage of data is different. It stores the data directly. Okay, but for Python list, it stores the data in a 2 ways. Okay, so 14 by 2, 28 bytes will be taken up for a single memory location. Okay, so that's why that's what you saw in the example also, right? In a programmatic example, you have seen it. So that is how it is beneficial from the memory location. Okay. Now, if you see, we are doing some XYZ operations. That is adding to list. First adding to list, and second adding to NumPy arrays. The same thing we are doing. Okay. So here we needed to pass it through a loop, right, for adding. But here we don't need to do that. We can do a clear matrix multiplication by a plus b, and then we are returning the time difference. If you see the time difference here for NumPy, for a normal list is 0.005. Okay, but for NumPy arrays it is 0.000999, something like that. That is too small, because when I was doing it for 10,000 for my machine and configuration, for 1000 actually, it was not even coming something. It was coming in a zero value first, not for 1000. And see, even if you see for 1000 lists, 1000 values in list and 1 lakh values in NumPy array, still NumPy is somewhat faster than list, right? If I do a 1 lakh in both, you will see the real difference. You will see it is 41% faster than a NumPy array. Okay. Now, if I just reduce a 0, it is coming in the range of 0. Okay. That's how lightning fast NumPy array is, because in NumPy array, the access is direct, right? So that is just going into the location, fetching the data and doing the addition or multiplication or whatever you want to do it. So that is what is being done in NumPy arrays. Okay. That is what is done in NumPy arrays. Okay. So that's how it works. Okay. So that's what is about this NumPy arrays.
Just a quick info, guys. Intellipaat offers data analytics course in collaboration with IIT and Pandas. Through this course, you will master Power BI, data modeling, data mining, and much more from the IIT Madras faculty and industry expert. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new height. So visit the course page link given in the description and take the first step towards the career in the field of data analytics.
What is the main purpose of inferential statistics? So, in order to answer this question, you guys should know what is inferential statistics. Let's look at the options. Option 1 is to make predictions or inferences about a population from a sample. Option 2, to organize and summarize data. Option 3, to create data visualizations. And option 4 is to store data securely. So kindly drop your answers in the comment.
Good morning, everyone, for having me on the class. Okay. All right. So, as you guys are aware that we are going to be having a session on inferential statistics today, right? So the class that I'm going to be taking you guys through today is going to be on inferential statistics. I have a couple of things prepared for you, planned for all of you guys, right? So before we get started with a session on inferential statistics, let me very quickly take you guys through the agenda that I'm going to be taking you guys through. Basically, in the lecture series of inferential statistics, what is it that exactly you're going to be studying? What and why is this specifically important for your career as a data scientist or a data analyst? Okay, both your careers will be mended well if you know the concept of inferential statistics. So in the agenda of the class today, my people, we are going to be learning about what exactly is inferential statistics. Okay, then I'm going to take you guys through an example of confidence interval. What exactly is confidence interval? Why is this important? What is hypothesis testing? Why is it a crucial topic in inferential statistics? What errors happen or occur in hypothesis testing? There are only two kind of errors. One is called type 1 or alpha error, type 2 or beta errors. We'll talk about that. From topic number 5 to topic number 8 is the most important topic, which is super critical and super crucial for you to learn. It's called t-test, f-test, z-test, chi-square and ANOVA. So the agenda for this class is going to be very simple. Okay. I'm going to be taking you guys through some examples. I'm also going to be taking you guys through certain understanding of what exactly is, inferential statistics. As a data scientist, or as somebody who comes or wants to go into the field of artificial intelligence or machine learning or data analytics or any kind of data analysis, okay, why is inferential statistics such a crucial topic? And also, inferential statistics is one topic I believe that every engineer should know. The reason is because it is such an important topic. It deals with a lot of concepts related to a large, data. So now that you've understood the agenda for the topic that we are going to follow, right? We will start today's session with learning what exactly is inferential, okay? Inferential statistics, okay? Stats. So before we get started with inferential statistics, isn't it good or isn't it better that if I take you guys through some previous examples of statistics, maybe a quick revision of statistics of sorts? Before we jump into inferential statistics directly, can we revise certain topics of previous statistics? Example, my people, in your 10th standard, you must have studied something called measure of central tendency, right? Number 1 was called mean. Number 2 was called median. And the third was called mode. Have you studied this in your 10th standard or your 12th standard or your school time? You must have heard of something called measure of central tendency. We call this mean, median, and mode. What do you mean by mean, sir? Mean is nothing but if you have a given number called 1, 4, 3, 9. Example, what do? 1 plus 4 plus 3 plus 9 divided by 4. This answer would be your mean value, your average value. Correct? If you think from the perspective of mathematics, this may not look very fascinating. But if you look from the perspective of data visualization, it will look like this. Have you heard of something called number line, my people? A number line? A line where numbers are represented. Like, for example, 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? So if you say number 1, right? So line number 1 is here, number 4 is here, number 3 is here, and number 9 is here. When you say you want to draw a mean, you are saying that you are taking a number that passes in between something that is the mean of all the numbers, correct? The average value of all the numbers. Does that make sense? Did this make sense? You are calculating the mean called x bar, which is a mean of all the numbers. So what would be 9 plus 4 plus 3 plus 1, 4, 5, 6, 7, 8, 17 by 4, right? What is 17 by 4, my people? What is the answer for 17 by 4? Quickly, somebody calculate. 4.25, right? So you will have something here. 4.25. So do you see that your x bar is the middle value of the entire cross section? Do you see this? It's like a middle value of the entire cross section, 1, 3, 4, and 9. This is what you call as mean value. But what do you mean by median value, my people? Suppose if you have 1, 2, 3, 4, 5. What is the median value of all of this? 3 is the median value, right? The number that goes on exactly in the middle. Correct? A number that's exactly in the middle of all these numbers, that is called as a median value. And what is a mode value? For example, if you have 1, 2, 2, 3, if a number repeats itself again and again, then the mode is 2. I'm very sure you must have learned about the topic of mean, median, and mode. Absolutely okay. What about, have you studied of something called variance, my people? Have you studied of something called variance? Very good. In statistics, okay, my folks, remember, I'm asking and I'm telling all of you who are in the class, remember, my people, in statistics, for one topic like variance, there are two different formulas. One formula will be for something called population, and the other formula will be for sample. Are we clear? Variance, standard deviation, and all these topics, all these clear ideas, okay? Variance is my doubt. I asked before also variance one here. Okay, sure, Raj. I'll explain you what is variance in a nicer way. Okay, don't worry. Remember one thing. Point number one for you to remember. Inferential. In statistics, variance or standard deviation, any topic, any formulation will have two formulas, either population, either sample. Okay, I'm only going to show you sample. I'm going to delete this and I'm going to tell you guys, my people, what if I make you visualize variance? Like how we visualized, right? Mean, right? We'll also try to visualize what exactly is variance. I'll give you guys an idea, and I think from this you will be able to understand. My people, whenever you have a number called -4 and you have a number called 4, what is the mean value of this number? -4 and 4. What's the mean? 0. -6 and +6. What's the mean? 0. -8 and +8. Is it still 0? Observe one thing. Mean is not able to tell how far the number is from 0, correct? This number is larger than this number, correct? The distance between, give me 1 second. The distance between this line from 0 to 4 and between 0 to 6, which is the larger distance? The distance from mean. We will consider this 0 as a mean. Which distance is larger? 0 to 4 is larger, 0 to 6 is larger, or 0 to 8 is larger? Which is the largest among all three? 0 to 8 is the largest, then this is second largest, and this is the smallest. Agree? This is the sense. But when we calculate using mean, median, and mode, do we get that information? Does mean, median, and mode has this information, or can it include this information? No. For such numbers, mean, median, and mode will fail. To answer or to solve that problem, we have a concept called variance. My people, remember this. Variance is used to calculate the spread of the data. What do we use it to calculate? The spread of the data. Example, suppose you have a variance formula, which is this, right? So variance equals to each data point minus its mean, the whole square, divided by sample size minus 1. X of I is nothing but each individual data point. Okay, data point, point. What is X bar? Mean of the data, or sample mean of the data. And what is N? N is the sample size. Okay, N is sample size. Sir, what do you mean by that? Suppose if you have a number called 1, 4, 3. So to solve or to calculate the variance or the spread within the data, you take 1 minus, my people, what is 1 plus 4 plus 3 divided by 3? Quickly tell me. 4, 5, 6, 7, 8. What is 8 divided by 3? In, or we can take a simple number, right? Like, or plus 2 by 4. So this would be 10 by 4, right? What is 10 by 4? 5 by 2. 2.5, right? So you will have 2.5, something like this. So 1 minus 2.5, the whole square, plus, sorry, there has to be a summation here, plus 2 minus 2.5, the whole square, plus 4 minus 2.5, the whole square, plus 3 minus 2.5, the whole square, all divided by the number of sample size as 4. There are 4 data points. So 4 minus 1 is 3. If you calculate this, you will get a number which will represent the spread within the data. How far off the data spread is. So my question to all of you is, 1, 2, 4, and 3 isn't very highly spread data. But what about 1, 8, 19, and 100? Can I say that the spread within the data is higher and the spread within the data is not that high? Does that make sense? So the variance value will be higher or larger for this value versus than this value. Are you clear? Is everybody clear? Variance is a statistical formula that is used to calculate the spread. How far apart are the numbers kept? The variance between 1, 2, 3, 4 will be a lower number, and a variance between 1, 10, 20, and 30 will be a larger number. So higher the spread, larger the variance. Are we clear in this? Did you kind of get the concept, my people? And don't worry, this is just me introducing the concept of variance. Your concept of variance is about to become much more clearer. You will get much better idea about what exactly is variance and where do we use it. Anyways, my people, after variance, a lot of you must have also heard about a topic called standard deviation. Haven't we calculated standard deviation in our schools when they used to teach us statistics, and we absolutely had no idea. We were struggling with calculating its formula. You remember? The variance, right? The variance formula is very, very simple. Summation of each data point minus its mean, the whole square, divided by n minus 1. Just put a square root. Or standard deviation is nothing but square root of variance. Can I call that these two are the formulas? Can I say this is the formula? Either you can take the formula of variance, or standard deviation is nothing but square root of variance. Okay, my people, I'm about to teach you something that will make your mind shift change. Okay, that will change your mind shift a little bit. In our younger generation or in our younger days, have you all used to share movies with your friends, with each other, but you used to compress your movies? When Netflix wasn't available, we used to download movies from internet, and we used to share movies with our friends, right? Like, for example, if there is a Ninja Turtle movie, or maybe if there is some other movie, we used to compress the movie and we used to share, right? So 1.5 GB movie would become maybe 800 MB, and we would put this in a CD or a pen drive, and we used to share it with our friends. Have you done this situation where you used to take a large movie, compress it, and share it with your friends? A lot, right? Yeah, that's nice. I'm talking about people who have not seen Netflix, like people like us. We have not seen Netflix. We've seen Doordarshan. That was our life. So coming from that era, right? We have used compression algorithms to take games, movies, and all of that stuff, and we've compressed it. My question to you is very, very simple, and try and understand what I'm trying to teach you here. If the variance of a number is 100, the standard deviation will be 10, because standard deviation is nothing but square root. Okay, suppose if the variance of a number is I don't know, 16. Okay, will the standard deviation be 4? Okay, my people, can I say that standard deviation is nothing but a compression of variance without losing the information? Example, you had a data point called 100 and a data number called 16. I just compressed and made it into a smaller number with retaining the information. Meaning, between 100 and 16, which is a bigger number? Between 100 and 16, which is a bigger number? 100. When I compressed both the numbers, still between 10 and 4, which is a bigger number? 10. So did I lose any information? Did any information get lost? No. Was I able to bring a bigger number down into a smaller number? Are you understanding what I'm trying to teach you here? That standard deviation is also a statistical concept that tells you what the spread of the data. Okay, the reason why we apply square root to it is a little complicated to explain, but for now, in your brain visually, do you understand what's happening? Variance is going to be a larger number because I'm taking a summation of all of the number, plus we are also doing the square of the number, isn't it? Aren't we doing each number whole square plus second number whole square plus third number whole square plus fourth number whole square divided by n minus 1? So the number is going to be larger, right? Whenever you calculate variance, to deal with it mathematically, don't you want the number to be a little smaller so that it is manageable? Does that make sense? So standard deviation is a square root of variance. It's nothing but a spread number which is just shortened or made compressed. That's it. Remember, standard deviation is represented by the term sigma, and variance is represented by the term s square, like this. I hope this is clear. Can we proceed forward? If I have your standard variance, standard deviation. I'm so sorry. Standard deviation. Yeah, that happens. That happens, my people. Not my fault. I just woke up and I did not get the coffee, so that may be the reason for it. Could be. Do you see something called in population variance? Okay, मैं आपको एक image निकाल के दिखाता हूँ. I'll show you an image and I will tell you guys the difference. Okay. This is important because this might come in your interview someday in the future. So I want you guys to be prepared for it. I'll just take an image like this. Okay, give me 1 second. Copy image and paste. Control Z and let me show it to you. 1 minute. Give me 1 second. Let me expand this a little bit. Oh yeah, that's right. My people, listen to me very carefully. You're about to understand certain things in deeper understanding. My question is, in population variance, you divide it by not small n, capital N, okay? The total sample size. And in sample, you divide by n minus 1. The first question is, you have to learn that when you calculate population variance, you have to divide it by the capital N. And when you calculate the sample variance, you have to calculate n minus 1. First of all, the formula for population versus the formula for sample is different. I hope everybody understood this. We have clarity for variance, standard deviation, and such different topics. The formula is different for sample and population. Are we clear? Number 2, sir, why do we do this? Why are we subtracting n minus 1 from sample, and why are we only dividing n? What is the reason? The reason is this n minus 1 is called Bessel correction. What do we call this term, my people? I want you to be aware of this. Okay. I know it's a deeper concept, but I want you to be aware of this. Subtracting a number, subtracting by n minus 1 in the sample, always in most formulas in statistics is called Bessel correction. The reason why we do this is because we fix the bias in the problem. Wrong. We fix the biasness in the data. Wrong. So just know that this is called Bessel correction. And if I have some time in the future, you let me know. I will teach you what exactly is Bessel correction also. You guys will understand why n minus 1 very clearly. Okay. Wrong. In the future, if we have some time, then I'll definitely take this up also. Okay. If we have 5-10 minutes extra remaining in our class, then I will teach you what is Bessel correction properly, because this is a little deeper concept. Anyways, are we clear, my people? Subtracting sample by n minus 1 is due to a concept called Bessel correction in statistics, and this n minus 1 is called degree of freedom. We'll talk about it a little later. Okay. Anyways, no problem. Is everything clear until here to everyone, all my students, everybody? Yes. Can we proceed forward with inferential statistics in a beautiful way, in a nice way, so that all of us understand things really well? Perfect. Okay. In order for me to teach you inferential statistics in a much more nicer way, I want you to understand one topic. I am very sure you guys have studied about something called population and sample, correct or not? You all have studied what exactly is a population, what exactly is a sample, correct? You guys have studied this. I don't need to teach you this. You guys have studied. Just to revise myself or revise the concept to everybody, can I take this concept but in a different format, in a different way? Example, you study in a university and the university has 25,000 plus students. You study in a university. In that university are 25,000 plus students. So the university is a population or sample? Is the university a population or sample? It's a population, correct? It's a population. All these people are population. Okay. The problem statement is you want to ask students, are you happy? Are you happy with your education? This is the question you want to ask everybody in the university. You want to take a survey from all the students in the university saying that, are you happy with your studies? That's it. This is the survey you want to conduct, right? Is it possible for you to reach out all the 25,000 plus students? Would it be possible for you to go to every 25,000 plus student and ask them, hey, are you happy? Are you happy? Are you happy? Are you happy? It's not possible. So from a population, from a 25,000 plus students, we take a sample, correct? We take a smaller sample of maybe 100 students. Agree? We take a sample of 100 students. Agree or disagree? And what we do is we ask these 100 students the question, are you happy? In the 100 students, if the answer is 70% people say I am happy and 30% people say we are not happy, this is the answer or the output you got from the entire survey. This was the answer that you got from the survey. My people, listen to me very carefully. You had a population. You wanted to take a survey. That survey you could not take directly. So what you did, you took a sample. From the sample of 100 students, you got some answers. 70% people say I am happy. 30% people say I'm not happy. The answer that you got on the sample, does it even make sense, or does it apply to the entire population also? Does the answer 70% happy and 30% people say not happy, will this be validated, or will this be also the answer of your population? Yes or no? The study of this is called inferential statistics. Are you clear with the basic definition of inferential statistics? Did you get like the basic idea of what inferential statistics is? When you take let me tell you certain things practically. When you take a sample from a population, do you only take one sample? Think logically. I want you to think from the most basic sense. My people, when you take a sample from a population, don't you take a sample which is not biased? I'll give you guys an example. Imagine you are working in a country where 90% of the people love coffee. If you are in a country where 90% of the people drink coffee, they don't drink tea. You want to calculate the survey, or you want to calculate the people who are, you want to calculate how many people enjoy tea. Your survey is how many of you enjoy tea. If you take a random group of the people, won't by default you will have more coffee drinkers, but you need both coffee and tea drinkers on a balance. You want a 50-50 split so that the data is not biased, because everybody will say they will hate coffee, they will hate tea. Agree or disagree? Does that make sense? If in a population everybody prefers one thing over more, shouldn't you now give more focus to tea drinking people? You have to bias your sample a little bit. Does that make sense? So my first question to all of you, okay, let me ask you this. If I am a tea company, what company? I'm a what company? What am I a company? I'm a tea company. I'm a chai company. Okay, good. Very nice. Remember, I'm a chai company. Okay. I want to calculate what flavor of tea do people enjoy. Do they want a very strong tea, mild tea, or very mild tea? Flavor. I'm talking about the flavor. If I take the population of all the coffee drinking people and I will put it in the tea drinking people, won't my result be wrong? Because they anyways don't like the tea. And in the entire population of the country, 90% drink coffee. Isn't my data going to be biased by default, because the most people that will come in the sample also will be by default biased towards coffee, so they will give wrong answers. So in order for me to really understand tea, I should then selectively take people who are more tea drinkers and lesser coffee drinkers. My sample has to now change, correct? My sample now cannot be random people who I can pick. Rather than I have to first ask them, okay, remember one thing, in statistics, the most important topic for statisticians was also a theory called sampling. What do we call this? What do you mean by sampling? How to select a sample from a population is also another field of statistics. Selecting a sample from a population is yet another field called sampling. Sir, what other kind of samplings do we have? So many: random sampling, purposive sampling, selective sampling, need bias sampling. So many different kind of sampling exist. But my question is very simple. When you take a sample from a population and takes and conduct some survey, and on that on that sample you get some answer, does this answer apply to the population also or not? To check this, the concept that we need in statistics is called inferential statistics. Did you guys get it? The answer that you get on your sample, does that answer apply on the population also? Is the population also saying the same thing? To validate that, we need to study something called inferential statistics. This definition of inferential statistics is going to become much more clearer to you once we take the class. This is the best definition that you will get it. In order for you to understand inferential statistics even better, I have something that I want to teach you guys, and this is super critical for you to be learned. Okay, give me 1 second. Is it at 100%? 100%. Okay. Now that you guys have decided to study data science and you guys wanted to make your life deliberately hard, and you wanted to make your life good and hard both at the same time, right? Allow me to introduce a concept. Okay, so do we as a data scientist will do survey? How do we get sample data? Oh, very nice, Harshita. Very good. I would like to copy this question if I may. This is a very good question, very practical question, by the way. I like it. Is this visible to all of you? Yeah. Question is very simple. As a data scientist, do we do the survey or do we get the sample data? In your practical career as a data scientist that I have spent in my life, data will always be, first of all, given to you. Understood, my people? As a data scientist in your career, no matter which company you will work in, the data will be given to you. Once the data is given to you, as a data scientist, the survey that you conduct is not the survey that I taught you. Okay, the survey that you will conduct is, I'll give you guys an example. Suppose you work in a finance company and you got a data like this: age, salary, okay, age, salary, years of experience, and all of this. Okay, you got a data like this. What is the age of the guy who wants a loan? What is the salary of the person who wants the loan? And how many years of experience does it come with? Example, this is the data. You can do inferential statistics on either age column, age salary column, or age salary and years of experience column. So the survey that you are conducting is not going to people and conducting their survey and getting an answer. The survey you conduct is within the data itself. I hope you got the clarity I'm trying to give you. Your survey is not a survey that you go out and collect the answers and then you get it. The data is given to you and you have to conduct the survey within the data for the columns that is given to you. You don't go outside and do any kind of survey. That's not our job. It's a job of market research companies, not our job. Whenever a data is given to you by the company, whatever data is given to you, you need to do testing within that data frame itself. There is no going outside. Okay, good. Anyways, coming back to the main topic, how do we select data? That depends on your company to company, job to job, profile to profile. It's a very open-ended question. Selecting data depends on so many things. Depends on what are you trying to solve. If you're trying to solve the average age for people to get a loan, then age. If you're trying to do two-way ANOVA, then you have to do age and salary. If you're trying to do two-way ANOVA with interaction effect, all the three columns, we'll learn about it a little bit more. Okay, maybe you'll try to get an idea then. Okay, my people, have you ever heard of a concept called normal distribution? Has anybody in my class ever heard about the term called normal distribution? This is also called as a bell curve. This is also called as Gaussian distribution. Have you ever had a chance or opportunity to hear about this thing called normal distribution or bell curve or Gaussian distribution? It looks like this. Okay, my people, it looks like this. It looks like this. It looks like this. Okay, I have not. So since I'm an artist of a very high caliber, my drawings are not imperfect. They are just like that. Okay, so they look like this. This is how a normal distribution looks like. Okay, this is what a normal distribution will look like. So the thing is, sir, what is normal distribution? And I absolutely have no idea about normal distribution. Okay, can I assume in my entire class nobody knows what normal distribution is? Is there anybody in my class who has never heard about normal distribution? Is there anybody in my class who has never heard about normal distribution? Anyone? You guys have learned about normal distribution? Okay, I'm going to ask you one question. Did you completely understand normal distribution? 1 sigma, 2 sigma, 3 sigma, all of that stuff? You guys were taught this concept? Mean one? No, that I'm not saying mean one, standard deviation 0. I'm saying that were you taught that in a normal distribution, you will have a center value where mean is equal to median equals to mode. Then one direction in the right will be 1 standard deviation. One direction will be 2 standard deviation. This will be 1 standard deviation to the left, 2 standard deviation to the right. Okay, so we will have to make our knowledge of normal distribution a large. Okay, my question to all of you is one thing. Okay, imagine, my people, imagine all of you will go to your village, and in your village you will have some school, correct? All of you, when you go to your village, you will all have schools, right? Some government schools, some private schools, right? Maybe nowadays villages are no longer looking like villages, but you will have a school. Suppose in your village you have 100 students. How many students? 100 students. If you make them stand according to their height, HEIGHT, if you make all the students stand according to their height, so won't the tallest of the tall people come in the beginning? These many people are tall, then most people are of average height, and then only few people will be small in height. Can I say if you make them stand according to the height, this is how the data will look like in histogram formation? tall people, most of them average, then short. Can I say that this is how your data of histogram will look like? If you make everybody stand based on their height, this is how it will look like. Okay. Did you observe one pattern? Did you all observe one pattern? When you rank all the students based on the height, very few people will be very tall. Very few people will be very short. But majority of the people will always be average. Very few people will be very tall. Very few people will be very short. Majority of the people are of average height. So my people, my question to you is, my actual answer to you is, imagine you have a plastic sheet. What sheet? What sheet? A plastic sheet that is taken, or that is held very very firmly by the two end. My people, listen to me very carefully. Imagine a plastic sheet, something that cannot break, is taken care or is held together by two people at the very end. If I drop rock is stone. If I drop stone into this, will this sheet take up a form like this? Will it take up a form like this? If I drop rocks on the sheet of paper, will it take up a form like this, where rocks are all full here, getting filled, or full here? Does that make sense? So that must mean the reason why normal distribution looks like it is a normal distribution is because normal distribution is a density curve. What curve? What kind of curve is normal distribution, my people? Normal distribution is what kind of curve? It's a density curve. What curve? Once again, I want all of you to tell me the answer once again. Density curve. Why do we call it density curve? Very simple. Listen to me very carefully, okay? I'm going to shorten this graph. Give me 1 second. Reduce this dimension, put it in the left. Okay. Listen to me very carefully. And I want you to never forget this concept, because if you know the concept that I just taught you now, you guys will become the pro at normal distribution. Listen to me very carefully. Sir, first of all, you taught me what is called normal distribution. You taught me what is called density curve. Sir, what do you mean by density curve? Whenever you plot a normal distribution graph in your life, you have the spread of the normal distribution, which is represented by x-axis, and you have the heap or the height of the normal distribution. If I decide to increase the height of my normal distribution somehow, what will happen to your distance? It will become, if you increase the height, somehow if you take this and if you make the height bigger, your normal distribution will become peakier, but the distance between the points will become shorter. And if you press it from the top, it will become smaller in peak, but higher in spread. Did that make sense? You can never increase the peak and also increase the dimension. That cannot happen. If you decide to increase its peak, your spread will decrease. If you decrease the spread, your peak will increase, right? If you increase the spread, your peak will decrease. Both the things are inverse to each other. They can't happen together. That's why it's called density, because in density, everything is just one particular 100% number. You can't change it. Are you clear? And I'll come to what is on x and y axis. Give me 1 second. I'll come to what is x and y. But are you clear with this concept? What is, you cannot change the dimension on it. Are we clear on this so far? Okay. Now let's understand it in more advance, in more details. A standard deviation is called standard deviation because on the x-axis, it's the concept of standard deviation. The standard deviation sigma that you calculated comes in the bottom, in the bottom of it. Give me 1 second. I'll show you guys in a much better example. Standard bell curve. Okay, bell curve. Oh yeah. This is the best one. Okay, copy and paste. I'm gonna expand the image a little bit. Give me 1 second. My people, do you see in the middle a value called mean? The center line that passes the central distribution or the normal distribution, exactly it will cut the normal distribution in half. This is called your mu or your mean. In normal distribution, your mean should be equals to your median should be equal to your mode. When your mean, median and mode all are very same numbers, you will get the center value called mu. Are we clear? If you want to plot a distribution of a data, you should get your mean equals to median equals to mode, and that's exactly where you will have a center line of your distribution. Depending on your data, if you calculate one sigma or one standard deviation, this much distance in one axis is called one standard deviation. Are we clear? Your mu plus one standard deviation will be this much distance, and your mean minus one standard deviation will be this much distance. Are we clear? This is not made up by me. This is a rule. If you have to plot a normal distribution, this is how you have to plot it. This is exactly how you do it. You can just simply call it one standard deviation. Okay, you can just simply call this one standard deviation, two standard deviation, and three standard deviation. To the left, you call it one standard deviation, two standard deviation, and three standard deviation. Are you clear, my people? On the x-axis, you plot one standard deviation, then take 2 times of that 2 standard deviation, then 3 standard deviation. Both of this on the right hand side and also to the left hand side, and your data will start looking like this. It will grow up, grow down. Sir, what does this mean? What is the meaning of this? It means, my people, just now we took the example of height of the people, right? Of the 100 students, of all the 100 students. Agree or disagree? 100 students were taken for according to their height. Make sense? A while ago, in the example of the data, only few people will have a very tall height, only few people will have a very short height. Just like that, in our normal distribution data, do you see this tail, my people? In the left hand side, a small thing that is getting ended here, like it's becoming shorter and shorter and shorter, and it's becoming shorter and shorter and shorter. This thing is called as a tail. It means that very few people are either very short, either few people are very, very tall, but majority of the people are what, my people? Average height. This is what the graph is representing. Did you understand? Did you get it? The tail of your normal distribution always represents what? Extreme cases. To the left hand side, extremely short people, because we are in the negative direction. To the extreme right, we are very tall people, because this is a positive direction. Most people are average. My question to you all is, if you take height, you will get this normal distribution graph. What about if you take wealth distribution in the world? Will your answer not be same, my people? If you take the wealth distribution in the world, very few people are super duper rich, very few people are very, very poor, but almost most people are average. Does that make sense? Either somebody will be very poor, either somebody will be very, very poor, or somebody will be very, very rich, but most of us are average. What about weight, my people? If you take random 100 people's weight in the market, or from people in the group, somebody will be very, very fat, or very, very obese. Somebody will be very, very thin, or somebody will be thin, but most people are of average weight. Agree or disagree? When statisticians figured out this, they saw that almost all the data in the world follows what distribution? All the data in the world follows normal distribution. This normal distribution is not going to leave your life. I'll tell you why. You all are working people. Is somebody in my class a working person? Somebody who are already working in a company, any other company? My people, have you ever heard that there are something called job appraisal? Do you know that every year you have a job appraisal? Job appraisal meaning your manager, suppose I'm a manager, right? Like I manage a team of 33 people, correct? I directly manage a team of 33 people. So I have to give these 33 people a rank between 1 to 5. 1 being the lowest, 2 being the lowest, 3 is okay, 4 and 5 being good worker. Matlab this guy has done an exceptionally great job. For 33 people, my people, is it possible that all 33 people did great in my company, in my team? Is it possible that all 33 people did the absolute best? Or can I say all 33 did the worst? No. In the job appraisal also, won't my team follow a normal distribution? Somebody did exceptionally great, but the number of people who did exceptionally great will be very lower. Somebody who did exceptionally terrible, the number will be lower, but most people will be average. Does that make sense? If you don't know this, every company in the world will try to fit you, all the employees, in a normal distribution. When you get your appraisals, they also fit you in a normal distribution. Most of you will get an average score of 3, believe it or not, and a hike of maybe 10% of your salary. But somebody who did exceptionally well, maybe the person will get a higher bonus or a appraisal. But remember, normal distribution will never leave your life. In fact, your salary increment is also dependent on this topic. So learn this well. Okay? Are we clear with the concept so far, my people? Did you guys understand the concept of normal distribution? Would you now be willing to calculate normal distribution very, very quicker without going through the headache much? Or have you ever felt while learning something new that sometimes it's getting a little overwhelming? Have you ever felt like that? It's becoming too much to learn within that span of time. Have you felt like that in any of the classes? Yeah, it does. Okay. Happens. I can understand. I can understand. Well, everyone, how do I say this to you? You guys will be learning machine learning. In the future classes, in some of the classes that you will be taking some of the classes on machine learning, the algorithms that will be taught to you, I'm not going to say that they are hard. Okay, my people, I'm not going to say they are hard. But for somebody who's listening to the topic for the very first time, it may sound very weird, right? Why are we doing this? Eventually, it will make sense. But in the very beginning, it might appear a little weird or it might appear a little hard. That is the challenge you will have to navigate. Okay, you'll be like, why are we doing this? What is the reason for it? And then eventually you'll understand, oh, okay, this is why we are doing it. So machine learning might become a little weird for you, not hard for a fact, but yeah, it might be a little weird for you that you're learning something in a very different way. So that could be one of the things, but I think that you guys will be able to overcome that. It shouldn't be a problem. Anyways, SQL is the most important skill that you have in an organization. I don't want to give you guys the hint or the advice, but I'm going to tell you guys one thing, that people get fired sometimes because as a data scientist, their SQL skills are not up to the mark. I have seen this happen to a lot of people, lot of new students. The reason is when they are expected to extract the data from the data warehouse, but they are still not able to get the data from the data warehouse writing a very simplistic query. They are not able to clean a certain kind of data, not able to do casting in the SQL query. The companies don't prefer such kind of people because they don't care about machine learning at the end, but you are not even able to do data extraction properly. That is a big no for certain companies, right? So especially in startups, right? Like if you aim or if you want to join startups and mid-tier companies, make sure that your SQL is not great. It will take some time for you to reach there, but if you call yourself 8 out of 10 in SQL, you guys are doing good. So please practice SQL. It's a very important skill. Without this, I'm telling you, no surviving in the industry. It's very, very hard. Okay. So just letting you guys know that it's super critical for you to learn SQL. Very important skill. Anyways, we have completed what is a normal distribution. I spoke to you guys about what is this normal distribution looks like and all of that stuff and all of that stuff and all of that stuff. Right? We spoke about it. We also spoke about, what exactly is sampling, what exactly is population. By the way, I also need to tell you one other thing, one other small topic. Population, if your population is 25,000 plus, and if you take a sample of maybe 100 or 1,000 or 5,000, these are all called samples. But if you take a number, if you take a sample which is very close to your population, for example, 23,000, okay? From your population of 25,000, you took a sample size of 23,000. The name of this is called census. Are you clear? Population, sample, census. Are we clear? You will have to learn this eventually later in your life. whenever you take a sample which is very close to the population number, that number or the name of that particular sample is not sample anymore, it is called census. Are we clear? I hope all of you are okay with my pace. Is my speed okay, my people? Quick feedback time. Are you okay with the speed, with the content, with the, how do I say this, with my communication? Are you guys okay with it? Do you want me to reduce the speed a little bit, increase it, or is the one that I'm continuing is fine? Is the one that I'm an increase would be good? Okay, that's fine. Okay. Now, coming back to the topic of normal distribution, right? We discussed, we have discussed about what is normal distribution and all of that stuff. Right now, I would love to take you guys through some definitions. Okay, it's very, very important. Okay, that the class is also following normal distribution, right? Anyways, that's good. Okay, let me copy the definition of inferential statistics from the PPT and paste it here, and we will expand on this. My people, is this the definition from the PPT that we have taken? It says that descriptive statistics describes the data. Inferential statistics is used to draw conclusions. How do I make this larger? Give me 1 second, my people. How do I make this? Oh yeah, right here. 11 को हम कर देते हैं 26. Yeah, that's right. Perfect. My people, this is the definition that is given to us in the presentation. Okay. Is this visible now for all of you? I'm also going to make this a little bold. Descriptive statistics describes the data, right? I'm not going to talk about descriptive statistics. You guys have already studied this. I'm talking about inferential statistics. Inferential statistics is used to draw conclusion. The keyword here is conclusion. Please listen carefully. About the population based on statistical finding on sample analysis. What this text is trying to say that is inferential statistics is used to draw conclusion. So the first word is called conclusion, right? So conclusion, basically an answer. You want a conclusion on. You want a conclusion on what, my people? What do you want a conclusion on? You want a conclusion on your population. But the conclusion will be given to you of the population based on what? What will you use to draw a conclusion on your population? Using a sample. Using a sample, asking this sample some question and making sure that this sample's answer also apply on the population. To validate this, we have a theory called inferential statistics. Are we clear? The PPT says the same exact thing that we had discussed a while ago. Sir, is there any theory or method to know how much sample or how many samples are sufficient to represent the universe? Yes, it's called increment. Okay, increment is not a theory. It's a concept in statistics called incremental learning. What it does is when you have a sample of 25,000 plus students, you take a sample of 100, 1,000, 5,000, 17,000 and all of that, and you start plotting the data. If any sample gives you same answer repeatedly for sample size, you stop there. So that becomes your incremental learning. Have a knowledge like that, but it's a little complicated topic. But you can do that. You can take multiple sample sizes also. You can also optimize for it. We have a theory like that in mathematics. We have that. Okay. Are we clear with the definition of inferential statistics, my people? I hope the definition is clear. Inferential statistics is nothing. You have a conclusion that you want to have on your population, but to make the conclusion on your population, you need a sample. So to applying statistics on your sample, you get an answer on your population. Okay. This point will become very, very clear now in a while. In just a second, it will become very, very clear. Are we clear in this so far? My people, in statistics, you will be hearing two things very commonly, and I do not want you to forget it, okay? One is called population parameter and sample statistic. Sample statistic. Remember, my people, whenever you calculate any population's mean, it's called population mean. If you calculate any population standard deviation, it's called population standard deviation. And if you take a population and calculate its variance, it's called population variance. Population mean, population variance, and population standard deviation together, or any one or any two, is called as what? Is called as what in statistics? It's called as population parameter. What do we call this? Population mean, population standard deviation, population mode, population median, All of these, when you calculate on a population, what do we call this? Population parameter. But when you calculate and when you take a sample and when you calculate its mean, its standard deviation, its variance, its mode, its median, all of these are called as what, my people? Sample statistic. Are you clear? In the entire PPT that I'm going to be taking you forward, they have not mentioned population mean or population standard deviation or population variance. They have not mentioned it. They have all mentioned it by the name population parameter and sample statistic. I am telling you right now that remember, any population, any calculation is called as population parameter, and you do the same thing on sample. It's called as sample statistic. Are we clear so far? Now, my people, you guys have understood the definition of inferential statistics. Inferential statistics is a field where you take a data, you have a population, you take a small sample. Does this sample's answer make sense for the entire population? For example, when you took a survey of are you happy in your education, you had a university of 25,000 plus students. But when you took a sample of 100, 70% people said that they are happy in the course and 30% people said we are not happy in the course. Does this mean from 25,000 plus students, 70% of the students are genuinely happy and 30% students are not happy? Because the answer that you got on your sample, does it even make sense on the population? Will the same logic apply on the population or not? To validate this, we use inferential statistics, right? That is what the definition of inferential statistics is. To continue or to learn inferential statistics, there is a concept called confidence interval. Okay, there is a concept called confidence interval. Sir, what do you mean by confidence interval? First of all, I'm going to write down the formula for confidence interval and everything will make sense. See, confidence interval CI, confidence interval is equal to X bar, which is your mean value, plus or minus Z score into S divided by root of N. Now remember, this Z value is Z score. Okay, I'll tell you guys what this particular thing is. Okay, this is the formula of confidence interval X bar plus or minus Z into S divided by root of N. But you will be like, sir, I don't understand. I don't know what you're trying to say. What is S? What is X bar? I am not clear. Don't worry, I'll explain it to you. My people, what is X bar? X bar is nothing but the sample mean. The sample that you have taken, its mean will be sample mean. Sir, what is this Z value? See, this Z value is called as a Z score, and I will help you understand what is Z score. Okay, I'll tell you how to teach it little later. What is S? What should be your S? S is the standard deviation or your sample standard deviation. For the sample that you have, your standard deviation is called as an S, and your N is the sample size. Okay, is your sample size. So confidence interval is calculated as X bar plus or minus Z into S divided by root of N. Very nice. This is the formula for confidence interval. But sir, what exactly is confidence interval? What do you mean by confidence interval? I don't understand. I have no idea about what is confidence interval. Okay. If I show you one example, you will understand the definition, the reason why confidence interval is important, and everything will be made clear to you. Can we do it? Can we take one example and everything will become crystal clear in your head? Yeah? Okay. Listen to me very carefully because the topic that you're going to learn now is super duper critical. Okay, very, very critical. Then I'm going to talk about range estimates and point estimates. Okay, very, very simple. So I'm going to take an example. Okay, I'm going to write down an example. Give me 1 second. Oh, right there. Oh, nice. This is awesome. Insert home 28. Okay, I'm going to make it 28. A random sample of, I hope this is visible. 55 males were taken and their protein consumption and their average protein, okay, protein consumption and their average AVERAGE. Let me expand this a little bit. Give me 1 second. Expand this a little bit. This much is fine. Okay. A random sample of 55 males were taken, and their average protein consumption for a day, we can say that is an average protein consumption in a day is for an average male is about 122 grams. वो तो ज़्यादा हो गया. I know it's too much, but I'm just gonna take some 122 grams. Okay. A random sample of 55 males were taken, and their average protein consumption was 122 grams. Okay, was 122 grams of protein. Okay, 122 grams of protein. PROTIEN, protein, with a standard deviation of, maybe we can say 12 grams, 13 grams, maybe up to 14 grams. We can say this is the standard deviations of 14 grams, right? A random sample of 55 males were taken, and their average, let's say, grams of protein consumption was 122 grams of protein with a standard deviation of 14% gram. Calculate population average with 95% confidence interval. With 95% confidence interval. The 95% confidence interval. Okay, ठीक है. My people, this is the question that has been asked to me by some statistician. Okay. Do you remember the definition I told you a while ago for one of the examples of, how do I say this? For one of the examples on inferential statistics, that whenever you have a sample, you make a judgment on your population. You remember we did this example of inferential statistical definition. You will have a sample, and based on the sample, you will make a judgment on the population. So let's take the data from whatever is given to us. My people, what and all is given to us? Can I say that the sample mean X bar is given to me? X bar is given to me that on an average 55 people, the average protein consumption per day is 122 grams. 122 gram of protein is what they consume every day. How many number of people have been taken in the survey? 55 people have been taken for the survey. What else is there? What is the standard deviation of the data? How many grams? 14 grams of the standard deviation. And what is the confidence interval, my people? The confidence interval is 95%. Okay. So keep this number as it is. I'll make you understand what is 95% in a while. Okay. Just for simplicity reasons, the Z value for 95% confidence interval is 1.96. Now, I want you to please remember one thing. Okay. How to calculate Z value is a little complicated topic. So I will be teaching you how to calculate the concept of Z score, how to do that in a test called Z test. In our PPT, here we have a test called Z test. I will be teaching you how to calculate the Z value directly from a manual task there in that topic. But for now, to get the answers faster, I want you to please not assume, this is actually the correct answer, that for Z value of 95%, the answer is 1.96. The formula for confidence interval is X bar plus or minus Z score into S divided by root of N. This was the formula that I had. If I apply this formula, I need to split the formula into two parts. Okay. First of all, I need to make this formula, split it into two parts. Why two parts? One formula will have X bar plus Z into S divided by root of N, and the other part will have X bar minus Z into S divided by root of N. It will be plus and minus, so I need to split it. For simplicity reasons, whichever is the plus sign, we call this as upper bound. UB. Okay, I'm going to write the full form so that you can refer my notes later. The full form for this UB is called upper bound. Okay, UPPER BOUND bound, and this is called as a lower bound, BOUND. So now LB lower bound equals to X bar minus Z into S divided by root of N, meaning what is X bar? 122 minus 1.96 into what is S? S is 14 divided by root of 55. And this is your lower bound formula. What is your upper bound formula? X bar plus Z into S divided by root of N. So X bar is what? 122 plus 1.96 into 14 divided by root of 55. Can somebody calculate the answer for this, please? I don't, because the numbers is The numbers I've taken is on the top of my head. Can somebody calculate the answer for this? What is 122 minus 1.96 into 14 divided by root of 55 and 122 plus 1.96 into 14 divided by root of 5? Upper bound is equal to 125.70 and lower bound is equal to 118.29. Okay. The lower bound is this much and upper bound is this much. Correct or not, my people? This is the answer that we got, yes or no? It means that, listen to me carefully, listen to me very carefully. You took a sample for 55 people and the average protein consumption is 122 grams. The answer that you got from the formula of confidence interval means, listen to me very carefully and tell me, my people, myself, I am a protein company. Okay, I make protein for all the gym or the health freaks in India. Is it possible for me to reach out to all the people in India? Is it possible for me to reach out to every single person on India or in India who consumes protein? No, right? So if my question is, what is the average protein consumption of the population, not the sample? The question that the protein company is asking is the average consumption of protein for the population. That is my question. But can I actually take all the population in India? I can't. So what did I do? I took a sample of how many people, my people? How many people sample did I take? 55 people sample I took, correct? The answer that I got from the sample is the average protein consumption is in India is between 118.29 grams to 125.70 grams. This range is the answer that I got from the confidence interval, and the confidence that I have that the population will consume any protein between 118 grams and between 125 grams. How much percent confident I am in my answer? 95%. Because what is the confidence interval that you took? What is the confidence interval that you took? You are 95% sure, confident that if you take a population, somehow if you are able to calculate the population of all the protein eaters in India, the population's mean, your population of all the protein consumption people in India and the mean of the people, the mean average consumption of protein is guaranteed to be between 119 grams and 118 grams. Did you understand? Did you understand the topic, my people? Did you understand the concept? Confidence interval will help you calculate a range. Some number between X range and Y range, a number between X and Y, okay, a number between X and Y, and the population's parameter is guaranteed to be between that, inside it. It means that the population of all the Indians protein eaters is guaranteed to be between 118 grams and 125 grams. We cannot tell accurately exactly how much it will be because that is not possible. But we can tell you between what range it will lie and how much percent confident I am that whatever range I have calculated, I'm very, very sure. Did you understand, my people? My people, remember one thing. Remember one thing. Sir, if I take a confidence interval of 95%, why can't we take a confidence interval of 95%? Who gives us the confidence value of 95%? Okay. First of all, question number 1. Confidence interval range or the value. Okay. The value of confidence interval. The value of confidence interval is always assumed. Are we clear, my people? In the data science industry and the statistics industry, everybody will be taking a confidence interval of 95%. This is a standard rule. My people, higher the confidence level, higher is the chance that my population calculations are correct. If my confidence interval number is higher, then the range I have calculated and my assumption that my population parameter calculations are correct. So higher calculations are always preferred. So if this statement is true, then it can go 95%, to 99%. This is the standard rate of calculating confidence interval in the interviews, in data science, in drugs calculations, in statistical tests. All these tests in the world, you always have a confidence interval of 95% to 99%. This is the rule, a standard practice that everybody follows. It can go beyond 95 up to 99. If you go 100%, then the range will be equal to population. Confidence interval is determined by the confidence level of how the data is collected. Okay, allow me to explain. Everything will make sense. Whenever you are doing any statistical test, will you calculate confidence interval, or before doing the experiment, you need to decide on what confidence I will accept the answer? Please tell me which statement is correct. Do you calculate confidence interval, or do you assume a confidence interval and then you will accept your answer if the confidence interval makes sense? First of all, let's get this clarity. Whenever you do an experimentation, okay, any statistical test, okay, I'll give you guys an example with which everything will make sense. Okay, imagine you are testing for a drug called Dolo. My people, Dolo is used to reduce the temperature of the body. Agree? If you guys are sick, if you guys have fever, if you take Dolo, it will reduce your temperature. This is called as Dolo is a medicine that will reduce the temperature. Okay. I want to test the effectiveness of the drug. Is this drug really effective? Does this really help people? So can I not split the 100 people group into two group? 50 people group and 50 people group. 50 people I will give some sweet medication and 50 people I will give Dolo, and I will test whether Dolo is really effective or not, or is it people's brain that is telling them no, because I ate a medicine I feel good. It's called placebo. If you don't know, this is how it is done. Before I even do an experimentation to test one thing or not, don't I need to say that I will calculate the population parameter at 95% confidence interval only? So 95% confidence interval is not calculated. It is always assumed. Are we clear? Is this point first of all clear? That 95% is assumed. It is assumed on the basis of one thing. How accurate do you want the answer? If you want the answers to be 99% accurate, my question to you all is very simple. My people, suppose this is my entire population. Do you agree? This is my entire population. Do you agree? This line is my entire population. Suppose at 95% confidence interval, I might get a range like this, correct? This is the range. This is the lower bound. Sorry, this is the upper bound and this is the lower bound. Agree? This is the range I got for 95% accurate. For me to be 99% sure, won't this range go beyond? Won't this range expand a little bit more to be 99% confident? Understand or not? If I do 100%, won't the entire population's range become my total range? If you want higher confidence, your judgment number should also be high, right? Does that make sense? Okay, listen to me very carefully, okay? I'll give you guys an example. My people, I have a population of all the people's height in the world, okay? All the people's height in the world, the average height of the population of all Indian men, okay? Let's say Indian men, all the Indian men. Can I say, my people, all Indian men's average height is about 172 centimeter, 5 feet 8 inches? The average height of Indians. This is the population, all the Indians in the world I have taken. Can I say all the Indians in the world, the average height of all the Indians in the world is 172 centimeter, 5.8. When I took a sample of Indian men, just a small sample of Indian men, I got a range between 182 centimeter to 165 centimeter. This range I got between 95% confidence interval. Tell me, is my population mean within this data? Is my population mean within this data? It is, right? My population mean of 172 is between the range of 95%. But if I have calculated for 99%, won't my number increase the range a little bit more? Now I will be between 190 centimeter and 142 centimeter. To be more confident, you have to make more judgment. The ranges will be much bigger. Does that make sense? so that the confidence you have that you are right will also increase with it. Did you understand? So the selection of confidence interval is on the basis of how bigger range are you okay taking in your answer. Does that make sense? How much range are you willing to take? Do you want a higher range or do you want a smaller range? It depends on your question, on your test, on the statistician. So confidence interval is always taken by the experimenter before doing the exam or before conducting the exam. I can even tell you one thing right now. If confidence interval is not given to you in any question, which value of confidence interval will you by default assume in any interview questions from today? 95%. That's it. 95% is the industry standard. Only and only if you are doing medical related data, then 99% confidence interval, because they want the accuracy to be higher. But for all other purposes, including data science, data analytics, what is the confidence interval everybody assumes? 95%. So first of all, are we clear with the concept of 95% assumption? Are we clear with the assumption of 95%? In the formula of z-score, have I taken the value of z is equal to 1.96? Lot of you had a questions on z statistics. So I'm telling you this. I have taken the value of z is equal to 1.96. Do you all see? I am highlighting it right now, right here. Can you see this is highlighted here? 1.96. Sir, how did you take it? Did I teach you how I took it, my people? Did I tell you why and how I took 1.96? Okay. Did I tell you the reason behind it? I did. If you don't know, let me repeat it myself. To calculate the z value of 1.96, I will have to teach you z test. So did I make a request to all of you in the beginning of the class that can you please allow me to take an assumption that the z value is 1.96 for this particular example? And when I'm going to be teaching you z-test, I will make it very, very clear why the z value is 1.96 for 95% confidence interval. Can I make this request to all of you that rather than jumping so many topics and getting you guys confused unnecessarily, let's do connect the dots. Let's go one step at a time. And when I promise you, when I teach you z-test, I will come back to this question and I will tell you now, does it make sense? And you guys will be like, okay, sir, now it makes sense. How did you calculate 1.96? So this is a request to all of you. Can I skip teaching you what is 1.96 using the z table? Because it's not very, very easy. I will show you how it is calculated also. Give me 1 second. Very simple answer I'll tell you, okay? Just very quickly I'll tell you so that you guys are sort of sure that don't worry, it will be taken care for you, okay? Right, give me 1 second. Okay, my people, do you see this number called 1.9 here? Can you see this number 1.9 here? This 1.9, I'm highlighting it here. Can you see this? I'm going to highlight it a little bit more. Can you see this 1.9 number here? 1.9. And can you see this number called 0.06? If you combine the numbers together, okay, do you find a number called 0.9750?
Wrong.
Okay. 0.9750, right? I will help you how to calculate this. You will get an answer called 0.6 and 1.9. Okay. This number is 97.50%, but the tail is towards called, okay, so you will see in Z table, we calculate two tail. One is the entire table to the right, one is entire table to the left. Okay. So I'll tell you how exactly 9750 will come in Z test. Don't worry, but we'll be able to calculate 9750 percentage pe pura answer, which is 1.96, and you'll get the answer called 1.96. So don't worry. Okay, so I'm going to skip this topic for now. I'm going to teach you guys this in the z-test part of it. When I'm going to be teaching you z-test, then you guys will be able to learn this well. Are we clear? Is everyone clear? I hope the concept is sort of clear between all of you, that the z value of 1.96 will be taught to you then. Okay. Do you want me to repeat the question and the solution once again? Yes? Only Raj is saying yes. Do you want me to repeat it? Okay. This is the question that is given to me by the protein company. Let's say Pushpa Protein. Okay. The name of my company is called Pushpa Protein. I want to know what is the average consumptions of protein in India. How much average protein do people consume in India so that I can make a packaging bottle and sell it to people per month basis, 30 day basis, I can give them so that on an average, they can consume 1 scoop every day and 30 days the packet will be over. I want to make that product. So what I did, I conducted a survey with how many people, how many males did I conduct the survey with? 55 males. Now look, I had no idea, I had no way, I did not want to discriminate against men or women. So I'm going to take males and females, but just for example, okay? So I have taken 55 males and the average protein consumption was monitored. So first of all, I took 55 people. I monitored what is the average protein consumption of these people. It is assumed to be, not assumed, it is calculated to be 122 grams. So 55 people consumed 122 grams. My people, do you see this thing called standard deviation equals to 14 grams? Standard deviation equals to 14 grams. Do you see this term called standard deviation equals to 14 grams? Yes or no? It means that in the data, in the entire data, it was observed that 122 plus 14 grams is how much, my people? What is 122 plus 14? Oh yeah, grams. Sorry. 136. What is 122 minus 14? 108. The data in the entire 55 people, somebody had consumed up to 136 gram, somebody had consumed as low as 108 gram. Collectively for 55 people, the average came up to be 122. That is what standard deviation means. I hope you're clear. The max values were also found to be 136 grams. The lower values were found to be 108 grams, but the average came up to be 122. I hope you are clear. That is what standard deviation of 14 means. Did you understand? Did you get it? The range was given to you, and between this range, the average came up to be 122 grams. We have to calculate the confidence interval. We have to calculate a range of population parameter with 95% confidence interval. This confidence interval is always assumed or it is always taken. So first of all, in this particular step, I have written down the data clearly, correct? This is X, which is the sample mean. Sample mean is 122 gram. The sample size is 55 grams. The standard deviation is 14 grams. The confidence interval is 95%. And the Z-score for 95% confidence interval is 1.96. In this step, I have taken nothing but I have taken the data from the question. Any confusion here? Any confusion in this part? This right here is the formula for confidence interval, correct? Confidence interval is equal to X bar plus or minus Z into S divided by root of N. This formula had to be split between the lower bound formula and upper bound formula. Make sense? This is the lower bound formula and this is the upper bound formula. Any confusion so far? Took the sample mean X bar is 122 minus the Z-score value is 1.96. The standard deviation is 14 and the sample size is root of 55. I got the lower bound formula called lower bound equals to 118.29 grams. And when I implemented it for upper bound, I calculated same 122 plus 1.96 into 14 divided by root of 55. I got an upper bound of 155 grams. What this particular answer means, or what this particular thing is saying is, if I take a population of all the Indian protein consumptions men from a sample, I am making a guess that the average protein consumption of Indian people or all the Indian men must be between 118 grams of protein to 125 grams of protein. I am sure that the population of all the Indian men who consume protein, I am sure that the average value, the real value, the actual true value of population mean lies somewhere between 118 grams and between 125 grams. This is what this confidence interval formula has given me the output of. And how confident I am of my answer? I am 95% confident of my answer. Did that make sense? We are done with the classes for today because we are done.
Just a quick info, guys. Intellipaat offers data analytics course in collaboration with IIT and Powertech. Through this course, you will master Power BI, data modeling, data mining, and much more from the IIT Madras faculty and industry expert. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to a new height. So visit the course page link given in the description and take the first step towards the career in the field of data analytics.
Our next quiz question is: what is the first step in a statistical analysis for a purchase case study? So let's look at the options. Our option 1 is data collection, option 2 is hypothesis testing, option 3 is visualization of data, and option 4 is creating a report. Want to see a lot of answers in the chat?
An important topic. You remember from the sequence that we had started learning inferential statistics, we learned so many more stuff, right? Like going through the agenda of what PPT we followed. First, we understood what exactly is inferential statistics, right? Inferential statistics is a way where you take a sample because that's the only data you have available. You don't have population available to you, or it's given to you. So sample whenever it's given to you, when you want to do judgment or make a judgment on your population from where the sample comes from, inferential statistics allows you to do a lot of other stuff. The first thing that you did when you work on your population, so coming back to the most simplistic of the definitions, right? When you are given a sample, okay, of anything, you want to make certain judgment on your population data. So what do? You will always be given something called as a sample. You will make a judgment on your population, right? The first thing where sample was given to you and you made a judgment on your data was confidence interval, right? Confidence interval is x bar plus or minus z into s divided by root of n. Then after this, you pretty much understood what is hypothesis testing. We were learning something called hypothesis testing errors, right? In yesterday's class, I was taking you guys through this particular example where we have four situations, four different scene of where the things could go wrong or where the things could go right. What do I mean by that? In scenario number one, in situation number one, what happened? We had a doctor, we had a patient. The patient in reality, in actual truth, had cancer. And the doctor also diagnosed that, yes, you have cancer. Okay, this is a good thing the doctor did because somebody was positive about something and the doctor's diagnosis was also, guess what, you're positive, right? What happened in the other scenario? The guy does not have a cancer, and the prediction that the doctor gave or the diagnosis the doctor gave is, don't worry, you don't have cancer, right? Which is a good thing the model did. In other situation, the patient did not have cancer. Right here, the patient does not have cancer, but the doctor says, misdiagnose him as you have cancer. Wrong situation. Something which is false, somebody saying it is true. Not good. In the other reverse situation, something is true, you predict it as false. Somebody has cancer and your diagnosis is, don't worry, you do not have cancer. That's not a good thing. Where was I heading with this definition? I was heading to a very important topic. What is that topic? The topic was, whenever we have hypothesis testing questions. So for example, in hypothesis testing, we have two kind of questions which we ask. One is called null hypothesis and the other is called alternate hypothesis. Did we learn this in yesterday's class? That in inferential statistics or any statistical test, you have null hypothesis and alternate hypothesis. Very good. Now, whatever I'm about to teach you now, please listen to me very carefully. My people, whenever you have a condition or two condition, null hypothesis or alternate hypothesis, we don't say in inferential statistics something is true or something is false. We don't say that. Instead, we say, do we accept it or do we reject it? Okay, this is the more technical way, the more professional and the correct way of saying the hypothesis. So I'll give you guys an example. According to the most simplistic of the understanding, my people, if I accept the null hypothesis, doesn't it make the null hypothesis automatically rejected? Because there are two other conditions. Does that make sense? If I accept the null hypothesis, by default, the null hypothesis will be rejected, right? And if I reject the null hypothesis, automatically the alternate hypothesis will be accepted. Make sense? Because they are reverse conditions of each other. So if I just work, accept or reject only null hypothesis, I don't even touch alternate, won't this give me the answer for alternate is true or null is true, or alternate is rejected or null is rejected? Does that make sense? I only and only accept or reject, never null. You either accept null hypothesis or you reject null hypothesis. The other condition is automatically taken care by itself. I'll give you an example. So what do you do? In one test, you said, I accept the null hypothesis. Automatically, what happened to your alternate hypothesis, my people? If you accept the null hypothesis, the alternate hypothesis stands rejected. Let's write it down. If you accept the null hypothesis, then your alternate hypothesis stands rejected. If you reject alternate null hypothesis, if you reject null hypothesis, your alternate stands accepted. They are opposite of each other. So you only and only accept or reject which condition? Only and only null. Does it make sense? You only and only work with null. You do not touch the alternate hypothesis. This is the rule. Are we clear? This is the rule. This is the condition based on which everything is dependent on. Are we clear so far, everybody? Very good. So based on this logic, whenever in reality, okay, give me and listen to this very carefully, okay? Type 1 and type 2 errors. Listen to this very carefully. Yeah, this is a good thing. Okay, I'm going to copy this and I'm going to paste this. Is this visible to all of you? Is this image visible to all? Very good. Listen to me very carefully. In reality, null hypothesis is true. In reality, null hypothesis is true. You rejected the null hypothesis. Did you do a good job? In reality, a null hypothesis was supposed to be true. You rejected it. Can I call this the type 1 error? In reality, null hypothesis was supposed to be false and you rejected it. Is that a good thing you did? So when null hypothesis is false, my people, this might not make sense to you immediately. Whatever I'm teaching you right now, the true, false, the null rejected, the accepted rejected. Of course, this is a little complicated to understand in the beginning, but I want all of you to make a little effort to understand this, right? Because this concept is very new for all of you. This may not make sense so much now, but I promise you, once I take you guys through inferential statistics in the examples in some of my further classes, this will make a lot of sense. Just try to make some effort to learn what I'm trying to teach you. I told you null hypothesis is accepted and rejected. In the entire thing, isn't null hypothesis is either true or false? In reality, okay, null hypothesis is either true, null hypothesis is either false. That means null hypothesis in reality was true, null hypothesis in reality was false. But what you did in your test, when you ran your test, when reality null hypothesis was supposed to be true, you rejected the null hypothesis. You did a reverse case. Here, you actually have reached something called type 1 error. Not a good condition. You don't actually have to worry about these two conditions. Ignore. You only worry about this. When null hypothesis was true, you rejected it. You did a type 1 kind of error. When null hypothesis was false, right? When the null hypothesis in reality is supposed to be false, but what you did with it, you not rejected, meaning you accepted it. Okay. The not rejected is nothing but accepted. Okay, people write it as not rejected, but it's rejected, so it's accepted. So when you accept it but it's supposed to be false, it's called type 2 error. It's called false negative error and false positive error. It's just like the confusion matrix that I showed you. This will just take a little time for you to understand, but once you understand this is very much logical. Pretty logical to how confusion matrix is. This is a confusion matrix and this is sort of like a tabular format. This is not a proper confusion matrix, but you understand the idea. Did you get what I'm trying to say? Did you understand what I'm trying to aim at? So my question to all of you is, just because inferential statistics is able to take a sample and make a judgment on the population, is it 100% perfect or accurate? Just because inferential statistics is able to take a sample and make a judgment on the population, is it not possible that sometimes you can get a type 1 or type 2 error in your examples? That means your answers are not correct. They may have some incorrectness in themselves, or the answers could be wrong by themselves. Is there a possibility of that? The answer is yes. Is it clear? Inferential statistics is just to give you guys a certain estimate, either point or range. Did you guys get the concept of the type 1 and type 2 error? They are not perfect. There could be errors in the program, and that can happen. It is very much possible. It's possible that there are type 1 errors or type 2 errors in the program. Are we clear so far? Now, my people, as you've understood very important and super complicated stuff, let's understand what inferential stats tests are and how do we implement it. Okay, there are tests called t-test, or there is a test called t-test. Let me write it like this. In inferential statistics, there are a couple of tests that are more important that you will be using in your career for a very long period of time. And the way I'm going to teach you these tests now, I want you to write the code in the exact same way. I want you to write down manually also in the same way possible. But the way I am going to teach it to you is going to be slightly different. I'll tell you how. My people, in your interview, assume you have a data scientist interview or a data analyst interview. Say you are going for an interview. Because the way technology has developed so well this time, nobody will be asking you to solve a t-test problem mathematically. Nobody, no interviewer is going to give you a sheet of paper and they will give you a problem statement and expect you to write the whole mathematics behind the t-test and do it. What is that you will be expected to do? Understand the problem and code the problem. Basically, write a program. This will take not more than 2 minutes to 3 minutes. Agree or disagree? But solving it mathematically may take 15 minutes to 20 minutes, depending on how good is your calculation speed. But my belief is, okay, if you ask me, my personal belief is, I'm very sure that you don't have to learn. So my personal belief is, at least once in your life, you should solve at least one problem mathematically. The reason is, you will clearly understand what exactly is happening behind my code, or within the code, under the hood. What is it that's really working, so that you can understand the foundational and basic knowledge very, very well. To really understand what this test is doing, solving it mathematically will make a lot of difference. So how I will take this class forward is, how many tests there are in inferential statistic? There is a test called t-test. There is a test called z-test. There is a test called f-test. There is a test called ANOVA, or analysis of variance. And there is a test called chi-square. What I'm thinking is, for all of you, for each test, I will teach you both mathematical and the code, mathematical way and a code, mathematical way and a code, mathematics, code, and code. This way, you will be able to understand the clear factor of how these tests are working, how do the internal mechanisms work. So you will be able to solve any given problem in your career for any of this test, both in paper and also with code. Let me also tell you one other thing. Writing and teaching you a mathematical part of it is not a part of your syllabus, but like I said, foundations are everything in life. This is how I'm going to proceed. So now that you have understood so many important concepts, you guys should be aware that how many tests are there in inferential statistics. There are so many, my people. Okay, so many tests exist, but the most important ones are the test called t-test. There's a test called z-test. There's a test called f-test. There's a test called ANOVA, and there is a test called chi-square. Okay, I am going to teach you right now a test called a t-test. Okay, a test called t-test. Sir, what is t-test? It's inferential statistics. Why does it have a weird name? Why does it have an alphabetical name called t-test, z-test, f-test, p-test, x-test, y-test? Why does it have a weird name? Okay, first of all, my people, t-test actually comes with the full form of t-test. Actually, some fascinating uh, facts for all of you. T-test's full form is called students t-test. Okay, students t-test. This is created by a very important and a very intelligent statistician called Robert Fisher, or Fisher, you can just call him Fisher. Okay, Fisher was working in a company where he was not allowed to give his name or name the company. So he created the test, or he wrote the research paper under the name students t-test, right? The reason he created this test was he was walking down a field one day where he saw two different paddy fields. Do you understand what is paddy? Do you know what is paddy, right? Paddy is a grain. We eat it. It's rice. Yeah. Mr. Fisher wanted to understand, can we identify the yield of the field? You understand what is yield, right? So if you have 1 acre of land and if you put tomatoes in it, how much will you be able to produce? So for example, if you are able to sow maybe 100 kg or 1000 kg of potatoes, not all the potatoes you will be able to produce, or you will have a yield of it. Some get destroyed in, I don't know, some get destroyed by the animals, all of that stuff. So Mr. Fisher wanted to understand, can I identify or predict or estimate a yield of both the fields of similar patterns? And can I say that the yields are same or equal or unequal? So this is one of the reasons why students t-test was written. Okay, but what exactly is students t-test? I'll tell you. My people, have you heard of the concept called population? Have you heard of the concept called population? The definition that I'm giving you right now is going to improve over a period of time. So the definition that I'm giving you is basic. So I'll talk to you like this. If you talk to, okay, if a pilot, a airline pilot talks to a 5-year-old kid, a 20-year-old kid, a 30-year-old man, and a 40-year-old gentleman, the definition of what he does will change, right? So a pilot will tell a 5-year-old kid, I fly in the air. Then a pilot will tell a 20-year-old kid that I fly an aeroplane which is highly aerodynamic in nature, which has engines such that I am able to fly at maybe 10,000 feet of altitude. Example. Your definition will change according to the people's level of understanding, correct? So the understanding and the definition of t-test that I'm going to give you now and the one that you will have it by the end of t-test will be slightly different. Okay, so try and take it like that. If you have a population, I take 2 samples. How many samples, my people? Sample number 1 and sample number 2. From one population, I've taken 2 samples. Are we clear? When you take 2 different samples from same population, you calculate the mean. What do you mean? Mean. MEAN, or average. You take the average of S1 and you take the average of S2. T-test is a test in inferential statistics that is used to compare. What does it do? What does it do, my people? What is inferential statistical test called t-test used for? T-test is a test that is used to compare the means between 2 groups. Example. I'll give you guys an example. The average protein consumption in India, according to the population, is about 122 to 130 grams. Example. If I take a sample of the population and it turns out to be 118 grams, example, and the sample 2 turns out to be, 127 grams. I am going to compare the sample one's mean, which is 118 grams and 127 grams, to compare the means between 2 groups or 2 samples that come from same population. When you do such test, that test is called t-test. Did you understand? Did we get the very basic definition of what a t-test does? T-test does nothing different. Nothing different. T-test is a test to compare the mean between two groups. When you compare two groups, you compare the means between them. When you have such test, that's called t-test. Very basic definition. Did everybody understand? It will become further clear when I take you guys through some more examples. But are we clear in the beginning? Very good. There are some rules if you want to apply t-test. What did I say, my people? There are some rules if you want to apply t-test. Rule number 1, the sample size. Whenever you want to implement a t-test, you cannot take a sample greater than 30. So that means the sample size whenever you have to run a t-test should be less than or equal to 30. Did it become clear? If you are 1.4 billion people in this planet called Bharatiya Indians, we are 1.4 billion population. But if I want to do t-test, the maximum sample size that I can take is how much, my people, everybody? What is the total sample size? How much can I maximum take my sample? Even if your population is 1.4 billion, 20 billion, 30 billion, 80 billion, 1 trillion, 1 quadrillion, 1 zillion, whatever, goes on and on and on. The sample size can only be up to 30. Does that make sense? Less than or equal to 30. This is a rule if you want to do t-test. I'll tell you why do we have to do this. There is always a why behind everything. Sir, why only 30? There must be a reason. I'll tell you later. But did you understand the first rule? T-test is a test that is used to compare what between two groups? Means between two groups. Are we clear? So these two things are important. T-test is used to compare the averages of one sample with another sample, and the second thing it can only have a sample size less than or equal to 30. 31, you cannot use t-test. T-test can't be used for a sample size even for 31. Can't use it. Sir, t-test is not very simple as it appears, not in the complexity. Okay, what is 30? Sample size. Imagine you manufacture 40,000 chips packet per day. You manufacture 40,000 chips packet per day. If you want to take a sample, random sample from the batch that you manufactured that day, what is the maximum sample you can take? How many chips packet will you take from the 40,000 chips packet you manufactured? If you want to run t-test, how many sample of packets can you take max? So 30 is nothing but sample size. T-test is actually of multiple different type. Type number 1 is called one sample t-test. T-test has multiple tests within itself. The first test in t-test is called one sample t-test. What do we call this? One sample t-test. The second type of t-test is called independent sample t-test. And the third type of test is called paired t-test. So basically, there are three types of t-test, not just t-test. There are three different types of t-test. Sir, what are these types of t-test? I'll make you guys understand this very, very well. Let's first take what is one sample t-test, okay? One sample t-test. My people, imagine you guys run a chocolate factory or a chips factory, okay? Just like how Mr. Prasad has a chips factory. Let's say you are owning a chips factory. Chips are potato chips or tortillas or any other chip factory. Imagine of that sorts, whatever you like. Imagine company manufacture 40,000 chips per day. How many day? How many chips per day? 40,000 chips per day. 40,000 is the manufacturing capacity of Mr. Prasad. Okay, that's the manufacturing capacity. Mr. Prasad has kept a standard. What standard? Mr. Prasad says each packet, individual packet of my chip will have 10 grams of 10 grams worth of chips. Each packet, each individual chips packet I will manufacture will have 10 grams worth of chips inside it, plus the weight of the plastic cover. But assume that entire packet weight should be 10 grams. Example, assume it. Okay. Did Mr. Prasad set up a standard for the company saying that each packet needs to follow this guideline very, very strictly? Agree or disagree? So tell me one thing. Did Mr. Prasad not do one thing by default, by mistake, or by deliberation, that from a big population, one of the sample is by default 10. The average is set at 10. No matter what happens, one of the sample becomes 10, and the other sample could be the sample you want. Maybe 30 packets of chips randomly taken from 40,000, or 25 random chips packet, or 40 random chips packet. Whenever you have such a standard to maintain and you do that kind of test, that test is called one sample t-test. Are we clear? Did you understand what is one sample t-test? One sample t-test is called one sample because from the population, how many samples, which sample was drawn from the actual data from the population? Only one, right? You randomly took 25 packets from 40,000 packets. Agree or disagree? But the other sample is by default set at 10 gram because that standard is set by my dear Prasad. Did that make sense? In one sample t-test, one of the sample called sample 1 is nothing but the standard a company sets. And the other sample is the number of samples you take from the original 40,000. Did that make sense to everybody? One sample t-test is a test to always maintain the standard in a company. I'm going to ask you guys a question. Won't this be the most important test in FMCG companies? Where every manufactured food item or billable item will be compared against a standard. Whichever company is packaging company, manufacturing company, can they use t-test, one sample t-test, to do comparison analysis? When somebody has a standard, like a standard of 80 grams per chocolate bar or 10 grams per chocolate, your standard becomes one of the sample 1, and the other becomes how many samples you want to take from the original batch, 40,000. From 40,000 chips packet, I will decide to take random 25 packets and I will measure the average. Logically speaking, everybody listen to me. Logically speaking, every chip packet, suppose you have taken 25 chips packet, shouldn't it have a sample? All the samples average should be 10 grams only by default. I'm asking you all a simple question. Logically speaking, I'm asking you guys a very simple question, okay? Try and understand what I'm trying to tell you. If I have taken randomly 25 packets of chips from 40,000 batch, this entire big batch, shouldn't each gram or each potato chip should be 10 gram, 10 gram, 10 gram? If I take the average also, shouldn't it give me 10 only at the end of the day? Mathematically speaking, shouldn't it? Raj sir, please wait for a little minute. I'll give you an access to the mic. Raj sir, please wait for a little while. I'll give you an access. I've taken your question, but let's take a little while, okay? How does hypothesis testing fit into it? So, Asha, we haven't gone to that stage yet. I'm making you understand the concept first. Then I'm going to show you how hypothesis test fit into it, okay? Yeah, so we'll go through that example. Don't worry. Let's not rush through concepts. Let's understand them, and then I'm going to tell you practically how this entire thing is implemented, okay? Okay, so let's take an example. We'll take an example to solve the problem also, but first understand what the topic is. My question to all of you is, rather than taking 25 random packets, I have taken 4 random packets, okay? I have taken 4 random packets out of 40,000. 40,000 was manufactured per day. In a day, it was manufactured 40,000. From that, I have taken 4. 4 packets I have taken. That means each packet will be 10 gram, 10 gram, 10 gram, 10 gram. Make sense? So average of this will be 10 plus 10 plus 10 plus 10 divided by 4. Logically speaking, can I not write it like this? 10 into 4 divided by 4. 4 cancels. The average is still 10. Make sense? Now tell me one thing. In one of the examples, I have taken one of the samples. One of the samples by default, I have taken how much grams? Or how many grams have I taken by default? The mean of this sample is by default taken how many? Yeah. If you take the mean of sample number 2, this also should give you 10, right? And you can compare 10 against 10 and say everything is good. The manufacturing went well. But if the 4 packets average comes up to 9.8 grams, where is the other 0.2 gram? Won't this give me an idea that there is a problem in the manufacturing? Some packets are now being produced less. The manufacturing isn't going well. So when I compare the original standard value with the new samples average, won't this give me an idea that there looks like somewhere the manufacturing there is a problem? The weights are not properly distributed, or 10 grams of wafers are not being put into every packet? This comparison will give me that idea, yes or no. Such tests, when you run with hypothesis testing, is called one sample t-test. Are we clear? That one sample t-test is a very good example of manufacturing. Whenever you compare it against a standard, you call this as a one sample t-test. Are we clear? Does this make sense to everybody? Is this easier to understand? You compare the sample against a standard, it becomes one sample t-test. Can I proceed forward next? Did you all get the one sample t-test? So after one sample t-test, there is another kind of test called independent sample t-test. Independent sample t-test, okay? Independent sample t-test. Now listen to me very carefully. This is also a very beautiful test and you will understand this very nicely, okay? So in independent sample t-test, do you remember, my people, I gave you guys an idea a while ago that we have an independent population, and from that population you take two samples, sample number 1 and sample number 2. But in one sample t-test, one of the samples that we take already has a standard set, that each sample is by default 30 grams, 40 grams, 80 grams, whatever it is. In independent sample t-test, your population is not one, it's two different populations. Population number 1 and then population number 2. Both these populations are independent of each other. From each independent population, you take its independent sample called sample number 1, you take an independent sample called sample number 2, and when you compare the mean or the average number between these samples, this kind of test is called independent sample t-test. I'll give you guys an example. My people, can I say India? Wrong. Okay. Can I say Indian students and American students? Wrong. If I want to calculate, are Indians more intelligent in mathematics or American more intelligent in mathematics? Indian students and American students are independent of each other. They have no relationship with each other apart from being a student. They are completely independent populations. Wrong. Indian students and American students are independent populations, culturally different. Wrong. In all other ways, they are independent of each other. Agree or disagree? So have I taken two different populations, independent students, Indian students and American students? So many millions of students. From Indian students, can I select a random group of 30 people? 30 Indian students. From all the Indian students in India, can I take 30 random group of Indian students? Can I take a 30 random group of 30 American students? Yes or no? And I can give both these students a common test called SAT, math stat. Make sense? I can give both the students, both 30 Indian students and 30 American students, a common test. And whichever student's average is higher, or we can compare the averages, right? Like for example, out of 100 marks exam on mathematics, Indian students got on an average 78% and American students got 68%. Will I be able to compare the means of two samples? Did that make sense to all of you, my people? Whenever you talk about independent sample t-test, the rule that there will be one population and two different samples does not apply anymore. In independent sample t-test, your population should be independent. When you take the sample from the population, they will also be independent. And when you compare the means between these two samples, such kind of tests are called independent sample t-test. This is much more easier to understand, and don't worry, I will teach you much more. My people, can I give you one more example of independent sample t-test? One more. I don't like to do this because I believe we are all Indians. Okay? But because culturally, right, North and South India are different, right? Like I live in South India, right? I live in Bangalore. I love the culture here, but I'm originally from North, right? I'm a Punjabi by culture, but I live in South. So if I want to ask one simple question, statistically, are North Indians, do North Indians eat more sweet food or South Indians eat more sweet food? Or are North Indians are North Indians okay with spicy food or South Indian okay with spicy food? Which culture is comfortable with much more spicier food? So to calculate the spice level, we have something called Scoville unit. Can I not take North India as a separate population and South India as a separate population? Take a random group of 30 people, make them eat very spicy food, mild spicy food, not a spicy food, and take a reading and compare the average? Did that make sense? Did that make sense? I'll give you one more example. Are students in Mumbai smarter than students in Bangalore? Are students in Mumbai smarter than students in Bangalore? Isn't this also independent population, my people? They may be students, but they are independent, right? It depends on the question I ask. Make sense? If I was asking the question internationally, then India and America make sense. But if I was asking a question with respect to states, then states are also different. Make sense? Yeah. Picking up two different set of samples from categorically two independent populations. They have to be categorically different. Absolutely correct, Chandrakant. Are we clear, my people? Such kind of tests are called independent sample t-test because the population are independent, sample will be independent, the answer will be independent. Make sense? All of you? Did you understand the concept of independent sample t-test? Yes or no? Very good. Can I proceed forward with something called paired t-test? Can I proceed forward with something called paired t-test? If you guys have given me the example, okay. The population needs to be same in both cases. The population needs to be same. Are you talking about the number or are you talking about the independence of the population? Coffee and tea example cannot work here because they are dependent. No. All of you need to understand one thing. My entire statistics is dependent on the way I ask the question. Will you agree? Wrong. The way the question is asked, my entire statistics depends on that. Make sense? Okay. When we take spice test, we will use 30 spicy, 30 mild, 30 less spicy. We will take only 30 people. The category we defined, the label could be many, not 30, 30. The number of people we will take 30. But mild, not mild, mild, we can take a survey like this. If it's mild, call it 0. Not mild, 1. Very spicy, 2. We can take a label like this. Okay, we can take a label like this and count the labels later, like 4 zeros, 3 twos, and 1 ones. We can take a label like that, and then we can do an averaging later. But point being, statistics depends very much on the way a question is asked. Okay, when we wanted to compare Indian students with American students, we know that this population is also different, this population is also different. Correct? Agree or disagree, everybody? But when I want to compare Indian students also, now you can't ask the question that which students are smarter, Indian or American. Now you will have to change your question. Looking at state-wise understanding, which state is important? Mumbai is smarter or Bangalore is smarter? Aren't these also independent according to the definition of the question? Does that make sense? Do you understand? Within Bangalore, listen to me very carefully. Within Bangalore, school A is performing good or school B is performing good. Isn't this also independent population? Because school A is different, school B is different, but both of them are in Bangalore. Rural, urban, whatever you see, statistics completely depends on the way you formulate the question. But the point is, they have to be independent of each other. They cannot be dependent on each other. I'll give you guys an example of dependence also. I'll give you guys an example. If I take all male students of an example, okay, let me ask you a question. If I take all the male students in class A and male students in class B, do you call this independent population or dependent population? Only and only male? They are still independent, correct? School A, male students, school B, male students, they are still independent, correct? Because they have no relationship with each other. Make sense? Does that make sense? Did you guys get the idea? Taking male separately, female separately has nothing to do with statistics. The question is simple. If the students in group A are also visible in group B or are also duplicated in group B, will they remain independent or dependent? If there is any duplication in group A and group B, will you call this independent or dependent? Example, somebody in group A plays guitar and somebody in group B plays sitar also. But a student called student A plays both guitar and sitar and is both visible in group A and group B. Will you truly have independence or there are certain dependencies? There are some complications like duplicacy. There are certain dependencies like sitar is dependent on guitar, example. They are both musical instruments like that. So dependency and independency depends on the way you ask the question in statistics. But when you take the concept that two populations are independent of each other, there is no relation between them. There is not one variable that causes this change and this change. If they are not dependent on each other, then it is truly called to be independent. And that's the kind of test you can run on one sample t-test. Are we clear? Are we clear? Did that make sense? Good. In machine learning, have you ever heard of a concept called correlation? Have you ever heard of a concept called correlation? Let me give you an example. If the price of the sugar goes high, if the price of the sugar go high, will the price of the coffee also increase in India? If the price of the sugar goes high today, will all the coffee owners increase the price? I'll give you one more example. If the price of the fuel goes high, will Zomato, Swiggy, Cab, all these people also increase the fare? So are these events independent of each other or dependent in each other? One event is causing a change in another event. Are they dependent of each other? Very good. Will the price of coffee increase the price of my laptop? Are these independent of each other? Are these independent of each other? Okay. When you take a group called group A and when you take a group called group B, are they independent or dependent? Depends on the question is being asked to us. Make sense? What context are you asking? Are you asking about coffee? Are you asking about laptop? That's why I told you independence and dependence depends on the question you ask. Okay. So did you understand the concept of independent sample t-test, my people? Independent sample t-test is a t-test that can be applied if the two populations are independent of each other. There is no relationship between them. You take a sample and you compare the means. Did we learn something important right now? Have you ever seen an ad on your TV where somebody will come on the TV and says that I was 100 kgs and I was very very sad. I was not feeling very confident in my life, but suddenly there is a magical pill that I ate and now I'm suddenly 60 kgs and my life is so good. I have so many new friends and all of that stuff, right? You know the example you've seen. Have you seen this before and after? Have you seen those stupid ads on the internet that makes you fair apparently? I believe every skin color people are amazing, but have you seen those ads in the past where a guy was like, I was feeling very very dark, but then I applied this, suddenly I'm fairer than the sun, right? All these nonsense ads you must have seen. What do you see in this ad? Before and after, correct? Before and after, correct? We had, I was before I was so heavy, I was not a very tall person, but after taking this medication I suddenly became very very tall. I'm able to reach the sky and touch the Indigo Airlines and directly sit inside the airline. Before and after ads, you have seen this thing, right? Paired t test is exactly that. Not kidding, I'll tell you. Imagine you take a random group of 4 people. Can I say this is a valid t-test? Yes or no? Does it follow the rule of t-test? I have taken a group of 4 people, a sample of 4 people. Is this a valid t-test? Yes or no? Very good. My people, paired t-test is used to run on before and after scenario. Example. Suppose there are 4 people I have taken, okay? 4 people. All these 4 people are diabetic, okay? All these 4 people are diabetic, okay? You understand diabetes, right? People who have sugar, high blood sugar in their blood. People who are diabetic need an external insulin in their body. I hope everybody knows this, okay? Imagine there are 4 people and they are all diabetic. And there is this new drug in the market that reduces your diabetes level, okay? Your sugar level in your body. So, can I say I can measure my blood level, my blood sugar level before taking the tablet, and I can measure after taking the tablet? And if I compare the means before and after, I will be able to get to know the validity or the validation of the drug. Does that make sense? I'll take a very bad example. Don't fall into the trap of taking pills for reducing your weight, okay? I absolutely am against it. You should never do it. Go work out. Don't be lazy. Imagine there is a pill called diet pill, okay? Suppose person number 1 was 100 kg before taking the diet pill and now he's suddenly 90 kg. He lost 10 kg. Somebody was 80 kg, lost 70 kg, became 70 kg. Somebody was 65 kg, became 50 kg. Okay. Somebody was 71 kg, became 65 kgs. Whenever you have a test, when you want to compare the before and after effect of anything, That kind of test is called paired t-test. The reason why it is called paired t-test is because for the same person number one, how many times do we measure his recording in a test? To do paired t-test for the same person, how many times do we take his recording, or how many times do we take his data? Twice. In a pair, we take the data before and after. Such kind of test is called paired t-test. Are we clear? Did that make sense, my people? The reason why this is called paired t-test, paired t-test is a test in one sample t-test that is used to compare something before something and after something. Paired t-test is used to measure the efficiency of something. I'll give you guys another example. I'll give you guys one more example. Have you learned something called abacus? Have you heard of something called abacus? Have you seen students on internet? Okay, I'm not sure. Okay, let me tell you. Have you seen students on the internet doing this and then calculating like a very big number? 45 into 645 plus 246 plus 195 minus 122. They do all of that stuff, right? And then there is this thing called abacus where you move your beads. I'll show you what is abacus. I'll show you. Have you seen this bead thing? Yeah, this is abacus. That is, I think there is a name for it. I know what it's called, Kumon or something. I'm not sure. There are multiple ways you can make your mathematics stronger. Imagine a student, or imagine if scientists want to know, okay, if scientists want to know whether you have actually improved after learning abacus in mathematics. So can we not take 4 students who were very, very bad in mathematics? Before we take the score, the average score they used to get in the test, after teaching them abacus, we will take. So can't we prove the effectiveness of abacus, that abacus is really good? Before they were scoring very bad and now they are scoring very good. Do you understand? Whenever you want to check the effectiveness of something, you do one sample you do paired t-test. Are we clear? Got the concept? Okay. Did you understand the difference in one sample t-test, independent sample t-test, and paired t-test? Are we clear? Can we take a mathematical exercise, people? The finally we come to mathematics of t-test. Can we take it up? Let's solve it. Perfect, my people. So now that you guys have learned what exactly is one sample t-test, the time of understanding how does t-test work has finally come. We are going to learn how to implement it. We are going to learn how to actually write it down, mathematically solve it, and then I'm going to make you solve it and make you understand all of this really, really well. Okay. Now, let's write down the first version of our question. I'm going to give you guys an example. Give me 1 second. Where is the text? Oh, text is here, right? So I will have to write down a text. Let's reduce the dimension of this to maybe 20, 36. 36 is fine. Is this visible to everyone? If I write a text like this, hello, it's pretty much visible. The average salary of the average salary of blue collar, let's not say blue collar, kind of discriminatory. The average salary of men in 2019 was $100. Okay, I'm just taking a random example. The average salary of men in the average salary of hotel chefs was $100 in 2019. However, considering a sample of Control Z, considering a sample of, let's take a sample size less than 30. We can take exactly 30 participants. It was found that the average salary is $140. $140 with standard deviation of $14, $15. I think we can take an average standard deviation, a very small standard deviation. So maybe $20. Yeah, we'll take a deviation of $20. The average salary of a hotel chef back in 2019 was $100. However, considering a sample of 30 participants, it was found that the average salary for 30 participants, for these 30 participants were $100, were $140 with a standard deviation of $20. Okay. Now let's ask the question: Has the salary increased in INCREASD increased in the last 2019, 21, 2, 3? Okay. 19, 20, 1, 2, 3, maybe 5 years. In the last 5 years, has the salary increased in the last 5 years? This is the question number 1, or this is the only question. Question is, has the salary increased in the last 5 years? Not increased. Let's not say increased. Let's say changed. Has the salary changed in the last 5 years? Okay. Solve the problem with 95% confidence interval. Okay. Confidence interval. Okay. I'm going to expand this a little bit so that you guys are able to see this. I'm going to also make this a little bold. Is this visible to all of you? Is all of this visible to you? Is this question visible to you? The question is very simple. Back in 2019, chefs were able to make how much salary? $100 on an average. Okay? It's a lower number, but just for understanding. $100 they were able to make $100 in 2019. But in the 2023 or in 2024, they took how many group of random people? 30 group of random people. When we took a random group of 30 people and we calculated their average salary, the average salary was how much dollars? $140 with a standard deviation of $20, right? We need to calculate, has the salary changed in the last 5 years or not? Has the salary changed? We are not asking has it increased or decreased. We are asking did it change or no, right? This is the question. We will solve this problem using one sample, using t-test, right? So this problem will be solved using t-test. Now, in order to solve the problem using t-test, the first step you need to do is write down the data, correct or not? The average salary of a chef is $100 back in 2019. Is this survey conducted? Is this research conducted already? Is this the truth? It's conducted. So can I say that the population mean, my population mean mu, my standard against which I will be comparing all my data is $100. Can I say this? This $100 has become my standard. So this problem just became a one sample t-test problem because my problem is already set. I have a standard of $100. Agree or disagree? My population mean is $100. What is my sample mean? What is my sample mean X bar? What is my sample mean? What is the sample's money that we calculated? $140. $140 is the sample's money. What is the sample size? How many people have we taken for the study? 30. What is my confidence interval in the entire thing? 95%. What is my standard deviation? It is $20. Right? I hope I've taken 20. Yeah. Is this the data that is taken in the question? Yes or no? Is this the data that is given to me in the question? Agree or disagree? I am teaching you how to solve a t-test using mathematics. Okay, mathematically, I'm teaching you how to run t-test. This is important. The first step is step number 1. Step number 1 is to write hypothesis first. Before you even solve a problem in t-test, aren't you supposed to write the hypothesis first? Agree or disagree? I told you this in the beginning of the class. You do not continue inferential statistics before you write a hypothesis. So my people, my null hypothesis and my alternate hypothesis. What can I say? My null hypothesis is that I still believe the old research is correct, that the average salary of my population, the entire population in 2023 also is how many dollars? $100. The sample mean is still going to be my, not sample mean, the population mean will still be $100 because my people, we may have taken 30 participants, but we are making a guess on the population, right? We are making a judgment on the population, right? Using the sample, we will make a judgment on the population. Correct or not? Agree or disagree? We will make a judgment on the population, right? Using the sample, we make a judgment on the population. So using a sample of 30 people, you say that the population mean in 2023 is still $100. But the alternate hypothesis is that the population mean is no longer $100. Did you understand? This is your null and alternate hypothesis. Simple as that. My question to all of you is very, very simple. Isn't it possible that the salary could also have decreased or also could have increased? Both the situations could have happened. Salaries could have decreased also, salary could have increased also. Now we have taken a group of 30 participants. How sure are you if I don't take other 30 participants, it will be less than $100? Are you sure? That no, it will always be greater than 100. Are you sure? No, right? We are not sure. So don't we need to check for less than $100 also and greater than $100 also? Does that make sense, my people? Does it logically make sense to validate both the cases? Has it increased? Has it decreased? If it is increased, can I call the salary has changed logically? Logically speaking, if it is changed, I can call it changed, right? If it is greater, I can call it changed. But if it is equal, it is not changed. Agree? We wrote hypothesis as step number 1. Step number 1 was writing hypothesis, right? Step number 2. In step number 2, you write something called significance value. Significance value is called as alpha. What do we call significance value as, my people? Significance value will be called as alpha. In significance value, we'll take alpha. Sir, in alternate, can we not take 140? Why not equal to 100? So, do you remember I told you that $140 is not our question. Our question is, has the population remained the same or has it not remained the same? So if it is up to $100, we say that that is the null hypothesis, that we prove that null is still 100. We say it is not equal to 100 because in this condition, $140 is clearly greater than 100. But are you sure when you are testing for the entire population, are you sure that some people have not gotten less than 100 also? So we don't check for $140. We see, because the question is, has the salary changed or increased? Has the salary changed? Correct? Not increased. If it was increased, then we would have mentioned in the alternate hypothesis greater than 100. Correct? If the question was, has the salary increased from the $100? If the question is increased, then I would have said the alternate hypothesis is mu is greater than 100. Okay? Fine. I hope you understood now. I hope it is clear now. Step number 2 is called significance value, called alpha. My people, significance value is called alpha. Okay? Significance value. To calculate significance value, you take 100% minus confidence interval. 100% minus, what is the confidence interval, my people? In the given question that we have, 95%. So automatically my alpha became how many percent or what percent? Did this make sense to you? Did you understand this part of the code? Significance value. If I look at it from a normal distribution perspective, this is my normal distribution. The entire graph, the whole normal distribution graph, can I consider this is the 100% of the graph? The entire graph can be considered 100%. My significance value alpha, my significance level alpha means it is totally how many percent, my people? 5%. Correct or not? It is 5%. This is totally 5%. Okay. Calculating for both lesser than 100 and greater than 100, in technical terms, we call this how many tailed test? This is called two-tailed t-test. Understand? When you calculate for both lesser than 100 and greater than 100 in the condition of this is called two-tailed t-test. My people, my alpha is how much percent currently? What's the total percentage of my alpha? 5. If I do two-tailed t-test, I will divide my alpha in two different tails. One in the left tail, other in the right tail. So how much percentage will be my left tail? 2.5%. And how much will be in the left tail? 2.5%. Together, my left tail and my right tail will be 5%. But because we are doing two tail, My significance level should be divided in two different parts. Are we clear? For people who don't know what is tail, I want you to just let it be right now like this, okay? Don't worry about it. You will understand this in a while. Whenever you calculate alpha, listen to me very carefully. Whenever you are calculating alpha and you are doing two-tailed t-test, your alpha will be divided in how many parts? Two different parts. In inferential statistics and in any statistics, you only do either one tail test or two tail test. There is no eight tail test, because in a normal distribution, how many tail do you have? Maximum tails? How many maximum tails do you have in a normal distribution? Only two. So the maximum you can do is only two tail test. Okay? Understand this. Either you can do one tail test or two tail test. Because this is a clear example of two tail test, your alpha is divided, one in the right tail, other in the left tail. If you do one tail test, you either do one tail to the right or one tail to the left. Any of this condition is okay. When you do one tail test, you need to specify, is it a right tail or left tail, and your job is done. How do you know when we do which tail? With over a certain experience, you will get it. Let me solve couple of more problems with which you will understand when to do one tail, when to do two tail. Okay, because this is a very first example. I will not be able to show you many versatile examples with which you will understand, is it one tail or two tail. So allow me to complete this example, and then maybe when I take the next example, I'll take it one tail. You calculated you calculated the hypothesis in first step, or you made your hypothesis in step 1. In step 2, you created significance value. In step number 3, you calculate something called degree or degrees of freedom. My people, the formula of degrees of freedom is very, very simple. DF, degree of freedom, is equal to sample size minus 1. What is your sample size? 30 people minus 1. So what is the degree of freedom that you're supposed to have? What is your degree of freedom? 29. You calculated degree of freedom also. Step number 4, decision boundary. Decision boundary. Sir, what do you mean by decision boundary? Very simple. Very, very simple. Is this my normally distribution data, or is my normally distributed data for all the 30 people that I have taken? All the 30 chefs that I have taken in 2023, this is the normally distribution data of them. I told you one thing. When you plot confidence interval, don't you plot a upper bound and a lower bound, my people? Do you plot an upper bound and a lower bound whenever you're doing a calculation like that? Yes or no? If this is my normal distribution and I want my answer to be 95% confident, don't I need to plot a lower bound here and an upper bound here? I need to calculate the lower bound for the data. Yes or no? I need to calculate my lower bound value and my upper bound value, correct? I need to calculate this. Very good. Okay. To calculate the lower bound value and upper bound value for 95% confidence interval, you have to go to which table? You have to go to which table, my people? You have to go to tea table. Which table? Tea table. Okay, not the drinking tea. That is a different kind of tea. This is a different kind of tea. Let me take it again. Give me 1 second. Wrong. The first question I'm asking is, are you doing a one-tail test or a two-tail test? Please tell that. Are you doing a one-tail test or a two-tail test? Are we not doing two-tail test? So which column will you select? Which row will you select? The bottom row. T table is different from Z table. It's completely different. T table and Z table we are doing two-tail test. So I have written two-tail here. My people, your two-tail combined together, one tail plus one tail, together two-tail combined, how many percentage do you get? Where is 5%? 0.05. Agree? 5% in fraction form is 0.05. For people you don't know, your 5% can be written 5 divided by 100. So you will get 0.05. That's why we got 0.05. In the bottom of the columns, in the left part, do you see this thing called degree of freedom here? Degree of freedom here, the one where I'm circling. Yeah. What is the degree of freedom? What is my degree of freedom? 29. Is 29 here, my people? Yes. If I scroll down, down, down and go down, right? And if I scroll through the column, do I reach a number called 2.045? Do I reach up a number called 2.045? According to the T table, okay, I'm going to zoom this a little bit more. 100. According to the t table, we got a value from the t table, correct? Are you all listening to me? Whenever you calculate a value from the table, be it t table, z table, f table, any table, whenever you calculate the value from a table, the name for that number is called critical value. What do we call this? What do we call this number? Critical value. Because you are doing t-test and you're calculating the value from the table, this is called t-critical. I'm going to call this number as what, people? I'm going to call this number as t-critical. Okay. So the t-critical value that I calculated from the table is how much, my people? 2.045. Because normal distribution is a symmetrical graph, your upper bound will be plus 2.045 and your negative will be minus 2.045. Did you understand? Your upper bound value became plus 2.045 and your lower bound value became negative 2.045. Did you understand? Whenever you calculate a value from the table, give me 1 second. I'm going to show you guys a magic. Listen to me. Whenever you calculate a value from the table, that value is called as critical value. I've written it in your code file. Every time you go for a table, every time you go to the table, you calculate the value, it becomes critical value. We calculated something called t-test, hence the value is called t-critical. Because you are calculating the confidence interval, the interval within which the population's parameter will lie, and because the normal distribution is what kind of curve? It's a symmetrical curve. Agree or disagree? Whatever is on the right, just put a negative sign, will come to the left. Did that make sense? Whatever you have a number here, because it is symmetrical, you just fold it. This will become a positive number, this will be a negative number, and this is your confidence interval range. Are we clear? Did everybody learn how to look at the table value? Did you guys learn how to read the table value? Did you all learn how to read the table value? Here is the decision boundary. The last and the most important step is calculating t statistic. Listen to me very carefully. My people, just because I'm calculating t critical value, doesn't it mean I have not implemented t-test yet? Because there is no formula that I've implemented. Sir, one silly question. If t-test can have max 30 sample, then why table have value? Not silly. Very good question. Listen to me very carefully and try to understand this. I told you that a t-test can have a maximum of 30 sample. Whenever you use a t-test, your sample size cannot be more than 30. But do you see here, you are allowed to calculate for a sample size up to 40, 60, 80, 100, 1000, meaning your original data must be 1001. So you did -1, so you got 1000. But meaning you had taken a data which was 1000. Does that make sense? You will not hate me if I give you this answer, okay? In t-test, you are allowed to take a sample size greater than 30 also. But you are only allowed to do that in special conditions. Are you clear? I will teach you the special conditions. I will teach you what these special conditions are. But remember, under special conditions, you are allowed to take sample size more than 30. Are we clear? Only when the special condition occurs. If the special condition does not occur, sample size cannot be more than 30. Are we clear? Are we clear? It's like this. I'll give you guys an example. My people, if you have, how do I say this? Imagine your friend has bought the most expensive supercar and he or she is your best friend and your friend is not around and the key is with you. You understand what I'm trying to say? That is a special condition, right? Because if you ask your friend, he or she will not let you drive the car. But because there are special conditions, you will be able to drive the car or you will drive the car. You understand what I'm trying to say? There are some special condition when your friend is not around, and in that special condition, you have the key of the car also with you. So you understand what I'm trying to say, right? Both the conditions are very, very special. It does not happen very often, but you are lucky that this condition exists, right? So just like that, if a t-test has to be implemented, okay, you have to have a special condition. Only then you are allowed to take a sample size greater than 30. Are we clear? Okay. So coming to t-statistic.
Wrong.
My people, this is a very important step and I want you to write this down. T is equal to, I am teaching you the formula. Sir, how
Wrong.
did you find out 2.045? See, this is
Wrong.
the T table, correct? This is my T table. Because I am doing a two-tailed test, I am
Wrong.
doing two-tailed test. In two-tailed test, both the tail combined are 5%. See, my alpha value is 5%, correct? My alpha is 5, and because I'm doing two-tail, hence I'm going to only select 5, okay? I'm going to select 5%, okay? This is my 5%. Here, the degree of freedom that I calculated was 29. Okay, the sample size minus 1 is 29. So you will see I have taken 29 here also. So what I did is, when you go down on this column, go down, scroll, and if you take this column, row, you get a number called 2.045. Now, Jaggesh, you have to be very careful. The number will be positive, but because you know in a normal distribution, the data is symmetric. So what will you do? 2.045 on the right tail part and minus 2.045 on the left tail part. That's how I got 2.045. I hope you're clear. I hope the concept became clear. This is how I calculated 2.045. But it character is showing. Okay, here it is. This
Wrong.
is the table right here. Right here. This is the table. Yes, sir. This is the T. This is called T table. This is not called a chart. This is called T table. If you just type on internet, just type T table. Just type T table. Any first link you click on it, it will open. Okay. Okay. Are you clear now? After this class, you will never see this table again. I will tell you with 100% confidence. Can I go back to T statistic? How to do T statistic? Whatever I'm writing right now is the formula for T. Okay, to calculate T test, this is the formula. T underscore statistic is equal to x bar minus mu divided by s divided by root of n. Sir, what is this? This is the formula based on what T test is built. This is the formula of T test. T test formula. This is the T test formula. Based on this is what we are going to be doing T test. Okay. Whenever you implement a formula or any formula, that number or that variable should be called as statistic. Are we clear? Whenever we calculate the value from the table, we call it T critical. When you do that using the formula, you should call it statistic, T statistic. Okay. Now, if I calculate T statistic formula, what is the value of X bar, my people? $140 minus $100 divided by standard deviation is 20 divided by root of 30. If you solve this thing, which I will have to solve in a code, but I don't know. What is the same formula for all t-test type? No. For one sample t-test, the formula is different. I would have actually taught you after this class, but yeah, it's different for different it's different. For one sample t-test, this is the formula. Is 10.95 the answer for this? So the t-statistic formula is how much, my people? 10.95. This is the t-statistic answer. Okay? Okay. This 10.95, my people, this 10.95, does it come on this number line of this normal distribution? Can I say 10.95 comes somewhere here? If my number starts minus 2.045, minus 1, 0, 1, 2, 3, 4, in the number line like this, does my value 10.95 come somewhere outside the boundary? Can I say that the number is coming outside the boundary of upper bound and beyond this range of this boundary called upper bound? Whenever a number comes outside the boundary, we call this number as a rejection region. Actually, we call the region as rejection region, and a number that comes within the boundary is called as acceptance region. If the number was 1.16, is 1.16 between minus 2.045 and plus 2.045, yes or no? Then the answer would have been accepted. But the number that we got is 10.95. Because it is outside the boundary, we do what with our null hypothesis? We reject our null hypothesis. Because the number of t statistic value is outside the boundary, we call this reject null hypothesis, meaning statistically proven that what is the null hypothesis, my people? That the salary of people is $100. This is proven to be rejected. What is the true condition? The condition is that the salary or the boundary is no longer 100, that the salary of people is no longer 100. No longer 100 because it does not fall in the range of LB and UB, no longer 100. Let me repeat the whole thing. The salary is no longer $100 or it has changed from $100. We are not calculating whether has it increased or decreased, correct or not? We are not telling with statistical significance that the salary has definitely increased. We say it is changed. It's no longer 100. Could be greater, could be lesser. Did everybody understand what I'm trying to say? Can I please write a... Okay, here's what we will do. My people, listen to me very carefully. I taught you an example mathematically. Can I teach you the code of it? And then I will teach you the whole mathematics once again and code once again to show you guys the difference. What will happen is the same exact problem statement. I know I have done the mathematics of it and I know not everybody got it 100%. I get it. But can I write a code for this? And then I'm going to come and teach you the math part once again. And I'm very sure you guys will understand what I'm trying to say. Okay. I want to show you guys some amazing stuff. So what I'm going to do now is let's take a code part of it. What is the time right now? 8:51. I will not have enough time. Okay. Let me write it for... Okay, let's not rush into things. Let me finish the code. My people, will you wait for 2 extra minutes if I write down the code? It's not a very complicated code. Like if you really ask me, it's not a very complicated code. It's very, very simple. It's just that I will be able to make you guys understand things much more detailed. So that by the time next week happens, you guys don't miss out on this and you will have at least something to practice. Cool? Okay. If you want to implement stats, import scipy dot stats. Okay, from scipy dot stats, what test are you doing, my people? What test are you doing? T. So import T. That's it. From scipy dot stats, import T. Import NumPy as NP. Simple, done. I've imported 2 important libraries. Now, my people, let's take down the data. Okay, let's take the data. DATA, data. DATA, data. The data says, what is my population mean, my people? What is the population mean? Isn't it $140? What is my sample mean? Isn't it $100? Oh, sorry, 140 is sample and population is 100, correct? Yeah, I think I must have reversed it. Yeah, is this correct? Okay, good. What is the sample size? Sample size is equal to 30 people. And hold on, I will also copy this question so that you guys don't worry about it. Give me 1 second. Copy this, go to the bottom and paste it. So this is the question for which this is the answer, okay? So that you guys are able to practice it well. The standard deviation is $20 and the confidence interval is 95%. So we'll take significance value alpha directly. Alpha is equal to 0.05, okay? Is this my data, yes or no? Okay. In the entire example that I showed you, do you remember the t-statistics formula? The t-statistics formula is sample mean minus population mean divided by standard deviation divided by root of sample size. This is the formula. Let's write down t-statistic formula, t-stat, okay? T underscore stat equals to sample mean minus population mean divided by, so you can divide it by standard deviation divided by, standard deviation. Let's take a bracket so that we don't miss out on this. Let's take a bracket here. Divided by NP dot square root of sample size N. So if I print F double quotes of T statistic is what? T statistics. So my people, what answer did we get in our example, in our code example, in our math example? What was the value of T stat that we got? What is the answer that we got? 10.95. If I run this, what answer did we get? 10.95. Did we get the answer 10.95? I can even control this 0.3f, 0.2f. Okay, yeah, 10.95. Now do I have the answer? Is this the t-statistic value? Yes or no? Once we calculated t-statistics value, did we also calculate the degree of freedom? The degrees of freedom is equal to sample size n minus 1. And if I print degrees of freedom, f double quotes of degrees of freedom, colon bracket degrees of freedom. What is the degree of freedom, my people? N minus 1. What do we need to calculate? T critical value, T critical value, correct or not? The one that we took from the table, the one that we just took from the table, the critical value. So T underscore critical is equal to, remember this and never forget this. Remember this and never forget this. Whenever you want to calculate the value of the table, T table, Z table, F table, whatever table value you want to do, the name of the method will be .ppf. The full form of .ppf is called percent point function. What do we call this? It's called percent point function. Whenever you want to calculate the value of the table without looking at the table, you have to do t.ppf. This is the value. To calculate critical value, here is what you have to do. 1 minus alpha divided by 2, comma, degrees of freedom. I'll tell you why do we need to do this, okay? Print critical value, T critical. I'm going to copy this. I'm going to F double quote, paste this here, this T critical value. Did I get the answer called 2.045? Yes or no? Is this the T critical value that I had? 2.045? This is upper bound or lower bound? Which bound is this? Is this upper bound or lower bound? If I want to calculate lower bound, remove this 1 minus. Yes, Shubhadeep, I'll come to the code. Remove this 1 minus, you will get minus 2.045. Point number 1. If you want to calculate T critical, F critical, Z critical, any table value, what is the name of the method? T.ppf or PPF. Are we clear? In inferential statistics, you will be dealing with 3 functions in your lifetime. The first function is called PPF function. What do we call this function as? Percent point function. The second function you will deal with is called SF, survival function. One is PPF, the other is called SF. Can we plot graph with label for this? Don't need it. It's an unnecessary stuff. Then the third function is called CDF, percent point function, survival function, cumulative distribution function or density function. This is the third function. To calculate the value of your table value or critical value, the only method in the entire code that will help you calculate the critical value in the entire statistics is PPF function. If you want to calculate P value, you calculate it either using SF or CDF. Are we clear? This distribution function and survival function is used to calculate something called P value, which I will teach you after some classes. But remember, are we using something called PPF function here? Okay. My people, are we doing one tail test or two tail test? Are we doing one tail test or two tail test? So shouldn't alpha be divided by 2? Should not alpha be divided by 2? So to calculate critical value, did you not pass in the table how many tail are you doing, one tail or two tail? Did you not pass this information to C in the table? First you checked whether it is one tail or two tail. So shouldn't we pass alpha by 2 because we are saying it is two tail? And also we checked for degrees of freedom in the bottom. So have I not passed degrees of freedom here? When I pass both the tail information and degree of freedom, won't it give me the table value? Yes? No? Maybe? Not maybe? Got it? Not got it? You guys need to give me that idea. Did we get it so far until this part of the code? Did you understand? Did you understand this part of it? Very good. What is the value of alpha? 0.05. Alpha divided by 2 is 0.025. That is exactly what we have passed. 1 minus alpha divided by 2 will give you plus, which is 2.045. This is the upper bound. And if you remove 1 minus, this is minus 2.045, which is a lower bound. Are we clear until here? Where is T defined? From scipy.stats import T. So T is my alias. 0.05 by 2 and degree of freedom. How do we have to multiply? What do we have to multiply? You don't have to do anything. This is a method. You don't have to do anything, sir. The way I'm teaching you is, or the way you are supposed to learn this is, you are not supposed to do anything. You have a function. You are just supposed to pass whether are you doing one tail test or two tail test. Okay, I'm going to ask you a question. If this was a one tail test and not a two tail test, should I have done alpha by 2? Should I have done alpha by 2? No. For one tail test, isn't my answer coming up to 1.699? Makes sense. If for some reason I was doing a one tail test, just pass alpha directly. But if you're doing two tail test, you have to do alpha by 2. I've already told you the theory behind this. Does that make sense? Does this make sense? Is this the drive that I have shared with you, my people? Is this the drive that I had shared with you? Agree? Okay, hold on. I'm going to upload the code file for you first of all. This is keep both the files. Give me 1 second. I'm going to upload the file so that I don't forget anything. Degrees of freedom. Okay. What seems to be the problem here? Degrees of freedom. Okay. Okay. Yeah. 0.05. So yeah, I hope you guys are able to see the code file also on the drive. Please confirm if you guys are able to see the code file on the drive. How this is used in corporate. Sir, पहले ही question में corporate का सीख रहे हो. We'll come to that. Hold on. Notes PDF here, please. You guys want to learn so many things so fast. It is amazing. I like it. I really love the fact that you guys want to learn so many things faster. But patiently, we will learn it. Don't worry. I will teach you where do we use this in corporate, how as a data scientist this is important for you, why will you need to learn all of this. So don't worry. We'll teach you everything. Okay, step by step. We'll go step by step. Can someone share the drive link here? Can someone please share the drive link to Murchana Sarma? Very important student. Give me 1 second. I will have to cover this. I hope I have covered all the parts. Yeah, all the parts I've covered. Left, right, left, bottom. But here also it's not 0.05, dear. This 0.05 is telling you that this is a two-tailed combined 0.05. But the values that are mentioned in the bottom are for 0.025. So don't think of it like this. Think of it like this. One tail and two tail combined are 0.05, right? But logically speaking, if two tail combination is 0.05, then it must mean that if I'm passing alpha by 2, it's written 0.05 here because this is just a label, but the values in the table are also 0.025. It's by default 0.025, but because it will be hard to write like that, they have given one combined label. If my confidence interval was 90%, example, okay, both my tails combined is 10% alpha, correct? But each tail is 5%. So you have to pass each tail here, not combined 10%. Each tail 5%, 5%. That's it. And you'll get the answer here. It was raised by mistake. Koi baat nahi, Siddhant. No issues. Chalo, take care.
Our ninth quiz question is, what does data cleaning involve? So option 1, removing or correcting errors in data. Option 2 is adding more data to the data set. Option 3 is visualizing the data. Option 4 is analyzing data patterns. So drop down your answers in the comment, guys.
Just a quick info, guys. Intellipaat offers data analytics course in collaboration with IIT and Pandas. Through this course, you will master Power BI, data modeling, data mining, and much more from the IIT Madras faculty and industry expert. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to a new height. So visit the course page link given in the description and take the first step towards the career in the field of data analytics.
And everyone, good morning. You do remember that whenever we read the value from the table, that value is called critical value. Do you all agree with this statement? Do you all agree with this statement that whenever you look at a value from a specific table, it becomes a T critical value or a critical value? In the example problem that I am solving right now, we calculated both the T statistic value and the critical value. It's not very old now, my people. It is very, very important to tell you the beauty of inferential statistics and how you can take advantage of all of this. Let me tell you how. In the manual problem that you solved or the mathematical example problem that we've solved together, to calculate whether we reject the null hypothesis or accept the null hypothesis, which two values are important for me to decide, do I need to accept the hypothesis or reject the hypothesis? It is T critical value, which is called T critical value, and underscore T statistic. Based on T critical value and T statistics value, we decide whether we accept the null hypothesis or reject the null hypothesis. But guess what? Whenever you start to code the solution up, or whenever you're doing programming of the solution, or whenever from now on in the future, whenever you're going to actually code the solution up, you don't use T critical and T statistic. You use a value called P value, and you use something called alpha. I have already told you what is alpha. Alpha is also called significance level or significance value, right? Significance level or significance value. We've calculated this using the confidence interval. Remember, if the confidence interval is equal to 95%, your alpha is equal to 100% minus 95%, which is 5%. So in the coding solution, you don't use T critical or T statistic. This is only used when you solve a manual problem. But there is a better way to get an answer, and that is P value and alpha. The guarantee is whatever answer you will get in the manual answer, the same exact answer you will get in the coding solution also. And then, my people, in this class, I will tell you what exactly this P value is. What is this big mystery around P value? Why is this important? And remember, my people, as data scientists, P value is a very critical information or a topic. This is important. No problem. Perfect. So, my people, I have told you the distinction between solving a problem manually and solving a problem code wise. What do you know? When you solve a problem mathematically, you will be using something called T critical and T statistic. But whenever you will solve the problem in the code level or with code, you will not use T critical or T statistic. You will use P value and alpha. Now, let's just test it out, sir. What did we do? Okay. First of all, did we calculate the T statistics value? Yes or no? Here, agree or disagree? Have we calculated it? Agree, yes or no? We have calculated it. Do we have the value of alpha? We have the value of alpha. Do we have the value of degree of freedom? We have it. We also have T critical. But do we need T critical and T statistics in the coding example based on what I just taught you guys right now? No. In the programming exercise, you don't need T statistics and T critical. So what do we need, sir? What is that we need? We need to calculate something called P value. Now, everybody, do you remember I told you that whenever you calculate the T critical value, the name of the method is called .ppf. It's called percent point function. Do you remember in the last class I had discussed this? Whenever you calculate any statistical test in the world, if you want to calculate its critical value, you have to use percent point functions. Let's not forget it. Let's never forget it. Okay. So the way to calculate P value, my people, and what exactly is P value? I'll tell you, don't worry. We are not going to skip on that topic. It's an important topic and I will teach you this. But in case if you want to calculate P value, you have a function. Actually, there are two ways to calculate this, but I'm going to teach you using the .cdf method. So what you do is you take 2 multiplied by, take a parenthesis bracket, 1 minus t.cdf. Whenever you have to calculate P value, the name of the method is going to be CDF, cumulative distribution function. Okay. T1 minus t.cdf, and you close the bracket, and inside this bracket you're supposed to pass 2 information. One of the information is actually the T statistics value that you have calculated. So I'm going to uncomment it out. Before you pass this, you pass something called abs. If you don't know what abs is, it's a mathematical function to convert anything negative into positive. It's called absolute value. If you take a negative 4, abs will convert that into positive 4. If you take abs of 4, the answer will still be 4. So any negative number will be converted into positive number. So when you have to calculate P value, actually there are ways to calculate P value, but 2 multiplied by 1 minus t.cdf abs of, you pass the T statistics value here, which is the T stat value. Once you've passed the T stat value, you come here and you pass the degrees of freedom. Now, if I go ahead and copy this particular thing, and if I go ahead and also paste this here, okay, let me just copy P value here, paste it here, and also take up the degrees of freedom from here and paste it up here. Do we have the P value printed, my people? 8.02 into 10 to the power of minus 12. Yes or no? Do we have p-value printed? Yes, we have p-value printed. Now, the line of code that I'm going to write right now will remain the same in all the tests. Okay, this line of code is universal. What do I mean by universal? Any statistical test you want to do in your life, including data science, machine learning, inferential statistics, or statistics in general, this will remain same. If your alpha, alpha, is less than p-value, or your p-value, let's always take it like this. If your p-value, right, is less than alpha, okay, you get an answer called, you print directly without any hesitation, we reject the null hypothesis. Okay, else you come down in the else condition, you go ahead and you print something called accept or fail to reject. Okay, so accept, or the best way or the technical way is fail to reject, fail to reject null hypothesis. What answer did we get in class when we solved the problem manually, my people? We got the answer as reject null hypothesis. Do you remember? What is the answer here? What print statement are we getting? Reject null hypothesis. We got the same exact answer that we did manually. Now, I know you guys have a lot of questions, and don't worry, I will figure it out for them. The biggest question that is going on in your brain is, what is this new thing called p-value? Isn't it? Aren't you a little curious what is this p-value and how is it able to replace t statistics and t critical? Is there anybody in this class who's thinking in that term? What is this p-value and how is it doing this magic of converting everything back into, and it's giving us the right answer? Okay, it's not like the answers are not correct. The way it is handling, the way it is working, it is giving us the right answer. But how exactly it is doing it, now let's try to understand this. Now my people, remember one thing, p-value is a very, very important topic, so you cannot miss this. My people, I'm going to explain it to you in a more easier sense. Okay, so try and have a focus on this. Let's say, for example, I take a population of, okay, I'm going to take a population of, I'm just going to draw a circle, sorry, not a circle, a rectangle, a population of all Indian policemen, okay, all Indian policemen. My people, if I take a population of all Indian policemen, I'm assuming I'm counting lakhs and lakhs of police force available in India, right? If I assume that these are, or this is the population of all Indian policemen, right? They must have some minimum height value and some maximum height value. They must, all the Indian policemen, if I take them, or if I rank them according to the height, there must be some minimum value of height, some maximum value of height. Let's assume that the minimum value of height is about 160 centimeters, right? And the maximum value of height is 190 centimeters, okay? The minimum height for you to become a policeman according to the legal requirements is say 160 centimeters, and the maximum can be anything. Okay, let's not cap anything at maximum. Suppose this is my population. My question to you is very simple. Listen to me and try to understand what I'm trying to tell you. Okay, I know it's the morning time, I know you all have just woken up. Drink a glass of water, everything will start making sense. In this entire population, let's take one random sample. What do you mean by random sample? You close your eyes and select 5-6 people from this entire population. Suppose you took a group of random sample like this. This is person number 1, this is person number 2, this is person number 3, and this is person number 4. This is the first sample I took from the original population. Can I do this, my people? Is this allowed for me to do? Am I allowed to do this? Absolutely correct. Whenever I take a sample and whenever I calculate the mean height, can I say the mean height is somewhere close to maybe 170 centimeter? The sample 1, whenever I took sample 1, the mean height of sample 1 was 170 centimeter. Can I assume this is true? It is possible. Very nice. When I take another random sample, okay, this is sample number 1. If I take another random sample, say random sample number 2, I took this person, this person, this person, this person, and this person. And whenever I took sample number 2, my people, isn't there a chance that whenever I take sample number 2, the mean height could be maybe 165 centimeter? So from the original sample 1 to sample 2, the difference between the heights is 5 centimeter. the difference of their average height is 5 centimeter difference, correct? The difference comes up to 5 centimeter, correct? Okay, good. Very nice, my people. Now stick to the topic. If I take another random sample, sample number 3, can I say that height of sample number 3 could be different from sample number 1 and sample number 2? It also could be different. It would be a different value, maybe 3 centimeter higher, but 2 centimeter lesser. Maybe if I take sample number 3, it is 3 centimeter higher to this, but 2 centimeter lower to this, or maybe 1 centimeter lower to this. Chances that like this can happen. Now, if I keep taking random samples again and again and again and again, multiple times, I take 10,000 random samples. My people, will you start seeing a certain range like beyond this particular centimeter of height, and below this centimeter of height, the height is not decreasing only and the height is not increasing only? Agree or disagree? After taking multiple samples, you start seeing a range beyond which your average height is not going to jump. You take how many samples after that you want, the range will remain same. After taking multiple samples, this range will become better and better. It's going to get more fixed, rigid. Beyond this, your height does not seem to increase or decrease. It no matter how many samples you take, your average height or the sample's height is somewhere inside only, inside this range only. Do you think you will start seeing this pattern? Make sense? But by mistake or by random chance, is it not possible that by default you can take all the tallest people? Randomly you chose them randomly only, but by randomness you decided to choose all four the tallest of the tall people. By random behavior, you chose to pick up the top 4 tallest of the tall people in the entire thing. Isn't there a slight probability that this average height or the range of the height, some sample exists in the data where the average height could be beyond this range or average height could be below this range? Does that make sense? Okay. Isn't there a slight chance that there exists some kind of data or some data points in my entire data that no matter how many random sampling I do, there exists a very slight chance that beyond the range also there is some data point where the average height goes beyond this also, below this also. So if I say P underscore value is 3%, okay, try to understand, my people. If the P value is equal to 3%, it means that in the given population, the chances of probability or the probability that when your range is decided, the chances that you get an extreme data whose mean is beyond this range or below this range is 3%. Makes some sense? I will repeat myself, don't worry. I will repeat it once again. Did you understand the topic, first of all? At least 5% of the knowledge did it go inside. I will repeat it, don't worry. I will repeat it once again. I just want to take a quick poll from everybody. A little you are able to understand, correct? A slight understanding you're getting, right? A little kind of certain understanding you're getting. Okay, I'll repeat myself again, yeah? Let's repeat the whole thing once again so that you guys are super clear this time. Cool? Let's repeat the whole thing. Okay. So my people, I started with the population of all Indian policemen. Can I assume in India close to 13 lakh police force exist? Let's assume a number. Across India, we have Indian policemen, okay? And I'm only including men because it's easier. For example, I'm not discriminating against women. There are 13 lakh police force, okay? If I take the population of all Indian policemen and rank them according to their height, the logical thing is there will be some minimum height of 160 centimeter below which we don't hire for policemen, and there must be some maximum height also, right? Because at the end of the day, height is also a finite number, correct? Height cannot be 80 feet person, 90 feet person. We don't have that capability anymore. Agree? So height will be some number. Minimum height will be some number, maximum height will be some number. Agree? We are ranking all the policemen based on their height. Yes or no? 160 centimeter, 170 centimeter, 180 centimeter, 190 centimeter, and all of that. Basically, this is how I am basically trying to tell you. This is their rank according to their height. This blue bar is my population, correct? The entire population of all Indian policemen. It's not my sample. Agree? Very nice. Perfect. Very good. Very good. Very good. If I take sample number 1, Random sample. Okay, I close my eyes and I point out to these policemen saying that, okay, you come, you come, you come, you come, and you come. Random sampling from these policemen. Say I took 100 random samples or 1,000 random samples. That number is not the problem. Some random samples you have taken. When you measure the average height of those people, when you take all the people's height and take the height, add the number up, divided by the total number you have taken of people, you will get some average height of the sample, right? This sample of 4 people, the average height of these 4 people is about 1 centimeter, 170 centimeter. Agree? Does that make sense? If I take sample number 2, random sample number 2, is it possible that I might get the same exact answer that I got in sample number 1? Is it necessary that whenever I take sample number 2, which is completely random, I will get the same average height of the people? No, this is not possible, correct? There is a possibility for that also, but it is not very high possibility. If I take sample number 2, this time maybe the random people I chose, their heights were lesser, so the average height of sample number 2 was 165 centimeter and average sample of this is 170 centimeter. Agree or disagree? Make sense? Yeah, okay. If you keep repeating this exercise for 10,000 samples, for first 2 sample, the range of the height that you got was 170 centimeter and 165 centimeter. This was the range you got in the first 2 samples. Agree? But when you start taking 10,000 samples and more samples, you will get like a range which is this much is the maximum height, this much is the minimum height. Agree or disagree? You will get a range, a certain range that this is 172 centimeters and this is 158 centimeters. After 10,000 samples, you got a certain range, 172 centimeter and 158 centimeter. After which, no matter how many times random samples I'm taking, all the average weight is coming between this range only. It's not giving me any nice answer. It's not giving me any answer or average value beyond 172 or below 158. It's not giving me that number. No matter how many times I take the sample, the sample's average seems to be between this range only. You will start seeing this pattern. Agree or disagree? If you don't know, the answer is yes, you will start seeing this pattern. The problem is, even though you will start seeing a range, isn't there a slight probability or a small probability that by mistake, by random mistake, you chose all the top 4 tallest people in the entire population? When you do this, isn't there a chance that the range or the average height of the person will be guaranteed to be beyond this range and below this range? Maybe if you select the most shortest people in the group, the range of the average height will be shorter than this range, beyond this range. If you take the tallest people, if you take the shortest people average will be lesser than this range that you have identified. Yes or no? Makes sense? First of all, p-value. Sir, what is p-value of 3% indicate? First of all, understand one thing. The full form of p-value is probability value. What is the full form of p-value, everybody? Probability value. P-value's full form is probability value. So when you say probability of 3% exists or a p-value of 3% exists, what are you saying? Whenever you have created a range, getting one more data point or getting some data point whose average will be beyond this range or below this range is only 3%. The chances you will get some data point whose average value will be beyond this range that you have identified or below this range that you have identified will be 3%. Only 3% chance that in random chance this may occur. In random chance or random problem, this problem might occur. Did you understand? Did you get what I'm trying to say? Does it not look very similar to a normal distribution, my people? The farther you go, the chances of seeing this data becomes lesser and lesser. Does that make sense? The farther you go away from the distribution, the chances of you seeing that data becomes lower and lower. That means they are more extreme values. Agree or disagree, my people? That the observations that are on the right hand tail part of the distribution and left tail part of the distributions, aren't they extreme values, my people? In the example of policeman example, when you plot the normal distribution of policeman example, extremely tall people will be found in which tail, my people? Extremely tall people will be in which range? Right or left tail? Extremely tall people will be in the right tail. Agree or disagree? Is the number of the people going to be lesser according to the rule of normal distribution? Make sense? The shortest of the short people will be towards the left hand side, my people. Most people will be in the middle. The range also decides, the most people also fall in this range. It's the extreme cases we are measuring. Yes. So p value is a probability value that tells you the extremities within your data. Does that make sense? Did you understand? Now understand the game, my people. Now you will understand the entire game. In the normal distribution, how do you decide whether you want to reject the null hypothesis or accept the null hypothesis? Whenever you draw a normal distribution, the first thing you draw is the boundary, correct? Upper bound and lower bound of the confidence interval, upper bound and the lower bound of the confidence interval. This value we calculate from the table T critical. From the T critical value, we calculate this value called minus 2 point something something and plus 2 point something something and minus 2 point something something. Agree? Isn't p value telling me the extremities within this tail and left tail? So rather than taking T critical, we take a p value. To replace T critical value, we have something called p value, which gives me the same information. So in the code, we did not take the critical value, but we took the p value. And alpha is because, tell me one thing, if my confidence interval is 95% and my confidence interval is 99%, I want you to please put some pressure on your brain and tell me the answer. If the confidence interval is 95% and confidence interval is 99%, which test among test number 1 and test number 2 is more strict? Which test is more stricter? Number 1 or number 2? Number 2 meaning the confidence I want in my answer, the confidence I want in predicting my population parameters like its mean, variance, standard deviation is 99%. So the chances of error are only 1%. Agree? The chances that I may be wrong is only 1%. So tell me one thing, aren't we comparing p value, which is nothing but T critical value, with the chances of error, which is nothing but alpha? So when we compare p underscore value less than alpha, we are basically testing for all possibilities to cover within that question. Whether to accept the hypothesis or reject the hypothesis, we are covering all the extremities. And alpha comes directly from nothing but confidence interval. So they are related to each other. Does that make sense? Did you understand, my people?
Our goal.
Did you get the concept? Yes or no? I want to hear it from all of you. Did you understand what I'm trying to tell you, my people? If you are solving a problem manually, which two statements will you take? Whenever you're trying to solve the problem manually, you solve with two things, right? T underscore critical value and T underscore statistics value. Agree or disagree when you solve it manually? We do this. When we solve in the actual programming part, we take P value and we take alpha value. Correct or not? These two things and these two things are different according to us for now, according to our understanding. I'm going to repeat this once again. Okay. It's not very easy for you to understand in the beginning, but it will start making a little bit more sense eventually over a period of time. It's like I am trying to teach you a bike. Maybe the first day it may not make sense to you, but it will make sense to you eventually. Listen to me very carefully. In the entire normal distribution, okay, first of all, let's take it slowly. Is this a normal distribution? Will everybody agree this is a normal distribution? Everybody will agree. Okay. A confidence interval of 95% means what? What does it mean? A confidence interval of 95% means, depending on the sample you will give me, depending on the sample data you will give me, I will judge in my population. What is my population mean? Me judging that the population mean, population variance, population standard deviation, anything called population parameter, I am 95% sure that the population mean or anything lies between a certain range. Isn't that what confidence interval means? That is what confidence interval means, right, my people? We have done the example of a protein powder eating example where we got the 108 grams to 122 grams, you are saying that I am 95% confident that if you take all the population of all protein powders consumers, the population mean will be between these numbers. I am very, very sure, 95% sure. So my question to you is, if a given problem tells you the confidence interval is 95%, doesn't that mean alpha value equals to 5%? Agree or disagree? This much will you agree? So alpha is representing what to you? Alpha is representing the chances of error you are taking, right? The chances that you will go wrong in the problem. That's what the chances are, correct? The chances you may not be able to get the answer correct, or the chances that I'm not confident is 5%. Agree? So alpha represents some kind of a chance I am taking on my prediction of population. Is this much clear? Are you clear with the concept of alpha significance value? Yes or no? I think this much you are clear. Very good, very good. Now, my people, is this normal distribution? Yes or no? Okay. In a normal distribution, to make a judgment whether you have to accept the null hypothesis or reject the null hypothesis, I need two things. What is those two things? One is called acceptance region and the other is called rejection region. Do you remember? I have taught you this in the last class. This is a rule or this is a technique made by statisticians. Our goal, we have to follow this rule or this guideline that is given to us by our elder statisticians, that to accept a hypothesis or reject a hypothesis, we need two things: an acceptance region, a rejection region. But acceptance region and rejection region need to be calculated using confidence interval. That means I need to plot the value of my upper bound and my lower bound in the normal distribution. I have taught you how to do this in the last class. Using the table, you can calculate the upper bound value and the lower bound value. If you remember, from the table, when we calculated this, didn't we call this particular thing T critical? This is what we called T critical and T critical. We just took plus sign here and a minus sign here. If you remember, is this much clear? From the definition of p-value that I just taught you right now, p-value deals with extreme values within the data. Agree? Our goal, extreme probabilities value in the data. So rather than calculating p critical, can I not just calculate the p-value directly? It also gives me the same information what critical gave me. The number is not same. The information is same. P-value is a probability value. T critical is a number. They are two different things. Agree or disagree? Make sense? I'll give you guys an example. Out of 100 rupees, what is 50% of 100, or what is, let's not take 100. Let's take 171 rupees you have. What is 12% of 171 rupees, my people? What is 12 rupees, 171, 12% of 171? How much is 12% of 171? Faster. Has anybody calculated? 20.52 Suhas and okay, 20.52. Are you correct, everybody? So tell me one thing. 12% is a probability value and this is a number, but they both represent the same thing. Given the original data, does p-value 12% and 20.52 represent the same information within 171? Does that make sense? P-value is a probability value, so it's a probability distribution number. But the upper bound and lower bound is a number. So are you understanding the difference between these two? Agree or disagree? So p-value and T critical represent certain information within the data. Apart from that, alpha represents the error. So if I take p-value and alpha, won't this help me with the acceptance region and rejection region? They are representing the same information that T critical and T statistics were informing. This is just another way of representation of the same information. But now you don't do it manually, you do it in a code. Our goal, did you understand? Yes, p-value is a percentage, it's a probability number. 0.8%, 0.616%, 0.9%, 3%, 8%. What p-value did we get here? 8.2 into 10 to the power of minus 12? 8.2 into 10 to the power of minus 12? Yes or no? This is the probability value. Did you understand this much so far? Why are we replacing T critical and T statistics value with P value and alpha? Are we clear? This part of the code will never change in your entire inferential statistics class. P value less than alpha is going to reject the null hypothesis. If else, it will accept or fail to reject the hypothesis. What do you mean by that? Listen to me very carefully, please, for 1 second. Everything will start making sense. There are two conditions. Your P value should be less than alpha. If it is less than alpha, what happens? You reject the null hypothesis. You reject null hypothesis. For something to be rejected, you need to be in the rejection region. For something to be rejected, you need to be in the rejection region. Yes or no? But if your P value is greater than alpha, you are in the acceptance region. You know what it is trying to tell you, my people? Listen to me very carefully. If your probability value of extremities is greater than your significance of errors, you are going to be in the acceptance region. Did that make sense? If your P value, the extreme things you're calculating in your experimentation seems to be higher than your chances of errors, you're in the acceptance range and everything is good and sunny. But if it is not, you will be considered rejected because you don't have statistical evidence to prove the answer. Did you get the concept, my people? I hope at least 20% of the information went into your brain. I know it's okay if it goes little by little in your brain. I am not expecting you to learn inferential statistics in 1 day. Nobody is expecting you that. In fact, I took so many years after which I understood the topic very well. It's okay. But is the concept clear, my people? I want you to take away one thing from this example that I taught you. In your manual exercise, you will use T statistics and T critical. After this class, will you ever calculate T statistics and T critical, or T critical? Forget T statistics. Will you ever calculate T critical in your life ever again from a table or in a code? Never again. To solve any inferential statistical use case or a test, the answer will always be with respect to P value or alpha. Are we clear? Confidence interval, if taken 95% and when calculate P value extreme, the extreme values can always fall in rejection area, right? Yes. Depends on the data, Anjana, and also depends on the problem statement. Usually on a note, P value is supposed to be lesser than alpha for the rejection to happen. If not, it will be in the acceptance region. If the value is lesser, then it will be in the... So it will be confusing a little bit, which is okay, which is fine, which is absolutely okay. But I hope you have taken one thing important out of it, and that is you need to use P value and alpha to accept and reject the null hypothesis. And this line never changes in the entire inferential stats class. Whenever you will calculate this test, the answer never changes. Are we clear? Also, one other thing, just a small update to you. Okay. If P value is greater than alpha, it means T stat slide in CI except null hypothesis. Is that right? Yeah. I want you to think of it like this. In the normal distribution data, were you all giving attention in my class when I taught you the concept that there is something called rejection region and acceptance region? I hope you will not make me repeat this basic concept once again. Because if it is blurry in your mind, maybe certain topics have not been clear in your head. Okay. But I have sort of connected the dots in a way where everything should make sense to you. But if it is not, it's okay. It's all right. Let me explain it to you in a different sense. For my hypothesis to be accepted and rejected, it completely depends on something which is called my confidence interval. Is this the right statement? My hypothesis completely depends on my confidence interval. Makes sense or not? I think this much you guys will agree, right? Confidence interval is like confidence interval is okay. Let me teach it to you like this. Okay, let's try to learn it like this. Imagine there is a movie. Imagine there is a movie, my people. Okay, imagine there is a big budget movie like Bahubali. Inside this Bahubali movie, there are so many actors. One of the actor is called P value. Okay, main character of the movie, P value, big bulky body, hero type figure. The second important factor is confidence interval. The second actor or actress is confidence interval. P-value and confidence interval are to be married together. Okay? Assume this much. P-value and confidence interval are main hero, main heroine of the entire story of my inferential stats class. Third thing, and the most important thing, is called T statistic. Okay? The T statistics value. And the fourth thing is called T critical value. Okay? These are the four important prominent figures in our entire story. Okay? For a normal distribution to work, for a normal distribution of my data, this movie cannot work without a script. If there is no director, no actor, no script, movie cannot work. Just like that, for a normal distribution is just normal distribution. I cannot accept or reject null hypothesis without having an upper bound value and a lower bound value. Is this much clear? That this is a necessity. Without this, the movie cannot proceed forward. Without this upper bound and lower bound value, my null hypothesis, my rejection and exception won't happen. That possibility will not happen. Agree? Okay. For my null hypothesis to be accepted or rejected, I need to create a boundary. That boundary is created by upper bound value and a lower bound value. Agree or disagree? Upper bound value and lower bound value itself is nothing but confidence interval. Agree? This itself is my confidence interval value. Okay. Because confidence interval value is my main heroine, okay, we have heroine sister called alpha. This alpha is everything confidence interval is not. Okay, confidence interval is such a good thing. Alpha is a bad thing. If confidence interval is 95%, alpha will always be at 5%. Alpha represents everything negative in the movie. Alpha in confidence interval or in inferential statistics represents the errors I'm okay to take in the entire thing. Can I assume this is correct? Alpha represents all the errors I am okay taking in my example. If my confidence interval is 95%, the chances of errors in the problem will be 10%. Agree? If this is the truth, if this is the reality, to accept or reject the null hypothesis, if any value, okay, comes inside this range, if any number comes inside this range, do we accept it or reject it? Any number comes within the confidence interval range, do we accept the null hypothesis or do we reject the null hypothesis? Very good. We accept the null hypothesis. Very, very nice. And if some number by default goes somewhere here or 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 somewhere here, do we accept it or do we reject it? Anything that is outside the boundary is rejected. Agree or disagree? Anything which is outside this particular range is rejected. I told you T critical value, the T critical value, which is this T critical and this T critical, rather than calculating two values, one is positive, one is negative, I can calculate the area here, right, of the tail. I can calculate maybe the probability of the tail. That will also tell me the same thing. Maybe it will give me the same information related to the information of the normal distribution. Rather than calculating two number, can I not calculate the probability of the tail occurring or the errors in the tail occurring? Rather than calculating the boundary, I will calculate the probability that this tail occurs so that we have no boundary. Just the probabilities of the tail. If that is the case, the probabilities of tail are nothing but my p-values, the extremities within my data. Alpha is all the chances of error I'm taking in my program. So if we compare p-value with alpha, it will solve the problem of me having to calculate the acceptance region or rejection region, because this automatically will take care of the acceptance or rejection, because I have now calculated the rejection range via this and acceptance range via calculating a boundary without making a boundary, which is via the tail. That's it. So imagine a normal distribution. Now it no longer has a boundary, but it has this. It has this. Does it also not represent there's an imaginary boundary here? But this time I chose not to make a boundary, just highlighted the tails. There is no boundary, but just tails. It represents the same information. Make sense? I hope it makes sense. That is the difference. Okay, let's have some questions. Why only p-value, since we can calculate using t-critical also in coding? You can do that, Asha, but the problem is p-value tends to be more accurate. Not just more accurate, it's more universal also. P-value is range and alpha is a number, right? P-value is a probability value here. It's not a range, it's a probability value. If you are doing a two-tailed test, you divide p-value, you multiply to with p-value and you get the answer. Actually, p-value is the probability only of one tail. When you multiply this with 2, you get the probability of both the tails. So my people, when you calculated the t critical value, did you not take the number here, whatever number you get, 1.96, you just put 1 minus 1.96, yes or no? Whatever number you got plus here, because normal distribution is symmetrical curve, you just put a minus 1.96 and you got this answer, correct? So if you calculate the p-value here only for one tail, can't you multiply 2 into whatever one p-value you got, and together now you have p-value to the left and p-value to the right? And this is why I calculated the p-value with 2 into. Did that make sense? Why have I multiplied 2 into? Because we did a two-tail test, right? Did we do one tail test or two-tail test? How many tail tests have we done? Two-tail test, right? Agree or disagree? Because we did two-tail test, we need to calculate p-value for both tails, right? That's why I have done 2 into. The actual formula for p-value is this much. But when you do two-tail test, you have to multiply 2 into this answer and you will get the answer correct. My question to all of you is, when we did the manual problem and the exercise problem now, did we get the same answer? Did we get the same answer? You will always get the same answer. Whenever you solve a coding exercise, you will always get the same answer when you do a manual test or a coding test. But whenever you go for an interview, or say by default you become a data scientist in some companies, will you be expected to work in a manual problem, or would you be expected to work via coding, or you will have to code the solution up? So I showed you, for example, how can you even calculate t critical value also, and you can calculate using the p-value also. But we still have to calculate t stats value to put in p-value formula. Yes, Siddhant. Yes, absolutely. So t statistics value has to be calculated. What I'm basically trying to say is you don't need t critical value anymore to compare and get the output. To accept and reject the null hypothesis, you will no longer compare t stats and t critical. You will compare p-value and alpha. That's what I meant. To get acceptance and rejections, you don't compare these two, you compare p-value and alpha. That's what I meant. Of course, you need to calculate t statistics. To calculate p-value, you need to calculate t statistics. Otherwise, you will not get the answer. Are we clear? My people, I think you should take one more example to get more clarity. But this time, rather than doing two-tail test, can we do one-tail test to see if the answers, how different they are? So that the clarity you will have in your brain will be significantly higher. Do you agree with me? The clarity that you will get now with one tail t test, how to solve that in a coding exercise, it will make your answer very, very clear. Are we learning Twinkle Twinkle Little Star? Our goal, or am I teaching you blah blah black ship? Are we learning Twinkle Twinkle Little Star in this class? Absolutely not. You think? Of course, Twinkle Twinkle Little Star. Okay, the point I'm trying to make is, inferential statistics is a concept or a topic that is complicated. I'm not gonna lie. It's absolutely a little difficult in the very beginning stage to understand. But remember one thing: it's the basics that you have to focus on, and I'm teaching you exactly the basics. After this class, if you guys don't revise, I'm telling you, this knowledge is gonna go away so fast. Whatever I've taught you, the concept of p-value, the way p-value is calculated, the way you have taken all of this, you need to revise this concept. Otherwise, everything will just go in the air and then you guys will just lose it off. So do that, make sure it makes sense. Okay. Anyways, I have taken a question for all of you from a website called Glassdoor. Have you ever heard of Glassdoor, my people? If you guys don't know, let me tell you a little something about Glassdoor. Glassdoor is a website where all the people, whoever have gone to companies like, Amazon, Meta, my company, and all of that, they will upload what was asked in their interview. So there was an interview question that this question was asked in an interview in companies called Wipro. Okay, this was asked in Wipro. This was asked in Edgeworth. Okay, this is Edgeworth. This is an Infosys company, if you didn't know. This was also asked in Bajaj, Allianz. I don't know what this company is, but okay, no problem. So this interview question, I have changed the question slightly. This has been asked in these companies now, okay, and I've taken this question from Glassdoor. What this says is, A school has been using the traditional teaching method and the average test score for students has historically been 70. A new teaching method is introduced and we want to test if it is significantly improves the score. We'll use a one-tail t-test here. यहाँ पे मेरा answer आ गया, but यहाँ पे आप इतना, you consider only this much. What do you see in this particular example, my people? What do you think is the question? Who understood the question well? You please let me know. What have you understood from this question? What have you understood from this question, everybody? I'm asking all of you. A school has been using a traditional teaching method and the average test score for the student is 70 historically. The population mean is 70. Awesome. But the question has an answer which is significant. They are not testing for difference in result, right? In the same example that we said, we just wanted to know if the salary has changed. But in this example, they want to prove whether it has significantly improved or not. So we are only looking for the right tail, right? Not the left tail. We don't want to look if the tests have been decreased or not. We only want to test whether there is an improvement. Tell me only and only if the improvement has happened or not. Otherwise, don't give me any answer. Agree or disagree? So only and only if improvement is being questioned, only the right tail is being asked. Correct? Only one tail. Specifically right-tailed t-test. So let's take the data, my people. Let's directly try to solve the problem. What do we import in this particular example? Maybe import NumPy as NP? Yes or no? This is the basic thing. From SciPy, okay? From SciPy, stats, import T, okay? Import T. You can just directly import T here like this. Can I say these are my import statements? Nothing different. My mu value. What is my mu value that is given to be 70? From the question, you have to understand whether it's a one-tail test or a two-tail test. Sometimes they do not give that information. You have to make always assume in that case to be two-tailed. But if they significantly mention greater than, great, lesser than, lesser, great, greater, greatest, small, smaller, smallest, only in the positive direction if the question is moving, then you are supposed to do one tail. You have to be very careful with the question that they ask. And see, this question has been asked in companies like Wipro and all of that. And I have taken this question from a very recent 2019 interview. 2019-2020 interview. So this is a good question, okay? So mu is equal to centi. Agree or disagree? The mu value is 70. Agree or disagree? Okay. Observe one other thing, my people. They just asked the question, they never gave the data. They just asked the question, they never gave the data. Their assumption is you will make data on your own also. The assumption that they are making is you will take some data. No problem. According to our common sense, we'll take the data. So the new test scores is going to be, we can take some random values, my people. Say, for example, 72. Give me some random number, 75. What else can we take? 68. Okay, very nice. What else? What next? Give me some random numbers. Let's write it down. 72, 75. Make sure that the numbers are below 100 only, right? 83. Okay, next. What else do we take? 80. Okay, very nice. 81. Okay, 71. What else do we take? 95. Very good. Next. 85. I have already taken, not taken. Okay, 85 next. 92. Very good. Okay. So my people, we have taken what is the length of new test score? Give me 1 second. 10 values. Okay, I think this makes sense. We have taken the length of 10 values. Okay. Have we taken the test scores after the new recent test scores? These are the most recent test scores. Yes or no? These are the most recent test scores. Agree or disagree? Okay. Now, my people, I also want to apologize to you, all of you. I'll tell you why. In the above example, did I make you calculate the t statistic separately and p value separately? Did I teach you how to calculate t statistics using the formula and p value separately using the formula? I have taught you how to do them separately. I made you write the formula completely for t statistics and for p value. In reality, in actual production code, you don't have to do that. You can calculate at once. You can calculate both the p underscore value, okay, and the t statistics, t underscore statistic, directly using one method, okay. The reason I wanted to teach you both is because I wanted you to know that this is how it works. But anyways, t dot t test independence, okay. So okay, you can actually import it like this. From SciPy import stats. Just don't do it like this. Do it like this. From SciPy import stats. Okay, stats. And here I will call stats.t test independent. Okay, stats dot t-test independent. T-test one sample, sorry, because we are doing one sample t-test, right? Inside this, you just pass new test scores and the value of mu. If you pass new test scores and the value of mu, and if I just copy this particular thing, give me 1 second, degree of freedom, I'll just copy this, give me 1 second and paste it here. And I'm also going to paste it here. First of all, let me take the value of p-value and let me paste it here. Let me paste it here, give me 1 second. And let me also take t-stat value, copy this and paste it here and paste it here. Okay, give me 1 second, paste it here. Did we get the p-value and t-stat value, my people? Did we get the value of p-value and t-stat directly? Look, I know I made you do this separately because I wanted you to be aware of this. You don't actually have to do this in production. I know, I apologize. But I know this is so much more easy, but you should always be independent of doing it separately also. So I thought that maybe if I show you that first, and then any of the examples we use, we'll use the functions directly. Okay, anyways. I told you that this line remains universal. Agree or disagree? This line, if p-value less than alpha, reject, else accept. This line I am not going to change in my entire inferential stats class, and you also won't change. So can I take exactly copy of this and paste it here? But rather than just saying reject and accept, let's write it in a nicer way. When I say reject the null hypothesis, what do you mean? My people, I'm going to ask you guys one thing, and it's going to be a little surprising for you, but you guys are going to love it. When you reject some null hypothesis, what do you mean? That there is a significant evidence that the new teaching method improves the test score. When you reject something, why do you say this? In the null hypothesis and alternate hypothesis, what do you write in null, my people? If you would have written this example manually, what would you have written in null? That the average score is still 70. The average score is still 70. Agree or disagree? That is your null. 70, not below. We cannot make that mistake. 70 exact, no below, 70 directly. But the alternate hypothesis is the mu value is greater than 70 because that is what we want to prove. So if I reject null hypothesis, will this not be the answer? Because if I rejected the null hypothesis, this condition became true and this needs to be printed because that condition is true. And if this is rejected, then this condition needs to be written. Make sense what I'm saying? Let me tell you guys it in a nicer way, okay? When we say null hypothesis, we say still the mu value is 70, correct? You will agree with this much? Will you agree with this much that the null hypothesis mean your average value or the average percentage of the student score is still 70? But your school has implemented a new teaching method. You want to test whether there is some improvement or not. So the alternate hypothesis is you believe that there is an improvement. There is some improvement which is beyond 70, correct? Agree or disagree? If you reject the null hypothesis, that means this entire condition is going to be false. The thing is, you want to print that the null hypothesis is rejected, but the answer needs to be that yes, because this is rejected, this answer is true. So you need to print this answer, right? Because null is rejected. And if alternate is rejected, then this answer needs to be written that it is still same because the alternate condition automatically becomes true. Make sense? So if we reject null hypothesis, can I say there is significant improvement? There is significant improvement. Significant improvement. And if I reject the null hypothesis, I can say there is no improvement. There is no improvement. 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 If I print the answer, what do we say? What is the answer? That the data that you have provided, I get null hypothesis that there is a significant that we fail to. Oh, by the way, did we give any alpha value here, my people? Did we give any alpha value here? No, right? Alpha value, it is still taking which old alpha? 5%. In the example problem, did they give us any alpha value? No. So always assume which alpha value if they don't give you any alpha. What will you assume? 0.05, yes or no? Agree or disagree? So you will always take an alpha of 5%. So when p-value is less than alpha, what did we do? We reject the null hypothesis first of all, or we accept fail to reject the null hypothesis? Depending on the test score that I see, is there any significant improvement in the people, my people? No, right? But can I shock you and surprise you a little bit? Are you ready for it? Are you ready for a little surprise and a shock? In the entire data set, some person got 72, somebody got 75, somebody got 68, somebody got 70, somebody got 83. Overall, people are still in the range of 70 only, right? In the entire data set, very rare people got 90, right? Most of them are 70. Agree?
Our goal
That is what the data is telling me, right? Let me, if the first person by default scores 89, the second person gets 92, the third person gets 89 or 87, or the other person gets, I don't know, 85. If I run this answer, what did it change in my answer? Nothing. It absolutely changes nothing. But according to our data, everybody is scoring on an average above 70, right? According to the logical sense, everybody is scoring better than 70. What mistake did we do? One other mistake that we do. Is it a one-tail test or a two-tail test? Is this a one-tail test or a two-tail test? It's a one-tail test. If it is a one-tail test, do we not have to divide the p-value by 2? Because now you are not supposed to take the exact p-value because it is only for one tail. If it is for two tail, you multiply, one tail you divide by 2. Because you're only considering one tail, you're not supposed to take. So what do we do, my people? Do we take p-value directly? No. We have to apply a condition. What is that condition? That condition is, if your t-statistic value, if your t-stat value is positive, which is greater than 0, what do you do with your p-value, my people? Your p-value is nothing but p-value divided by 2. If I take the entire answer and run it, what answer do we get now? P-value divided by 2. Give me 1 second. P-value is p-value divided by 2. Do I do a round off division or a simple division? I think I can do a simple division, which should be fine. Give me 1 second. T-test, one sample, mu. Have I taken the mu value correct? I've taken the mu value correct. Give me 1 second. T-stat divided by 2. If p-value is less than alpha, p-value is if p-value becoming less. Give me 1 second. P-value, what is it becoming? Let's print this first. It's becoming 3.66. What is the alpha value? Oh, it is still greater. Okay, I got it. Okay, I understood it. First of all, Santadas Wadhwani, your question is very, very simple, my dear. The reason why we are doing is one tail. The reason the entire question is one tail is because what is it asking? A new teaching method is introduced. We want to test if it is significantly improves the score or not. My question is, I want to test whether I am getting the correct answer or not. My test is only for improvement. So improvement comes in left tail or right tail? Which tail does it come in? If I want to talk about this particular value, does it come in the range of right tail or left tail? If it comes under the right tail, my dear, am I doing the thing correct then? Then am I doing the whole, process correct? So tell me, my people, even though the test score seems like they are higher than this value, but according to the distribution of the data, what answer are we getting? Reject null hypothesis. What does reject null hypothesis tell you? What does the reject null hypothesis tell you in this particular example? For the new test scores that we have just generated and passed the value of mu, whatever we have passed, what does it tell you? It tells you that there is no improvement. It accepts the alternate to be the truth. Okay. When we take the entire data and now reduce it a little bit, like for example, 61, 60, 67, 67, 65, 45, 56 and 35. If I run this answer, what does it say? What answer does it say? It says reject null hypothesis. There is a significant improvement. What did we do in our code in the printing mistake? Did somebody catch it? What did we do in a print in the print statement? Do you see what did we do in the print statement? Okay, I'm gonna remove this. Okay, I'm gonna take this out. You'll understand in a second why the answers are different. If I take this out and get this answer, are we getting reject? Agree or disagree? Are we getting a reject? Reject means it's getting rejected. Okay. If I change the number slightly, 92, 93, 95, 96, 91, 97, 90, and 95. And if I run this, is it giving accept or fail to reject? So what should be my answer for which condition should my answer be for? Like what would I do for this entire condition? This thing. And also one small mistake that I've done here is this t stat value that you see here. We have okay. First of all, okay, observe one other thing. If I print this particular answer, do you get the value of p-value 26 and t-stat called 2.6549800 something something? Is it a positive number or a negative number? The t-stat value, is it a positive number or a greater number or a negative number? 10 to the power of minus 8. Do you understand the meaning behind this, my people? 2.654980561. What does it mean? No matter how small the number is it still a positive number? If I take this condition here, remove this condition if t stat is greater than 0, okay? Just take p value and divide p value by 2. Will it still keep my condition same? Will the whole thing still keep the condition same? If my p value is equal to p value by 2, I will say p value underscore new, okay? This is my new underscore p value underscore new, and I will take this part of the code. Listen to me very carefully, okay? Underscore new. What does it do? If I print this particular thing, right, p value new is not defined. 1 second, let's cut this part. Give me 1 second, Control X, run this. Why am I taking new here? Yeah, if I run this, paste it here and remove this part and run it. Okay, does it give me the same exact answer? There is no change in my code because p value is positive and I'm not worried about that condition. I got the answer. So what actually should I have written here and what should I have written here? What would I write here in the reject and what would I write in this particular part? In the reject part, what would I write? No significant improvement. And in this part, would I have written improvement? Hence, it is saying accept or fail to reject means clearly people are performing better. Agree or disagree? So I would have written actually the reverse, but I also wrote the same condition, but it actually had to be reversed. That yes, there is a significant improvement because everyone is scoring above 90, which is greater than the average of 70. Agree? I hope you understood what I meant. So see, according to the data, it understood itself that there is a significant improvement and it gave us the answer. I hope you got what I'm trying to say. You got the answer for it clear? Did everybody get the answer? Automatically, first of all, did you have to calculate t statistics and p value separately? Did you calculate it separately? Or did you use one method and you calculated everything separately? Acha, by the way, is this an example of one sample t-test, independent sample t-test or pair t-test? What is this example for? You are comparing against a standard. So what example is this? It's a one sample t-test, right? Because you're comparing against a standard. Didn't you take a population mean here, my people, 100, a standard? So isn't this one sample t-test for two tail test? This is one sample for in one tail test or right tail test. Two different examples. Are we clear in this part? Done. What do we write down for this example? Okay, from this example code, what did you understand? Forget the code first. Question. What can you expect in your interview to happen? What are you going to expect in your interview to happen in the exam? Tell me. Whenever you're giving an interview or whenever you're going to go for some example or some kind of a problem statement you're going to be getting in your career, what is that one thing that you're supposed to do? In your career, you will get the data. You're not supposed to assume the data, but in an interview condition, you will have to make data on your own. Did we make the data on our own? Yes or no? Read the question properly. If confidence interval is not given, what do you do with your confidence interval? 95% is the assumption. What do you do? Once 95% is given to you, what do you do with this particular part of your alpha? Become 0.05. Whatever population statistic that they have given it to you, you take that, right? Whatever your new new test scores, that whatever you have to take that, right? P value t stat, actually this is supposed to come after this. Give me 1 second. Actually t stat is supposed to go here, not here. P value here, right? Okay, then you're supposed to take this part of the code. By the way, you all know, right, that in t test or in stats or in Jupyter Notebook, you can just write stats dot and you can click on enter and you can get this t test one sample independent from stats and rel. You can have an option to calculate this, like you can have an option to calculate this multiple times. You have a way to get that output automatically without going on internet. So you just need to know the name of the method. Once you do this, you calculate your t-stats, you calculate your p-value, you calculate this particular thing. So when we reject the hypothesis, significant difference, non-significant difference, you get the output and you get the specific output depending on the question you have asked. Agree or disagree, my people? Are we clear with the whole thing? With one sample t-test here and one sample t-test here. The only difference is you calculate this separately and you calculate this separately. Agree until here? In t-test, what did we learn? Did we learn one sample t-test, independent sample t-test, and paired t-test? We've completed one sample t-test, independent sample and paired t-test. What do we do about this? Do we need to finish that? Do we need to have an example for independent sample t-test, also paired t-test? Do we need to take out an example for that particular thing? Agree or disagree? What do you think? For independent sample t-test, what is the example? What did we know? What did we know or learn about independent sample t-test? What did we do? We assume that the populations are independent of each other, right? So if you look at this question that has been asked in one of the interview questions also, I have brought this to you by the courtesy of a website called Glassdoor. Okay, I'm letting you know this is a beautiful website. This is another example that is given there. Okay, see here, they have something called test scores of different schools. Suppose you have a two group of students from school A and students from school B. We want to determine if there is a significant difference. Have they asked for greater or lesser? Any of that? Did they ask for anything greater than great, greatest, lesser than lesser, least? What tail will you implement here? What would you implement in this part of the code? It is a two-tailed test. Has to be two-tailed test. Okay. So if I change this or if I write the example in this part, first thing to do is, what do you understand from this question? In the independent sample t-test, what do we understand from the question? We have two different schools. Our assumption is that the schools are independent of each other, correct? Because they want to test which schools perform better. Agree or disagree? So in this example, do we need to take one sample or two samples? In the one sample t-test, we took one example. But in this example, do we take one or two samples? How many? So import NumPy as NP. So I'm just going to say import NumPy as NP, right? Okay, done. Import NumPy as NP. What do we import if I want to import two sample t-test, or if I want to import, or if I want to implement the independent sample t-test? So from SciPy, import stats. Okay, just do import stats. Okay, stats, done. That's pretty much the same thing that we do. Stats, done. From import, I've written this twice. From SciPy, import stats, done. Okay. First of all, is the data given to you, yes or no? This problem has been asked in your interview. You all are sitting in an interview setting. Have they given you any data? They have not given us any data. But you know for a fact that to apply t-test, it is parametric, meaning it needs to follow normal distribution. So can I say school SCHOOL underscore A underscore scores? So can I say school A scores equals to np.random.normal? If I use this method, it will give me. So for simple example, let's take a sample size. Okay, they have not even given us a sample size. So let's assume the sample size that we will take for this particular example is, how many students do we take, my people? You guys tell me. How many students do I take for a sample? For school A and school B, 25 people. Very nice. Chalo. So if I want to print size equals to 25, okay, this is school A scores and this is school underscore A scores. But the problem is, okay, Sonali, we cannot take 50 people because this is t-test. I hope you know that in t-test, sample size cannot be greater than 30. For t-test to be run, you cannot take a sample size more than 30. Okay, just keep it in your mind here. It's an important topic. My people, when I created a random normal distribution data, I got as negative value. Can somebody get negative 41% in their exam? Is it possible for somebody to get a negative 41%? No. Is it possible to somebody to get minus 90%? No. 98%? Yeah, possible. But this is not 98%. This is 0.98%. This is a problem of scale, right? So if I come here, if I give an average value of maybe 82 as an average value and the scale of maybe 4, if I run this now, does this make sense? Does this make more sense to me? Does this make that, okay, the first student got 84%, the second student got 80%, the third student got 82%, the fourth student got 85%? This makes more sense, right? But the data is revolving around 80% and 90%, correct? The range is not very versatile. Even though this follows normal distribution, the range is not very versatile. Agree? It's between 80% or 90%. The numbers are only between 80 and 90, correct? What can I do to change the scale? Isn't there a number called scale here? If I make it 8, now do I have versatility? np.random.uniform. You can use this method to make it float point values or int values. It's by default int. Did I change the versatility? Now I have the lowest number, which is the lowest number? 71%. And the highest percentage somebody got is maybe 95%. Agree or disagree? Now we have versatility in the data. So can I take the same exact thing of school A scores, copy the whole thing, paste it here, but change this for school B scores, and now I have 2 random values. But the problem is, every time I run the code, does it not give me random values again and again, again and again, again and again, again and again? It keeps repeating it. Also, observe one more problem. I run it once again. Listen to me. Observe once again. I'm going to run it again. I'm going to run it again. I'm going to run it again. Maybe in the 19th or 20th iteration, the problem is some number here will be greater than 100 also. Some number that you will generate here will be greater than 100 also. Scale needs to be always between 4 to 6, not 8. If I run this, now is my answer correct? Now, how many times you run it, it will not go beyond 100 because your scale is smaller. Now, to keep my data standardized and fixed, to fix the data between one standard value, can I use np.random.seed? Have you ever heard of the concept called random.seed? Have you ever heard of a concept called np.random.seed? No. Listen to me very carefully. My people, if I print this answer once again, print this once again, print this once again, print this once again, is my number changing again and again and again? Every time I run the code, it's randomly generating new data. For my problem statement to work correctly, I need to generate the random data only once. And after this, no matter how many times I run the code, the random number should not change. It should only make the random generation once and it should become fixed. In order to do that, there is a method in NumPy called np.random.seed. Can you give me a 2-digit random number? Anybody? A 2-digit random number? Any 2-digit random number, 10. If I run this answer, I have run it. If I run it once again, did my random number change? Did the random number change? No, right? I'm going to run it once again. Did it change now? Scale represents standard deviation, Jagesh. This represents standard deviation. Each unit standard deviation is what scale represents. Scale is the standard deviation. Location or log is basically the mid value, the center point value, the average value of the normal distribution. Did I run it once again and did it change the number? No. So basically it generated the random value once and after this it becomes freezed or frozen. So in the np.random.seed, whatever number you pass inside, if I have passed 10, you will also get the same answer. If you randomize it and you run it, you will also get the same random number and my answers and your answers will start matching. Are we clear? Agree, disagree? Clear hai? Is it inside our brain? Okay. Did we just generate our own data? This was not given to us by the interviewer, but we generated our own data. Yes or no? The data is generated. Okay. Once the data is generated, since we are doing t statistics, t stat comma p underscore value equals to t stat comma p value equals to stats dot, because you are doing t test independent, is there a function called t test underscore independent? Yes or no? Here we use something called one sample, t test one sample, but this is independent t test. So I have called independent sample t test. Can I take school A scores, paste it here? school B scores and paste it here, and my job is done. Agree, disagree? And I'll take the whole thing, same exact value, copy here, paste it here. If I run this particular value, am I getting some t-stat value and p-value? Agree or disagree? Am I getting some t-statistics values and p-values? Yes or no? What is my alpha to be taken here? My alpha will be how much, my people? 0.05. I'm assuming 95% confidence interval. Yes or no? So if I take this part of the code, p-value less than alpha, come here, can I paste the same exact thing? I don't need to change this particular line of code for anybody. Tell me one thing, when you reject the null hypothesis, what are you saying? When you reject the null hypothesis, what do you say? If you reject the null hypothesis in the example problem where school A is different from school B, can I say school A and school B are same, performing the same? And in alternate hypothesis, school A is not equal to school B, they are different. This is our null hypothesis and alternate hypothesis. Agree or disagree? My null hypothesis is school A and school B are same. So basically, there is no improvement here. Agree or disagree? I can write it down in an English statement. I can say that school B's teaching methods and school B's, basically, if I write down in school A equals to school B, no improvement. If I write here, I can say improvement, correct? Or significant improvement. If I reject the null hypothesis, suppose if I reject null hypothesis, which print statement will I print? This one. If rejection happens, then this is the print statement. If rejection of alternate happens, then this is the print statement. So if I take this particular part of the code, reject null hypothesis, what do we write here? If we reject null hypothesis, there is a significant improvement. So can I say there is a significant improvement? And if I say accept or fail to reject, I can say there is no significant improvement. Or there is no difference in school A, school B, or there is a significant difference in school A and school B scores. School B scores. What B scores? And here I can say there is no significant difference, or school A and school B scores are same. School A and school B scores have no are same. If I run the answer, what did we get, my people? Because the random values of school A and school B has an average of 82 and 82, what did we do? This particular value here, this particular thing here, for school A students, the average percentage, how much I have taken, my people? 82%. Agree? For school B also I have taken average. So isn't the school A and school B average same? And that's what we are getting. The data is not same. The data is different, my people. See, if I print school A scores, listen, school A scores if I print and school B scores if I print, is the data same? Is school and school B's data same, my people? It's not about the data. It's about the mean of school A and school B same, correct? The average of both the school is still same. So tell me one thing, if I make the school B's average maybe 87%, can I say now they are different? One school is definitely performing better than the other school. If I run the answer, did it change? If I run this particular, I also need to change the scale. Okay, let's keep the scale a little bit. This was 82, this is 87. If I run this answer, it still says school A and school B scores are pretty much same. What if I make it 92? What if I do now? What happens now? Value, sorry, not new, p-value new. Sorry, it's p-value, yeah. If I change it, can I say there is a significant difference, my people? Because school A on an average scores 82%, but school B scores 92%. So according to statistical test, can I prove that yes, there is a significant difference? And the answer we got the same. There is a significant difference. But if I make this 82 also same, is it the same thing? That there is no difference, school A and school B is same? Agree or disagree? If I make this 82, 83, is it still the same, my people? 82 and 83% are not far away from each other. Agree or disagree? School A is on an average performing 82% and school B is 83%. So shouldn't it be the same answer? It won't change because there is no significant improvement. Agree or disagree? If I run this code once again, what should it print? What will it print? In fact, if I run this answer, what will it print? Will it say reject, null, or accept? What will it say? The answer is going to be same. Is it same? See, if I'm running it again, is it same? It is same, right? There is no difference. But if I slightly increase the school B's percentage, right? Say school B is now performing on an average 89% and school A is 82%. What will happen to our answer now? What will happen to our answer now? What will happen to our answer now? Reject or accept? If I run this, did you get reject? There is a significant difference in school A and school B scores. School A performs better than school B, or sorry, school B performs better than school A. Hence, there is a difference between both your schools or both the education methods of the school. Did you understand? Statistics is giving you the proof of improvement by itself in front of your eye. We did nothing, statistics did that for you. When p-value gets multiplied and divided, very good. When you do two-tailed test, you multiply your p-value with 2. When you do one-tailed test, you take your p-value and you divide it by 2. This is the condition for doing one-tailed test and two-tailed test. I hope it is clear. Whenever you do two-tailed t-test, you take the p-value multiplied by 2. Whenever you're doing one-tailed t-test, you take the p-value and divide it by 2. Okay? Okay? Cool? Okay. Questions, please, my people. Did you understand what's happening in this code? Are you all clear with the part of the code? How does it function? How was it able to understand? Yes or no? Do we have one-tailed t-test in the case of independent t-test? Yes, absolutely. Depends on the question. If this school would have asked, is there definitely increment? Oh, Gopinath has asked a very nice question. My people, listen to me and please understand what I'm trying to tell you carefully. The question is there a difference in the test in the school's performance or not? Agree or disagree? The question specifically asks for a difference. Does it ask for a greater difference or a lesser difference? Anything is fine, correct? Everybody, greater difference is also okay, lesser difference is also okay. Yes or no? So tell me, my people, if one school is performing 56%, on an average, the school students are only getting 56% and the other school is getting 82%. The answer will be there is a significant difference. Agree or disagree? The code is not telling you whether somebody is performing better or not. The code is telling you whether there is a difference or not. So did we get the same answer? There is a significant difference. The difference could be lower or higher. That's not what the code's responsibility is, because the question is not asking greater or lesser. The question is asking whether there is a difference. If you wanted to calculate, is school B performing better than school A? Which test will this become? Is school A performing better than school B or B performing better than school A? This would have become one-tail test. Makes sense? But because you have only asked for difference, I have implemented something called two-tailed test. Hence, my p-value is not being divided by 2. If this was one-tailed t-test, I would have divided my p-value by 2. And then I would have calculated this. Does that make sense? Because the program that you have written only tells you if there is a difference or not. There is a difference, right? One school's performance is different from other school's performance. And now if the other school also reaches up to 82 or 83%, no improvement, A and B are both same. So do we not have to multiply by 2? No. In this part of the code, in this way of writing the code, you don't have to multiply it by 2. If you're writing using the .cdf method, only then you have to multiply by 2. Are we clear? Did that give you an idea? Only if you are doing the .cdf method, you have to multiply by 2. Only if you're doing two tail. If you're doing one tail, remove the 2. It'll be one tail. That gives you peace, my people. Does that give you guys some idea? Are we clear? Did you understand how did you implement an independent sample t-test? This was a simple independent sample t-test, nothing complicated. This was just like a simple example. Sir, one more question, not related to topic. Can you tell how to check syntax in Python or argument in a function? Go to documentation. CDF is for one sample t-test, right? CDF is a method, Gopinath, that is used to calculate p-value. It doesn't matter where you use. T-test, F-test, Z-test, chi-square, ANOVA, whichever test you do, CDF is used to calculate p-value. If you are doing two-tail test, multiply by 2. If you are doing one tail, remove 2. That's it. My people, my question to you is very, very simple. I'm going to give you guys a small question that has been asked in TCS interview. Okay. You guys already know what TCS company is, but just letting you know. This question has been asked in a TCS interview. Believe it or not, not many people were able to solve it. Suppose a group of students wants to test the effectiveness of a memory technique called method of loci in improving memory retention. The method involves associating items to be remembered with specific locations in a familiar environment such as a room or a house. Okay? They want to test the score of a student before taking a test and after taking a test. What kind of tests will this be? Imagine you go to tuition classes. All of you go to a tuition classes. Before taking the tuitions, your score used to be very, very bad. Terrible score you used to get. But after taking tuition classes, your memory has improved. You've become better. To measure the before and after effect, what kind of test does it implement to do that? Paired t-test? Because that is the only test that takes 2 readings for 1 data. So tell me one thing. This is clearly an example of paired t-test. But have they given us the data? Absolutely not. Haven't they given us the confidence interval? Absolutely not. What do we need to do? First of all, we need to import. So can I say import NumPy as NP? Same exact thing. I need to from SciPy, import from SciPy, right? I need to import something called as stats, right? Done. First of all, I need to generate data. If we do not multiply when we are, if we do not multiply when we are using t-test independent, then why are we dividing when we are using t-test one sample? If we do not multiply when we are using t-test hold on, give me 1 second. Then why are we dividing when we are using one sample? Chandrakant, that is because the example was for one tail test. Because you calculated one tail test, that's why we divided the p-value by 2. But when I calculated p-value in the beginning of the example, okay, first of all, let's get that clarity first. Did I calculate p-value using a method called .cdf? Agree or disagree? Did I teach you? Okay, you need to understand certain things very, very clearly, my people. Did I teach you 2 different ways of calculating p-value, way number 1 and way number 2? First, get this clarity. In this class today, I taught you how to calculate p-value in 2 different types or 2 different ways. Do you all agree with this statement? One directly, one without directly or indirectly. One using the method called .cdf. Agree? When you use .cdf, you have to multiply your p-value with 2. Only if you do 2-tailed test. If you do 1-tailed test, remove this 2 and your p-value will be calculated directly. Meaning, if you are doing 1-tailed test here, okay, this p-value is calculated for 2-tailed test, correct? But if you are calculating 1 tail using the CDF method, what do you remove from the code? Into 2. This p-value will give you the proper p-value for 1 tail, correct? You don't need to divide by 2. Are we clear? If you do it like this, you don't need to divide by 2. To calculate 1 tail, you just remove the multiply by 2 and this is your answer for 1 tail. Done. Your job is done. If you use the .cdf method, if you use the t-test underscore one sample, t-test underscore independent, if you do such cases, and in these conditions, you have to implement 1 tail, then you have to divide by 2. I hope the idea is clear. Did that make sense? When you do use .cdf method, there is no need to divide p-value by 2 because here just remove 2 and your p-value will be for 1 tail directly here. But do we use this method anymore? No, right? This is just another way. You know what? I can erase this code, my people. Don't worry. I will delete it from the file. Please focus on coding it like this, okay? I wanted to teach you multiple different ways. Don't get confused. It's very, very simple. When you use .cdf method, you multiply by 2. If not, you remove 2 and that's your job done. But if you do .t-test independent one sample or t-test independent, whenever you do this kind of p-value calculation, you calculate t-statistics and p-value directly. So that's why when you do 1 tail, you have to divide p-value by 2. Does that make sense? Is there any confusion in this part of the thing that I just said? Any confusion here? Anyone? Are we clear? Remember this. I know inferential stats is so much that you have to handle, but guess what? This is what you have to do. It's not something you can run with. Are we clear until here, everybody? Okay. If you guys can give me 2 more minutes. Acha, okay, it's already 9, correct? I thought we have 5. Oh, I thought we have so much time. Okay. ठीक है, okay, no problem. I think we can wind up here.
Just a quick info, guys. Intellipaat offers data analytics course in collaboration with IIT and Pandas. Through this course, you will master Power BI, data modeling, data mining, and much more from the IIT Madras faculty and industry expert. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to a new height. So visit the course page link given in the description and take the first step towards the career in the field of data analytics.
Okay, my people, welcome back to this session and a very good morning to all of you. What do you guys think? The reason why we don't take the value of t greater than 30 is whenever we do t-test, right? Whenever t-test happens, t-test has its own distribution. Okay? T distribution, it is called as. So I'm going to show it to you how it looks like. Okay, you just have to go to Google and type T distribution. So distribution. Okay, so when we go to image, the most easiest way I'm going to make you understand it is with this example. Okay, give me 1 second. T distribution. Oh, perfect. Okay, so give me 1 second. Is this visible? Crop certain things out. Yeah. Okay. Observe one thing, Raj. Whenever your t-test has 1 degree of freedom, look at this purple line. Does the peak, okay, sort of like the peak is at a certain level, right? The peak is peak and then you have a distribution. But observe that the tail are very farther away from the data. Yeah? Yes. The tail is farther away from the data. You increase the degree of freedom, the peak increases a little bit more further. Okay? And it reaches a little bit more closer to the data. You keep increasing the data, as in you keep increasing the degrees of freedom, as in your sample size. The more you increase at certain level, t distribution matches the standard normal distribution. Do you see this? Is absolutely correct. The reason I said partly is because what basic fundamental understanding that we learned in the very beginning of the class, the most fundamental information was distribution, specifically normal distribution, is a density curve. Agree? It means if I increase the peak, the dimension or the spread decreases. Agree? If I increase the peak, imagine I have a graph like this. Okay. If I increase the peak of normal distribution, how many different kind of normal distribution can exist? Suppose this is one of my normal distribution. Agree? If I increase its peak, imagine you touched the topmost portion of the normal distribution and you increased it. When you increase it, the distance, the spread it covers will decrease because it's a density curve. And if I press it from the top, the distribution may look like this, right? This also could be a normal distribution, but the peak is decreased, but the distance has increased. So what happens is, because this behavior is noticed, right? If the sample size for the t formula, the t statistic formula that we've written, right? X minus mu divided by s divided by root of n. So what they observed is, for t distribution, if you increase the sample size for more than 30, it approaches incredibly close to standard normal distribution. And it makes no sense. What you mean by that is, when it reaches standard normal distribution, here, the standard deviation of the t-test that we want versus it has for the normal distribution becomes equally same. We want it to be different, hence we do a different test called t-test. You understand? Do you get what I'm trying to say? For a standard normal distribution, t-test is smaller than this. We want this smaller graph with whatever its difference of the spread is versus the peak is. If you increase the dimension, it reaches very close to standard normal distribution, for which we have multiple different tests. We don't need to do that. So that is why we don't do it. So your understanding is correct. Your article absolutely said the right thing. Did it make sense? Whenever you study about the difference between t-test and normal distribution, right? Always observe for one thing, and that is, whenever you take t-test, and the sample size or the degree of freedom is 1. So let me ask you a very simple question. If the degree of freedom is 1, minimum sample size is how much? 2? 2, right? Sample size is equal to 2. Degree of freedom is 1 because degree of freedom is sample minus 1. Agree? Meaning, what I'm basically trying to say is, whatever degree of freedom you have, if you do plus 1, that will be your sample size. Freedom is 1, plus 1 if you add, that will be plus 1 is your sample size. This plus 1 is your sample size, this plus 1 is your sample size. Observe whenever your t distribution is, or whatever, whenever you are doing t distribution, the reason you're doing t distribution is because here the tails are not exactly matching, or they are becoming closer and closer and closer. They never touch the x-axis, right? This axis that you see, right? They don't touch. But whenever you change the dimension of this peak, do you see some change in the standard distribution also? This part, if the peak of the graph changes to blue graph, to orange graph, to green graph, peak is increasing. But with peak, there are changes happening in the distribution also, right? Including the standard deviation, including how much percentage of the data can I cover. So that is because the article that you read says, if you take sample size more than 30, right, the distribution of the standard distribution that you have in the data arrives at standard normal distribution, which makes no sense. It beats the purpose of using t-test. Okay, there is an interviewer, okay, a person, before taking this this amazing memory test, what you do is, I'm going to give you a list of 20 names. It could be list of cities also: Bangalore, Mumbai, Pune, Hyderabad, Patiala, Chandigarh, Tanda, and all of that stuff. I will give you a list of 20 words, okay, and I will ask you, how many do you remember? Okay, so let's say out of 20 words, you were able to remember 11 before the test, right? Before taking this effective memory test, before you were able to remember only 11 out of 20. But after you took the test, after you took this memory effectiveness, technique or pill, whatever it could be, you are now able to suddenly remember 15. Now, I am asking you all a question, a very simple, commonsensical question. From 11 to a jump of 15, is it significant or insignificant? Before remembering the test, say a score of 11, and now you're able to suddenly remember 15, is it a significant jump or a non-significant jump? I believe it's a significant jump, right? So let's see what this particular thing is gonna say, right? That's nice. I'm from Tanda, by the way, just letting you guys. So anyways, the fact that you were able to remember only 11 questions or 11 cities name before taking the memory test and after test. This is a very good example of what test? Is it not a good example of a paired t-test? Agree or disagree? This is what a good example of a paired t-test look like, before and after scenario. So observe one thing and be very observant about it. In the question given to us, did the interviewer give us any other information? Confidence interval, data, any other idea? No. See how smart these people are. They just don't want to test your inferential statistics skills. They also want to test your programming skills. Why? Because you will have to create your own random data by yourself. So that proves you know NumPy, that proves you know programming well, and then you have to write up the code for inferential statistics that proves that you remember the names of the method. So remember this. This is exactly how it shows up in your interview. And once inferential statistics class is done, I am going to show you one example how we data scientists use it in an actual data. Okay, so once you guys have learned the proper inferential statistics tests and all of that, I will show you one small example that how we as data scientists, if some company gives us some financial data, how do I apply it on a financial record or maybe some other record? Okay, so first of all, people, have they given us any data? Yes or no? Absolutely not. There is no data given. I have to create it by myself. So first of all, if I want to create that particular result or if I want to run that particular result, what do I need to do? I need to create something called before scores, correct? The scores that people have scored before taking the test. Agree? Yes or no? The scores people got before taking the test. So can I say np.random.normal? This will help me create a normal distribution data, and I can say how many data points do I want? 20 data points I want, because there will be 20 students. Okay. Or if the number of students has not been defined, you can pass whatever you want. Let's take, for example, 30 students, no problem, right? Before scores is this much. But the problem is we need to give the average value, right? Because if I just print before scores, can somebody remember minus 0.2 score? Can somebody has an average score of minus 0.2? No. Correct? Yes. Which I have created a variable called before underscore score is equal to np.random.normal. The problem here is the normal data that I'm printing has negative values. Is it possible that the average of somebody can be negative? Mathematically, is that possible? No, sir, it is absolutely not possible. It's like we waking up in the morning. It is like trying to teach somebody inferential statistics in the morning, 7 o'clock. It's equally hard. So what do? We change the mean value, right? So can I say that before taking the score, on an average, people were only able to remember 11 out of 20. Can I say this? Before the method of loci interesting memory technique, they were only able to remember up to 11. And can I say a scale value, a standard deviation value, so that the difference between data is higher? Maybe 6. If I run this, the problem here is, look at this particular thing. Am I getting minus 1.90 and minus 0.44 and 6.27? The reason is here, the normal distribution. If I make it to 10, is there any negative value? Is there any negative value here? No. We are assuming this 11 is an assumption. Okay. We are only assuming 11 because they have not given us any foundation. So we are only assuming. So can I say before the score, people were able to remember up to only 11 keywords, up to 11 on an average, only 11 names of the cities. But if I say after score, okay, after underscore score, after taking the method of loci, let's take the same exact code. And for some reason, I'm going to say that on an average, they were able to remember up to 15. Okay. Up to 15. Okay. Up to 15. So do you think this is on an average a significant jump? I think it is a significant jump. There is one more problem. If I keep running this data, the random number will keep generating. So np.random.normal, this np.random.seed, this will give me a value only created once, and it will not repeat itself. I mean, it will keep itself same. It will not generate random data again and again. After I am done with this, the t stats value, comma p underscore p value, okay, p underscore value equals to, what do we call? Because we are implementing something called paired t-test, just call stats dot t-test underscore rel. Rel is relational. Okay. Why seed equals to 10? In the same above example, did I give a seed value of 10, my people? Giving the seed value of 10 will generate some random data. Agree? You can pass any number inside this. It could be 10, 20, 40, 50, whatever. Whatever number I am giving, you also give the same number. So my answers and your answers will match. Because you are dealing with random numbers, my results will be different from your results. Because we don't want different results, I am fixing or freezing the random numbers. Generate the random number once, never ever change them again. That's why any random number you can pass inside the seed. Because yesterday somebody recommended put 10, I am putting 10 here also same. Okay, good. So my people, I'm going to pass something called before scores and after scores. Okay, now I am done. I just want to print the value of t-test and p-value. So can I just copy this part entirely and paste it here? Did I say that all of this is going to be the same, my people? This particular thing will not change. Shubhadeep, give me 5 seconds. Let me teach this code. I'll raise your hand and then we'll talk further about what you did not get. Okay, don't worry about it. Your alpha value in the problem statement will be 0.05, which is 5%, right? Let's remove this part of the code. Let's remove this part of the code. Now tell me one thing. When we did normal distribution, when we did null hypothesis and alternate hypothesis, what would be your null hypothesis in the question and what would be your alternate hypothesis in the question? Let me copy this question and let me paste it here so that you guys are able to see it. Okay, let me expand this a little bit. Give me 1 second. Give me 1 second. Expand this a little bit. Maybe make it a little bold and increase the size to, oops, I think it's too much. I think let's do this much. Okay. Is this visible? Question to everyone? Very good. In this particular problem statement, have they given any confidence interval? First of all, I want all of you to focus. If you miss out any one line, it may not make sense to you. Is confidence interval given to you? The answer is no. If the confidence interval is not given to you, I always told you to assume 95% confidence interval. I have repeated myself for millions of times this time. And the alpha value also will become 0.05, which is nothing but 5%. So nobody has any question why I have taken the alpha 5. Are we clear with point number 1? Okay. Point number 2. Did they give any information about greater, greater than, greatest, lesser, lesser than, least? Anything like this? Has it mentioned or has it been mentioned in the code? If they have not mentioned any significant way of telling something greater or lesser, what tailed test do we assume by default? It's a two-tailed test. So nobody has any question in that also. It's a two-tailed test. Very good. Now that you have taken these two information, okay, let's answer this question of np.random.seed. Do you see this thing, this function called np.random.seed? Yes or no? Do you see this method called np.random.seed? In yesterday class, I had taught you guys this, but anyways, I will repeat myself once again. np.random.seed is significant improvement, so one tail. If it is a significant improvement in memory, then we say it is one tail, but let's say significant difference, right? Let's not say improvement. Otherwise, I have to do. Great catch, by the way. Significant difference, okay? Not improvement. If it's improvement, we'll have to do one tail. Good catch, by the way. Now, the focus is np.random.seed. What is np.random.seed? Whenever you deal with something called random or random values, whenever you run the code again and again, for example, if I import random, oops, Control Z, right? What happened? Control Z, Control Z. No. If you import this library called import random, okay, import random, and if I say random dot rand int, okay, rand int, random integer between 1 comma 10, if I keep running this cell again and again and again, is it giving me random numbers again and again and again? Every time I run the cells, the results of the answers keep changing. Agree? The random numbers are again and again different. Agree or disagree, everybody? Because you're dealing with this problem, what do? We want the random number to be generated once, and after this, I want it to be freezed. I don't want it to change again and again. Because you don't want them to change again and again, you use a method called np.random.seed. And inside this, some number you pass, 10, 15, 40, 50, 45, whatever number you pass, the same number, if I also use np.random.normal, if you write the code np.random.normal and pass the number 10, my random numbers and your random numbers will be equal. Otherwise, you will get a different random number. I will get a different random number. Agree? So this number is the key to get both of us the same answer. You and I, we get the same answer. Okay? Anyways, we are running this particular test. Okay? By the way, this is not significant improvement. Okay? This is significant difference in memory. If you say improvement, what test will you do here? We can also do one tail, by the way. But if you have difference, what is the answer here? Is it a one tail or two tail? They are only asking about improvement. So then it will become one tail. By the way, if we want to convert this entire data set into one tail, all we have to do is divide p-value by 2. I hope you know this. We can also do one tail in this. It's no problem, right? But let's say for simplicity reasons, it's significance difference, okay? So now that you know the confidence interval is 95%, the alpha value is 0.05, which is 5%, and this is a two-tailed test. What will be your null hypothesis here, and what will be your alternate hypothesis? Always in null hypothesis, you assume everything is good, everything is fine, life is beautiful, everything is amazing. Whatever is happening from the beginning, that's what's happening, correct? If your null hypothesis in for this particular question is the difference in before the test and after the test, they are equal, right? There is no difference. Before is also same, after is also same. Agree? If I write it down in English, what would I say this? How would I say this? Sir, can we also use random state also, right? Random state is a different method, Priyanka. We can also use that. But if you use that, you have to sort of be very careful about under what pretext you use it. I'll also give you an example of that, Priyanka. Okay, good. By the way, yeah, we can also use random state. We use that in machine learning a lot. I'll also tell you how to use that. Okay, don't worry. Good recommendation. My people, what would be your null hypothesis in this case? In null hypothesis, what do you say? Is the difference equal or the difference is same? How do you write it? What will be your null and what would be your alternate? Can I say A and B are equal and A and B are not equal? Can I make this claim A and B are equal? If A and B are equal, is there a significant improvement, or can I say no significant improvement? And here I can say significant improvement. Correct, right? Here I can say no significant difference in method of loci, and here I can say significant improvement. Yes, it did make a difference because they are not equal. So they are different. It could be lesser also, it could be greater also. So tell me one thing, if null hypothesis becomes false, or if I reject null hypothesis, so null is rejected, but the proof is significant improvement, correct? That there is a significant improvement, I will say this. So tell me one thing, I'm coming back to my question. I reject my null hypothesis. What should be my answer? There is significant improvement in the memory of the students. Can I say this? Insignificant improvement with method of loci. Can I say this, my people? There is a significant improvement in memory of the students with method of loci. And if I take the exact same thing, copy it, come here, paste it, and I will say there is no significant improvement with method of loci. Agree or disagree? If I run this, what answer do we get, my people? According to our common sense, this is also correct. Initially, people were on an average only able to remember 11 cities out of 20 cities. But now they are able to remember 15. Anybody who has seen basic arithmetic will tell you this is a significant improvement, right? Yes or no? Everybody, please tell me. This is a very critical time for me to understand. You guys have understood it. Okay, if I want to make this answer as accept null hypothesis, can I say that if initially in the beginning, before taking the method of loci, you were able to remember up to 11, but after taking the method of loci, you are able to remember 12. Is 1 point improvement a significant difference? What is maybe remembering one extra keyword a significant improvement? What is the answer? There is no significant improvement with method of loci. Did we prove our theorem well, or not theorem? I mean, did we prove our analysis of t-test well? That even that is saying the same thing? Makes sense? Do you understand? Everybody? Did you get the concept, my people? Everybody got the concept? The concept was very simple. If initially you are able to do something and after you are able to do something, if your answer is significant, t-test will automatically tell you if it's a significant improvement or not a significant improvement. Did everybody get the concept? What are we doing? How are we playing in this t-test part? In this else condition, p-value is greater than alpha. That's why it went to fail or reject, fail to reject, accept or fail to reject. Yes. That's why it went into the else condition. If it was less than alpha, it would have done the reject null hypothesis. I hope everybody got it. I am just going to move forward with my with the explanation of z-test. I believe this is crucial for all of you to understand. This t-test, z-test, f-test. Okay, listen to me very carefully. Do you see this image that I'm gonna, okay, right here. I'm gonna copy this. Why is it? Okay, let me give you 1 second. I'm gonna copy this image and I'm gonna paste it here. Is this visible to you, my people? All of you? Yes or no? Okay. This is the reason or the special condition where t-test is allowed to be used greater than 30. I'll tell you guys an example. In the problem statement that you're working on, do you know the population standard deviation? For the problem statement that is given to you, in the problem statement, have they given you the value of population variance or population standard deviation? Remember, if variance is given, can I calculate standard deviation? Yes or no? What if population variance is known? Okay. Given is simply meaning known. If you know population variance or standard deviation, what's the importance? Yes, I know the population variance or the standard deviation. Can I say population variance and population standard deviations are nothing but population parameter? So I'm just going to call them param. What? Population parameter? Okay, very good. If you are given the population parameter in the question, is the sample size above 30? If the sample size is above 30, what test will you implement, my people? I told you in the beginning of the class, if the sample size is greater than 30, what test do we use? Z-test. We close our eyes and we use Z-test. If the sample size is greater than 30, we use Z-test. Everybody knows this. If the sample size is less than 30, what test do we use? T-test. But in any problem statement, if you don't know the population variance, if you don't know the population standard deviation, then what test will you implement? Which test will you implement? T-test. And in this particular test, because you don't know the population variance or standard deviation, what do? You don't care about the sample size. Are we clear? Only if the population variance or standard deviation is kindly known, certainly known, you can do this. If not, you have to calculate or you have to run t-test, and this time you don't care about the sample size. Does that make sense? Are we clear? Can somebody tell me, I'm going to ask you guys a question. Is it okay if I ask you all a question, a small question? What do you mean by do you know population standard deviation? Will this be given to you in the problem? If you think that is the understanding, I'm going to ask you guys a very simple question. Everybody please answer. Can you know population standard deviation always? This is only possible if the test is already done. Yes or no? Do you remember in all the examples I told you, there was already some research and test conducted already in the past, and we are taking its mu value, the standard mean, the population mean or the population variance or the population standard deviation, because that test has already been conducted and validated. Do you know this? Did you notice in independent sample t-test, paired t-test, and all the examples, we already had conducted some interview or some survey, and we were taking the previous survey as a base example. So if it is conducted, then we do know the population standard deviation, right? Or population mean or population variance. In all three values, if we knew, we were able to do t-test exactly like this, right? This was the flow we have always taken to do the test. Agree? This flow, my people, is usually rare. And in your careers, you will not usually go with this particular route. It's possible to go through that route, but you're not going to go through it. But it's good to know. So are you clear that, of course, t-test you can do only if the sample size is less than or equal to 30, but there are special conditions when t-test can be implemented for size greater than 30. Also, are we clear? I have written it down in the notes today. Yesterday, I uploaded the notes here like this. Do you see this particular thing, my people? Do you see this particular image or the video that I've uploaded? You guys are able to see this, right? These are my handwritten notes that I have given it to you. Here, do you see, my people? I've already written something called, give me 1 second. Yeah, do you see this graph? Do you see this graph? If you zoom in, do you know population standard deviation? Yes, sample size greater than 30. This part of the code, I've already mentioned this. So you can take this also as a reference. Okay? Are we clear? Are we clear until here? Let me not push your, let me not confuse you even further. Are we clear until here? Do I have everyone's blessing in the class? Good. Okay. So now my question is very, very simple. Okay? Make your understanding slightly different. Okay? We have done t-test, and you know the difference in t-test and z-test was what, my people? The sample size is less than 30 and the sample size is greater than 30. Both t-test and z-test are parametric test. What do you mean by parametric, my people? What did I tell you about parametric in the beginning of the class? In the very beginning of the class, what was the difference of parametric test and non-parametric test? What was it? What do you mean by parametric test? Does everybody remember? If your data follows what distribution? Normal distribution. Doing a test on such kind of data is called parametric test. What is the difference or the common between t-test and z-test? They are both a test to measure the mean between two samples. Are we clear? Mean between two different samples. It's the same exact test, but the only difference is you take two samples and you calculate the mean. You take two sample, calculate the mean. Only the sample size in t-test could be less than 30 and the sample size could be greater than 30. Agree or disagree? Until here, are we clear? Until here, are we clear? Clear until here? Okay. So now what we are going to implement, my people, is we are going to implement something called z-test. In this z-test, Z-test is a parametric test that is used to calculate the means between two groups or two different samples. It is exactly like t-test, but the only difference between t-test and z-test will be the sample size. The way and the number of sample size that we take is higher in z-test versus in t-test. What do you mean by that, sir? Let's take a very simple example, right? What you remember in the very beginning, I gave you guys an example of the shampoo bottle company. If you are a chocolate manufacturing company, you are able to manufacture a chocolate. Every chocolate is supposed to be like a standard a standard 80-gram bar, and then we were able to compare. This is an example of one sample t-test, independent sample t-test, or pair t-test. Is it one sample t-test, independent sample t-test, or pair t-test? It's an example of one sample t-test. So remember, in z-test you have one sample z-test, independent sample z-test, and paired z-test. Can somebody tell me what is the difference between both two? What is the difference between one sample t-test and one sample z-test? The only major difference is the sample size. Thank you so much. That is amazing. Only difference is sample size. That's it. Nothing much. Just a sample size. So let's take a very simple example. Okay. And I'm also going to type it down for all of you so that we don't have to do it. Okay. Let's take a very simple example, right? Why am I not able to run this? Give me 1 second. Option, or I will have to type it down. A factory has, I was telling you guys about a small question that I have thought of writing it down. Okay. So let's say we have a very simple question. A simple factory has a machine that dispenses say 80 ml of fluid. Okay. So let's write it down, Jupyter notebook. Okay. So let's say that a factory has a machine that dispenses 80 ml of shampoo, which is also fluid, in a bottle. Okay. So we have a factory that dispenses 80 ml of fluid in a bottle. Let's make the question a little bit more interesting. So we can say that we have given a standard value of 80 ml to be dispensed in the fluid, and we can actually say stuff like, oh, we can actually prove that the machine is working fine or not. We can do that. So let's say that the average amount of fluid that is dispensed by the machine, based on some random sample of 40 to 43 sample size, they have come up with the example that it dispenses certain amount of fluid. Okay. So a factory has a machine that dispenses 80 ml of shampoo fluid in a bottle. While taking a sample of, let's take it like that, while taking a sample of 40 bottles, 40 bottles, 40 BOTTLES, an employee, a factory worker noticed that the sample mean was about 78 ml. Okay. With a standard deviation of 14 ml, because not even 40 ml, we can keep it to very, very less. I mean, it should be, because if 80 ml of fluid gets dispensed in a machine, I don't think the machine makes a mistake of dispensing more than about 1 ml to 2 ml. Let's keep the example practical. So maybe 2.5 ml. Okay. With a standard deviation of 2.5 ml, calculate if there is a difference in the actual dispensed fluid from the original standard set, DARD set. Okay. At a confidence interval of 95%. Did you guys understand this question? We have a machine, and the machine's job is to dispense 80 ml of fluid every time. 80 ml of fluid means every time a machine is being manufactured in this particular factory, what is the disposition or the dispensing fluid capability? It's 80 ml. Every time a machine is injecting a fluid in a bottle, it injects 80 ml of fluid. But what they have observed is they took a random group of 40 bottles, and when they measured the mean, they came up to be about 78 ml, and the deviation is about 2.5 ml, meaning some bottles are above 80, some bottles are below 80, right? So we need to write first of all the null and alternate hypothesis, and first of all we need to prove is the machine working properly or not. So rather than saying if there is a difference in actual dispensation or fluid or not, we can also prove if the machine works fine or not. Okay, we can actually prove machine working fine or not. Machine working fine or not. I'll tell you how we can do that. Okay, so first of all, this is the question. From the given question, did you understand the question? First of all, everybody, what the question is? It's a standard question. In your example, what is the data that is given to us? What data has the code or the data is, what data is it given to us? What is our population mean in the entire data? According to this particular example, what data is given to us? Yes. What is my sample mean? Okay, so if I write down the data here, what is my sample mean in this example? Is it 78 ml? What is my population mean? 80 ml. What next? What else is given? Standard deviation of what is given? 2.5 ml. So can I say 2.5? What else is given? Sample size is equal to 40. And can I say alpha equals to 0.05? Agree or disagree? Okay. My people, do you remember I took you guys through an example of t-test manually? I showed you guys how to solve a manual t-test problem, and then we did 3 code exercises. In this class, I'm going to first show you the example of z-test in code, then we will do it manually also, so that we get both code understanding and math understanding. Okay, because you remember in the beginning of the class I told you confidence interval is equal to x bar plus or minus z into s divided by root of n, and for some reason for z value at 95% was 1.96. Do you remember? And I told you that please give me some time, I will prove this to you how it is 1.96. Have you forgotten or do you remember? You remember we had to learn this. I told you, don't worry, I will teach you how to calculate this 1.96 using the table. Yeah. Well, we have not done that yet. So please remember that we are yet to finish that. Is this the data that we have? Sample mean, population mean, standard deviation, alpha, and all of that stuff. In order to implement z-test, the only difference is you import NumPy as NP. Okay, same exact thing, no changes. But if you want to implement z-test from SciPy dot stats, you have to import something called norm. Okay, you have to import something called normalization. Anyways, a normal distribution of normalizer. This is my data. What do I need to calculate here, my people? What is the formula of z-test? Okay, my people, the formula for t-test was x minus mu divided by s divided by root of n. Do you remember? We had this. T-test is equal to x bar minus mu divided by s divided by root of n. The formula for z-test is x bar minus mu divided by sigma divided by root of n. What is s in statistics and sigma in statistics? What standard deviation? S is population or sample. Is S sample standard deviation or population standard deviation? Sigma sample or population? S is for sample and sigma is for, I want to show you an example. Okay, look at it very carefully. Variance formula. Oops. Give me 1 second. Give me 1 second. Variance formula. Okay, let's click on this. Let's look at sample, population, and oh, nice, right here. Okay, whenever you have the term sample, is the Greek letter, no, not Greek letter. Do you have a letter called S? So S stands for sample or population? Sample. Very nice, very nice, very nice. Very good. Absolutely correct. And this sigma stands for what, my people? This should stand for population. This should stand for sample. So whenever we do z-test, look at it very carefully, okay? Z-test formula. Okay, I'm just going to click on z-test formula. So do you see, is this the correct formula that I wrote down in the same exact class for you? Standard deviation of population, number of observation, which is sample, mean of population, mean of sample. Have I written the same thing here in front of you? X bar minus mu divided by sigma by root of n, and t-test is nothing but, let me also take z-test formula, t-test formula, okay, so that we can have both of them together, okay, side by side to each other. Yeah. Is this t-test formula and z-test formula, my people? Let's take a better one example. Yeah, I think this is 1 sample, 2 sample. I don't want this. I want a better example. Give me 1 second. I want to show you guys the formula for both. Okay, we've given it here. Okay, copy it and paste it here. Give me 1 second. Do you see this image in front of you? You have Z is equal to X bar minus mu divided by sigma. Sigma represents population standard deviation. S represents sample standard deviation. I hope this first difference is clear between Z-test and T-test formula. The formula remains the same. It's the what standard deviation are you considering? Is it sample standard deviation or not that? So in the code, if I need to calculate Z-stat equals to sample mean minus population mean, can I say this is according to the formula? Sample mean minus population mean divided by standard deviation, which is this particular value called 2.5, divided by NP dot square root of n, SQRT of n. Is this correct? Is this code correct? Sample mean minus population mean divided by whatever standard deviation you have given me divided by NP dot square root of n. Is this formula correct? So can I say print of F double quote of Z underscore statistics? Z stat is colon bracket Z underscore stat. Okay, so Z underscore stat. What Z statistics value did I get, my people? Minus 5.05 something something. Agree or disagree? In the example of actuality or in the actual code example, do you need critical value? In your actual code, do you need critical value? Whenever you are coding your solution up, will you ever need critical value in your life? No. What? But can I still teach you how to print critical value for Z-test? Because it is for your own benefit. You can print it whenever you want. Whenever you want to print critical value, what did I tell you? The name of the function will remain same, right? So can I take the critical value code from here, copy it, come exactly in the bottom and paste it here? I'm just going to come here and paste it. Instead of calling it T critical, let's call it Z critical. Let's call it Z critical. But I will not be able to use T anymore, correct? I need to use norm.ppf, but ppf, right? .ppf is a method to print your critical value in every part of the code. T-test, Z-test, F-test does not matter. You will always use .ppf. Agree or disagree? But in this part of the Z critical code, do we have any degree of freedom in Z-test? That is one more difference. In Z-test, there is no concept of degree of freedom. You don't calculate degree of freedom. Have I calculated any degree of freedom here? Did I calculate any degree of freedom here? Absolutely not. So if I come here and print Z critical, what is my answer, my people? 1.96. But have I calculated the left tail or right tail? Have I calculated the lower bound or upper bound? Which bound have I calculated? The left. No. We have only calculated left. If I want to print right, Z critical underscore left, okay, I'm going to take the whole code. I'm going to paste it here and I'm going to say Z critical underscore right. If you want to calculate right, do you need to subtract 1 minus alpha by 2? Agree or disagree? So this is Z critical left. Okay, Z critical underscore left. I'm going to take the entire code, come to the bottom, and I'm going to say Z critical right, R-I-G-H-T, and I'm going to make this as R-I-G-H-T. If I print this, are we clear? The right tail and the left tail, 1.96 and minus 1.96. We got both the answer. The left part of the upper bound and the lower bound. Let's also say left is equal to lower bound, and this is called as an upper bound. Can I say this, my people? This is going to be lower bound, upper bound. Does it make sense? Am I talking something which is not understandable by anybody? This is the lower bound value of Z critical, the one that you will get from the table that I will teach you, and this is the left part. Are we clear until this part? But do you need critical value at all in any code of Z-test? We don't. It is absolutely of no importance to me. Agree or disagree? I'm not going to be using it anymore. What is the next thing that I calculate here? I just need to calculate something called P underscore value. How do we calculate P value? To calculate P value for T-stats, for Z statistics, if I do 2 into multiply by, what does this mean? If I do 2 multiply by something like 1 minus norm dot, okay, norm dot CDF inside this abs of Z underscore stat, whatever Z score value you have calculated, Z stat. Is this the way to write or calculate P value in Z statistics? I have not decided this. This is just how it is written in the syntax. 2 into 1 minus norm.cdf of part and absolute value of z statistics. If I print the p-value, p_value, what answer do I get, my people? Am I getting 4.2 something 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 into 10 to the power of minus 7? If my p-value is less than alpha, okay, if I take this particular thing, copy it, paste it exactly here, okay, and print it here, I just need to remove this method of loci part and change it, method of loci part, change it. Now you guys tell me, what should I write here? If I reject null hypothesis, what does it mean? If I reject null hypothesis, okay, let's write down hypothesis for this particular question, okay? For this particular question, let's write down hypothesis. This is the question that is given to me. Copy this particular thing and paste it here. For this particular question, help me write the hypothesis, right? Tell me, for this particular question, what would be the null hypothesis? The null hypothesis would be that the average disposition in the bottle is still 80 ml, correct? That means the machine works fine, correct? The null hypothesis is machine working fine. Don't worry, everything is fine. In the alternate hypothesis, the null value, the mu value is no longer 80. It is not dispensing 80, machine not working fine. So if I reject null hypothesis, can I say machine not working fine? Machine not working fine. And can I say here machine working fine? Is this correct according to all of you? If I run this, what is the answer? What answer did it give us? Based on the data that we see, there is not much significance in the improvement, or there is no much significant disposition problem, and the answer is going to be machine is working fine. There is no problem, it is all fine. What if I change some number here? What's going to change? What number do I change so that we can get a different result here? Can I change the sample mean itself? If every bottle is supposed to have 80 ml of fluid, and then suddenly the average comes down to 60 ml, and if I run the answer, what is happening to my answer? Is it saying machine not working fine? Correct, right? You guys are understanding what I'm trying to say, right? If the machine standard value is, it is supposed to have 80 ml, and your 40 bottle sample is averaging up to 60 ml, clearly there's a problem in the machine, right? It's not dispensing, correct? So answer is machine not working fine. See, we got the answer. What if I am dispensing 75 ml? What should be the answer here, my people? Machine working fine or not fine? It will still be not fine, correct? If I run this, what answer did we get? Machine not working fine. Okay. If I make this exactly 80, what happened to my answer? What answer did we get? The machine is supposed to dispense 80 ml, and your disposition for all the sample is also 80 ml. Is the machine working fine or not fine? Because according to the standard of the company, every bottle is supposed to be 70, 80 ml. But now the actual bottle is only implementing 70. What should be my answer here? Machine not working fine. Because how much gap exists between the standard and the actual value? 2 ml gap, right? There exists a 2 ml gap. 2 milliliters of difference exist between the value. Agree or disagree? Every bottle is supposed to be 80 ml, but is it actually 80 ml? Would it be 80 ml? No, right? Because it is not exactly 80 ml. Can I say there is a clear difference in all the samples? All the samples are not exactly 80. Makes sense? So did we just print or prove using statistics if we are getting a similar results or not? Tell me one thing. If I was having it 79 ml, and if I run this, is it still not giving me machine not working fine? Agree or disagree? Because you still have a gap of 1 milliliter of fluid. Unless and until your answer is exactly 80 ml, your machine is not working fine. There is a problem. Are we clear? Did you get the concept, my people? Did you get the understanding? If your standard is 80 ml, and if your samples don't match up to 80 ml, there is a clear problem in the entire machine, and that is what we have proven. How did we identify this is a z-test and not a t-test? What made me identify that this is z-test, not a t-test? Because the sample size is greater than 30. Agree or disagree? The sample size that is given to me in this particular example statement is greater than 30. If the sample size is greater than 30, what do you usually go with? You go with z-test. But to be sure, you also validate whether it follows the population standard. Thank you so much, sir. Thank you so much, Suhas. Perfect. Are we clear? Did this make sense? Very good. My people, let's solve the problem manually. By the way, do we have time? Oh, we have a lot of time, right? Let's solve this problem manually and see what answers do we get. Can we do it? We did it in code. We got the answers in code. Agree or disagree? We got the whole answers in code. Now let's do it whole manually. Sir, in order to do manually, did I tell you that z-test and t-test are different? The tables of z-test. Okay, first of all, where is the question? Where is the question? Here's the question. Give me 1 second. Let's copy the question. Let's make it happen. Copy it. Come to the bottom, paste it. Is this visible to everybody? Is this question visible? I think we need to remove the hashtags. They look a little weird. Hash, remove the hashtag, remove the hashtag, and remove the hashtag. Okay. Is this, let's take down the data. What data is given to me, my people? Is population mean given to me? Yes or no? Let's make it 100% and let's reduce the size of this. Give me 1 second. Reduce the size of this a little bit. And is population mean given to me? Yes or no? That's very nice. Population mean is what, my people? Your population mean is how much? 80 ml. Is it 80 ml or is it 78 ml? The population mean, sample mean is 78. This is 80. Let me write down in a nicer way. Give me 1 second. Population underscore mean. Population mean, is it called mu or x bar? What do you call this? A population mean is called mu, right? Is how much? 80 ml, correct? What is the sample mean that is given to me? X bar, 78 ml. What is the standard deviation that is given to me? 2.5 ml. What is going to be my confidence interval? 95%. Okay. That means my alpha will be equal to 0.05. I hope so far nobody has any confusion in the data part. Is everybody clear with the data part? Just the data part? Any confusion in the data part? What if we tweak this question and say that the machine is working fine if it is under standard deviation, and it not, it goes below or above standard deviation? That is also, Vinayak, a very good way of tweaking the question. But what you would be doing, Vinayak, is you would be shifting the value of standard deviation instead the samples. What do you say? Samples mean. In an exam or in a practical concept, okay, imagine you have a bottling company. Will you be worried about calculating the range where my range is varying, or will you be more focused on calculating the fluid disposition? Which is more in your control? Let me give an example. Imagine you are manufacturing a cookie or a chocolate bar. Okay, so example, chocolate bar. Every chocolate bar is supposed to be 80 grams of chocolate in your each chocolate bar. If you manufacture 1 lakh chocolate bars a day, it will be hard for you to calculate the standard deviation, because for which you need a lot of data. But if you take a random group of 40 chocolates, measure their weight, see, this can give me a better indication whether each chocolate bar, is it averaging out at 80, near to 80, or far away from 80? So what we do is, in such conditions, we try not to deviate or touch standard deviation. We only and only try to touch or get variations within only the average value of samples. But the standard deviation is a very clear-cut answer which is already given to us, or they have tested it and given to us. But we don't calculate it, or even if we do calculate it, we don't change it. So we only mess with just the mean, not the standard deviation. I hope it gave you an idea. I mean, I hope it clears some question in your brain. It did? If it is, then please let me know. Is this the data that is given to me? Yes or no in the question? Yes, everyone? Very good. Step number 1. What is step number 1 always if you do hypothesis testing or inferential statistics? What is step number 1? Hypothesis, right? Writing the hypothesis. What is your null hypothesis and what is the alternate hypothesis? Agree, everybody? Mu is still 80 ml. Mu is no longer 80 ml. So that means either left or right. We consider both, left and right, right? This is step number 1. What is step number 2? So sample size n. Yeah. Oh, yeah. We did not take sample size n also, right? N is equal to 40. This is the sample size in our data. My people, step number 1 and data is clear. Are we clear until here? Until step number 1, capital N. Capital N. No, it is small n here. It's the sample, not the population size. It's the sample size. It's n. It's going to be n. What? It's not population sample. So what is step number 2? Your confidence interval is how much percent, my people? 95%. Agree? Your alpha value should be 100% minus 95%. What will be my alpha here? 0.05. Agree or disagree? Or for people whose maths is a little weak, please tell me how this is 0.05. Because 100 minus 95 will become 5%. 5% is 5 divided by 100. So alpha is 0.05. I hope this is clear to everybody. Called 0.05. Alpha is equal to 0.05. This is the significance value or significance level. I hope everyone is clear until here. Once this is done, we create step number 3, which is called decision boundary. Please remember, did I calculate any degree of freedom here? Was there any degree of freedom calculation done in this part of the code? No, sir. In Z-test, there is no concept of degree of freedom. Please remember this. So what is step number 3? Decision boundary. B-O-U-N-D-A-R-Y. Sir, what do you mean by decision boundary? Is this the normal distribution I assume my data take for all the 40 samples? Is this the normal distribution I assume my data will take for entire session? Okay. Unlike T-table, Z-table works slightly differently. Okay. You have to listen to me very carefully because I'm about to say certain things which may not make so much sense to you now, but please just listen to me. Take this normal distribution, okay, and I'm going to keep it in the side. My people, if the entire normal distribution is considered to be 100%, okay, the entire normal distribution is considered to be 100%. When alpha is equal to 0.05, this is my alpha. If I am doing two-tailed test, will alpha divide itself by 2 to the left and alpha divide itself for right? Matlab left tail will be alpha by 2, right tail will be alpha by 2. Agree or disagree? Because for two-tailed test, alpha by 2 plus alpha by 2 is alpha, correct? Because alpha by 2 plus alpha by 2 is nothing but 2 alpha by, or let's not explain it like this. Let's say alpha divided by 2 plus alpha divided by 2 collectively is alpha, right? So tell me one thing, 5% will be here 2.5% and this will be 2.5%. Agree? This will be 2.5%. The left tail will be 2.5%. The right tail will be 2.5%. Would you agree? Okay. Now tell me one thing, my people. You already know that normal distribution curves are symmetric. Agree? If I calculate just the upper bound value, just this upper bound value, I just need to put a negative sign to this number and this will become my negative bound value. Agree? My lower bound value. But to put a boundary here, this boundary stops at what, my people? Alpha by 2. This much is alpha by 2. So how much is this distance? This much distance is 100%. The whole curve is 100%. The whole thing is 100%. This section is alpha by 2. So how much will be this section? What will be this much section? This would be 100% minus alpha by 2. Make sense? Agree or disagree? Did that make sense? Okay. Let's give a very simple example. This is a bar of chocolate. Let's call this chocolate to be 10 centimeter. Agree? Everybody, let's call the entire chocolate to be 10 centimeter in length. This much part of the chocolate. This much part of the chocolate is 3 centimeter. Example. Then this part here, this distance to this distance. How much is this? Isn't this 10 minus 3? Yes or no? If the entire thing is 10, this is 3. Isn't this 10 minus 3? If the entire thing is 100%, this is alpha by 2. Isn't this going to be this much to this going to be 100% minus alpha by 2? Does that make sense? This part will be 100 minus alpha by 2. Yes or no? Make sense? 100% minus alpha by 2 is how much percent? 2.5%. What is 100% minus 2.5%? What is 100% minus 2.5%? 97.50%. If you convert that into number, will it become 0.9750? Agree or disagree? Is this much calculation clear? Until here, are you clear? 0.9750. Until here, are you clear? Okay. If I go to Z table, listen to me very carefully, okay? Z table. If I go to Z table, go to images. Actually, I can go to any Z table. Let's go here. Okay. Have we cut the left part of the table or right part of the table? How much have we cut? We have cut this part, right? The right part, correct? We have not cut the left part. We have cut the right part. In the right part, okay, if I take an image, take the entire thing, copy, okay, table copy, come here, go to the very left, take this table and paste it here. Is this table visible to all of you? Is this visible to all of you now? Okay. Please give 100% attention and focus here. You're getting an answer called 0.9750 somewhere here. Can you see this? You're getting a reading called 0.9750 here. This 0.970 is related to which row? 1.9. Agree? It's matching up at a row number called 1.9. If you go up, is it matching up to a column number called 0.06? If you add 1.9 plus 0.06, what do you get? 1.96. Yes. So did you get 1.96 for this number? For the positive cut? Just take the negative of it and put it in the left, negative 1.96. And this is your boundary. So when I told you for the confidence interval of 95%, your Z value is 1.96. This is how we calculated it. Are we clear today? Finally, you got one satisfaction that one unanswered question is done. Did you understand the logic behind it? Why are we doing? Because there is no degree of freedom in Z test. There is no degree of freedom in Z test. That is why we have to do 100% minus alpha by 2 to get the upper bound with which we calculate the lower bound also. Any confusion so far, my people, my beautiful, beautiful students? Did I also teach you how to calculate 1.96 using code? This is how you write the code. This is how we calculate this particular thing called Z critical left is equal to norm.ppf. Z critical right is equal to norm.ppf 1 minus alpha by 2. You calculate something called Z critical value. And if I run this, do you see we are getting minus 1.95? If you round this number 95996,386, you will get 96, right? 1.96. So your answer will be 1.96 only. If you round off 95555 something, you get a 96. Are we clear? Okay. My people, look at this table. Okay. Please carefully look at this part of the table. Okay. Just look at this part of the table. If I had cut the left part of this, okay, left part of this particular thing, what would you change in your example? How would we have calculated a number? If I would have just taken this part of the code, wouldn't it have been 0? Okay, 2.5%, 2.5 divided by 100. What is the answer? 2.5 divided by 100. What is the answer? What is this number called? Yes, 2.5 divided by 100. You will get a least significant zero, right? 0.025 because the 2.5 itself is 25 divided by 10, right? So you get 0.025. In this part of the code, where do you get 0.025? Where do you get 0.025? I'm going to take a photo of this. Give me 1 second. Whole code, copy. And this table must be visible to you, correct? Okay, give me 1 second. Is this visible to all of you? Do you get a number called 0.0250 here? Yes or no? What to the left hand side, what is mapping here? Negative 1.9. Yes. To the top, do you get 0.06? If you add them together, what do you get? Not plus 0.06, minus 1.9 minus 0.06, because you want to keep them together, not plus. What do you get? My question to you is very, very simple. You took a normal distribution. Agree or disagree? You took a normal distribution. You can either calculate the lower bound. If you want to calculate from the lower bound, it is already by default alpha by 2. You know this. Agree? But if you want to take from the upper bound, it is going to be cutting here. But because this is alpha by 2 and the whole thing is 100% of the curve, this distance is 100% minus alpha by 2. Now my question to you is very simple. Sir, why are we cutting here? Isn't it the question, my people? I understand we are doing this whole thing and we are cutting it here. But did you understand why are we cutting? What to create what? Why are we creating a boundary? To get the upper bound and the lower bound. I hope this much is clear. It's a basic answer. To get the concept of upper bound and lower bound, we calculate this much so that we get the distance of what the upper bound starts at and where the lower bound starts at. I hope that is clear to everybody. You can either take it to the left side or right side to calculate both the interval of the values. Are we clear? What did we calculate it from both alpha by 2 and 100% minus alpha by 2 both? Until this part is clear, my people, what value did we get from Z table? What is the Z critical value did we get? 1.96, yes or no? Now, I calculated Z critical value. What is my Z statistic value using the code, my people? My Z stat value was minus 2.5, correct? We have calculated it here using the formula. Minus 2.5 in the normal distribution curve. If your normal distribution curve upper bound is plus 1.96 and the lower bound is minus 1.96, okay, 96, minus 2 comes somewhere here, Alva. Minus 2 comes somewhere here, no? So is it in the rejection region or acceptance region? What answer did we get? Let's make it 78, not 79, even if it make it 78. What answer did we get? What? Reject. What? Did we get reject? Because minus 2 comes in the rejection region. Hence, we have rejected the null hypothesis. Did we get the same answer? When we did it manually, we did it code-wise. Are the answers matching? Yes. What? In the manual code, we compare Z critical with Z statistic. In the code, we compare p-value and alpha. Are we clear so far? What? So I have answered one bigger thing that I had pushed from a very long period of time to teach you why did we get Z value of 95%, 1.96. Will you please remember now how we got 1.96 here? Without any confusion, the Z-score value for 95% confidence interval is 1.96 plus or minus 1.96. Are we clear? We are left with one important thing. Everybody, please do not forget. What is that? You remember in this example of this paired t-test, we wanted to do one sample t-test. In this particular code, we wanted to do one tail. Sir, we want to do one tail t-test in this one. You remember? This is pending, my people. Please do not forget, okay? This is pending. This example of doing the whole thing is pending. So this part we will learn, okay? What is the time now? It's 8:58. This is going to take a lot of time. And now doing 1 minus alpha is also clear. Yes, that's perfect. Okay. My people, did you understand the concept of t-test and z-test? If I ask you guys a very simple question, I want you to ignore everything, not ignore everything I've taught you, but forget it for a second, whatever I've taught you. Whatever I've taught you, forget all the mathematics and all of that for a reason, keep it separate. My question to all of you is, the reason you are learning inferential statistics is what exactly? Why are you learning inferential statistics, everybody? What is the main core reason for it? To become data scientist is not... That's correct, that's good. Why? To what? You guys are amazing. Some really nice answers. Validate your population parameters, right? The only reason I am showing you the whole thing, learning the whole statistics is because in the real life scenarios, in the real world situation, you very rarely get to see population that is small. Would you agree or disagree? In the real world scenario, in your company also, example, all of you are working for a company called Microsoft. Okay? Listen to me carefully. You are all working for a company called Microsoft. Okay? This Microsoft company manufactures softwares. Okay? Suppose you made a pythrope of Pepcell. Okay, suppose you have made an web, a software like that. You want to know how many people in the world will use it. Can you make that judgment? Or on how helpful it is, how many people might use it, what is going to be my potential target audience? You can't do that. You can only make a judgment using the sample, right? The happiness score, the ease of business, and all of that, you can only make sense with the sample. So every company you are going to work for in data science, only rare will they have a population which is small, but usually they will have a very target audience, big target audience, and a small sample size. So using the sample, making a judgment on your population, and knowing different ways, how many different types of ways exist inside it, t-test, z-test, f-test, ANOVA, chi-square, and all of that. Learning all of this is because you want to make a sense of the population using the sample. That is the only reason you are learning all of this. So in the entire example that I taught you, did we not made sense on the population based on the sample? Did it anywhere give me population standard deviation, population mean, population something? No, we had sample standard deviation, sometimes population standard deviation. The data jumps between population and sample, and our job is to make it understand whether the answers are significant or not significant. That is your job with inferential statistics. Do not get lost in the mathematics, the code, get overwhelmed and think this is so complicated. It is not. Am I the only inferential stats knowledge out there in the world? No. Do I recommend you guys should absolutely read some blogs, some videos to validate whatever I taught you? At the same time, learn something extra, maybe with different example. The way I give examples and way somebody gives an example, won't somewhere it will click. Whatever knowledge I have given you, you have received 15% to 20%. Won't it be better if you read somebody else's blog or some other YouTube, and when you are able to relate with my knowledge, oh, I remember Rudra sir had taught us p-value like this, he's teaching p-value like this, now I understand. Won't this click in your brain, my people? Am I lying, or am I saying something weird, or am I making sense? Please do that. I recommend you do that. Read some blogs, read some materials. You will be able to relate with my content. How Rudra sir is teaching something, how this guy is saying something. Oh, now I'm able to understand. Are we clear, my people? Will you do this for me? Yes. Good. Nice. Good. So my people, what I'm going to do is we are going to try what you tell. Can we call it applied stats? This is applied stats, Rajkumar. This is whatever you're learning right now is applied stats. You will be getting a question like this in your career also, in your job interview also, and this is how you apply it.
Just a quick info, guys. Intellipaat offers data analytics course in collaboration with IIT and Powertech. Through this course, you will master Power BI, data modeling, data mining, and much more from the IIT Madras faculty and industry expert. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to a new height. So visit the course page link given in the description and take the first step towards the career in the field of data analytics.
So the class that we are going to be taking today is going to be very, very simple. First, we are going to learn what is z-test for proportion. That will give you a very good idea on how z-tests are performed. Then we have to implement something called f-test, right? F-test, to make f-test better, to make it more versatile, to make it much more compatible on multiple complicated data, we have another test called ANOVA. Now remember, ANOVA, analysis of variance, is a part of f-test. It's not separate from f-test. We keep it separate because to have the make the understanding very, very simple. And after ANOVA, we have something called chi-square, right? So these are the tests that we are going to be completing today, right? What talking about z-test for proportions, right? This is one of the most important tests that you're going to be talking about. This is called z-test of proportion or for proportion. right? But in order to understand what is z-test for proportion, our life is very simple, right? What do you mean by the term proportion, right? Proportion, can I say, does it mean the word ratio? If I very simply in English say proportion, what do you mean by that? I'll give you guys an example. To make a very good biryani, okay? Example, you need the right amount of proportion of rice with masala, right? Say 4 cups of rice with 1 cup of masala. Can I say that the ratio is at 4:1 ratio? If you want to make good tea, like for example, if you really want to make good tea, can I say 5 cups of milk and 1 cup of water will make like a right proportion of fluid with which we can make tea? So proportions are predominantly what we call as ratios. Ratios are important for us to deal with, right? So why are we learning proportions, or what seems to be the use of proportions? Why are they important? The reason they are important is because I have a small question and we want to solve it. What is that question? The question seems very, very simple, right? So if we talk about z-test for proportions, right? Imagine, my people, we have a very simple example, right? In a sample survey, right? Oops, give me 1 second. You guys are able to see my whiteboard, right? Like, you guys can see the whiteboard, right? Okay. Good. Now, in a sample survey, the question is in a sample survey conducted in, let's say, Bangalore, 960 people out of 1860, 1890, some people, 960 out of 1860 people, I think they are both odd values, were vegetarians. Okay. In a sample survey conducted in Bangalore, 960 out of 1860 people were vegetarians and others were non-vegetarians, right? Can you calculate if vegetarian eaters and non-vegetarian eaters are in equal proportions at 95% confidence interval? Okay. See, my people, look at this question. Okay. This question is, in a sample survey conducted in Bangalore, okay, out of 1860 people they conducted the survey from, about 960 people turned out to be vegetarians out of non-vegetarians. So the rest of them were non-vegetarians. We want to understand whether the proportions of vegetarian peoples and non-vegetarians, are they equal or not equal? So it's a very simple question. The question is very, very simple. It says, out of the survey and the research that is conducted, 1860 people and 960 people, right, among both of them, are they equally proportional in the entire population, or are they not? So I'm going to ask you a question, right? In a very simple sense, if you just take this data, there is totally 1860 people and 960 people out of it. So out of 1860, if you divide by 960, what do you get? So suppose 1860 you divided by 960, what do you get? What number do you get here? 1860 by 960. So 1860 by 960, right? 960. What do you get? You get 1.93. But that's not what we are supposed to do. Because if you want to calculate proportion, it is the smaller number by bigger number, not the bigger number by smaller number, right? If you want to calculate percentage out of something, you do the reverse operation, right? So you have to do 960 divided by 1860. What happens with this? You get 51. It means what? The vegetarians people and non-vegetarian people are approximately 51% of each other, right? Vegetarians are 51% and the rest are 49%, right? Is 51% closer to 50 or 49% closer to 50? Are these numbers closer to 50? So the answer that we will get will be significant, right? Significant. They are both the vegetarians and non-vegetarians are almost equal in count. Isn't that the answer that we are supposed to get? Because the distance or the difference is not that much, or the difference is not that vast, right? So in case if you ever get a question on proportions, you are supposed to deal with it very simply. So the very first thing you do is you import NumPy as NP. Very simple baseline. Calling this particular library is very, very important. But this time you will be importing not SciPy, but you will be importing stats model. Specifically in stats model, you import a package called stats dot. You have to use something called proportion. And from proportion, you import something called z-test of proportion. So you have to import something called proportions z-test. This library stats model is different from SciPy. SciPy is used differently, stats model is used differently. Pretty much the functions, the methods, the way to implement it is very, very same. Let's take an example. Let's take the data, okay? Vegetarian underscore count. How many people are vegetarians in my example, my people? What was the vegetarian count? And what was the total population? What is the total population of the people? So vegetarian is how many? 960 people, right? Vegetarian. What is the total population? 1860. This is the data. My people, whenever you calculate the difference, right? P underscore hat, whatever you calculated now, vegetarian count divided by total population. You got what answer when you divided this value? Vegetarian count divided by this. So for example, if I go ahead and print P hat, what number did we get? Remember that whenever you calculate proportion, it is always smaller numerator divided by larger denominator, correct? Not P not 1860 divided by 960, not this. This is going to give us the ratio of something else which we don't want. This is what we did. So this was the value of P hat. Now, what is your null hypothesis and what is your alternate hypothesis, right? So my null hypothesis would be very, very simple. The proportions of vegetarians and non-vegetarians are 50%. So proportion of vegetarian and non-vegetarian eaters are almost or equal to, or vegetarians are equal to 0.50 or 50%. What would be my alternate? Proportion of vegetarians and non-vegetarians are not equal to 50%, right? Copy and paste. Are not equal to 50%, because here one of the questions is equal proportion. Equal proportion means we want to check when they are equal to each other. When you take 100% and divide it by 2, what do you get? When you take 100% and divide it by 2, do you get 50? Meaning vegetarians would be 50 and non-vegetarians would be 50. Agree? Vegetarians would be 50, non-vegetarians would be 50, right? Now, what we have done is we've created our null hypothesis and our alternate hypothesis. Sir, how do we actually run it? Very, very simple. What confidence interval have they given us to solve it on? Let's say for some reason, today we don't want to do it at 95%, we'll do it at 99%. If your confidence interval is 99%, what is your alpha? If your confidence interval is 99%, what will be my alpha? My alpha will be 0.01%. Agree or disagree? So if you want to implement z-test of proportion, the first thing you will write is z underscore statistics comma p underscore value equals to proportions z-test. You call it like this and you put a bracket here. The first thing you have to pass is, are you testing for vegetarians or non-vegetarians? For vegetarians. So the variable here is count equals to, you have to pass the vegetarian count, bracket, press enter, which is the next particular value. Total number of observation, your entire total data side is called knobs. My people, remember knobs full form is number of observations. So you will pass something called total population as your total number of observation. In this example, are we doing for equal proportion or unequal proportion? We are doing a test for equal proportion. So what do? You pass another variable called value equals to 0.50. Very, very simple. And you put another variable, another parameter called alternative equals to, and in this part, my people, whenever there is no information for greater, greater than greatest, lesser, lesser than least, when you have certain things like this, what tail do we prefer so that we get a safer answer? For getting the answers that are safer for both the tails, rather than implementing one specifically two-tailed. So instead of this, we say two-sided, which is basically two-tailed. So what did we do here? In the z-test for proportions formula, we took the value of z-test, we took the value of p-value, and we got this beautiful method called proportion z-test, which takes count equals to vegetarian, number of observation is total population, value equals to 0.50, which is equal proportions, alternative equals to two-sided. So if I, rather than print z-stat and p-value, if I come here, copy the whole thing, if p-value less than alpha, exact same code, come over here, but just remove the null part and alternate part. So I'm just going to remove it and take this part out also. So my people, in the z-test for proportions part, vegetarians and non-vegetarians are equally popular or not equally popular? If you write this reject null hypothesis, so we have to reverse the conditions, right, for null and alternate. So proportions of vegetarians and non-vegetarians are not proportional, right? So when you do reject null hypothesis, what do? Proportions of or vegetarians and non-vegetarians are what, my people? What are not what? Equally popular or follows 0.50 50% of each other. If I copy the whole thing and paste it here and say are equally popular, because we have to reverse the conditions. If I run this answer, what answer are you going to be expecting? Is vegetarian count divided by non-vegetarian count mean they are equally proportional to each other? That means the numbers are closer to each other. Agree? Vegetarians divided by non-vegetarians, that means the whole thing is closer to each other. So if we run this answer, what do you get? What? Don't worry. Vegetarians and non-vegetarians are equally popular or equal in proportions, because when you divide 960 divided by 1860, they are equal in proportions. Agree or disagree? But my people, for some joy, if I remove 960 and make it 200, are they equal in proportion now? So if I run this answer, what answer am I supposed to get? Is it accept or reject? Would it be accept the null hypothesis or reject? What did we get? Did we get reject? That vegetarians and non-vegetarians are not equally popular. My people, 200 is how many percentage of 1860? Can somebody tell me? 200 is what percentage of 1860? Can somebody tell me? About 11%, 10%? I'm assuming about 10%. Would you agree with this statement? If you divide 200 by 1860, what answer do you get? Faster, what answer do you get? About 10%? Okay. My people, can I say that in the entire question, can I make small changes? Is vegetarian 20% or 10% of the other population? Can I make that statement? Vegetarians are 10% of the rest population. From the entire population, vegetarians are only 10% of the count. Agree or disagree? Because you have told me that the answer is 10.75. So I will take 11%. So can I take the proportions value as 11%, and now if I run the answer, did I get it? Did I get are equally popular or at 11% popular? Did you understand what I did here? Are vegetarian percent, see here, first we were doing equal proportions, correct? 50% each. 50% each. But here, vegetarians are how many percentage proportions to other people or non-vegetarians people? 11%, right? So did I not change my value from 50 to 11? What does that make sense? So can I make the statement like this? Are vegetarians about 25% of non-vegetarian people? Is this the correct statement? Is this the right statement? If you are doing a survey in Bangalore, listen to me, everybody. If you are doing a survey in Bangalore, you'd found out that out of 1,860 people you met, only 200 people were vegetarian. You want to test at least is 1/4 or 1/4 people vegetarian? If I run this answer, what answer do you get? Not equally popular, meaning vegetarians are not 1/4 of non-vegetarian people. They are even lesser. The number has less significance, or the numbers are much more lesser. Did you understand? You can manipulate this particular number called value depending on what proportions you want to test. 25%, 75%, 50%, 100%. You can change the value and your answer will start popping up in that same exact fashion. What did we get it? Are you clear? Proportions test is a test to validate proportions with respect to the entire data. Are we clear, my people? Give me yes and a no. Did everyone wake up? Good morning, everyone. Are we here, everyone? Good morning. Good. What? 200 divided by 1860, everyone. What is the answer? 200 divided by 1860. What is the answer? What? You get approximately 10.75%, correct? 200 divided by 1.860 is approximately 10%. It means what? Vegetarians are how many percent? 200 divided by 1860, meaning 10.75%. If vegetarians are 10.75%, how many percentage will you find for non-vegetarian people? What? So 10.75, if you take 100 minus 10.75, what do you get? 89.25. So 89.25% people are non-vegetarians, correct or not? These are non-vegetarian people and these are vegetarian people, folks, correct? My question of my coding is, are vegetarians and non-vegetarians at least 45? Is the ratio or the split of vegetarians to non-vegetarians are vegetarians 25% at least or non-vegetarians 75% at least? Depending on the data did we give, are vegetarians 25% and non-vegetarian 75% distribution? No, right? No. So what answer did we get? Vegetarians and non-vegetarians are not equally popular, correct? But if I make this closer to 11%, what answer will we get now? I am asking, are vegetarians 11% and non-vegetarians whatever 100 minus 11%? Is this the proportion? The answer is yes. Vegetarians and non-vegetarians are at 11% proportions. This is what proportions z-test means. And this is how you test for multiple different proportions value. Are we clear now? Did we get this? Now, my question is very simple, okay? You have heard of a very important statement or a very important line of something called F-test, right? This is a supercritical test. You guys have studied Z-test, T-test, all of these tests, very, very important, supercritical, very, very crucial. But the difference is, sir, when we did t-test, we kind of identified one important problem, that t-test is used to calculate the means between two groups or two samples. Why don't we do this mathematically instead of stats? The reason why we cannot do mathematical in z-test of proportions is because to deal with it, it's a little complicated mathematically. Unlike t-test and z-test, z-test for proportions are not very easy. So z-test of proportions or ANOVA, analysis of variance, these are some larger problems that are very hard to just solve in the exam or to just solve it manually. So we are doing it like this. Anyways, coming back, all of you come back to F-test. I told you, when we do t-test, we calculate the means between two samples and then we find out and we analyze the answer. What is the difference in t-test and F-test? F-test is used to compare the variance between two samples. What, my people? What is the core difference? Everybody, faster. F-test is used to calculate the variance between two groups or two samples, no longer the mean. Only means are used in t-test and z-test. Agree? Yes? In t-test, the sample size is less than 30 and in z-test, the sample size can be greater than 30. This is a rule, a law. But in F-test, there is no regulation on what could be the sample size. You can take up to 30, less than 30, greater than 30. It won't make much of a difference. It will not make any changes. In fact, when you take samples in t-test, suppose if you take population called A and a population called B, A population are 30 students, B population is 30 students. You take two groups and both the groups have same number of students. In F-test, you don't have that regulation also. Suppose if you take two groups, suppose population from population A, sample A and then sample B. If sample A has 20 students, sample B can be having 14 students or 15 students or 17 students. The mismatch of numbers are also allowed. That's okay. Only to a certain extent. You can't take one sample here and 20 sample there. You can't take such a high difference. You can take a very minimal distance and that will also suffice. That minimal distance is also okay. So first of all, what did you understand about F-test, everyone? F-test is a parametric test or non-parametric test? Listen to me carefully. What do you think is F-test? F-test is what kind of test, my people? F-test is a parametric test. What kind of test? Parametric test. Meaning what? It will only consume normal distribution if the answer is correct. Correct? So t-test was parametric, z-test is parametric, F-test is parametric. Are we clear? In t-test and z-test, we took the samples as the means between two group, correct? We took mean as the differentiator when we ran the test. Agree? Very good. When we do F-test, do we anymore do mean between two samples, or do we calculate variance between two samples? What do we calculate? Variance between two samples. Is this point clear? Very good. In F-test, are there any regulations that the sample size only supposed to be this much, greater than 30, less than 30? Do we have any of those restrictions? No, sir, we don't have any of those restrictions. In fact, when we take one from one big population, if I take a sample called A, another called sample B, are they or do they need to be equal in number also? The answer is no. You can have unequal proportions also. Let's take a beautiful example and learn this. I'll give you guys a very simple example. Very simple example. My people, let's take a little food example. Okay. Imagine you have a company that manufacture Lays, okay, that manufacture Lays and Kurkure, okay. You have heard of this, right? You have heard of Lays and Kurkure, right? These are food items apparently that people prefer so much over any other food item. Imagine there is a factory that manufactures both Lays and Kurkure, okay. Lays or Bingo for that matter of fact, anything, any number is fine. So what we do, we take a data like this. In F-test, the data is actually written very, very simple. Suppose samples. So first we have Lays and then we have Kurkure. So how many different products have I chosen to compare each other from? We have taken Lays and Kurkure. We have taken two different products to compare, right? So these are the sample size. I'm also going to draw like a line here so that this is sort of simple. Okay, this is sample Lays. So sir, how many number of packets do I take the sample? Suppose I took like a very simple 10 packets of Lays and I'm taking like 30 packets of Kurkure. Okay. What I'm going to do is I'm going to calculate the mean. Okay. So what is the sample mean? So sample mean. When I took 10 packets of or Lays, I found out that 10 packets of Lays on an average have 15 grams worth of chips in it. Okay, but when I took 13 packets of Kurkure, I found out that there is an average of 14 grams of Kurkure in it. Example, right? Remember one thing, whenever you do F-test, there are two different possibilities. One, they will give you variance directly. Okay, the variance values will be given to you directly, but in the second condition, variance value will not be given to you, but they will give you something called sum of square deviation. In our example, they have given us sum of square deviation. So say sum of square deviation for this is 90 and this is 108. Now, I need to take you guys through a little old journey. Reason is, do you remember the formula for variance, my people, which is xi minus x bar the whole square divided by n minus 1 summation and this is particularly this, right? So variance is equal to this much. Do you remember summation of this is the variance formula? Square root is for standard deviation, my people. Square root is for standard deviation. Please do not be confused like that. When you take variance and you put a square root, that becomes your standard deviation. I hope you are clear with this difference. It's not square root. Variance is only this much. Okay? Okay. My question to you is very, very simple. Okay? The distance of the original data minus mean. So can I say, suppose this is my data point, this is my data point, this is my data point, and this is my data point. This is my mean value. My people, this line here, difference between the original data point minus its mean. Can I say this is my mean value called mu or x bar? From x bar, my original data called d, this is called as the distance. This is the distance between my original data and the mean value. Agree or disagree? And after which I need to calculate the distance and I need to square it. Yes or no? I need to take the distance between the mean value and the original data and take a square. This is called sum of square deviation because I will be taking sum of all the distance between this and mean value, this and mean value, this and mean value, and this and mean value. Once I take all the distance, I need to square them. So the numerator of the variance formula is called as sum of square deviation. Agree or disagree? So in your F test results, they will not give you variance directly, but they want you to calculate variance by yourself. So in our example, have they given us sum of square deviation separately? Yes or no? They have given us sum of square deviation separately. Agree or disagree? Yes, sir. They have given it to us very, very differently. So, sir, how do we solve this problem? How do you solve the problem of F test? Whatever I have told you, whenever you want to solve any test in inferential statistics, what should be your step number one without which you should never even continue the test? Hypothesis testing. Agree or disagree? The hypothesis statements. So my null hypothesis will be what, my people? That the variance of Kurkure and the variance of Lays will be what, my people? Will be equal. Agree? What? My variances will be equal. But what is my alternate hypothesis? My variance of Lays or Kurkure and my variance of Lays will not be equal of each other. Here in the question also, we have no understanding of greater than, lesser than, or anything. What is always the safest thing to assume? Two-tailed. You will never go wrong. There is no greater than, greatest, greater, lesser than, lesser, least. None of this is mentioned. So what is step number 2? Step number 1 is sorted in F test to calculate variance, to calculate variances or to calculate variance itself. Tell me, my people, what is the formula for Lays? If I want to calculate the variance of Lays, how do we calculate it? The formula is summation of xi minus x bar the whole square divided by n minus 1. This is the formula. Agree or disagree? For Lays, what is the sum of square deviation? 90. So can I say 90 divided by, what is the sample size here? What is 10? 10 minus 1 is what? 9. What is 90 divided by 9? 10. So what is the variance of Lays, my people? Is how much? 10. What? Agree or disagree? Yes. What is the variance of Kurkure KUR is equal to summation of individual data point minus its mean the whole square divided by n minus 1 is equal to, what is the sum of square deviation here? 108. 108 divided by total sample size is 13, right? Not 15, 13. Sample size is 13 divided by 12. 12 nines are 108 if I'm not wrong. Yeah. So Kurkure is how much? 9. Agree or disagree? That is the Kurkure. Yeah. Okay. Step number 3 is beautiful and amazing, and you guys will love F test more than all other tests. The formula for F test, my people, is very, very simple. F underscore statistics equal to variance 1 divided by variance 2 only and only in the condition that variance 1 is larger than variance 2. In Lay's Kurkure, sorry, in the variance of Lay's and variance of Kurkure, which variance is bigger? Which variance is larger? So can I say that the F statistic, listen to me, for variance of kurkure is larger, right, my people? The variance of Lays is larger or kurkure is larger? So variance of S of Lays, Lays, divided by S square of kurkure is equal to, my people, 10 divided by 9. Agree? What is the answer for 10 divided by 9? I think it's a recurring number. What is 10 divided by 9? 1.11. 1.111 recurring. Okay, it repeats itself. My people, because you took Lays at the top, because Lays is at the top, what is the degree of freedom of Lays? What is the degree of freedom of Lays? What is the total sample size of Lays? 10. What is 10 minus 1? 9, comma. What is the kurkure's degree of freedom? It is 13 minus 1 divided by 12. So you are supposed to write your answer like this. My F underscore statistic value for 9 comma 12 degree of freedom is 1.111 recurring value. This is the answer that you got from the F stat value. But sir, I don't know how to create a table value, or have I calculated the critical value here, my people? Did I help you calculate any critical value here? Did we do this? No. Sir, what do we do? Very simple. Come here. Go. Acha. Okay. Very good question. My people, what for the entire problem statement, let's say the confidence interval is 95%, meaning your alpha is 5%. Because you're doing a two-tailed test, your alpha divided by 2 is 2.5%, yes or no? Your alpha divided by 2 is 2.5%. So tell me one thing, if I go to F table here for 0.025, for alpha 0.025, I have this table. I'm going to take a screenshot, or I'm going to zoom this, my people. Okay, very simple. To the left hand side, to the very first, what is the degree of freedom? What is the first degree of freedom that you're supposed to compare on? 9. What is the next degree of freedom that you're supposed to compare on? 12. So in the row column, is the first value 9? Yes or no? Is the first value 9? Yes. Is the first value 9? 9 here. What is the last value? 12, correct? Right here, 12. If you match 12 and 9, what number do you get? What number do you get? 3.4358. That is the number that you're getting. So the F critical value, the F underscore critical value for your 5% alpha is 3.43 something, so 44. Did you understand? This is your F critical value and this is your F stat value. So please tell me, depending on this problem statement, do you accept the null hypothesis or reject the null hypothesis? What do you do? Is in the normal distribution value, your F critical is 3.44 and minus 3.44. And your F statistic value is 1.11. Is it in the acceptance region or rejection region? I accept the null hypothesis. If you accept the null hypothesis, what do you mean? It means that this statement that the variances of both this are very closer to each other or near to each other is true. Or I accept this hypothesis that the variance of kurkure and the variance of Lays are closer to each other. My people, isn't 9 and 10 closer to each other? Common sense. Aren't 9 and 10 closer to each other? Variances of Lays and kurkure are almost close to each other. So the answer is also true, that yes, the variances of kurkure and Lays are pretty much same. So tell me one thing, sir, if I want to implement this in code, first of all, let's take the data. For F-test data, what data do we have for F-test, my people? What have they given us? So first of all, import NumPy as NP. Right? This is NumPy as NP. Very, very simple. From SciPy dot stats, import F. Your job is very, very simple. If you're doing F-test, just import F. What data is given to us, my people? What is the data that is given to us? Can somebody take a screenshot of this? Sample size, sample mean, and sum of square deviation. Has somebody taken a photo or have made a note so that I'll be easy? Okay, chalo. I want you guys to give me the data very, very fast. What is sample 1? Okay, sample 1. sample 2. I want sample number 1, sample number 2. I'm going to keep it very, very simple. What is the mean of sample number 1? X1 equals 2. I want the mean of X2 equals 2. And I want sum of square deviation for sample number 1 and sum of square deviation for sample number 2. Okay, faster. What is sample number 1 size? Is 10. Okay, sample number 2 size? 13. Okay, good. Sample number, what is the sample size that we have taken for this? For X1, I think we took 15, right? Okay. What about X2? 14. What about sum of square deviation 1? 90. What about sum of square deviation 2? 180. Perfect. Okay. So we have taken the data properly, right? Now that our data is taken, have I made some mistake? 108. Oh, okay. Sorry. Yeah. Is this correct? Have I taken the data properly? Is my data taken properly? Okay, fine. Calculate variance, variance. So my people, can I say that variance underscore lays, lays, the lays, variance of lays, right? What is variance of lays? Sum of square deviation 1 divided by, to calculate the variance of lays, what did we do? Lays is 90 divided by 9. What is 90? Sum of square deviation 1 divided by n1 minus 1, correct? Divided by n1 minus 1. Agree or disagree, my people? This is the variance of lays. Is this the variance of lays? So if I print variance of lays, the answer will be 10. Very good. Okay? If I take variance of KUR, kurkure, is equal to, what do we do? SSD2 divided by n2 minus 1. Can I say this is the variance of kurkure? So we have first calculated the variance of this. To calculate the value of F statistics, you don't even need any formula. F stat is what, my people? Which variance is bigger? Variance of lays is bigger, so that divided by variance of kurkure, correct? And if I do this and if I print F statistic, the answer is 1.111111 recurring, what we calculate in our start. So we don't need to calculate it. F statistic is done. This is done. The next thing is degree of freedom. For degree of freedom for first sample or underscore lays is equal to, what is the degree of freedom for lays? N1 minus 1. And the degree of freedom for kurkure, which is KUR underscore KUR, is equal to N2 minus 1, correct? My people, this is the formula. The degree of freedom for lays and the degree of freedom for kurkure. Agree? Now, the most important thing is, when we do a coding example, we don't find critical value, but we calculate the value of p-value. If I have to calculate p-value, p underscore value equals to, in the entire history of inferential statistics, which method will always be used to calculate p-value? F.CDF. This is the method with which you will calculate p-value in t-test, z-test, f-test and all of that. In the F.CDF value, F statistic value, which is this F stat value that I have calculated, I have added. Okay, so F underscore stat is added. No problem. Degree of freedom of lays, which is basically this, and degree of freedom of kurkure, I have added this. If I calculate print my p value, which is double quote, put an F here, and I will say p underscore value. Okay, p underscore value is colon p value. What p value did we get, my people? P value is this. If you calculate, this is the particular p value instance. So my people, our alpha value is taken to be 0.50, correct? 0.05, sorry, 0.05, 0.05. If I take the entire thing p value less than alpha, copy it and paste it here, what happens? What do? Do we reject the null hypothesis or accept or fail to reject the null hypothesis? So let me remove vegetarian, non-vegetarians are equal, vegetarians and non-vegetarian people are equal. I'm just going to remove it, okay? We'll write that later. Control Z, remove it. What answer am I going to get if I run this? Do we accept the null hypothesis or reject the null hypothesis? What did we do in our example? In our example case, did we accept the null hypothesis or reject the null hypothesis? We accepted. What did we do here? Did we also accept the null hypothesis? We did the accept the null hypothesis. And reject and accept meaning variances are equal. What? And here, if it was rejected, variances are not near or equal, are not equal, EQUALL. This is the answers that we got. Now, one of the question is, sir, we don't know which is bigger. Variance 1 is bigger, variance 2 is bigger, so that F statistic value can be done properly. To calculate that, Do we have a method in Python called mx equals to max of variance of Lays divided comma variance of Kurkure? Yes or no? Can we do this? Do we have this method in Python that gives me the maximum value of this? Yes or no? If you don't know which value of fstat is bigger, so can I write the same exact function like this? Can I write control Z, control Z, control Z? Can I write the same function like this, copy, paste? Here, the answer will be maximum of put a bracket, variance of Lays, variance of Kurkure, copy, paste, comma, and the bottom value will be minimum of variance of Lays, variance of Kurkure. If I copy this and if I paste it, oops, control Z, paste it here. If I comment this out, comment the whole code out and print the fstat value here, am I getting the same answer? If you don't know which value is bigger in fstat or which value is minimum, just write the method called max of variance of Lays and Kurkure, minimum of variance of Lays and Kurkure. It will take the maximum value of this two variable, minimum of this two variable. You will be able to divide and the answer is clear. Are we clear? So rather than implementing it like this, you can implement it like this. It went in the brain. Did it go inside the brain? Very good. Very nice. Very nice. Now, without understanding one important factor and making it all clearer. So tell me one thing, between t-test, between z-test, between f-test, if I want your answers to be, or if I want your tests to be done based on variance, which among these tests will you go for? Now, let me ask you a question. If your sample size is less than 30, but you want to take means between two data, what test will you implement? What? Very good. I have a sample size of 31 and I want to calculate the difference of some question that I'm trying to identify. And I would like to take means between these two groups. What test will I implement? Absolutely sorted, boss. Very good. The difference between t-test, z-test and f-test, simple and sorted. Simple and sorted. Remember, t-test and z-test and f-test, the only thing common in all these three tests are they are all what kind of tests? Parametric tests, meaning the data that they expect to consume or the data they assume on which you are running the inferential test on follows what distribution? Normal distribution. If it does not follow normal distribution, what do? You apply transformation on the data. You first apply transformation, and after transformation is applied, then pass the data on the parametric test. This should be clear, okay? I have already taught you this in the beginning of the class. Are we clear? Did we understand? If your data does not follow normal distribution, life cannot be simple, it cannot be sorted. Now, my people, let's take one more example. Let's say we have a superstar called Vadvani in our class. Okay. If you don't know who Vadvani is one of our students in the class. Okay. Imagine Vadvani has created his restaurant called Vadvani's Paradise. Okay. Vadvani's Paradise. Imagine Vadvani has created his own hotel called Vadvani's Paradise. And Keshav is one more person in our class. He wants to purchase the hotel from Vadvani. Okay. Keshav wants to purchase the hotel from Vadvani. Keshav is like, I want to purchase your hotel. So what Vadvani will say is, and Keshav will say is, because Keshav is a very smart guy. Okay. Keshav is not going to just believe Vadvani's words and be like, oh, okay, nice. You are saying profit is good. I'm just going to buy your hotel. No. Vadvani says, and Keshav says to Vadvani that tell me one thing, on Monday, Tuesday, Wednesday, Thursday and Friday. Okay, Saturday, Sunday is holiday for everybody because Saturday, Sunday is God's day. Nobody's supposed to take that from you. So, Keshav asks Mr. Vadvani, okay, Keshav says to Vadvani, tell me on Monday how many people come and eat in your restaurant. So, Vadvani will say, this is Vadvani's expected value, okay. Vadvani says that, you know what, on Monday, 25 people come and eat in my restaurant in the entire day. On Tuesday, 30 people come. On Wednesday, 35 people come, 60 people come, 70 people come and they eat in my restaurant. Okay. Now, Keshav says, you know what? I don't want you to tell me 25 people, 30 people, 35 people, 60 people, 70 people, all these people come and they eat in the restaurant. Even if 30 people on a day, on an average, if they come and they eat in the restaurant, I will purchase your restaurant. Okay. If this is the data that you claim and this observation is what I found to be true, I'm going to purchase your restaurant. So, my people, the question is very simple. Claim made by Vadhwani and the observation made by Keshav, are the claim or is the claim matching with the observation? Is the reality matching up with the claim made by somebody? When you do such kind of test, this kind of test is called as chi-square test. Did that make sense? Whenever somebody makes a claim about something that I believe it will be this much, and when the observation is done, and you get a similar result or results that are closer to each other, that is when you say that the claim is matched. My people, on every day Monday, 25, 30, 35, 60, 70, on an average, every value is above 30, correct? All the values are about 30, correct? What makes sense? All these numbers are above 30. What does it mean? That the claim that is made by somebody and the observation that is observed by somebody, the observation, if you want to match the claim made by somebody and check and validate is the observation fitting the claim or not. To do this test, we have a test called chi-square. This test is very, very simple. What is the claim? What is the observation, my people, between value number 1 and value number 2, or row number 1, row number 2? What number is claim and what is observation? Can I say this is the claim of Mr. Vadhwani? Row number 1, every Monday 25 people will come, every Tuesday 30 people will arrive in the restaurant, every Wednesday 35 people will arrive. But what is the observation that has been taken into consideration? 30 every day, correct? Minimum number of 30 every day. So the claim and observation is what we are going to validate. Is the observation matching up with the claim or not? If that matches, then we have our answer. If it does not match up, we do not have the answer. Did you understand in which conditions do we implement chi-square? What chi-square is called as goodness of fit test. What do you do? What do you call this? Goodness of what test? What do you call chi-square as? Goodness of fit test. My people, the claim somebody made and the observation somebody made, are they fitting well with each other or not? This is what we called goodness of fit, right? Are they fitting or gelling up well with each other or not? This is what we call goodness of fit. Make sense? Understood? Tell me one thing. I'm going to give you a slightly different data. Listen to me very carefully. Slightly different data. My people, tell me what the observed value is this much. Let's say 23 people came and ate in the restaurant, 16 people came and ate in the restaurant, 14 people came and ate in the restaurant, 19 and 28 people came and ate in the restaurant. Okay, this is the observed value. Expected value is every Monday, up to 20 people also, if they come and they eat in the restaurant, I'm okay. 20 people, 20 people, 20 people, 20 people. So can I say I have taken for Monday, Tuesday, Wednesday and Thursday? Agree or disagree? On Monday, Tuesday, Wednesday, Thursday and Friday. For 5 days week, I have my data. 23, 16, 14, 19, 28. This is my observed value. This is my expected value. My people, let's take the same data. What was the observed value, my people? The observed value is 23, 16, 14. 23, 16, 14, 19. 19, 28. What is the expected value? Expected value is 20, 20, 20, 20 and 20. Okay, this is the expected value. This is the observed value. This is the expected value. Correct, my people? Just like F test, how beautiful is chi-square is very, very simple. You don't have to work too much towards understanding. If this is the data that is given to me and my job is to make sure to test whether the observation and claim are matching with each other or not at say confidence interval of about 95%. Okay, this is what I want your answer to be sorted. So what is step number 1 that we will solve? Is it the hypothesis testing that we will do? Step number 1 is usually the hypothesis testing that we have done in all the examples. So my null hypothesis and my alternate hypothesis is what? My null hypothesis is that my observation is always equal to the expectation that is done, right? My observation and my claim, they are fitting well with each other. This is my null. My claim and my observation, they are all beautifully sitting well with each other. But in your alternate hypothesis, the observation is not equal to your explained or your claim. That is what I'm testing. So step number 2, which is calculating the chi-square statistic value directly. Sir, how do you do this? The formula is very, very simple. The observed value minus its expected value, you have to take it. So chi-square statistics formula is summation of observed value minus expected, the whole square divided by expected value. So what do you mean by this? What is the observed value here and expected value here? 23 minus 20 divided by 20, the whole square, plus 16 minus 20, the whole square divided by 20, plus 14 minus 20, the whole square divided by 20, plus 19 minus 20, the whole square divided by 20, plus 28 minus 20, the whole square divided by 20, right? This is the data. This is observed value right here minus expected value, the whole square divided by 20, observed value, expected value, observed value, expected value, observed, expected divided by 20. Right now, to answer this, I will have to calculate it via some formula. Give me 1 second. Can somebody calculate this faster? Can somebody calculate this? 23. Let's calculate it now. 23 minus 20 will be 3 square, right? 3 square is 9 by 20, plus 16 minus 4 is 16 by 20, right? This is also going to be 14 minus 20 is 36 by 20, plus 1 by 20, plus 8, 9, 10, so 4 by 20. Yeah, this should make your life easier, right? Like 9 plus 16 plus 36 plus 1 plus 4 by 20. What do you get approximately answer as in this particular example? About 6.3, correct? Okay, fine. So your chi-square statistic value that you calculated from the number was 6.3, right? According to the formula. But your job is not yet done. Why? Because we have calculated the statistic value, but what have we missed? What have we not yet calculated, which is important for manual problems? We haven't calculated the chi-square critical. We haven't calculated the critical value. Sir, how do you do that? Very, very simple. You come here, chi-square table, click on it, come to this particular table and open this table up, right? Or not this, but open maybe scriber's table. Not even this, but where is the table? There's not even table in this entire thing. My God, close this up. Let's see any other table. Chi-square table. Yeah. In this particular example, my people, right? What is your alpha value that you have taken? What alpha value did we take in the example? What alpha value do we have? It is, let's also make our life easier, okay? Let me also make your life a little bit easier, okay? How many weeks have we taken, my people? Monday, Tuesday, Wednesday, Thursday, and Friday. Totally Monday plus Tuesday plus Wednesday plus Thursday plus Friday is together 5 value, right? 5 sample size, right? You have 5 samples. So your degree of freedom will be 5 minus 1, correct? So the degree of freedom, step number 3, okay? Let's calculate it. Step number 3. Your degree of freedom is n minus 1, which is 5 minus 1, which is what, my people? 4. Is your degree of freedom going to be 4? Agree or disagree? So tell me, my degree of freedom here is 4. Okay, I highlighted it at 4. My degree of freedom is 4. Okay. What is the alpha value that you have calculated? What calculation mistake? What is the calculation mistake? Did we not calculate the chi-square critical value correct? Is the chi-square critical not correct? 28 minus 20 is, okay. Oh, yeah. I think this should be 64, right? I'm sorry, yeah. 8 8 is 64, right? I think this is not 464 by 20. I assume this is correct. This should be 64 by 20, not 4, right? Yeah, 64 by 20, correct. Yeah, now it is 6.3. Okay. What is my alpha value? 5%? Is my alpha value 5%? I'm going to zoom this a little bit, okay? I'm going to make your life easy. Is my alpha value 5%? Very good. My degree of freedom is 4. My degree of freedom is 4 and my alpha value is 5%. If you match the numbers, what number do you get? 9.488. 9.488 meaning, we'll round it off. 9.488 meaning your critical value is 9.4988. I'm going to take it at 9. So is my critical value 9.49 and my stat value this much? So in the distribution of the data, what is your assumption? My confidence interval starts at plus 9.49. It will end at minus 9.49. Where is the number accepted? In somewhere here, 6.3. So are you in the acceptance region or are you in the rejection region? So if I take this entire particular number, is it acceptance or rejection? You're in the acceptance region. So what are you claiming? You say that I accept the null hypothesis. That is the answer, right? I accept the null hypothesis, meaning that the observation made by somebody and the claim made by somebody, they are matching. So here we just prove that, you know what, the observation that you bring in and the claim that you bring in, they both are very closer to each other or are equal. Hence I say your observation is equal to claim. And my people, logically it is also same. Aren't 23, 16, 14, 19 and 28 on an average closer to 20, 20, 20, 20, 20? If you look at it from a very simplistic sense, 23, 16, 14, 19, 28 is anyways closer to 20, 20, 20, 20, 20. So we should have gotten the same answer. But you know what? The beauty is the answers that we are generating right now is a proof from statistics. So tell me, my people, if I want to calculate the chi-square statistic formula, okay, so chi underscore statistic is equal to, my people, if I write the program like this, will you understand? I have taken chi-square statistics equals to 0. I took chi-square statistics equals to 0 for observed observed underscore val comma expected underscore val in what I'm gonna zip the value zip of observed comma expected. So observed comma expected. What is this going to do, my people? It's going to generate 23 separately, 20 separately. So from observed value, the value of 23 will be in this variable called observed val, and the number 20 will be in the variable or the pointer called expected val. So now that I have these numbers taken separately, what do? Chi-square statistics plus equal to, take bracket, observed value minus expected value divided by what do? But before divided by, we have to take a square, correct? The whole square divided by, what do? Divided by what value? Expected value. So if I run this particular answer and print chi-square statistic, what answer do we get? Very nice. What answer did we get? Observed value minus expected value, the whole square divided by expected value. What answer did we get? Chi-square statistic value. What answer did we get in our example problem? What was the chi-square statistic value here? 6.3. What did we get here? What answer did we get? 6.3. Is this correct? Apart from this, what is the alpha on which we have to solve the problem? 0.05. Agree or disagree? And the degree of freedom is sample size minus 1. I will take 4 directly. So tell me, my people, do you have any need for calculating critical value? Critical value in a programming exercise? Do you need to calculate critical value? But should you learn this? Should you learn how to calculate the table value by default also, so that you don't have to look at the tables in your life again and again? From SciPy dot stats, import chi-square. How do we import chi-square? We import chi-square like this. If I want to calculate critical value, chi underscore critical chi underscore critical value is what, my people? Chi-square dot ppf. PPF method is used to calculate what value in statistics? What is the difference in PPF and CDF? I want answers, please tell me. PPF will help me calculate what and CDF will help me calculate what? Where do I use PPF? PPF is used to calculate, I don't want the full form, I want answers. PPF is used to calculate critical value. CDF is used to calculate p-value. Remember this. It's not the no. PPF is used to calculate your critical value. PPF, percent point function, is used to calculate critical value. CDF is used to calculate p-value. Please remember this much. If you don't remember the full form also, it's okay. If you don't remember the full form of these answers, it's okay. Remember that PPF is used to calculate your critical value. Your CDF is used for your PF value. So if I come inside this, if I come in this chi-square.ppf, alpha, whatever alpha you have, you divide, you take the alpha value, pass in the degree of freedom. What is the critical value that we got from this particular example? One small mistake that I did here is 1 minus alpha degree of freedom. What answer did we get? 9.4887. What is approximately this answer? What did we get here? The chi-square critical 9.49, which is 9.488 something. I have rounded it off to 9.49. What answer did we get? But do we need critical value in our example? We don't need critical value at all, because how do you solve this problem? If you solve this problem, how will you solve this problem? Will you solve the problem using the concept of p-value? Agree or disagree? If I want to solve the question or this particular answer from the concept of p-value, the way p-value is written in chi-square is different. You have to write 1 minus chi-square dot. Now, which method will I use if I want to calculate p-value? If I want to calculate p-value, how do we do? Dot CDF. Very good. What do I pass? Chi-square statistic, because that is what we have calculated. Degree of freedom is what we have calculated. So if I take if p-value less than alpha, okay, if I close this, if I take the entire same thing, copy it, write it down here, remove the vegetarian, non-vegetarian nonsense, remove it from here, remove this part from here, and if I run this answer, what answer did we get, my people? Accept or reject the null hypothesis? What answer did we get here? Are we accepting the null hypothesis or rejecting the null hypothesis? We are accepting it. In our answer, what did we do? Did we accept or reject? In our example, is this in the acceptance region? Accept. So here, please remember only one small thing, and this is not your fault. This is not even the fault of anybody. SciPy is written by somebody, right, my people? There is somebody who is the contributor of SciPy, correct? Some people who made SciPy, correct? They have made SciPy. People who created SciPy, okay, whenever you calculate chi-square statistics, right, there is a formula. If you don't, actually, it's a little deeper for me to teach you. But what happens is, to calculate your CDF value, right, like this table value, there is also something called probability distribution test, okay, PDT it's called as. So what happens is, in calculation of chi-square's PDT, they calculate it not directly like chi-square.cdf, you have to do 1 minus. So remember, only and only in chi-square, if you want to calculate the p-value, you have to put this 1 minus. That's because you have to do PDT calculations. Only then you get the original value back, which is the p-value. So if you're calculating p-value using chi-square, please remember your p-value has to be calculated like this. And this is not taken by us. This is the formulation through PDT. Using CDF formula, you have to calculate it like this. Are we clear? Only in chi-square you have to be very, very careful. Rest your life is beautiful, smooth. You will have no problem. Okay. Chi-square is non-parametric test. Any difference we have to take? Yes. Beautiful, Anjana. Appreciated. Now, the test that I just taught you right now, chi-square, is this parametric or non-parametric, people? Do you think this is a parametric test or a non-parametric test? What kind of test is this? It's a non-parametric test. The reason why it is called non-parametric test is because, tell me one thing, I want to show you guys something. My people, here 23, 16, 14, 19, 28 is very close to 20, correct? These numbers 23, 16, the observation and the expectations are closer to each other. Agree? What if I make the observation changed? 40, 60, 50, 80, 90. If I run the answer, did I reject the null hypothesis? Did my answer just suddenly change? It was accept the null hypothesis, but now it is no longer changing. So isn't here the claim versus the observation is being matched very properly? Are we not able to create a system where observation of claim and the expectation we are not matching with the expectation of accept and reject the null hypothesis? We created a code where claim made by somebody and the actual value made by somebody or the reality we are matching. And if you take the answer almost equal to same, the original value 28, 19, 14, 16, 23, and the answer comes fails or acceptable. So remember this. This is called as an expectation based value, right? In the entire thing. Yes. So Pooja, the reason why I made this plot is for you to understand to accept the null hypothesis or reject the null hypothesis. You can also take it like this because this is non-parametric. You take a value like this. Your upper bound is 9.49, lower bound is minus 9.49. Where does this 6.3 come in? In the range of 6.43 here. The reason why we plotted a normal distribution was to tell you whether the number falls in the range or not. The data follows normal distribution versus the claim that we make is the number inside the range or outside the range is different. So rather than plotting a normal distribution graph, just plot a range like this. Just a range. Does the number fall inside the confidence interval or outside the confidence interval? For this, we don't need normal distribution. I hope you're clear. Whenever we are calculating this value, then you don't plot normal distribution. Just say that within the confidence interval, is my number falling or is it falling outside? Depending on this, we accept or reject null hypothesis. So depending on the same example, we got the null hypothesis to be rejected. Now remember one thing, one small question. When we say non-parametric, okay, the data is supposed to follow normal distribution or not normal distribution. What can it handle? What does it handle? It can handle normal distribution. But the problem in normal distribution and not normal distribution is also variables. Variables. What do you mean by variables? Do you have continuous variables and discrete variables or called categorical variables? Example. Temperature is measured as 13 degrees, 13.4 degrees, 19 degrees and all of that. Is temperature a continuous variable or a categorical variable? Is temperature a continuous variable or a categorical variable? It's a continuous variable. What about weathers of the world? Monsoon, rainy, autumn and spring. Are these categorical? My people, now let me expand your knowledge of parametric and non-parametric test also. The test is supposed to be called parametric and non-parametric, not just on the terms of normal distribution, does it follow or not, but also what kind of variables do you follow? Are you a continuous variable or a categorical variable? The data, if I plot 23, 16, 14, 19, 28, I may or may not get a normal distribution. I may get a distribution that could be skewed. It's okay. But my data here, is it categorical? My buckets are simple: Monday bucket, Tuesday bucket, Wednesday bucket, Thursday bucket, and Friday bucket. So is my data continuous or categorical? Is my data continuous or categorical? Isn't it categorical? It's not continuous, it's categorical. Okay, first of all, let me first make you all understand. Do you all understand the difference between continuous variable and categorical variable? You guys know this, right? In statistics, in categorical, you have studied nominal data, ordinal data. Nominal mein order matters, ordinal mein order does not matter. You guys have order does not matter here. Okay, give me 1 second. Nominal, ordinal data. Okay, not ratio. Yeah, okay. Have you studied this, my people, in statistics? That data is of two types: categorical or qualitative data, quantitative or numerical data. Under qualitative data, we have categorical things like nominal and ordinal, and then we have interval and ratio. Are you aware of this in statistics? I'm going to copy this and I'm going to paste it here. Give me 1 second. Are you aware of this thing in stats? You are aware of this, right? Okay. If you are aware, the data that we are following, this particular data, which is the observed data, we have 23, 16, 14, 19, and 28. The data might look continuous to you, but it is not continuous because each data is falling into its own individual bucket, right? Monday bucket, Tuesday bucket, Thursday bucket, Wednesday bucket, and Friday bucket. So is my data continuous or categorical? What is it? If the data itself is categorical, Is it possible for you to ever plot normal distribution with a categorical data? If your data itself is categorical, will you ever be able to plot a normal distribution? No. So this test is proven to be non-parametric then parametric. I hope you understood what I meant. Did you get it? If your data itself is categorical, how do you expect your answer to be in normal distribution? No. I hope it makes sense. Example, if you want to eat the ice cream and don't want to eat the ice cream. So say I want to eat the ice cream, don't want to eat the ice cream. Is this categorical or continuous? Is this categorical or continuous? Okay. I will go to school. I will not go to school. Maybe I will go to school. Is this categorical or non-categorical? I will split my data in Monday, Tuesday, Wednesday, Thursday, and Friday. Is this data categorical or non-categorical? Is this data categorical? Categorical data? Is my data also split like this? Monday, how many people came? Tuesday, how many people arrived? Wednesday, Thursday, and Friday? So are we dealing with categorical data or numerical data? So now, redefining the definition of parametric and non-parametric test. In parametric test, it is not just important what distribution your data follows, but it is also dependent of the variables you have following, yes or no? If the distribution is normal distribution and of continuous type, what implement will you do? Parametric test is the right kind of test for it. Agree? If you are following normal distribution and you have categorical or continuous value, normal distribution. If you do not have normal distribution and if your values are continuous or categorical, what will you do? Non-parametric. Are we clear? Is this distinction understood by everybody? Okay. But sir, if my data follows normal distribution and I'm categorical, what do I do? Isn't this one of the question? If my data follows normal distribution and it is categorical, then what do I do? Is this condition ever possible? Is this condition ever possible, my people? Is this condition ever possible? I want you to tell me, can something follow normal distribution and be categorical? By chance. Give me one example of that chance. Give me one example of that chance. Give me one example where the data is categorical and also it's normal distribution. What is that data? I would love to hear it. What data do you think is categorical, follows normal distribution? I would love to see that example. Excuse me. There will be none, my dear. Are we clear with the definition of parametric and non-parametric, my people? The answer is clear, yes or no? Are we clear with the chi-square value? Did we get the output correct? Did we get fail to reject or accept or reject null hypothesis? Agree or disagree? If the data is not normal distribution, you said we have to transform data. What does that mean in z-test, t-test, f-test? It means when your data does not exactly follow normal distribution, it is either left skewed data or right skewed data. What we do is we take this entire distribution, we transform it either using log transformation or Box-Cox transformation. We convert it into a normal distribution data with unit mean and standard deviation of a unit standard deviation also. Once it is converted, you are allowed to apply it on a z-test, t-test or f-test. It means from converting my old data into normal distribution, there will be some loss. There will be certain data that we will ignore, remove, because we will make them all as an outlier value. This process is what it means. This is the effort it takes for you to apply if the data does not follow normal distribution. Are we clear? This is the step by step that you have to follow. Now, between all these tests, t-test, f-test, z-test, ANOVA, which is called analysis of variance, and chi-square. Do you remember I told you guys in the very beginning of the class, when should you use which test? I taught you this example. Give me 1 second. I'll tell you this in a much more nicer way, in a much nicer and a more simplistic sense, right? So do you remember we learned an example where t-test and z-test are used to do what? They are used to compare the means between two samples. Step number 1, t-test cannot be used for sample size greater than 30. Even z-test is used to test the means between two groups. The sample size can be greater than 30 And the other thing about t-test and z-test is what? I think this is pretty much it, right? They are all parametric. So I'm just going to write number 3, parametric, or I don't need to mention parametric and all of that. But when we talk about f-test, f-test is used to calculate variance between two groups, means between two groups. T-test is also means between two groups. This is the difference between t-test, z-test and f-test. And when we do chi-square can only be used on categorical variables, right? So that it's non-parametric. The problem in chi-square is that the data size should be greater than 5. Remember, in the example of chi-square, how many variables have I taken or buckets have I taken? 5 minimum. Or the number of samples I have taken is 5, correct? In chi-square, the sample size should be greater than 5. If the sample size is less than 5, you will get error or you will have issues in the problem. So chi-square works with the dataset sample size minimum greater than 5. It should need more than 6 and greater. It should not be 4, 3, 2, 1 like that. It will not work. Second thing, it is non-parametric. You guys have understood this. It is a non-parametric test because I deal with categorical variable. Sir, what about ANOVA? Analysis of variance. You must have observed one thing so far, and this is a little crazy. So far, t-test, z-test, f-test, all these tests are only allowed to function with maximum how many groups of data? How many groups of data is it maximum allowed to be with? But the beauty of ANOVA is you can compare more than 2 groups at once. You can compare more than 2 groups at once. At the same time, you can compare their variances also. You can compare their mean also. There is no restriction on it. Are we clear? What did you get it? You can compare more than 2 groups together. That means 3 groups, and you can either check their variances between groups or means between group. ANOVA is such a versatile test that it does not care about any of this. It can just be used to compare more than 2 groups. Example. Sir, what size are usually taken for ANOVA? For ANOVA also, if your sample size is greater than 5, it will be more beneficial. If your sample size is less than 5, you will start getting type 1 and type 2 errors in the problem. Because the rule of statistics says, if your population is bigger, take a bigger sample. If your population is smaller, take a smaller sample. But take a considerably big sample. Agree? If you have taken 100 people as a population, at least take 10 or 15 people as sample. Don't take 2 or don't take 3. Agree or disagree? It's called law of numbers. This law is called law of numbers. I hope you are aware. If you are a salesman, and if you go to 10 houses to sell one product, go to 100 houses to sell 10 products. I know this may appear like a common sense, but this is a law of numbers, right? This is called law of numbers. I hope you know this. If you did not know this, let me also tell you one beautiful thing. My people, do you know that in statistics, it's a proven fact that the more time you spend in learning something, the more becomes your skill. Have you ever heard of something called 10,000 hour rule? Have you ever heard of this concept called 10,000 hour? Let me tell you. 10, 1, 2, 3,000 hours in days. Okay. 416, right? In 10,000 hours, okay, if you keep yourself dedicated and spend 10,000 hours on one particular aspect, you become an expert in that topic. So the more time versus the skill, the more time you spend, the more skills you grow. Isn't this the law of numbers? The more time you are spending in learning something, the more skills you are growing. More time you spend, higher the skill value. Isn't this related to law of numbers? Also law of life maybe, but law of numbers, this apply, right? The more you do something, the more you become good at it, or the better you become good at it, or the better you become at it. Simple, right? So remember, just like that, in the exact same way, number of sample sizes or the samples that you take make more sense, right? So tell me, my people, to make this sample size understandably very, very clear, let's take a very simple example. I'm not sure if any of you have any farming experience, but I come from a farming family. So I'll tell you guys, we use something called fertilizers. Have you ever heard of something called fertilizer? Have you ever heard of something called fertilizer? Fertilizers, my people, are used in farming industry to help the plant grow or to help our crop grow so that the yield that we have is higher, right? So let's say I have a fertilizer and I have taken 3 plants. Okay, my people, my aim is, my job is, I have 3 fertilizers. Okay, I have 3 fertilizers: fertilizer A, fertilizer B, fertilizer C. Okay, I have 3 fertilizers. I want to check if all fertilizers are equally good, or are equal in capacity, or unequal in their capacity. What do you mean? See, my job is very, very simple. I have a fertilizer called fertilizer underscore A is equal to, I have taken 7 plants. How many plants, my people? 7 plants. Okay, I have taken 7 plants. The first plant grew by 12 centimeter in 1 month. The second plant grew by 13 centimeter in 1 month. The other plant grew by 15 centimeter, then 13 centimeter. 1, 2, 3, 4, 5, 6, and 7. Okay, these are 7 plants, and after 1 month, fertilizer A, because of fertilizer A, there was a 12 centimeter growth, 13 centimeter growth, 15 centimeter growth, 13 centimeter growth, 15 centimeter growth. This is for fertilizer A. Now for fertilizer B, I will say 13 centimeter growth, 18 centimeter growth, 11 centimeter growth, 13, let's keep it to, 12, 16 centimeter, 8 centimeter of growth. Let's reduce this also a little bit, and 12 centimeter of growth. This is fertilizer B. Okay, this is because of fertilizer B. Now we will copy the whole thing and we will paste it with fertilizer C. Okay, there is another fertilizer, and because of this fertilizer, there was a 11 centimeter growth, 12 centimeter growth, 14 centimeter growth, and 15 centimeter growth, 16, 15, and 12. Okay, this is fertilizer A, fertilizer B, fertilizer T. Now, how many groups are we comparing together? Rather than comparing 2 groups, how many groups are we performing at once? We are comparing 3 groups, meaning we are comparing 3 fertilizers together. Now, if I want to compare the fertilizers, I have to do this. What do I have to do? From SciPy dot stats, import what, my people? F underscore one way. This is just another way of writing ANOVA. F underscore one way. I have taken 3 groups: fertilizer A, fertilizer B, fertilizer C. Sir, what do? I want to perform which fertilizer performs best, or I want to check which fertilizer is doing good. So my people, if you want to check which fertilizer is doing good, can I do this, my people? Import NumPy as NP. My people, can I do NP dot mean? Okay, NP dot mean of, if I pass fertilizer A, okay, okay, I need to run this first. Give me 1 second. Fertilizer A, if I do this, NP dot mean of fertilizer B, run it, and NP dot mean of fertilizer A or fertilizer C. My people, between fertilizer A, fertilizer B, and fertilizer C, on an average, who is performing good? Is A, B, or C? Which is performing good? A. So we can calculate which fertilizer is doing good by simple calculation of mean, correct? You don't need a fancy inferential statistics test to calculate who is performing good. A simple mean will give me which is performing good. But why do I need inferential statistics for? Is fertilizer A, B, and C equally performing same, or are they not same? Correct? Equal or not equal? That is what null and alternate proves, right? Null hypothesis proves that fertilizer A, fertilizer B, and fertilizer 3, they are all performing the same. But in alternate hypothesis, we say that fertilizer A is not equal to B, and B is not equal to C, and A is not equal to C, meaning A not equal to B not equal to C. Agree? A is not equal to B, not equal to C. All 3 are performing different. Agree or disagree? Common, simple mathematics, basic mathematics this is. So if I want to implement ANOVA, you have to write this: F underscore statistics, comma, P underscore value is equal to The reason I'm writing F statistics is because ANOVA comes under which test? ANOVA comes under which test? Under F statistics. ANOVA is a glorified F test. So my people, F underscore one way I called. What will I pass? Fertilizer A, comma, fertilizer B, comma, fertilizer C. Very, very simple. I have fertilizer A, fertilizer B, fertilizer C. But I don't know, sir, what will be my alpha. Can I say that my alpha should be 96% this time? Let's change it. So what will be my alpha, my people? If my confidence interval is 96%, what will be my alpha? 0.04. So if I print it like this, print, okay, one way ANOVA, okay, or ANOVA, analysis of variance, okay, I'm going to write analysis of variance, okay, print. What do we do? F double quotes, fertilizer A, okay, so let's say F underscore stat is colon F underscore stat, okay. Let's copy the whole thing and let's print it here, and let's print P underscore value, VALUE, and this will become P underscore value. We are not done yet. P underscore value, and if I run this, I got F stat P value, but the code remains the same because P value less than alpha, that is what will accept and reject my hypothesis. But rather than writing it like this, let's write it beautifully. Sir, what do you mean? When we reject the null hypothesis, what do we say? There are significant differences in mean heights of the plant. I can write it like this. So if I reject the null hypothesis, there are significant differences, diffferences, between plant heights, heights. There are no significant differences in the plant size. Okay, I'm gonna copy it and I'm gonna paste it here. My people, according to you, what should be the answer? There are significant differences because 13 centimeter, 12 centimeter, and 14 centimeter means there are significant differences, right? There is growth of up to 12 centimeter to a growth of 2 centimeter of a plant growth. So there is at least one fertilizer that is doing an amazing job at making the plant grow well. So when we got this answer, it meant that any one of the fertilizer is doing a better job than all other fertilizers. That means reject null hypothesis or accept to fail means you have accepted the null hypothesis that A is equal to B is equal to C. What do you understand out of this? How many groups can you compare at once? There are no significant differences. Yeah, I mean, there are no significant differences in the answer. So how many groups did you compare at once? Can I compare 10 groups together? Can I compare 10 groups together in ANOVA? What do you think, my people? What should be the answer to this? Yes. But can I show you one small thing that will make you feel good? Suppose the sample data is how much, my people? How many samples do I have here? What's the total sample length? 7. If I remove 3, how many will I be left with? If I remove 3, how many will I be left with? So if I put a hashtag here, and put a square bracket here, come back, square bracket here, come back, square bracket here. What is my sample size? 4. If I run it, did it give me any error? I took a sample size lesser than 5. Did it give me any error? No. If I take 1, just 1, okay, just look at this answer, my people. You will be a little shocked, but I have to shock you a little bit. If I run this answer, what did you have? What happens? Did you get some error? No, not comma. Comma is not the error, dear. Comma is never the error. F1 way requires that at least one input has a length greater than 1. Meaning, okay, if you want greater than 1, no problem. I'll put a hashtag here, hashtag here, hashtag here, okay, and take this 12 and put it inside. Take this 18, put it inside, and take this 13 and add it inside. So, comma 13. And put a bracket here outside, put a bracket outside, put a bracket outside. If I run it, are there any errors? Are there any specific errors? No. From understanding which fertilizer is doing good, we are able to understand Keshav. The question was to check for best fertilizer by comparing capacity, but we are getting there are no significant difference in plant height. My dear, see, if you change the answer like this, okay, Control Z, Control Z, Control Z. Let me tell you which fertilizer does a best job. Give me 1 second. Remove. If I take fertilizer number A, remove the value like this, 18 centimeter, 19 centimeter, 20 centimeter, 19 centimeter, 18, 17 centimeter, 18 centimeter. So 1, 2, give me 1 second, 2, 3, 4, 5 and 6. I need to add one more, 18 centimeter. I run the answer. What answer do you get? There are significant differences between plant. Did I change the answer of the whole statistical test? Did I do that? Did we change the answer from reject, accept to reject null hypothesis? Yes. Why did this happen? Because fertilizer A, fertilizer B and fertilizer C, is there a significant difference? Instead of the answers all being in the range of 12 centimeter, 13 centimeter, 14 centimeter, clearly there is a winner. Who is the winner? Among all these fertilizers, which fertilizer is a winner? Why is it a winner? Because in comparison with all the fertilizer, one fertilizer is not equal to all. When something becomes not equal, either that thing is good or either that thing is bad, correct? That is what inferential statistics has taught you, right? When A is not equal to B is equal to C, meaning there is clearly a difference. A and B and C are not equal, meaning either A is performing very good or bad. I'll give you guys an example. Did you guys get the answer that there are significant differences between plant height? Yes or no? Because fertilizer A has immense amount of growth, correct? Agree or disagree? But if I make the answer like this, 1 centimeter, 5 centimeter, 6 centimeter, 5 centimeter, 4 centimeter, 3 centimeter, 1 centimeter, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, yeah. Will the answer remain the same also in this case? There is a difference and there are significant results. It's just that the plant growth is lesser. And if I run it, isn't the answer same? Because your growth is higher or lesser. That's the aim later. But the aim is, are they equal or not equal? In this condition, is fertilizer A, B and C equal? Are they all in the same ranges? No. I hope you understood what I meant. Keshav, it is common sense, my dear. When we do np.mean, my dear friend, np.mean, if you do, you don't need to calculate which is doing better. For that we need we don't need inferential stats, my dear. Understand the difference. See, which fertilizer is performing better? Okay, I'll tell you without even running the inferential stats. See, everything is commented out, my dear. Everything is commented out. And I'm going to make this 11, 15, 16, 15, 14, 13, 15. Okay, I am not doing anything. Okay, Keshav, nothing. I'm running this output and I'm running this code. Among all three fertilizers, without running inferential statistics, which one is performing better, Keshav? Does inferential statistics tell you ever that which group is better? Has in any of the test have I shown you? Have I ever shown you in any inferential test that inferential test is able to prove is A better or B better ever? In alternate and null hypothesis, have I ever made a statement saying that HA backs? So Keshav, the answer to this is inferential statistics is not the test to measure who is performing better, who is not performing better. Inferential stats is to check whether are you equal or are you not equal. Are you equating with me or are you not equating with me? So with f_1 way, the job is not to test whether you are best or A is best or B is best or C is best. No. With this, the only thing we check is all the group are or all the group better. I'll give you guys one more example. My people, to feel energetic or to suppose you are sleepy, okay, you want to sleep and you are tired. Do you drink Red Bull to suddenly get this rush of energy? People in this country drink Red Bull or an energy drink so that we don't feel sleepy. But apart from that, people also drink tea, people also drink coffee. Would you agree with this? People have a habit of drinking either Red Bull or tea or coffee. Now tell me one thing, if I want to measure a study that, does Red Bull work better in removing the sleep, or is my sleep better controlled with Red Bull, tea or coffee? If you want to run ANOVA, you can't run which is better. That you can calculate with the mean value which is performing better. That's not the aim. The aim of the question is, does Red Bull and tea and coffee are all three effective at removing sleep or they are not effective? So your answer will be only tea and coffee are effective, Red Bull does nothing. You got what I'm trying to say? Which is performing better is not the question. The question is, are all three good for the same task, or are all three bad for the same task? Like, oh, I hope you understood what the question meant. Okay, very nice, dear. Very nice. Good. My people, remember one thing: your inferential statistics is not yet complete. Okay, the reason is, even though I taught you t-test, f-test, z-test, ANOVA, chi-square, the reason why it is not complete is because, do you know, you always have to do hands-on first. Whatever code I do is something else that is separate, but there has to be a practical case study for you to complete. I hope you know this, right? Like, you cannot complete inferential statistics directly just like that. So there also will be a hands-on class for you, where there will be more examples, where whatever you have learned, you're going to be implementing. So remember, you need to remember these very, very well. All of the things that I taught you, it needs to be in your head. If you miss it, I am telling you, guys, it will become very overwhelming. I don't want you to feel very demotivated. I don't want you to feel sad or upset saying that, oh my God, I'm not able to learn. It's getting hard. It's not about hard. You just need to read other sources also. Apart from my classes, read blogs, watch video, all of that stuff. You have to do so much more. Are you understanding? You can use my notes, Intellipaat's notes. You can read blogs. You can read, YouTube videos. If you want, I will create one YouTube with all the inferential stats, tips, and tricks, so that I'll share the link with you. You guys see if you guys want to get a use out of it. And the beauty is, do you think I would let you go without something important, like without giving you guys an important? Oh my God, what happened? Is my screen visible? Yeah. Do you think I'm going to let you go without whatever we have learned so far, whatever I have taught you so far, right? I must have learned it from some place, right? I also was not born into a privileged background where my grandfather is a statistician, or I don't know, I'm learning something from somebody great. No, I also had to develop the skill, learn the skill, right? I had to go through all of that, right? Siddhant, and he's a YouTuber also. You guys did not know that I do YouTube. I teach data structures and algorithms. I help. So I help students who want to go into organizations like Microsoft, Adobe, Amazon, Google, Meta. So if people are, or if the students want to apply for such large companies, so what we do is we try to make them learn data structures, because if you want to go to that, people learn it. It's called data structures and algorithms. Anyways, you don't have to worry about it. Okay, don't worry. It's not a very great stuff. My people, I have something important for you. There is a book that I personally follow. Google will lay off LOL. Why do you think I only teach people to go into companies like Meta, Microsoft, and all of that, but myself, I'm not in such company, or I never go and apply to that company? That is because I know these companies have a layoff culture, right? Remember one thing, my people, this is just a small piece of advice to all of you. Your company does not matter, your work matters. If somebody in your career or in your life boasts about that, look, I'm in a company called Google and you are in some random company, trust me, just ignore and do not reply, because that person will be laid off the minute there is a small news about recession. But if you have spent time in your company, and if that company values your work and effort, bigger company does not matter. It's the kind of work you do matters. If you are in a small startup but you have built a platform where your customers are happy, your clients are happy, and somebody built a 5 line of code in Google and says that, look, I'm a Google developer, trust me, you're winning in life. I myself follow this advice. So I work in companies that truly value the customers, the employee. And one other nonsense, never believe. No company can be your family. Okay? You guys are going to start your career. Your company cannot be your family. You will be sick. Your company CEO is not going to come and put a sheet on top of your head and say that, oh my God, my dear employee is sick. It's your family who will take care of you, never your company. So never feel ashamed in leaving the company if it becomes toxic. Okay? If they start saying things like, no, you have to work extra, no, you have to do that, we always end up feeling bad that, oh my God, if I leave now. Be so skilled in life that jumping a company is not an effort. Yeah, it's a communication. You want to jump, you talk to somebody, you have an interview, you talk to the interviewer and you just shift the company. But never fall into the trap of companies are families. Companies are never families. I'm telling you this right now. Companies are communities. They are communities of like-minded people to work with, but they are not families. So remember, never fall into that nonsense trap of companies a family, companies everything. Family is everything. Your health is everything. Follow that. Otherwise, you will fall into a very, very bad trap. So coming back to the topic, my people, all that inferential test I taught you, I learned it from so many books. But one of the books I learned it from is this book called 100 Statistical Test. I'll show you guys an example. My people, did we follow step 1, step 2, step 3, step 4, step 5 just like this? In our examples, I taught. The book that I have already given you in your drive is called 100 Statistical Test. This book will become your reference to learn whatever I taught you with my notes. You will be able to learn not just that, but more. I have uploaded all of this on your drive. Cool. This is a very good textbook that you should refer. If this is a good resource you read, I'm telling you, your inferential stats will become good. Okay. Do you want my Python folder also? The code that I wrote today, the Python file? Okay, now imagine for 1 second, everybody, listen to me. Imagine for 1 second, when I joined the class today in the morning, not many people were responsive in the class today. So if you want me to upload the file, and what if my responses are slow? Would that be a good thing? If we start reciprocating the same energy, do you think that is a good thing I will do? What do you think about this? Because when I joined the class, I was screaming to the top of my lungs and I was like, okay, guys, did you understand? Did you understand? And nobody was responding on the class. And now I'm like, these guys want Python programs. What do we do? It is because the topic has become too complex. So by the time we understood time, I understand. I don't blame you people. See, I always tell you guys are okay, but when I teach machine learning and deep learning to a batch, right, I tell them, we are not learning twinkle, twinkle, little star. We are learning machine learning. You are learning inferential statistics. It is hard. It is up to an instructor to make the session interactive, fun, or whatever the instructor can do. But it is hard at the end of the day. No joke. It is hard. So yes, you will feel it is hard, right? Now, no matter how much I try hard, it will feel a little hard because the topics are complicated. It takes a little time to understand. So don't worry. Okay. Anyways, I'm going to give you the Python file also. And I think you guys should be able to do it. And also wait 1 second. The reason I have taken this entire subscription of this particular thing is so that we can upload the copy. Give me 1 second. Save as a PDF file, and save. Okay. Give me 1 second. Save. But where will it save? Rough work will go to desktop and save. I did not know this. I had no idea. Sir, if you teach us, we will respond 101%. The thing is, even if you guys respond to me, the most important thing that I have to handle is, to get the feedback that you guys have understood it well. That's my more important aspect. If you guys have learned it well, and I mean, I'm amazing. I'm happy. Oh wow, guys, this is good. Look at this. The entire thing turns out to be really nice. So from now onwards, I will use this platform only. It teaches well. It's really good.
10th quiz question, which is also our last for this particular quiz. What is the purpose of hypothesis testing in statistics? So our option 1 is to determine if a result is statistically significant. Option 2 is to collect more data. Option 3 is to visualize data trends. And option 4 is to create new variables. Again, I'm expecting a lot of answers for this particular question in the chat. Kindly drop down your answers in the comment, guys.
Just a quick info, guys. Intellipaat offers data analytics course in collaboration with IIT and Pandas. Through this course, you will master Power BI, data modeling, data mining, and much more from the IIT Madras faculty and industry expert. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to a new height. So visit the course page link given in the description and take the first step towards the career in the field of data analytics.
Okay. So guys, we are going to do a case study.
and its name is purchase case study. Okay, so for this case study, I'll be using something called purchase data. Okay, I'll start by importing the libraries. That is, main libraries Pandas, NumPy, and Matplotlib. Okay, and then I'll be loading my data. Okay, so this is going to be our data, which is the purchase case study data. So purchase case study data is data about the customer details who have done the purchase actually. Okay, this is the data. You can see that there will be a user ID, basically the user's ID. There will be a product ID, and there will be the gender of the user. There will be the age of the user. So age is going to be in the form of 0 to 17, 55 plus, like that. It's in the range format. Okay, then occupation, city category, stay in current city years, marital status, stay in current city category is, it can be something like rural, urban. In that way it has been given. Okay, it's not properly mentioned, but it will be like that. Now stay in current city years is given in a way that, okay, how many years that user is staying in that city, from how many years that person is staying in that city. Okay, then marital status is that whether the person is married or not. Product category is there. Product category 2 is there. So product category 1 and product category 2 is given in a way of quantity. Okay, how many quantities? That is what actually product category 1, product category 2, and product category 3 is showing. Okay, how many quantity? Now purchase, it is the total amount for which they have purchased. So these are the columns. Okay, and these are the meanings of these columns. Fine. It's already encoded data, so that's why the marital status and all is showing like that. Clear? Some of the columns are already encoded. Okay, so I've done with the importing of dataset. Okay, I've done with the explanation. So from over here, I'm starting with my exploratory data analysis. Okay, fine. Starting with my EDA. So data.info, as seeing the data.info, you can see that in which all format different columns are getting saved, right? In which all columns the different which all formats the different columns have been saved, you can see over here, right? Integer, object, float, in 3 different types of data format or data type. Fine, guys. Now what I'm going to do, if I want to see the unique values, okay, if I want to see the unique values, then I can see that. For example, the stay in current city years. Okay, the stay in current city years is showing as object. But don't you think that the stay in current city years should be integer? Right? Don't you think that it should be integer? So I guess there is this 4 plus. There's this 4 plus given over there. So might be that is why it has been considered as object, right? So let's see the unique in that data. Okay, let's see the unique in that data, so you'll be able to understand. So I told you, right, 4 plus means 4 years plus. Okay, that is what actually 4 plus means. 4 years plus. It's been 4 years plus we are staying over there. That is what 4 plus. So over here you can see the unique data in this 2, 4 plus 3, 1, 0, then none. Okay, these are the values. Over here we are having the 4 plus, that is why it is showing as object. So what we can do over here is you can simply change the 4 plus. Okay, you can change that 4 plus and make it as 4, so that we can later on consider it as an integer. Okay, it's fine that if it is going to be 4 or 4 plus also. So we have to change it to 4. So how we are going to change it to 4? How we are going to replace it? We are going to write this equal to this dot replace four plus to 4. And then if you are going to see the unique value of this, you will be able to see that it's changing as 4. Can you see it? Is it clear? But still you can see that one thing. Still one thing you can see that the other things. Okay, the other than 4, all the other things are still in string only, still in object only, right? So what we have to do? We have to convert it. Okay, we have to convert this into integer. So since we want to convert this into integer, we have to use the PD to numeric. You guys might know about the PD to numeric, right? So I'll be using the PD to numeric over here. Okay, that's a type conversion. PD to numeric. So I'll be writing this this equal to PD to underscore numeric. Then I'll be pasting the data errors equal to course. So errors equal to course. Okay, what it will do? Errors equal to course will fill all the null values. Okay, that is what errors equal to course means. Okay, for filling all the null values, we will be using errors equal to course, and then we will run it. And if you are going to see now the info, then you can see that the stay in current city years has been changed to float. Clear? I'll explain this again. Okay. So first of all, let me say it is not going to change it to integer. So whenever I'm going to do it in the numeric, okay, it's automatically going to get changed as float only. Okay, it's automatically its function is done like that. That is why it is changing as a float. Second thing, now I'm explaining this again. Now I'm going to change my object data, okay, into integer or float. Whatever it is going to be changed into a numeric data. Okay. Now when I'm doing this, okay, there are null values also over there, right? In this columns there are null values also. That in this current year, city years, there are null values also. Now since the null values are there, okay, if I'm going to do the conversion, I'm going to get error. Okay, I'm going to get the error because null values, how you are going to convert into numeric? There is no possibility. So I'm going to get some errors. So in order to avoid those errors, okay, in order to avoid those errors only, I will be doing errors equal to course. So when I'm doing the errors equal to course, what will happen is like all the null values are going to get filled. Clear? When I'm doing the errors equal to course, the null values are going to get filled. I'll say, okay, so see when this parameter, okay, whatever but you see if we are having any of the new numerical values are there, okay, any of the non-numerical values, whatever we are going to have, that will be replaced with an For example, let's take an example. Okay, let's take an example. Now I'm going to say that I'm having a data. Now that data is going to look something like this. Okay, I'm giving you an example. If I'm having a data, and everyone see very carefully, if I'm having a data, and that data is going to be like, see, I'm having integer, sorry, string to, just listen, see, we are having 3, and see, think that I am having a invalid data. Okay, think that I am having a invalid data, and then we are having a 4 also. Okay, so what it is going to do over here, when I'm going to convert this into some numerical data, so this is going to cause an error, right? One invalid data, right? So what it is going to happen, it is going to make this as NA. When I'm doing cos equal to errors equal to cos, okay, it is going to make this as NA. Understood? So this is basically making this as NA, so that I can convert any non-numerical also into numerical. See, NaN is going to be, see, apparently at last we will be removing the NaN, right? There will not be error, no error data will be there. So apparently at last we have to deal with the NaN value. So we are actually making it as a NaN. We are actually going to consider it as a NaN. That's what actually we are going to do. I have loaded the data set. Okay, purchase data. And then I have started with the EDA process. Okay, in EDA process, I have done some basic things like converting the data to numeric. Fine. Now we will be seeing the unique value count in some other data, some other columns. Okay. Now, which other column do you think that it can become integer? Age. So let's see about age. So over here you can see that age has been given in this way: 0 to 70, 55 plus, 26 to 35. So obviously this is actually not going to be an integer or float. It is going to be an object only. Okay. Since it has been given in the range format, so it doesn't matter if it is going to be 55 plus also. We don't have to change it. Since all others are in the same way, okay, we don't have to change it. There is no use of changing it, because it is going to be considered as a category only when we are going to label encode. You will be apparently going to do the label encoding later once again. So that time it is going to be considered as categories. Fine. Fine, guys. So I can just give you the reason over here. We don't need to fix 55 plus, as it will be considered as category while label encoding. Clear, guys? Now, the main other thing that is we have to see with the null values, right? Now we are going to see the null values. Data is null dot sum. Okay, so this is going to be a null value count. Can you see the null value count over here? So you can see the total data. Okay, total data is somewhere, this is 2,63,000 data is there. Right, 2,63,000 rows are there. Out of that, you can see that almost 1,82,000 are null values already. Fine. Now tell me, what should I do with the null values? Obviously, we can't drop this. Okay, obviously we can't drop this. Why? Because this is like a very huge data. 1,82,000. If you are going to drop, then that is going to result in data loss. First thing. Okay. Now replacing it with average is also, or replacing it with mean is also not going to be a good idea. Why? Because you can see that this data itself is 2 lakhs only. Out of the 1 lakh, if you are going to replace with median, that is not going to be proper. That is like obviously all the data we are giving it as manually, so obviously it is not going to give you a proper answer. But then you can consider this in this way that okay, over here the null values are something which are not there, right? For example, over here product category is 1 is 3 count. Now product category 2 NaN means it means there is no count for that or 0 count for that, right? Right. And product category 3, if it doesn't have any count, it means that it is 0 count. So the best option is to always replace it with the 0. Clear, guys? So in this case, what we can do is we'll replace it with 0. So dropping is not at all a good idea. Why? Because data loss it will result. Okay, don't drop it. So how we are going to replace it with 0? We are going to write data. First one is product category 2. Product category 2 dot fill NA. Then we'll be writing the 0 and then in place equal to true. Right? 0 comma in place equal to true. Hope you guys know the function of in place equal to true, right? Same, instead of product category 3, I'll be giving the product category 2, I'll be giving the product category 3. So we'll be done. Clear, guys? Everyone? Are you guys clear with this code? After this, if you're going to see the data, then you'll be able to see that it has been reduced or it has been filled. Fine. So now what you can do with the rest of the null values? In place equal to 2 is something which we use when we want whatever changes we are making over here, right? Okay, that changes has to depict in the entire data set. That is why we are doing the in place equal to true. Fine. Normally what we will do, normally if we are doing something, okay, we'll be writing the over here also we'll write, right? Data product category equal to. So instead of that data product category equal to, we'll be using in place equal to true. So it will be taken effect. Fine. Okay. Yeah. Just like Chandran said, now we can safely drop. Okay. Now we can safely drop the null values because now the count is very less. Okay. So whatever count is less, so we can just write the data dot drop NA in place equal to true. And at last we are going to be left with no null values or 0 null values. You can see now there is no null values. Clear? Fine. Obviously, if you want to find all the records, okay, with NaN, you have to see the data itself. Okay. You have to see the data itself. So for that, what you can do, you can just remove this sum from over here. Then you will be able to see all the null values. It will be shown in the Boolean way. Okay, false, true. If it is somewhere false, true. Like if there is any null value somewhere, then it will be shown like true. Okay, that way it will be shown. SAP, it is going to be like NaN. So you can't understand what it is over there. Should be written as NaN, NaN, NaN. Okay. Or you can use the loop. You can simply create a loop. Now it is not going to be zero, null value, right? So that is what I'm saying. Priyanka, now it is no more a null value. That's why we have resolved the null value. Okay. So you can even create a loop to see all the NaN values. In that loop, you can mention why we have dropped. Obviously, we have to drop. We can never go with a null value for a process. Always we have to impute all these null values whenever we are going to do, because the missing values, okay, is going to create a problem in our analysis. We want everything to be considered. That's why. Fine. Yeah, over here in this data set, okay, in this data set, most of the null values are going to be actually 0. So since there is no count only, it became 0 apparently. Okay. Because you can just think about that. In product category 1 and product category 3, it shows the quantity. So when there is no quantity or when there is 0 quantity, it is going to be mentioned as NaN. So that is why I converted everything into 0. Got it? Clear, guys? Now I'm going to do the label encoding over here. So label encoding, for that we have to import the library from sklearn.preprocessing, import label encoder. Then after that, I give the alias. I'm going to change. So which all were the object columns? First of all, we will see which all were the object columns which we wanted to convert. So we are having the main things which we have to consider. That is a city category is there. All right. That is in the object. Then we have the product ID. We have the gender. We have the age. Okay. So these things we have to convert into numerical. Okay. See, this is the label encoder. Okay, label encoding library which we are using. Okay, label encoding. sklearn.preprocessing import label encoder. That's a label encoding data. So whenever we want to convert any of the categorical data into a numerical data, we'll be using something called label encoding. Okay, now label encoding is something which is going to encode whatever categories we are having. Okay, you can say on the basis of proper order, on the basis of proper alphabetic order otherwise. Okay, so if you are going to have something like A, B, C, then the label encoding is going to do what? Label encoding is going to encode all these things properly. Okay, it is going to make it into number format. Okay, in proper order. That is what label encoding means. For that only we are using over here the label encoder. Okay. Now I'll be doing it separate. Okay, one by one I'm going to do the label encoding. That is starting from the cities category. So I'm first selecting the city category. Now city category, what it is going to be? It is going to be label encoding, fit transform, data city category. Okay, the same way I'm going to do for the other things also. That is for the product ID. Now again for the gender. So I hope we are done. Okay. So this way. So why we are doing this transformation again, or why do we have to do the label encoding again? So why? Because some of these things, okay, we won't be able to. Okay, some of these categorical datas we won't be able to directly make it into numerical format in the using the as type or using the PD to numeric. We won't be able to do that. Okay. So in that condition, we have to use some method called encoding. Why? Because at last the whatever statistical performance we are going to do, we won't be able to do those statistical performance in a categorical data. We have to come to a numerical data in order to perform all the statistical tests. Right? Even if it is going to be a machine learning also. If just think that we are going to do some machine learning model, okay, model building. Okay, over there also we won't be able to do any of the like coding anything with the categorical data. We have to do it with the numerical data at last. Okay. So in that case, if we have to take, okay, if we have to take something like in numerical like data, then we have to convert it. Fine. So that is why we are doing the label encoding. Fine, guys. Yeah, you can decode it back and later. Okay, but it's not necessary because over here you are actually going to perform the statistical test. You are not going to see these things back. If you're doing the machine learning, you're over there going to do the prediction with that for the target. So you will be learning those things later, I guess. Okay. But changing any of the categorical into numerical is a very must thing, because obviously in a category you won't be able to do any statistical test, right? That is not possible. So how we will know whether to use this library or not? Obviously, if it is going to be object and if it is going to be a categorical data, you have to convert into numerical data. So for that, you have to use this library, label encoding or label encoder. That's all. Clear? Obviously, gender also is in object. So obviously, you have to convert that also. So now in this, okay, in this gender is not that much important. Okay. In this, gender is not that much important. It's very fine if you're not going to convert this gender also, because with gender I'm not going to do any statistical test. Okay, in this gender I'm not going to do any statistical test, so it's fine if you're not going to consider gender also. But since it was an object, that's why I considered that also. And if you're going to do the machine learning later, in machine learning it is must that you have to convert this gender also, because obviously your machine won't be able to understand the categorical data, so machine need that in the format of numerical data. Fine. So once I am done this with this thing, you will be able to see the info. Everything will be converted into integer or float values. Can you see? All the objects have been changed. So your data will be in an encoded format like this. So data will be in a 0, 1 format. City category was an object earlier. City category also was in the form of object. See, it was an object. Can you see? It was an object. That's why we did that. Gender also converted. Gender also converted into integer right now when we have done with the encoding. See, gender also that is fine. The bit is going to be totally fine. That doesn't matter. Okay. See, now there is nothing which is still object. You can see where is object. I can't see any object over here. I can't find any object. Product ID is also integer. You can see. Priyanka, you can see very clearly. Even the product ID is been changed as integer. Okay. Nothing is actually over here. Occupation. Okay. Occupation over here shows what? Okay. Occupation over here is actually already encoded data, I guess. Okay. It might be an already encoded. That is why it is showing like that. Fine, guys. So now you are going to see your data. So this is going to be your data. You can see that this is the data. Fine. Now, what is the next thing which you are going to do? You are going to do statistical analysis. We are going to start with the statistical analysis. That is a main step or main idea behind doing this case study. Fine. Hope you guys are aware about the statistical analysis. Okay, so I'll not be much going into statistical analysis, the deep into statistical analysis. Okay, I'll be going with whatever you guys have already learned. So in statistical analysis, I'll be giving a small brief about that. The things or the steps which are involved in the statistical analysis, I'll mention it over here. Okay. That is first thing is going to be the data collection, right? So we have already done data collection. Then the second thing is preparing samples. We have to prepare samples. Third thing, obviously we won't be able to consider the entire data for the statistical test. So for that, we have to create a small sample. You might have already learned that, right? Then after that, you have to create two hypotheses, right? That also you might have learned, creating two hypotheses. That means one is what hypothesis? What are the two hypotheses which you are going to create? Tell me. What are the two hypotheses which you will be creating? Yeah, one is null hypothesis. One is null hypothesis and the other one is alternate hypothesis. These are the two hypotheses. Now, fourth one is going to be, we have to apply the appropriate test. Okay, you have to understand the appropriate test and apply it. That is the next one. So that you will be applying based on a requirement, okay, or case. Now the fifth one is, obviously you will be getting, okay, you will be getting you'll be getting a this p value. Okay, you'll be getting a p value. Now with the p value, you guys are going to understand whether it is going to be accepting the null hypothesis or rejecting the null hypothesis. So that how you are going to understand. If p value is going to be greater than 0.05, then you will accept the null hypothesis. Okay, and if it is going to be less than 0.05, then it rejects the null hypothesis. Okay, so these things are already clear for you guys, I hope. Okay, already you guys are aware of these things. So still I have given a small brief about this. Okay. So these were the statistical analysis, okay, which we'll be doing, right? Which normally we'll be doing statistical analysis, that is data collection, preparing samples. Then we'll be creating the hypothesis. Then obviously we'll be applying the test, which are appropriate tests are there. We'll be applying that. Then on the basis of p value, we'll be evaluating it. Okay. So in the case study, okay, we have been given with certain type of question. So this is the first question. I'll paste the first question over here, but I don't have the PDF or anything of that. Okay. In one notepad, I have been given with some of the question. So this is the first question, that the average purchase made by the men of age 18 to 25 was 10,000. Is it still the same? Okay. So they are saying that, okay, it was observed that the average purchase made by the men of the age 18 to 25 was 10,000. Is it still the same? This is the question. Okay. So when you see this itself, okay, you will be getting different types of ideas. What type of test? Okay, what type of test you have to do. But before doing that, you have to do the collection of data. So for that, you have to first of all filter the data. Okay, filter the data means you have to first take all the category of men. That is the first thing. Then your second task is you have to take all the categories which are in between 18 to 25. These are your two main things. Now you have to understand one thing. You have to just compare it with the previous data. In previous data, it was first all female, then male. Okay. But when you got label encoded, okay, first all the female became 0 and all the male became 1. Right? Can you see that? All the female became 0 and all the male became 1. So over here, male represent 1. Okay, male over here represent 1. Male over here represent 1. So you can just easily using the comparison. Bobby, easily using the comparison, you are able to understand. See, gender, age is going to be 0 to 17. Right, sir? So 0 to 7, about the gender. It is all female. All the first 0 is female, first is female, second is female, third is female. Now go to the label encoded data. In label encoded data, first is, this is female, so it became 0. Now this is male, obviously it is going to be 1. Okay, the opposite of female is 1. That's all. So male has been going to be considered as 1. Now, how we are going to filter the data? I am creating a new data. equal to new data equal to I'm writing data age equal to 1. Say age equal to 1, I'm writing why, because it is in the first category 18 to 25. Okay, since it is in the first category, it is going to get 1. Okay, since it was in the first category, it is going to get 1. So always label encoding is going to encode on the basis of order. Okay, on the basis of order only it is going to encode it. So because of that, 18 to 25 is going to get 1. Fine. This 0 to 17 is going to be 0. 18 to 25 is going to be 1. 26 to 35 is going to be 2. So on the basis of order only label encoding is going to work. Got it? Clear, guys? So this is 0. This is going to be 1. This is going to be 2. This is going to be 3. And this is going to be 4. And at last this is going to be 5. This is how label encoding is going to work. So obviously that is why I'm mentioning age equal to 1. So that means I am only selecting this category, that is 18 to 25 category. Okay. So if it is going to be characterized, okay, on the basis of that, it is going to label encode, that is like on the basis of order which they have been given. Okay. The alphabetic order, you can say otherwise. And data gender equal to 1. Okay. One is data age equal to 1, and the other one is data gender equal to 1. So data gender equal to 1 means I am selecting all the males, and data age equal to 1 means I am selecting all these categories 18 to 25. Now, yeah, see, for mapping that, if you are having some confusion, okay, I can help you with a code. Okay, so there is a code actually. When we are doing the label encoding, we normally use that code. So if you are going to use that code, you will be able to understand it little better. But the issue is like right now, since we have already done with this, we will not be able to use that code again over here. That is the only issue. But I'll help you guys with that code also. Okay. See, suppose if we were not doing this label encoding like this, okay, suppose if we were not doing the label encoding like this, we have a code. Okay, we have a code which we can use in order to do the label encoding. That I'll write it over here. Okay, so now that is a loop code. Okay, that is a loop actually which we'll be using. That loop, using that loop, we'll be able to understand it. I'll just write it over here. So I'm actually selecting all the object column in that loop, and I'm going to convert all this, and I'm going to fit transform data I. So I'll show you how this program works also. Okay. So right now I don't have any other files, so I have to basically go with this code only. Dot transform and lead dot class service. Okay, so this is going to be your code. Okay, now if I am going to run this right now, it is not going to work. So basically, I guess I have to start running it from the starting, then only it is going to work. Okay, so what I'll do, I'll make this as comments. Okay, I'll make all these as comments. This thing, so you are already understood, right? Converting this. So I'm just making these both as comments. Now I'm only going to run this. Okay, so I'll restart the kernel and I'll start running it from the starting. See, so right now over here, you will be able to see each and every encoded data. Each and every encoded data you will be able to see. Since it is like very big, okay, since it is a very big data, you have to basically go deep down in order to see. So over here, can you see the column age and its encoded data? Over here, 18 to 25 has been converted to 1, 26 to 35 has been converted to 2, 36 to 45 has been converted to 3, 46 to 50 has been converted to 4, 51 to 55 has been converted to 5, and whichever 55 plus has been converted to 6. Now is the explanation clear for everyone? Whoever was having doubt regarding the label encoding, right now is it clear? And about the gender also, female has been converted into 0, male has been converted into 1. Clear now? The previous code also, it is doing the exact same. Okay, with the previous code also, we are doing the exact same only. But what we have done over here, I have done like I have shown, okay, whatever things what actually happening in the previous code, I have made it little wide over here. That's all. Yeah. Okay, I have made it little more wide over here. No, it's not an index value. Okay, Vinayak, it's not an index value. Yeah, obviously, previous code is little easy. You can go with this previous code. But just this is for the understanding how it is getting encoded. Now about these codes, okay, right now even if I'm going to teach about this code also, you guys are not going to get understanding that much because these things are under the machine learning. Okay, you guys have not reached the machine learning, I hope. So after the statistics only, I guess it is going to start, right? It's basically I'm creating the loop. I'm basically creating the loop for the label encoding, and after that I'm showing the original and the encoded. So original means this is going to be my original class. Now for the encoded, okay, there is something called the classes. The label encoder dot classes is there. So in that you will be getting the encoded value. That is what actually it is happening. So this is the label encoder dot classes, and whatever after transforming with the label encoding, it is going to be this, the new data. Got it? Even if it is going to be bigger also, it is going to start giving from the 0 only. Okay, let it be big also, doesn't matter, it is going to start by giving 0. You can see, and it is going in order 0, 1, 2, 3, 4, 5, 6, like that it will go in order. Okay guys, fine, we don't have to waste much time over there because it's for the basic understanding. You should understand that what it is and how it is happening. So that's how we have taken age equal to 1 over here. That means 18 to 25 has been label encoded as 1, and the gender has been encoded as 1 over here. Okay, male. For male, it is 1. Fine till here. So what will happen if we are going to do this? I'm going to get a new data, and that new data is going to be this. Okay, we'll be getting somewhere around 36,332 datas. Fine guys, 36,332 datas we'll be getting when we filter this. Now my question is, what is the test which you guys are going to apply over here? What is the test which you guys are going to apply over here for finding this? One sample t-test, right? It's so obvious that it is going to be a one sample t-test. It's so obvious, right? First of all, there is no standard deviation given. Obviously, so t-test. Now, second thing, obviously it's a one sample because it's mentioned 10,000. Right? So obvious that it is a one sample t-test. So we will see the average. Okay, the average purchase. We can see normally itself the average purchase. We can see if you want how you will be seeing the new data. Purchase dot mean. So this is your average purchase. The mean of the purchase. This is the mean of the purchase. Okay, the purchase column mean is this. Okay, first I'm going to create a sample. Okay, sample equal to, I told you, right? We have to create a sample also. After filtering the data, we have to prepare the samples. So I'm going to prepare the samples. I'm going to collect new data equal to new data dot samples. I am going to consider, I'm going to see normally how many samples we are going to consider. Any idea? Okay, see guys, understand one thing. Okay, when you're doing in the when you're learning in the theoretical way, it is going to be 30. Okay, but yeah, obviously, so it is going to be 30. Now, in order to, when you are using in the practical way, when we are doing it in the practical way, okay, at least 10%, minimum 10% of these values I have to consider. Okay, whatever values I have given or got over here, at least 10% of that values I have to consider. So for example, it's 10% will include this 36,000, 10% will approximately, it is going to be 3,600. Since it is 3,600, I am going to consider 3,600. Okay, and it's not necessary that you have to give the random state, but if you want, you can give it. Right? So 10% I'm considering. Okay. Obviously, it is obviously like that. So for t-test, it is less than 30. For c-test, it is greater than 30. Okay, that is how it is taught for everyone. That is true. That is the truth only. Okay. So if I'm going to consider like very less amount of samples over here, it is going to be an issue. Okay, so at least minimum of 10% of this entire data, if you are getting a sample, then that is going to be more easy, or that is going to be more accurate value we are going to get. Okay, see, what if the question is asked in exam, or we should have what in the interview? In the interview, obviously, it should be, you should mention it as 30 only. Okay, because it's taught in the way that it is if t-test is going to be taken, then it should be sample size should be less than 30, right? And right, if it is going to be greater than 30, and if standard deviation is known, then it is c-test. Okay, that is the way it has been taught. But since we need the proper type of answer or proper type of accuracy, or sorry, not proper type of accuracy, proper type of calculation, that's why we are taking 10% of the t-test. Okay, so it's an assumption. Over here, we are taking just the assumption. We are not taking the proper. Okay, we are taking the assumption of this. Right. Not till any limit. Okay, not you can take till any limit, but since we want to consider it for a proper answer, that's why we are considering 10% of the data. Okay, fine guys. So often this is a confusing thing. So over here, we are going to consider 10% of the data. Fine. And over here, it's one sample by, because you can see that over here only 10,000, only one sample has been given. Okay, it is asking whether it is still the same. Okay, so it's not going to be two-tail. Random state is going to do all these process, okay, with a randomly generated data. Now that randomly generated data can be same if you guys are also using the random state 5, then for in your system also that randomly generated things are going to be same. Fine. Okay. If SD is not given, you can go with that. So in the question it is not mentioned. So obviously you can go with the t-test. And obviously it is a t-test only. Let me just see. Data frame has no. Okay, see, that is a mistake by the code. Actually, it is not samples. It is sample. That is why we are getting. So it is going to be sample new data dot sample. we can consider somewhere around less, very least, okay, number. Okay, now you can consider less than this also. That is also going to be fine. Okay. Now it's an assumption only. That's what I said. This is an assumption only. You can consider less than this. Okay, guys, are you guys understanding it? It's just an assumption. You can consider less than this. Now, if you guys are very much comfortable in considering very less data, that just like you guys are saying 30, you can go with that. Fine, totally fine. Okay, fine, guys. Now, should we make the hypothesis testing? Should we make the hypothesis if we are done till here? So how we are going to make the hypothesis? The hypothesis is going to be made on the basis of p-value, right? So what is going to be the null hypothesis over here? According to the question, what is going to be the null hypothesis? So according to the null hypothesis, we are going to get that the average, okay, the average, whatever average we are going to get, or the mean, that is going to be equal to, mean will be equal to 10,000, right? Mean will be equal to 10,000 means what? That is what actually they are telling, right? Is it still the same? It was 10,000. Is it still the same? So that is going to be the null hypothesis. And our alternate hypothesis is going to be what? Alternate hypothesis equal to mean will not be equal to 10,000. Fine, guys. So how we are going to import the one sample t-test? How we are going to do the one sample t-test? From scipy.stats, we are going to import t-test underscore one sample. Okay. Now, what is the assumed mean? This is the assumed mean is 10,000, right? Our assumed mean is 10,000. Okay. Now, when we are doing the t-statistics, we will be giving t-stat and p-value, okay, which both are important for us. But p-value, on the base of p-value only, I am going to do the assumptions. So I'm going to do the t-test one sample. Our sample is what? Our sample is purchase. Okay. And our assumed mean I am giving. I'll be printing two values, that is the p-value and t-stat, and you will be getting a p-value of somewhere around 1.79. Is it greater than or less than 0.05? You can see that over here there is an exponential raised to minus 10 also. So don't leave this. Okay. So in this case, what you have to do is just write if, just do the conditional statement. If p-value greater than 0.05, okay, print. So if it is going to be greater than 0.05, what is going to happen? It will accept the null hypothesis, right? So if it accepts the null hypothesis, then what will happen? What is going to be the answer? You can say mean will be equal to 1,000. Okay, you can say null hypothesis, that is equal to, I'm just writing this fully over here. Else, what is going to happen? Else, print, you can say that alternate hypothesis or rejecting the null hypothesis. So you will be able to see what is happening over here. What is happening over here? See, when we are running it, what is the answer we got? We are getting that it is rejecting the null hypothesis, it is accepting the alternate hypothesis, and because of that, mean is not going to be equal to 10,000. The mean is not going to be equal to 10,000. Fine, guys. With the 30 samples also, you can try this. Okay. So that confusion is going to get over. So that's why I said this is going to be assumed value. Fine, guys. Till here, is it clear? See, well, 30 samples can represent all the populations correctly or is not is a second concern. Okay, so according to your theory only, I was saying that. According to our theory, what our theory is there regarding the t-test, okay, one sample t-test, that only I was telling. Fine? It's a lol moment actually. Guys, this is the next question. The next question, guys. Just read this question and see whether you guys are able to understand the question or not. Okay. See whether you guys are able to understand this question or not. That is what actually I want to see. Over here, I confirmed it again. Okay, over here, it is one sample only. Okay, over here in the first question. Please understand that it is one sample only. Okay, don't, if you are having any confusion over there, please avoid that confusion. It is one sample only because you are comparing a single sample mean to a known value. Okay, you are comparing a single sample mean to a known value, so it is going to be a one sample only. Please don't have any confusion over here, please. So about the tail, see if it is going to be only if there is a specific direction given. Okay, if there is a specific direction given, like it is going to be greater, then you can say that it is one tail. So if there is no specific direction given, whether it is going to be greater or whether it is going to be lesser, then obviously it is going to be two tail only, right? Now, tell me guys over here, what is the question actually mean? Does it mean that 35% of the women are like out of the total? Okay, 35% of the women are spending more than 10,000. Sorry, 1 lakh, whatever it is, 1 lakh or 10,000. Yeah, 10,000. Is it that what it means? Out of all the women, okay, out of the 100% of women, 35% are spending more than 10,000. Is it what it means? Tell me. No. So that is why I said there can be a confusion over here. It is not like that actually. Okay. Out of the total population, okay, out of the total population, which includes men and women, okay, over there, 35%, okay, were spending more than 10,000. Okay, percentage of women who is spending more than 10,000 was 35%. That is what actually it is saying. Got it? Out of all the population, not out of the population of women. Okay, not out of the population of women only. So that is, don't have that confusion. Okay, normally people get that confusion over there. So it's out of total population. So what I'm going to do over here, I'm going to going to take all the purchase, okay, which is going to be greater than 10,000. So over here, what is going to be my null hypothesis? Over here, what is going to be my null hypothesis? My proportion, okay, over here it is proportion. Proportion is 35%. That is my null hypothesis. And my alternate hypothesis is what? Alternate hypothesis is proportion is proportion is not 35%. This is my alternate hypothesis. Okay. So right now I'm taking all these, I'm just filtering it out. Okay, I'm going to filter it out. So you can see that if I'm going to filter it out, data purchase, which is going to be greater than 10,000. 10,000. We'll be getting somewhere around 91,000 data. So we'll be getting, okay. Out of this 91,000, okay. Out of this 91,000, we can see that if the gender dot value counts, if you are going to take, we will be getting 72,372 are men, right? That means, what do you mean by this? The simple the explanation for this, okay, the most number of purchases has been done by men only, more than 10,000. That means 72,372. Women have done 18,685 count of women have there who have done more than 10,000. Got it? not 35 women, okay? Not 35 women, I'm saying 35 percentage. Here it is 35 percentage, not 35. It's not a number mentioned over there. Okay, so these are the value count. Actually, without even going with any of the statistical tests, okay, you will be directly able to do it. You'll be directly able to do it without even going for any statistical test, right? How you'll be able to? How you'll be able to test it? You'll be able to divide it. Just divide it and see whether you are getting the 10% or not. Sorry, 10,000 or not. How much percentage is it? Is it going to be the 35% of total? Your total is this. See whether it is 35%. So according to that, you'll be getting the answer. So right now, this is the count. This is the value count. This is the men count and this is the female count. Now tell me which test we should perform over here. That is my question. I can give you a small clue. Over here it is going to be the proportion, right? 35%. So proportion only we are actually seeing. Now you can just guess. Obviously, it's the C proportion. Okay, the C test. Right, that is what actually we are going to use it over here. The percentage it's already given over here. So we should assume that it's a proportion. We should understand that it's a proportion. So we should actually go on the basis of that. In that case, if we are going to go, okay, we have to do some main things before that. That is, first of all, we'll take the count. Okay. I'll just mention the count. So this is the number of women in the sample. Now, the number of observation. Okay, number of observation I will be writing. That is the number of observation I am giving as knobs. Okay, number of observation. That means don't get confused later. That is number of observation. Number of observation is going to be the total and my p-value. Okay, I'm going to give my p-value. That is my hypothesized value. I'm going to give p0 equal to 0.35. All right, so over here there is no doubt. So your count, your knobs and p0 values, your count is going to be, and knobs is going to be, and p0 we have already given. Count, knobs, p0. So your count is 18,685. That is the number of women in the sample. Then 91,057 is the total number of observation. 0.35 we are taking as the hypothesized value. Let's continue. Okay. So just like I said, okay, we will be easily able to understand this without even doing any of the statistical tests. We will be able to understand it very easily. How? We'll just, if you are going to divide this, okay, if you are going to divide this with this value, sorry, not with this value, with the total value, it should be. With the total value, if you are going to divide it, the answer which you are going to get is 20%. That is 0.20. Is 0.20 greater than or less than? Let me know. It is going to be less than 0.05. If it is less than 0.05, okay, then what does it mean? Reject, right? So obviously you will be rejecting the null hypothesis. So that is going to be the answer, but still we have to use the statistical test in order to confirm that. Okay, so I'm going to use over here. Okay, I'm going to use over here the from stats models. Okay, dot stats dot proportion invert because since it is a hands-on session, okay, the team is not going to allow to continue with the next class with the same. That is the issue. So you guys are going to be left with one question, right? That is why. So I'm just completing this only. Over here, knobs equal to knobs count equal to count, it should be. Okay, so we are getting obviously, see, p-value is 0. We are getting the p-value is 0 itself. So what does it mean? It means itself it is very less, right? So obviously you are going to reject. Okay, p-value is obviously p-value is less than 0.05. Okay, so that means you are rejecting the null hypothesis. So what does it mean? You are rejecting the null hypothesis means what? That means the proportion, whatever proportion of women, okay, spending more than 10,000 is not 35%. Okay, it is less than 35%. It's a great win for all the women over there. It's less than 35%. Okay, that means they are not spending that much. Don't worry. Fine, guys. Thank you, guys. Have a great day. Thank you all.
Just a quick info, guys. Intellipaat offers data analytics course in collaboration with IIT and PowerTech. Through this course, you will master Power BI, data modeling, data mining, and much more from the IIT Madras faculty and industry expert. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to a new height. So visit the course page link given in the description and take the first step towards the career in the field of data analytics.